Hello world, my name is David Malin, and this is CS50's Introduction to Programming with Python. Whereas CS50 itself is an introduction to the intellectual enterprises of computer science and the art of programming, this course is specifically focused on programming in Python itself. At the beginning of the course, we focus on a topic in programming known as functions and variables, mechanisms via which you can write code that solves smaller problems, but you can compose those smaller solutions into solutions to larger problems still. We'll then transition to a look at conditionals, a way in code of expressing yourself logically to maybe do something if some question has an answer of true, or not do something if the answer is false. We'll transition thereafter to introducing you to loops, the ability in code to do something again and again and again some number of times. We'll then transition to something a little more technical known as exceptions. Unfortunately, a lot can go wrong when you're writing code. Some of it your fault, some of it perhaps someone else's fault, but you can write code defensively, so to speak, and actually catch those kinds of exceptions, those errors, and handle them properly so that the users you're writing code for don't actually see the same. Thereafter, we'll take a look at libraries, third-party code written by other people often, or perhaps yourself in the past, that you can use and reuse in your own project so as to avoid reinventing the wheel again and again. We'll look thereafter at something called unit tests. It turns out you'll actually write code to test your own code, but you won't have to write tests for your tests. Indeed, this is a best practice in industry, writing tests for your code so that, one, you can be sure that your code today is, hopefully, if your tests are correct itself. But moreover, if you or someone else modifies your code tomorrow or down the line, you can rerun those same tests to ensure that those new changes have not broken anything about your own code. We'll then take a look at something called file I/O, I/O for input and output, the ability to not just store information inside of a computer's memory, but rather save it persistently to disk, so to speak, to files and folders. We'll then take a look at another technique known as regular expressions, whereby in Python you can define patterns and you can validate data to make sure the human types something in as you expect. You can use regular expressions to extract data, perhaps from some data set you're trying to analyze. We'll then take a look ultimately at object-oriented programming, a paradigm, a way of writing code whereby you can represent in code real-world entities. And this is in addition to other paradigms of programming that we'll also explore, among them procedural programming, where you write lots of those functions, procedures really, top to bottom to solve problems step by step, and even something known as functional programming as well. And then at the very end of the course, we equip you with all the more tools for your toolkit. And additional building blocks, additional vocabulary via which after this same course you can go off on your own and either take other courses or solve projects of your own using all of these mechanisms. Now this course itself assumes no prior programming background, so you don't have to have written a single line of code in Python or any language yet. But this is also a course that you can take before, during, or even after CS50 itself if you'd like to get all the more versed with Python. Each week via the course's lectures will we introduce you to any number of concepts that we'll then drill down more deeply into in the form of problem sets each week. That is, programming projects that will enable you to apply some of those lessons learned to problems of your very own. And by the end of the course, you'll have solved so many problems that ideally are representative of problems you'll eventually encounter in the real world. Whether you aspire to solve code in the technical world, or perhaps in the arts, the humanities, the social sciences, the natural sciences, or beyond, you'll have ultimately the vocabulary and the technical skills via which to approach the same. This then is CS50, and this is CS50's Introduction to Programming with Python. All right, this is CS50's Introduction to Programming with Python. My name is David Malin, and this is our week on functions and variables. But odds are many of you, most of you, have never actually programmed before, so let's start by doing just that. Let me go ahead here and open up my computer, and on it a program called Visual Studio Code, or VS Code, which is just a very popular program nowadays for actually writing code. Now, you don't have to write code using this particular tool. In fact, all we need at the end of the day is a so-called text editor, a program for writing text. And heck, if you really want, you could even use something like Google Docs or Microsoft Word. You'd have to save it in the right format. But really, at the end of the day, all you need is a program for writing text, because that's what code is, text. Now, within this particular program, I'm going to have the ability to create one or more files via this top portion of the screen. And I'm going to do so by diving right in and doing this at the bottom of my screen. At the bottom of my screen is a so-called terminal window. And this is a command line interface, or CLI, interface to the underlying computer, be it your Mac or your PC or even some server in the cloud. And what I'm going to do here is literally write code and then the name of the file that I want to code, for instance, hello.py. As we'll soon see, any program that you write in Python generally has a file name that ends in .py to indicate to the computer that it's indeed a program written in Python. Now, you'll see here at the top of my screen, I have a blinking cursor, a line 1, which is where the very first line of my code is going to go, and then just a tab that reminds me of the name of this file, hello.py. And without even knowing much Python, I'm going to write my very first program here as follows. Print, open parenthesis, quote, hello, comma, world, close quote, and close parenthesis. And you'll see that at my keyboard, some of my thoughts were finished for me. I only had to type one parenthesis, and the other one automatically appeared. And that's just a feature that we'll see of tools like this tool here. Now, even if you've never programmed before, odds are you can guess, infer what this simple program is going to do. And it's only one line. Print, open parenthesis, quote, hello, world, close quote, close parenthesis. Indeed, when I run this program, ultimately, it's just going to say hello to the world. And in fact, this is a very famous, perhaps the most canonical program that you can write as your very first program in Python or any other language. And so that's what I've done here. But on my Mac, my PC, even my phone, I'm generally in the habit, like you, of running programs by double-clicking an icon or just tapping on the screen. But I see no such icons here. And in fact, that's because my interface to at least my current Mac or PC or some server in the cloud is, again, only a CLI, command line interface, which even though it might feel like it's a step back from the menus and buttons and icons that you and I take for granted every day, you'll find, we think, that it's ultimately a much more powerful interface and incredibly popular to use among programmers in the real world. So to run this program, I'm going to have to use a command. And I'm going to move my cursor back down to the bottom of the screen here, where previously I already ran one command, the command code, which has the effect of opening VS Code in my computer. And then I passed in the name of the file that I wanted to code up. Now I have a chance to type a second command, and you'll see I see a second $sign. Now, the $sign here doesn't indicate any kind of currency or money. It just is the symbol that's generally used to indicate your prompt, where the command line interface wants you to put those commands. Now, the command I can run here is going to be this. I'm going to run Python of hello.py. Now, why is that? Well, it turns out that when I actually write code in a language like Python, it's, of course, stored in that file, hello.py. But I need to interpret the code top to bottom, left to right, so that the computer knows what to do. Indeed, at the end of the day, even if you don't really know much about computers, you've probably heard that computers only understand zeros and one, the so-called binary system. Well, if that's the case, then something that says print and parenthesis and quote unquote hello world is not surely zeros and ones. We have to somehow translate it into the zeros and ones that the computer understands. Now, fortunately, so long as you've installed such a program in advance, there's a program as well as a language called Python. So Python is not only a language in which we're going to write code, it's also a program, otherwise known as an interpreter, that you install for free on your own Mac or PC or some server in the cloud. And you can then run that program, that interpreter, passing to it as input the name of your file, like mine here, hello.py. And then that program, that interpreter, will handle the process of reading it top to bottom, left to right, and translating it effectively into those zeros and ones that the computer can understand. So let's do just that. Let me go back to VS Code here. I already typed out Python of hello.py, but I didn't yet hit enter. And that's what's now going to kick off this command. And hopefully, if I didn't mess any of this up, I should see my very first program's output to the screen. And voila, hello world. So if you too have typed exactly that same code and have executed exactly that same command, you will have written your very first program, in this case, in Python. Well, now let's take a step back and consider what is it that we actually just did and what is it we're looking here on the screen. Well, first and foremost, in most any programming language, you tend to have access to what are called functions. A function is like an action or a verb that lets you do something in the program. And generally speaking, any language comes with some predetermined set of functions, some very basic actions or verbs that the computer will already know how to do for you, that the language really will know how to do for you, and you, the programmer, the human, can use those functions at will to get the computer to do those things. Now, the program in question here, hello.py, is using one function. And you can perhaps guess what it is. That function is, of course, going to be this function print. And that print function, of course, doesn't print some preordained string of text. That is to say, it prints whatever it is you want it to print. And here, too, do we have another piece of terminology in the world of programming, namely arguments. An argument is an input to a function that somehow influences its behavior. The people who invented Python, of course, didn't necessarily know what it is you and I are going to want to print to the screen. So they designed this print function using these parentheses with the ability to take as input some string of text, be it in English or any other human language, that is what you want this function ultimately to print onto the screen. And what is it that the program's ultimately doing on the screen? Well, it's printing, of course. It's showing us hello world on the screen. And that's generally in programming known as a side effect. It can be visual, it can be audio. In this case, it's something that appears on the screen. And functions, therefore, can indeed have these side effects. One of the things they can do as this verb or action is to display on the screen as a side effect something like those words that we wanted, hello world. So that's my first program. And, you know, I'm feeling pretty good. Everything worked as planned. I didn't make any mistakes. But honestly, when you're learning how to program, and even once you've learned how to program years later, you're going to make mistakes. And those mistakes, of course, are referred to a term you might already know, which is that of a bug. A bug is a mistake in a program. And they can take so many forms. And take comfort, perhaps, in knowing that over the coming weeks, you're going to make so many mistakes. You're going to have so many bugs in your code, just like I did, and just as I still do. And those bugs themselves are just mistakes that are problems for you to solve. And over the weeks to come, we're going to give you a lot of tools, both mental and technical, via which you can solve those problems. But just don't get discouraged if when writing your program for the first time, it doesn't even work that first time. It will, with time, with practice, and with experience. So let me deliberately now make a mistake that there was a non-zero chance I might have done accidentally already, but I got lucky. Let me go ahead and just suppose I forgot to include something like the closing parenthesis at the end of this line of code. You know, the code is almost correct. It's like 99% of the way there. But now that I've pointed it out, it's pretty obvious that it's missing that closed parenthesis. But even little, seemingly minor details like that, that you and I as humans wouldn't really care about. And if you're sending an email or a text message, whatever, it's just a typo. It's not that big a deal. It is going to be a big deal to the computer. A computer is going to take you literally, and if you don't finish your thought in the way the language expects, it's not going to necessarily run at all. So let's do this. I'm going to go ahead here and clear my screen down at the bottom, just so I can start fresh. And I'm going to go ahead and run this version of my program after having made that change by deleting the parenthesis. I'm going to go ahead and type Python again of hello.py. And this time when I hit enter, I'm hoping I'm going to see hello world, but here we have an error on the screen, a so-called syntax error, which refers to my having made a mistake at my keyboard. And this one, fortunately, is pretty straightforward. It indeed says that this open parenthesis was never closed. And so that's probably pretty intuitive now what I need to do. I need, of course, to close it. Unfortunately, sometimes the error messages we'll see in the coming weeks are not going to be nearly that user-friendly. But there, too, again, with experience, with practice, will you get better at debugging such programs. Let me now make sure that I indeed fixed it correctly. Let me go ahead and run now hello.py and hit enter. And voila, we're back in business. Well, let me pause here and see if we have any questions now about Python itself, writing or running even the simplest of these programs.
Could I write code inside a Word or, for example, Microsoft Excel? And what's the barrier to doing that?
A really good question, and allow me to very explicitly say to the entire internet that you should not write code with Microsoft Word. I mention that only because it's a tool via which you can write text, and code is at the end of the day just text, but it's not the right tool for the job. We don't need bold-facing, underlining, paragraphs, and the like. We generally want something much simpler than Microsoft Word or Google Docs, and so VS Code is an example of just a more general-purpose text editor. Its purpose in life is to allow you, the human, to edit text. Nowadays, these text editors come with many more features. In fact, you'll notice that even in my code here, even though it's just one line, there's a bit of color to it. The word print for me is appearing in blue. The parentheses are black. And we'll see as we might write more lines of code, more and more of the lines will come to life in various colors. Now, that's just one feature of a text editor. We'll see, too, that it has features like this built-in terminal window. It's going to have a built-in tool for debugging or finding problems with code. And it's just a very popular tool nowadays. But there are many, many others out there. You're welcome to use them for this course and beyond. We just happen to use this one in large part too because you can also use VS Code nowadays for free in the cloud. How about one other question here on programming with Python or Hello World or syntax more generally?
Okay, I was trying to ask if it is not possible to run the code without using the terminal window.
I think I heard, is it not if it's possible to run the program without the terminal window? Are you?
Yes, sir.
OK, you froze for me again, but let me infer what the question is. So in this environment, as I've configured my computer, I can only run these Python programs via the terminal window. Now, that's good for me, the programmer, or the person who's trying to learn how to program. But it's not very good if you want to ship this software and have other people use your actual code. You can absolutely write programs and then allow other people to use not a command line interface, but a graphical user interface, or GUI, GUI. This is just one mechanism. And perhaps I think the best one with which to start writing code, because eventually it's going to give us a lot more control. Allow me to forge ahead here, but please feel free to continue asking questions along the way, if only via the chat. And let's consider now how we might go about improving this program. Let's go about improving this program to make it a little more interactive and not just assume that everyone is going to want to be greeted more generically as hello world. Let's see if I can't get this program to say something like hello David, or hello Jeremiah, or hello Horatio, or whatever the actual user's name is. Well, to do this, I'm going to go back up to hello.py, and I'm going to add another line of code at the very top that simply says, for instance, what's your name, quote unquote, with an extra space at the end. So I'm printing to the user, asking them a question for some input. But now I need another function to actually get input from the user. And perfectly enough, Python comes with a function named input. So here I'm going to go ahead and call a function input, open paren, close paren. And that's going to prompt the user with just a blinking cursor waiting for them to type something in. Now, it turns out if I read the documentation for the input function, it actually takes an argument itself. I don't need to use print separately and then prompt the user for input. So I can actually simplify this code before we even use it. I'm going to go ahead here and take that same string from print, put it as an argument to the input function, and get rid of the print altogether. And in fact, that print would have added a new line anyway. So now I've just got a prompt where the user's cursor is going to end up blinking at the end of the line, asking them, what's your name? In my terminal window, I'm going to run Python of hello.py, enter. OK, we're making progress. It seems that this new function input is indeed prompting me, the human, for input. So I'm going to type in my name, David, and hit enter. Unfortunately, it doesn't really do anything with my name. It just outputs it immediately. All right, well, I could fix this, right? I could go up to line 2, and I could change world to David. And then back in my terminal window here, I can do Python of hello.py, enter. What's your name? David, enter. And there we go. All right, now I'm up and running. Now my program is working as intended. Of course, this isn't really working as intended here. Let me go ahead and try pretending to be my colleague Carter here. Well, Carter's name is this. I'm going to go ahead and hit enter, and I'll see, of course, hello Carter. Well, obviously not, because I've hard-coded, so to speak. I've written literally my name inside of the string. So we need some way now of actually getting back what the user's input is and doing something with it ultimately. And for this, we're going to leverage another feature of programming, specifically a feature of some functions, which is that they can have return values as well. If you think of input as being, again, this action, this verb, you can actually personify it as maybe a person, like a friend of yours that you've asked a question of. And you've asked your friend to go get input from someone else. Go ask that person their name. And if your friend comes back knowing that person's name, well, wouldn't it be nice if they handed that name back to you? That's kind of what we need metaphorically the function to do, is get the user's input and then hand it back to me so that I, the programmer, can do something with it. But if it's going to be handed back to me, I kind of want to put it somewhere so that I can then print it back on the screen. I need to do the equivalent of take out like a piece of paper or a Post-it note, write down on this piece of paper what it is the human has said so that I can then feed it into as input that print function. And to do that, we're going to need one more feature of programming, namely variables. And odds are most everyone's familiar with variables from math class way back when, x and y and z and the like. Well, programming has that same capability, this ability to create a variable, in this case in the computer's memory, not just on a piece of paper, and that variable can store a value, a number, some text, even an image or video or more. A variable is just a container for some variable. A variable is just a container for some value inside of a computer or inside of your own program. So how do I go about expressing myself in this way? Well, I think what I'm going to do is introduce a variable that's a little more interestingly named than x or y. I could just say this, x equals input, but I'm going to use a better name than a typical mathematical variable here, and I'm going to literally call my variable name. Why? Well, in programming, because I have a whole keyboard in front of me, I can use more descriptive terms to describe what it is I'm writing. And now, though, there's an opportunity to consider a specific piece of syntax. We've seen parentheses. We've seen quotes, all of which are necessary when passing inputs to a function. But this equal sign here that's in between input on the right and name on the left is actually important. And it's technically not an equal sign per se. It doesn't mean equality as much as it means assignment. So in Python and many programming languages, a single equal sign is the assignment operator. And what that means specifically is that you want to assign from right to left whatever the user's input is. So the equal sign copies from the right to the left whatever the return value of the function on the right is. So again, the input function clearly gets input from the user. That's why I was able to type my name or Carter's. But it also sort of behind the scenes hands that value, that return value, back to me, the programmer. And if I use an equal sign and a variable, no matter what I call it, I can store that input in that variable so as to reuse it later. So now sitting in the computer's memory somewhere is a container containing David, quote unquote, or Carter, quote unquote, or whatever the human has typed in. But here it's easy to make a mistake. Suppose I decide to try to print that name. And so I kind of, on a hunch, type in this, hello, comma, name, just kind of plugging in the name of the variable. Well, let me go ahead here and run Python of hello.py and hit enter. That's going to prompt me for my name. And let me type in my name, D-A-V-I-D, but I haven't hit enter yet. And perhaps via the chat, what's going to happen here when I now hit enter? I'm hoping it says, hello, David. I'd be OK if it says hello, world. But I don't want it to say what it's actually going to say. And yep, what we're seeing in the chat is, well, it's probably going to say literally hello, comma, name. So that's not quite right. So we need another way of printing out the value inside of that variable rather than just this word name. Well, let me try this in a couple of different ways. Let me try this as follows. Let me go ahead and maybe undo this because I've gotten pretty good already at saying hello. So let's draw that line in the sand and just say, all right, let's at least get hello, comma, out the door. Let's now print name, and just on a hunch, I'm going to try this. I'm going to use print again, because you can use these functions as many times as you need, and I'm going to pass to the name, to the print function, the variable called name. But notice, I'm being a little clever now. I'm not putting it in double quotes, because we've seen already that double quotes means literally print out N-A-M-E. I'm getting rid of the quotes this time in hopes that now by passing the variable called name to the function called print, it will in fact go about printing the contents of that variable, that is, its so-called value. All right, let's go ahead and do this here. Python of hello.py, enter. What's your name? David. And now, crossing my fingers still, I see hello, comma, David. All right, so it's not the best program. I'm kind of cutting some corners here, so to speak. I'm saying, hello, David. on 2 separate lines. So it's not as elegant, it's not as pretty, it's not as grammatically appropriate in English as just saying it all in one breath on one line, but at least I've solved the problem. Just not very well yet. But let me take a step back now and perhaps introduce a couple of other concepts with which we should be familiar, which is as our programs get longer and they're no longer just 1 line or 2 or even 3, eventually our programs are going to become dozens of lines, maybe even hundreds of lines long. Let's set the stage for success moving forward. It turns out that Python and a lot of programming languages also support something called comments. Comments are notes to yourself in your code. And you include comments by way of a special symbol. In Python, it's going to be the hash symbol, typically. And that allows you to write the equivalent of a note to yourself, but in a way that's not going to break your code. The computer actually ignores your comments. It's just there for you. It's just there for your teacher. It's just there for your colleague with whom you're sharing ultimately that code. So if I go back to VS Code here, and I just want to add some comments to this program to explain to my teacher, to myself, to my colleagues what this program is doing, well, let's go ahead and do that. I'm going to go at the very top of my program. And on line 1 now, I'm going to move that original line of code down a bit. I'm going to add a hash. And I'm going to say something like this, ask user for their name. Now, I don't have to use that language. I don't have to use that text. I could use any human language whatsoever. It doesn't have to be English. But I'm going to now, below that, just say something like this, say hello to user. And you'll notice that VS Code by default is kind of graying out my comments. They're no longer blue. There's no red. There's no color in them. And that's just because they're notes to myself, and the computer ultimately is going to ignore them. But what we have now is 2 comments, ask user for their name, and then a second comment, say hello to user. And I've just kind of commented each chunk of code, like each line or lines plural of code that are doing something noteworthy. Why? Well, tomorrow morning when I wake up, having slept for quite some time, forgotten what it is I did the previous day, it's convenient with comments to just see in English or your own human language what it is this program is doing, so that you don't have to read the code itself. And better yet, if there's maybe a mistake down the road, you can read what your intention was, and then you can look at the code and figure out if your code's now doing what you intended. So this isn't really necessary for a program this small. It's pretty obvious with just 1 or 2 or 3 lines what the program's doing. It's just as fast to read the code than the comments. But getting into this habit is generally a good thing, to comment your code every 1 or few lines so as to remind yourself and others what it is your intent and your code is doing. What's nice about comments, too, is this. Comments can also serve to be sort of a to-do list for yourself. There's this notion in programming of pseudocode. Pseudocode isn't a formal thing. It's not one specific language. It's just using English or your own human language to express your thoughts succinctly, methodically, algorithmically, so to speak. But pseudocode, therefore, because it's not Python and it's not necessarily English, it just kind of allows you to outline your program even in advance. So for instance, if I wasn't sure today how I wanted to go about writing this program, but I did know what I want to do, I could have started today by just writing this in hello.py. No code. I could have written just a couple of comments to myself. Step 1, ask user for their name. Step 2, say hello to user. Then, once I've outlined my program in pseudocode, then I can go in there and say, all right, how do I ask the user for their name? Well, I can do input, quote unquote, what's your name, question mark. And then on the left here, I can maybe put a variable and assign it to that. OK, how do I say hello to the user? Well, I know I can use print to say things on the screen. Let me say hello, comma. And let me now print the person's name. So again, pseudocode is a nice way of structuring your to-do list, especially if you have no idea how to write the code, because it breaks a bigger program down into small bite-sized tasks. All right, let me pause here to see if there are now any questions on comments, pseudocode, return values, or variables. Any questions we can clear up here?
Yeah, my question is, does the function input work for any type of information or only for words?
Yeah, really good question. So according to its documentation, and we'll look more at formal documentation soon, input is going to expect what's called a string. That is a sequence of text, be it in English or any other human language. But it's indeed going to be expecting text with which to prompt the user. A good question. How about another question from the group, if we could?
I wanted to ask how I make several line comment.
Oh, how do you do many lines of comments, if I'm hearing you correctly? Sure. You would just keep doing them like this. You just prefix each of the lines with a hash symbol, like I'm doing here. There is another technique for doing multi-line comments in Python that actually tend to have special meaning. You can do 3 double quotes like this, and then anything in between here is a comment. That's another technique, or you can use single quotes as well, but more on those, I think, another time. All right, well, if you don't mind, let me forge ahead here and see how we might improve this program further, and also introduce a few other features that we might want to take into account over time. So it turns out that we can certainly improve on this program, because it's a little disappointing that I'm cutting this corner and saying hello, comma, and then on a new line, printing out name. Like, we can do better. And most programs you use on your phone or your laptop certainly keep text together when people want. So how can we go about doing that? Well, there's a few different ways. And in fact, the goal here is not so much to solve this one problem, but to demonstrate and emphasize that in programming, Python and other languages, there's so many ways sometimes to solve the same problem. And here's one way to solve this problem. Let me go in here, and let me go ahead now and say hello, comma, and let me just add to the end of that the user's name. So I'm using plus in kind of an interesting way. This is not addition per se. I'm not adding numbers, obviously. But I do kind of want to add the person's name to the string of text, hello, comma. Well, let me go now down to my terminal window and run Python of hello.py again. Enter. What's your name? I'm going to type in David. Enter. OK, it's better. It's better, but there's a minor bug, albeit aesthetic here. There's missing space, but let's just use some intuition here. Well, if I'm missing the space after the comma, why don't I go ahead and just add it manually here? Let me now rerun the program, Python of hello.py, enter, David, enter, and there we go. Now we have something that looks a little prettier in terms of English grammar, hello, comma, space, David. And now if we rewind, you might have noticed before or wondered why I had this seemingly extra space after my question mark, namely here. There's a space after the question mark but before the double quote, and that was just for aesthetics too. I wanted to move the user's cursor one space to the right so that when I type their name, or they type their name, it's not immediately next to that same question mark there. But there's other ways we can do this. It turns out that some functions, print among them, actually take multiple arguments. And it turns out that if you separate the inputs to a function, the so-called arguments to a function, with a comma, you can pass in not just 1, but 2, 3, 4, 5, onward. So let me go ahead and pass in not just hello, comma, space, but that followed by name. And this is a little confusing potentially at first glance, because now I've got 2 commas, but it's important to note that the first comma is inside of my quotation marks, which is simply an English grammatical thing. The second comma here is outside of the quotes, but between what are now 2 separate arguments to print. The first argument is hello, comma, space. The second argument is the name variable itself. So let's see how this looks. Python of hello.py, enter. What's your name? David, enter. OK, I've kind of overcorrected. Now I've got 2 spaces for some reason. Well, it turns out, and this is subtle, when you pass multiple arguments to print, it automatically inserts a space for you. This was not relevant earlier because I was passing in one big argument to print all at once by using that plus operator. This time I'm passing in 2 because of the comma. So if I don't want that extra space, I don't need to pass in one myself. I can just do this. And now notice if I run this program again, Python of hello.py, type in my name, David, now it looks grammatically like I might want. Now, which of these approaches is better? This approach uses a function print with 2 arguments, hello, comma, and the name variable. The previous version, recall, technically used 1 argument, even though it looked a little curious. It's 1 argument in the sense that the computer, just like mathematicians, are going to do what's inside of parentheses first. So if inside of parentheses you have this string of text, hello, comma, and a space, which I need to add back, then you have a plus, which means not addition per se, but concatenation, to join the thing on the left and the thing on the right. This ultimately becomes the English phrase, hello, comma, space, David. And then what's being passed ultimately to the function is technically something like this. But it's doing it all dynamically. It's not me typing in David as I discreetly did earlier. It's figuring out dynamically what that value is after concatenating hello with the value of name, and then passing that ultimately to print as the sole argument. Let me pause here to see if there's any questions on numbers of arguments now to functions.
Can we use a function many times to solve a certain problem which we can encounter many times in our code?
You can. You can use a function many different times to solve some problem. What we'll soon see, though, is if you find yourself as the programmer solving a problem the same way again and again and again, it turns out you'll be able to make your own function so that you don't have to keep reusing the basic ones that come with the language.
I was curious about the comma and the plus sign. So after plus sign, can we give just one variable, and after comma, can we give multiple variables? Like, what is the difference?
A good question. So in the context of strings, and I keep using that term, string is a technical term in a programming language. And again, it means a sequence of text, a character, a word, a whole paragraph even. So the plus operator is not just used, as we'll see, for addition of numbers in Python like we do on paper pencil, but it also is used for concatenation of strings on the left and the right. If you did want to combine not just two strings, left and right, but a third and a fourth, you can absolutely keep using plus, 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 and chain them together just like in math. Eventually, that's going to start to look a little ugly, I dare say, especially if your line of code gets long. So there's better ways that we'll actually soon see. And a good question as well. Well, let me come back to the code here in question and see if we can show you just a couple of other ways to solve the same problem, along the way emphasizing that what we're technically talking about here, yes, are strings, but there's even a technical term for these strings. In Python, it's just str, so to speak, str for short for string. As you may know, if you've programmed in other languages, people who invent programming languages like to be very succinct, to the point. So we tend to use fairly short phrases to describe things, not necessarily full words. So while you might say string, technically in Python, what we're really talking about, these sequences of text, are technically strs. This is an actual type of data in a program. But we'll soon see that there's other types of data in programs as well. In fact, let's see if we can't improve this in one other way. I like the progress we've made by keeping everything on the same line. Hello, comma, David. All on the same line. What more, though, could we do in terms of solving this problem? Well, it turns out that we didn't have to give up entirely with using print twice. Let me rewind a little bit and go back to that earlier version where I wasn't really sure how to solve this problem. So I was using print once to print out just the hello and the space and the comma. And then I used print again to print name. That, strictly speaking, wasn't bad, but there was this visual side effect that I just didn't like. It just looked ugly to have these two lines of text separate from one another. But there's another way to fix this. Clearly, it seems to be the case that the print function is automatically outputting a blank line. It's moving the cursor automatically for me to the next line, because that's why I'm seeing hello on one line and David on the next, and then my prompt, the $sign, on the line below that. So print seems to be presuming automatically that you want it to move the cursor to the next line after you pass it some argument. But you can override that behavior. Again, functions take arguments, which influence their behavior. You just have to know what those arguments are. And it turns out that if we look at the documentation for Python's print function, we can actually look up at this URL here. docs.python.org is where all of Python's official documentation lies. If I poke around, I can find my way to more specifically this URL here, where I can find all of the available functions in Python and the documentation therefore. And if I go a little more precisely, I can even find specific documentation for the print function itself. And rather than pull that up in a browser, I'm going to go ahead and highlight just one line from that same URL, which is this. And this is easily the most cryptic thing we've seen yet. But this is the official documentation for the print function. And one of the best things you can do when learning a programming language is honestly learn to read the documentation, because truly all of the answers to your questions will in some way be there, even though admittedly it's not always obvious. And I will say too, Python's documentation isn't necessarily the easiest thing, especially for a first-time or a novice programmer. It too just takes practice, so try not to get overwhelmed if you're not sure what you're looking at. But let me walk you through this example. This, again, is a line of text from Python's official documentation for the print function. What this indicates as follows is this. The name of this function is, of course, print. Then there's a parenthesis over here and another closed parenthesis way over there. Everything inside of those parentheses are the arguments, the potential arguments to the function. However, when we're looking at these arguments in the documentation like this, there's technically a different term that we would use. These are technically the parameters to the function. So when you're talking about what you can pass to a function and what those inputs are called, those are parameters. When you actually use the function and pass in values inside of those parentheses, those inputs, those values are arguments. So we're talking about the exact same thing. Parameters and arguments are effectively the same thing, but the terms you use from looking at the problem from different directions when we're looking at what the function can take versus what you're actually passing into the function. So what does this imply? Well, this syntax is pretty cryptic. But at the moment, just know that an asterisk, a star, and then the word objects means that the print function can take any number of objects. You can pass in 0 strings of text, 1 string like I did, 2 strings like I did, or technically infinitely many if you really want, though that code's not going to look very good. After that, we see a comma. Then we see another parameter here called sep, short for separator in English. And notice the equal sign and the single quote, space, single quote. So quote unquote space. I don't know what that is yet, but I think we've seen a hint about it. Let's focus, though, for a moment on this. The print function takes another parameter called end, and the default value of that parameter is apparently, based on this equal sign and these quotes, \n. And what is \n, if you'd like to chime in the chat? Anyone who's programmed before has probably seen this, though if you've never programmed before, this might look quite cryptic. \n means new line. And it's a way textually of indicating if and when you want the computer effectively to move the cursor to the next line, create a new line of text. And so technically, if we read into the documentation, we'll see more detail on this. The fact that there's a parameter called end in the documentation for the print function just means that by default, this print function is going to end every line with \n. You don't literally see \n. You see a new line. You see the cursor moving to the next line. Now, by that logic, let's move backwards. Sep for separator. The default value of separator is apparently a single blank space. Well, where have we seen that? Well, recall in an earlier example, when I passed in not just 1, but 2 arguments to the print function, recall that they magically had a space between them. In fact, they had that space plus my own space, and that's why I deleted my space, because at that point it was extra. So this just means that when you pass multiple arguments to print, by default they're going to be separated by a single space. By default, when you pass arguments to print, it's the whole thing is going to be ended with a new line. Now, just by knowing this, and let me literally wave my hand at the rest of the documentation for another day. There's more things that print can do, but we're going to focus just on sep and on end. Let's see if we can't leverage this now to solve that original problem. The original problem was this. I don't like how hello, comma, David is on 2 different lines. Well, that's happening again because print is automatically printing out a new line. So let's tell it not to do that. Let's tell it by passing a second argument to the first use of print to say end equals quote unquote, not \n, which is the default automatically. Let's make it quote unquote nothing else. Let's override the default value so there is no new line. There's literally nothing there. And let's see what happens. Let me now go down to my terminal window and clear it. And I'm going to run Python of hello.py enter. I'm going to type in my name, David. And I think now everything's going to stay on the same line because, and it did, this line here, 5, is going to print out hello, comma, space, but then nothing at the end of it because I changed it to be quote unquote. The second line is going to print the name, David, or whatever the human's name is, and it will move the cursor to the next line because I didn't override the value of end there. Just to see this more explicitly, if you do something cryptic like, well, I have no idea what's going on. Let me just put in temporarily 3 question marks here. We'll see the results of this too. Let me go back down to my terminal window, run Python of hello.py, what's your name, David, and now you see literally really ugly output, but you see literally what's going on. Hello, comma, space, then 3 question marks, end that print statement, and then you see DAVID. So not a good outcome, but it demonstrates just how much control we have here too. And let me rewind further. Recall that in our other version of this, when I passed in hello, comma, and name, they were separated by a single space. So Python of hello.py, DAVID, enter. That just worked. Well, what if we override the value of sep for separator? Instead of being 1 space, we could say something like question mark, question mark, question mark, just to wrap our minds around what's going on there. Let me now do Python of hello.py, david, enter, and you see two. These two inputs, hello, comma, and the name are now separated in an ugly way by 3 question marks because I've overridden the default behavior of sep. And even though the documentation uses single quotes, I've been in the habit of using double quotes. In Python, you can use either. Strictly speaking, it doesn't matter, but you should be consistent. And I generally always use double quotes. Python's documentation, though, always uses single quotes. Questions now on these types of parameters. And allow me to propose that we give these an official name. Up until now, when we've been passing values to print, those are called positional parameters. Positional in the sense that the first thing you pass to print gets printed first. The second thing you pass to print after a comma gets printed second, and so forth. But there's also these things we've now seen called named parameters, named SEP, separator, or end, END, for the line ending. Those are named parameters because, one, they're optional, and you can pass them in at the end of your print statement, but you can also use them by name.
This may be a weird question, but I was wondering, what if someone wants to like add actually quotation marks within the quotation marks?
Yeah, I like how you think. This is what we would call a corner case, right? Just when we've made, right? This is all sounding great, at least as programming goes. But wait a minute, what if you want to print a quote? That's a really good question. Well, let's see if we can't figure this out. Suppose that I want to print out not just the user's name. Let me simplify this further. Let me go ahead and get rid of a lot of this. And let me just say something like, hello. Maybe I'm being a little sarcastic here. Hello, friend. You know, in that kind of tone. Well, this is not going to work, actually, because you are trying to use quotes to be like friend in finger quotes, but you're also trying to end the sentence. And if I try running this, let's do this. Python of hello.py, you'll see that this is just invalid syntax. Perhaps you forgot a comma. And this is actually a bit annoying. Sometimes the error messages you see are misleading. Like the computer, the language doesn't really know what's going on, so it gives its best guess, but it's not necessarily correct. But I can solve this problem in a couple of ways. I can do this. I can change my outermost quotes to single quotes, because recall a moment ago I said you could use double quotes or single quotes so long as you're consistent. So that's fine. If you use single quotes on the outside, you can then use double quotes on the inside, and you'll see them literally. So for instance, if I run Python of hello.py. There we go. Hello, friend. But there's another way. If you insist on using double quotes, as you might want to, just to be consistent, you can also use that backslash character again. We saw the backslash n a moment ago, and that meant we don't want a literal n to be in the output. We wanted a new line. So the backslash actually represents what's called an escape character. An escape character is one that you can't just type necessarily once on your keyboard. You need to express it with multiple characters. So I can actually put backslashes in front of these inner double quotes so that the computer realizes, oh, wait a minute, those aren't quotes that finish or start the thought. They're literal quotes. So now let me go back to my terminal window, run Python of hello.py, enter, and now it's working as well. So escaping is a general technique that allows us to do that too. And if I may, let me rewind now on these examples and go back to where we left off with my code. I'm just undoing all of that because I want to get back to the point ultimately of specifying now a final way of solving this problem. Well, it turns out that we have yet another way we can solve this problem, which is perhaps the most frequently done now, or at least the most elegant when it comes to setting us up for longer and longer uses of strings. You can use a relatively new feature of Python that allows you to do this. You can literally put not the name of the variable like that in your string, because we already saw this is wrong, right? If you do this, you will literally see hello, comma, name. But what if I do this? What if I put curly braces or curly brackets around the variable's name? Notice VS Code is actually very subtly changing the color of it. So VS Code knows something interesting is going on here. Let me run this program, but I'm not done yet. Python of hello.py, enter. david, enter. OK, obviously not what I want. But I need to tell Python that this is a special string. This is what we're going to call a format string or an F string, a relatively new feature of Python in the past few years that tells Python to actually format stuff in the string in a special way. And the symbol via which you do this is a little weird, but this is what the world chose. If you put a F at the beginning of the string, right before the first quote mark, that's a clue to Python that, ooh, this is a special string. Let me format this in a special way for you. Let me now rerun the program. Python hello.py, enter, david, enter, and now we see the goal this whole time, hello, comma, David. We don't start with this way because I think if we did this the first way, you'd be like, why are we doing this? What are all these magical symbols? But this is just yet another way to solve the same problem. But let me propose that we consider now yet other things we can do with strings. And it turns out that even as we've been doing some relatively simple operations here, we've generally been trusting that the user is going to cooperate. And that is to say that they're going to actually type in what we want them to type. Now, just because they type a string, though, doesn't mean it's going to look the way we want. You and I, honestly, as humans, are actually in the habit on websites and apps of like accidentally hitting the space bar a lot, either at the beginning of our input or at the end. Maybe because the space bar tends to be so big, it's pretty common to get accidental spaces before or after some user's input. You and I are definitely in the habit of not necessarily capitalizing words like we should. If we're sending text messages, we're probably being a little quick and just sending everything in lowercase, for instance, if that's your style, if your phone's not fixing it for you. Maybe in a formal letter, you would capitalize things properly. But you and I as humans, we can't really be trusted to type things in a nice way necessarily when using some piece of software, be it an app or a website or something else. But it turns out that strings themselves come with a lot of built-in functionality. And you can see all of that in Python's own documentation here. The string data type that we've been talking about comes with a lot of functionality built in that means that we can manipulate the user's input to do more than just join it with something else like hello. We can actually clean it up or reformat it in a way that hopefully looks a little better for us. So let me go back to my code here and let me just demonstrate what might happen if a user doesn't cooperate. If I go ahead here and run Python of hello.py, enter, let me just sloppily hit the space bar a few too many times. Why? I just wasn't paying attention. And now I'm going to type in my name, david, and I don't know, I hit the space bar a couple more times. Like it's kind of a mess. It's all lowercase. That's not going to necessarily look grammatically right. It's got spaces here and here. The program is going to print exactly that. And that looks really bad, at least if we're prioritizing aesthetics and grammar. Like, why are there so many spaces after the comma? This is not a very nice way to greet your users. But we can clean this up. It turns out that built into strings, which again is this data type, so to speak, this type of data in Python, is the ability to actually do things to that string. So let me do this. I can actually go ahead and do something like this. Name equals name.strip. And what does this do? Remove white space from string. And what do I mean by this? Well, on the right-hand side, notice I've written the variable name called name. I've then used a period or a dot. And then I seem to be doing what's a function, right? Anytime we've seen a function thus far, we see it's the function's name, print or input. Then we see a parenthesis, then another parenthesis. And that's exactly what I see here. But I'm using this function a little differently. Technically, this function is, in this context, called a method. And what do I mean by that? Well, if name is a string, aka stir, well, it turns out, according to the documentation, there's a lot of functions that come with strings in Python. And you can access that functionality by using the name of a string, like literally name here, then a period, then the name of the function, and then an open parenthesis and a close parenthesis. Maybe some arguments inside of those parentheses, but in this case, it doesn't need any arguments. I just want to strip the space from the left and the space from the right of the user's input. But that's not enough. I want to remember that I've stripped off that white space on the left and the right, so I'm going to use the equal sign again here. And notice that just as before, this doesn't mean equality. This means assignment from right to left. So when this line of code here, name.strip, returns to me, aka a return value, it will return the same thing that the user typed in, but with no more white space to the left or to the right. So then the equal sign assignment is going to copy that value from the right to the left, thereby updating the value inside of my name variable. So you can not only assign values to variables, you can absolutely change the value of variables by just using the assignment operator, the equal sign, again and again and again. And it will just keep copying from right to left whatever the new value should be. So now if I rerun this program, Python of hello.py, enter, I have david, oh, let's do it again. Space, 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 david in all lowercase, space, space, enter. It's better. It hasn't fixed my capitalization, so I'm still being a little sloppy with the first D, but it has stripped off all of that extra space. Super minor detail, right? Like this isn't all that exciting, but it just speaks to the power of what you can do with just a single line of code. Now, what else can I do here? Well, I could capitalize the user's input. Let me go ahead and try this. It turns out that I could also do this, name.capitalize. So let me go ahead and capitalize user's name. And again, I'm making comments, and there's no one right way to write the comments. I'm just using some short English phrases here to remind myself of what I'm doing. What's now going on here? Well, let me go ahead and run Python of hello.py, enter, space, 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 david, space, space, enter. OK, now it's looking prettier, right? No matter how the user typed in their name, even a little sloppily, I'm now fixing that. But let's try something. I'm getting a little curious here. How about this? Space, 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 david, space, Malin. I'll use my last name now. Enter. OK, so ironically, capitalize is not really capitalizing everything we want. It's clearly capitalizing what? Just the very first letter. So it turns out that, again, there's other functions in Python that come with strings. And if we poke around the documentation, scrolling through a URL like that, I bet we'll find another solution, one of which is actually this. Let's actually change this to title. There's yet another function that come with strings called title that do title-based capitalization, just like a book or a person's name, capitalizing the first letter of each word. And this is just going to do a little more work for us. So let's go ahead and run this. And as an aside, I'm kind of tired now at this point of typing Python, Python, Python all the time. It turns out that when using a command line interface like this, you can actually go back through all of your old commands. What I just did a moment ago was I hit the up arrow. That immediately goes back through my history of all of the commands I've ever typed. So this is just a faster way now for me to repeat myself than typing everything manually. Let me go ahead and hit enter. Space, 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 david, Malin, space, space, all lowercase, enter. Now it's looking better. Now I've capitalized things and cleaned things up. But what about my code? I've got like 8 lines of code now, 4 of which are comments, 4 of which are actual code. Do I really need this much? Well, not necessarily. Watch what I can also do in Python. Let me not bother capitalizing the user's name separately. Let me say this, and capitalize user's name. I can chain these functions together. I can add title to the end of this. And now what's happening? Well, again, with a line of code like this, you first focus on what's to the right of the equal sign. Then we'll get to the left of the equal sign. What's on the right of the equal sign? This line here. Well, what does this mean? Get the value of the name variable, like david space Malin, then strip off the white space on the left and the right. That is going to return a value. It's going to return david space Malin without any white space to the left or right. What do you want to do with that return value? You want Python to title case it. That is, go through every word in that resulting string and fix the first letter of the first word, the first letter of the second word, and so forth. And then, now we can finish our thought, copy the whole thing from right to left into that same name variable. And you know what? I can take this even one step further. Why don't we go ahead and do this if we want? Let me get rid of all that, and let me just do strip and title all on that first line. And now we've gone from like 8 lines of code to 4. It's a lot tighter. It's a lot neater. And even though reasonable people might disagree, it's arguably better because it's just easier to read. Fewer lines of code, fewer opportunities for mistakes. It just allows me to move on with my next problem to solve. All right, let me pause here and see if there's any questions on these methods. A method is a function that's built in to a type of value, like these functions are, or on f strings, which we saw a moment ago.
Yes, hi, thanks, David. So is there a way to remove the spaces between the spaces that I might have added?
Short answer, no. If you read the documentation at that same URL earlier, you'll see that strip removes from the left and the right, but not in between. In fact, there's two other functions that come with strings. One's called lstrip. The other's called rstrip that allow you to do one or the other. If we want to start getting rid of space in the middle, we're going to have to do a different trick altogether.
How many functions can we combine like this dot strip, dot title you have combined? So how many we can combine?
Yeah, a really good question. Technically, as many as you want. But at some point, your code's going to start to look really, really bad, right? Because the line of code is going to get really, really long. It's eventually going to maybe wrap around again and again. So at some point, you just kind of say like, that's too many. And you start breaking it up into multiple lines like I did, maybe reassigning the value to the variable as needed. And this is actually a good question. If I can pivot, Divya, off your question, I mean, what do people think? If we could go ahead and put everyone's hands down for a moment, let me ask this. Is the way I've done this now with strip and title and input all in the same line better than my previous approach? In Zoom, you can use the yes icon or the no icon. If you think this version is better, say yes. If you think this previous version was better, for instance, this one here, where we had everything broken out, say no. And then we'll see why in just a moment. I proposed earlier that reasonable people can disagree, and that's absolutely the case. Doing it one way or the other isn't necessarily best, at least if you can justify it. Let me go back to the most recent version here. All right, so we're seeing a lot of yeses and a lot of nos. Why don't we go ahead and call on one of the yeses if we could? Someone who's voting yes, why do you think the current version of this code is indeed better than the previous longer version of the code?
I think it's more readable, so I can say, hey, this is the name variable. It gets some input, and then remove the space and give it a title, and there you go. You have a hello name.
Yeah, I think that's pretty reasonable. It's very readable, at least if you're in the habit, as you are in English, of reading left to right. It just kind of flows very naturally as a result. The line is not really that long. It's certainly fitting nicely onto the screen, so I think that's a good argument. How about a counterpoint, though? Someone who voted no, if we could call on someone who thinks this is worse.
Because it's not readable at all. It seems like it's a very long line, so I think it's better to separate.
Yeah, I think that's persuasive too, right? It's getting a little longer. And even though my sentence here, what's your name, is relatively short, you could imagine that this could get even uglier quickly. If I were asking a longer question of the user, that's going to make this line of code even longer and therefore less readable. It might be less obvious to me or my colleagues that I am calling strip or that I am calling title. It might be kind of an unexpected surprise. So I think that's reasonable too. In short, there is no right answer here. And in fact, part of the process of getting better at programming is getting your own sense of style, or working for a company where they might prescribe which way is better than the other because they just want everyone doing the same thing, even though reasonable people might disagree. Ultimately, though, so long as you have what's a pretty good argument in favor of one way or the other, like ultimately that's what's important. If you're just doing things because you don't really know which one's better, that's not great. But if and when you start to acquire opinions, and if your boss, if your teacher, if your colleague, your friend can challenge you and say, wait, why did you do it like this? They might not agree with you, but at least have an answer, and that should be sufficiently persuasive in general. Now, strings come with a whole bunch of other methods as well, among which is one called split, which can, as the name suggests, split a string into multiple smaller substrings, so to speak. For instance, if the human here is in the habit of typing in their first name, then a space, and then their last name, and you want to go ahead and greet them only by first name, well, we could actually leverage that single space between the first name and last name and split that string into two smaller substrings. How can we do this? Well, let me go ahead and in between these lines proactively comment that we're about to split user's name into first name and last name. And then let's go ahead and take that name variable, which currently contains something like, presumably, David space Malin. And let me go ahead and call split and pass in as the argument to split a single white space, thereby indicating that I indeed want to split on that character. Now, it turns out split's going to return a sequence of values, ideally a first name and then a last name. And we can actually, in Python, assign both of those values from that sequence at once to some variables. For instance, first, comma, last equals. And that's going to have the effect from right to left of putting the first such value in the first variable, the second such value in the second variable. So now on my last line of code, I can go in and say hello, not to the full name, something like David Malin. I can just say hello, comma, first. All right, let's go ahead and clear my terminal window, run Python of hello.py and hit enter. I won't bother with any leading white space this time, but let me go ahead and type in David space Malin, and crossing my fingers as usual, hello David is what we now see. All right, so we've seen so many examples thus far involving strings, but certainly programs and programming languages can manipulate other types of data as well. Let's go ahead and transition then to another very common type of data in Python, in programming more generally, namely integers, otherwise known in Python as int, int. So just as str, str is short for string, so is int in Python short for integer. Well, what's an integer? Well, just like in math, it's a number like -2, -1, 0, 1, 2, and all the way toward negative infinity, all the way toward positive infinity. But there's no decimal point in an integer. It's just a number like -2, -1, 0, 1, and 2 onward. That's an int. Of course, in the world of mathematics, there's lots of symbols that we use, and we've seen plus before, although we used it for a different purpose. But Python supports these symbols and more. And Python allows you to add numbers together, plus, subtract numbers, multiply numbers, divide numbers. And the only one here that might look a little strange to people or unfamiliar is this % sign, but it doesn't mean percent in this context. If you use a single % sign in a Python program, that's actually the so-called modulo operator, the operator that allows you to take the remainder after dividing one number by another. So we'll see examples of that before long, but the first 4 of these are perhaps quite familiar. Well, it turns out that in Python, you don't necessarily have to keep writing code in a file like hello.py and then running it in a terminal window. One of the features that many people like about Python is that it supports this, a so-called interactive mode. Like you can start writing Python code and immediately execute each of those lines interactively, especially if you don't care about saving all of your lines of code. You just want to execute code and get back some answers. So for instance, let me go back to VS Code here, and let me close hello.py, and let me click on the little triangle over here in my terminal window just to make it much bigger, just temporarily for a moment. So I'm not creating any .py file now. I'm just going to run Python by itself at my prompt. And you'll see when I do this, I get some cryptic looking output and the date and time at which the program was last updated and so forth. But I ultimately get 3 triple brackets like this. This is the interactive mode for Python. So I'm running the Python interpreter. And anytime I type a line of code in the interpreter, it's going to execute it immediately. I don't have to keep running Python again and again. It's as though in the human world, if you were standing next to a human who speaks some other language and you're just having a conversation with them back and forth, it's all happening, the translation, immediately. So what might I do in interactive mode? Well, I could do something like 1 + 1, enter. That's actually code. All right, you might not think of it as code, but if you know a bit of arithmetic and you know numbers and you know plus, that's valid Python code. And you can use Python really as a fancy calculator. But I could do other things too. If I want to print to myself hello, comma, world, I can also print out that line of code there too, hello, world. So it's interactive in the sense that the moment you execute a line of code, boom, you see the result. We're generally not going to do that because at least when teaching the language, we tend to want to do things incrementally. And we want you to be able to see where it is we came from. And we want to be able to try things again and again, especially if we make mistakes. But know that this is indeed a feature of Python, this so-called interactive mode. But let's focus for a moment now, not just on that interactivity, but really on the fact that Python apparently supports integers and mathematics and some of those basic operations. And let's see if we can't make maybe our own little calculator. So let me go ahead and open up VS Code again. And I'm going to shrink down my terminal window. And I'm going to create a new file called calculator.py. So to do that, recall, I can type code down here. And the name of the file I want to create, .py. Enter. That gives me a new tab up top. So I have already closed hello.py. I'm now in calculator.py. And let's just make a simple calculator that does some addition for me. But I'm going to do it in a file so that we can iterate on this and make changes for better or for worse over time. Let me go ahead and first declare a couple of variables. I'm going to do the mathematical thing of calling my first variable x, my second variable y, and then I'm going to give myself a third variable, z equals x plus y, and then I'm going to go ahead and print out z. Now, this program, admittedly, not very exciting or interesting. In fact, it's a little less interesting than printing stuff on the screen like before with strings. But we'll build on this and see what other features exist in Python that we can leverage. So hopefully, if Python knows its math as well as I do, when I run python of calculator.py, I should see, hopefully, that 1 plus 2 equals indeed 3. All right, so not that surprising and not that interesting. And honestly, this isn't the most useful program because it's always going to calculate 1 plus 2 equals 3. Let's at least make this program, say, a little more interactive, right? We already know from previous examples how we can get input from the user. Let's bring back that input function. And let's do this. Let me go ahead now, and at the top of my code, let's change x to not be the number 1 always. Let's change it to be whatever the return value is of asking the user for x. And I can use any English or human language I want here. I'm going to say, what's x? Just like I asked before, what's your name? And I'm going to do the same thing for y. I'm going to use input again, but this time change the question to be, what's y? All right, at this point, I think I'm going to leave the rest of the code the same, z equals x plus y, and then print z. But what's nice now is that I think I have a nice interactive calculator. Right now, it's not going to do 1 plus 2 all the time. It's going to do whatever the user types plus whatever the user types. So let's try this. Let me go ahead and run the program. All right, let's do it. 1 is going to be x. 2 is going to be y. And of course, everyone in agreement, 1 plus 2 equals 3. Huh. What's going on there? Either your math class misled you or I have misled you. Why don't we call on someone here to see if you can't help us reason through what the bug is? What's the mistake? Anjali, if I'm saying it right?
I think the issue is that it's concatenating strings because you use the plus operator instead of adding.
Perfect. So perfect intuition. We've seen that plus is used a little differently in the context of strings because it concatenates. That is, it joins the two strings. And that seems to indeed be what's happening here, even though the user typed a number. But the interesting thing here is that when you get user input, because they're using a keyboard on their Mac or PC or their phone, it is always going to be text. It might look like a number, but by default, it's coming from the keyboard as a string. That is as text. And so how do we go about resolving this if ultimately we don't want to treat those inputs as strings? We want to treat them as actual numbers. Well, we need another function. And it turns out in Python that you can convert sometimes from one type of data to another type of data, for instance, from string to int, by doing something like this. Let me go back into my code and let me change x before adding it to y to be whatever the integer version of x is, plus whatever the integer version of y is. So it turns out that int is not only a type of data in Python, it's also a function. And it's a function that if you pass in an input, like a string, so long as that string looks like a number, like 1 or like 2, it will convert it to an actual number that you can perform mathematics on instead. So if I now go back to my terminal window and run Python, and let me show you another trick. Calculator is kind of a long word. It's a little tedious to type. Notice what I can do in my terminal window in a command line interface in general. If I start typing CAL for calculator, I can actually hit tab to finish my thought. So autocomplete is possible in a terminal window like this. Type the first letter or few letters, and then boom, with tab, it'll finish your thought for you. Or you can go back in your history like I did with the up and down arrows. Let me go ahead and execute this. What's x? 1. What's x? 2? And there we go. Now we have a general purpose calculator that's going to support not just addition of 1 and 2, but now any two integers that the user types. And let me now improve this, right? We've seen how we can make improvements to code. And I don't know if it's going to necessarily be better, but let's try this. Do I really need the z variable? It's worth noting that I'm creating a variable called z, and then I'm immediately using it on the next line of code. Now, that's not that compelling because if you're creating a variable and then immediately using it but never again using it, did you really need to take the time to introduce another symbol and another variable just to use it once and only once? Well, maybe not. Maybe we don't really need z in this way. Maybe I should go and do something like this. Maybe I should get rid of z here. Maybe I should change this to be int up here, change this to be int up here, doing something that's pretty interesting now, even though it's a bit of new syntax. Notice that you can nest functions, so to speak. You can put one function call, that is the use of a function, inside of the use of another function so that the return value of the inner function becomes the argument to, or the input to, the outer function. So just like in math, if you have parentheses, 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 your teacher probably taught you to focus on what's inside the innermost parentheses first and then work your way out. Same thing with programming. That's what Python's going to do. It's going to look at what's inside of the parentheses first. It's going to get the answer, and then it's going to pass the return value to the outermost function. So what happens on line 1 now is that the input function gets called first. Then the result of that, quote unquote 1, becomes the input to the int function. And same on line 2. The output of what's y becomes the input to this int function. And now there is no z. I could just do print x plus y. And because I've taken the time to convert each of those strings to an integer, I think we're OK. So let me try this. Python of calculator.py, enter 1 and 2. And we're still getting 3. Not 12, or not 12, 1, 2. We're indeed getting 3. And we've additionally gotten rid of the variable because we didn't necessarily need it, it seems, especially if only using it once. Well, here too, let me put everyone's hands down for just a moment, and let me ask, as before, this version now, which uses int around the invocations of input and does not use z, is this better than the previous version? If you want to vote yes, go ahead. Or if you prefer the old way, vote no. The old way, I'll undo all of this as we vote, instead looked like this. All right, and let me go back to now the newest version. Let's take a hand of the yeses. Someone who thinks this latest version is better.
I think this way is better because it allows us to immediately see what the x and y variables are with integers, and so we know what to expect from them. And also the print argument is more intuitive. We avoid too much clutter in the code.
I think those are all good reasons. It's nice and succinct. The lines of code are not very long. I don't need to know what z is because it doesn't exist. It just see print x plus y. I like that. But someone who prefers the older way, where we did have z, and we more explicitly passed individual variables to the int function.
Yeah, hi. I think the earlier version is better because when, if user input something else other than int, let's say they type 1 and 2, so it will be easier to debug.
This version, or this version here, or the old version?
The old version.
OK, that's fair. And in fact, I'm being very careful today as best I can not to mess up. I have thus far only inputted integers when I'm expecting integers. And Raul's actually pointing to something we'll come back to in the coming weeks. How do we actually handle errors? What if the user doesn't type in the number 1 or the number 2 or a number at all? What if they type in a word like cat, C-A-T? That's not a number, and I bet I can't convert it to an integer. But for today, I'm not going to focus on that. I'm just going to hope that the user cooperates, but that's not going to be the case. And so perhaps one way would set us up for more success when it comes to handling those errors. Now, for today's purposes, which is better? I like both. And I think both of you made very valid arguments in there too. So long as you have a justification that feels pretty reasonable, that's what ultimately matters. But acquiring, again, a sense of the trade-offs here. Well, is this way better? If so, why or why not? Just understanding what those trade-offs are. But generally speaking, prioritizing readability is a very good thing. Making your code readable for someone else is a very good thing, and very good for you too, so that when you wake up the next morning or you come back the next week or the next year, you too can read your own code without having to waste time trying to remember what you did. And simplicity tends to be a good thing too, keeping your code simple. So as you get more comfortable with programming, you might be tempted to try to combine an entire program into one long line. For instance, let me do just that. Technically speaking, we don't really need x in a variable. We don't really need y in a variable. We could also do this. I could just get rid of x and y altogether. I could then now eliminate that and make it just one line of code. OK, so in some sense, you might be inclined to think, wow, that's really nice. You made it one simple line of code. I would argue this actually isn't that simple. Now I think I'm starting to nest too many things. I have to think about print and int and input. I then have to notice that, OK, I've opened 2 parentheses. I've closed 2 of them. There's a plus. You're making me think too much. And anytime you make me think, you're wasting time. And anytime you complicate the look of the code like this, you're just going to increase the probability of mistakes, syntactical mistakes or logical errors in your code. So of all the things we've done, this is the only one that I would argue, yes, it's one line and it's nice and compact. It's just not readable enough. I would shy away from doing this, especially since 2 of those function calls are getting input from the user. But there too, reasonable people might disagree. But that's the kind of like visceral reaction you should have sometimes when code starts getting a little too complicated, a little too clever, perhaps for its own good. All right, well, it's not just integers we have access to. Let me propose that we transition from integers to one more data type here, namely a float. So again, a string is a sequence of text. An int is an integer, like -1, 0, and 1. A float is a number with a decimal point, properly called a floating point value. And you can think of the floating point as being the decimal that might be over here or over here with some number of digits to the left or the right. Mathematically, it's a real number, a number that has a decimal point in it. So that's a third type of data that Python supports. Right now, our calculator is somewhat naively assuming that the user is only going to type in integers. But if I want to support floating point values too, I think I can just make a couple of tweaks. So I'm going to go back to VS Code here. And instead of just converting the user's input, x and y, to integers on line 1 and 2, let's just make a simple change. Let's actually convert it to a float on the first line and a float on the second line here. Now I think if I go down to my terminal window and run Python of calculator.py, let's type in a number like 1.2 with a decimal point and 3.4 with a decimal point, and there we go. We have 4.6 as the final answer. So that wouldn't have worked before if I was only expecting integers from the user, but now that I'm expecting floating point values and accommodating it, I can actually now do floating point arithmetic as well. But suppose that I don't really want the final answer to be a floating point value like 4.6. I would be happy if we just round to the nearest integer. So I want to support the user typing in floating point values with decimal points. But at the end of the day, I just want to round the result to the nearest possible integer, for instance. Well, it turns out that here too, Python comes with some functionality built in. And in fact, if we return to this URL from earlier, wherein all of the Python built-in functions are listed, there's one called round, which does exactly as we would expect. It takes as input a number and then rounds it for us, for instance, to the nearest digit, to the nearest integer. But if we look a little closer at that documentation, as we can here, I'll provide an excerpt. This is what the function looks like in the documentation. And recall that earlier we looked at the documentation for print, and this is similar in spirit, that this shows us not just the name of the function, but its available parameters. That is, inputs that we can provide when using this function. But this is a little cryptic too, just like print was, and it adds some syntax. So let's see. The name of this function here is, of course, round. And its first argument is a number. Notice this time there's no star. There's no star objects like there was for print. The round function takes just one number as its first argument, period. That's its positional parameter. But notice this syntax. And this is a convention in programming or technology more generally. Generally speaking, when you see square brackets in documentation like this means that you're about to see something optional. And so what this means is that if you want to specify more precisely the number of digits that you want the round function to round to, you can specify it here by adding a comma and then that number. So if we read the documentation, if you don't specify a number of digits, you just specify the number to round, it rounds to the nearest integer. But suppose you want to round to the 10th place or the 100th place, that is 1 or 2 digits after the decimal point, you could additionally pass in comma 1 or comma 2 to be more precise. So that's what the documentation there is saying. Let's see if we can't then translate this to some actual code for us. So if I go back now to VS Code and I consider that I want to go ahead and round x and y, I can do this in a couple of ways. I could do round x plus y, but you know, I'd actually kind of prefer to break this now out into 2 lines. I don't have to, and reasonable people here might disagree, but I'd like to revert to a scenario where I'm printing z so that I can just a little more clearly to myself, to others, say z equals the rounded result of x plus y. It's not necessarily the better way to do it, but I'm a little more comfortable with breaking out my thoughts one at a time, especially if I want to start commenting each of these chunks of code. All right, let me go down to my terminal window now and run Python of calculator.py. What's x? Let's do 1.2 again. Then let's do 3.4. And now it was previously 4.6, but now it's been rounded up to the nearest integer, which of course is going to be 5. All right, what if I wanted to change this a little further? What if I wanted to support maybe really big numbers, irrespective of rounding? Let's just do something like this. Let me go ahead and run Python of calculator.py again. And let me just add 999 plus 1. And notice I don't have to type decimal points, even though I'm converting to float. My program will just allow me to type decimal points, but I don't need to oblige. The answer, of course, here should be, and is in fact 1,000, whether or not we round. So that's just arithmetic with integers here. But in the US, we tend to format long numbers by putting commas after or before every triple of digits. Other countries flip it and they use periods and commas instead. That's a system setting. You can change that on your own Mac or PC or device for Python or any language. But for me, I'm using the US approach here, which is periods for decimal points and commas for separators. What if I wanted this to be outputted as 1, 000? Just to make it a little more clear that it's 1,000 and not something like 100. That's even more useful when it's like 1,000,000, 1, 000, 000. Wouldn't it be nice if we could automatically output those numbers as well? Well, it turns out that we can. There is a way using Python to actually specify that we want to include commas like this. And here we have an opportunity to bring back our old friend, the f string. First, let me do something that's not that productive. First, let me do this. Let me print out the value of z. But wait a minute. I can't just say quote unquote z, because that's literally going to print z on the screen. So let me wrap it with those curly braces like I did before. But that too was not enough. I literally needed to add an f at the beginning of my string to tell Python that this is an f string, a format string. That now is going to print out, not very interestingly, just the value of z itself. So that I'm going to great lengths just to print z, when really I could have just passed z as the sole argument. But just to ensure that I haven't broken it, let's do this again. 999 plus 1, enter. OK, it's still 1,000. So I didn't make anything worse. But notice, and this syntax is unfortunately a bit cryptic, notice that I can actually do this. I can put a colon after the z, and I can put a comma thereafter. This looks very cryptic, admittedly. And even I have to constantly look things like this up in the documentation to remember the syntax. But here, let me run it again. Python of calculator.py, 999, 1, and now notice that the number has been automatically formatted for me. If I were in a different country or locale, I could absolutely override this to use periods instead of commas or vice versa. But in this case here, it's just happening for me automatically. So there too, we see a hint of what it means to really format a string. There's even more power, more powerful capabilities built into that. All right, let me pause here to see if there's any questions now on floats, on rounding, or on this use of f strings.
Yes, so I have a question. So when using floats, is there like a cap to how many decimal points it can have?
A really good question. So floats, yes, and this is a problem we'll revisit before long. Floats cannot represent numbers infinitely precisely in a nutshell because computers only have so much memory. They only have a finite amount of memory. You and I only have a finite amount of hardware inside of the computer. So at some point, they're going to have to round. Right now, I'm rounding automatically. Effectively, computers will eventually have to do that for us. But we'll see that as a fundamental problem before long. Allow me to turn back just for a few final examples on float before we introduce a few final examples that allow us not just to use functions, but to make our own. Let me propose that we also try our hand at a bit of division here. Let me propose that we modify this calculator now to still take a couple of floats, but let's now just do something a little simpler than a little different from this, just doing x divided by y. And let me go ahead and get rid of my format string and just keep it simple for now, printing out z instead. And what are we going to see here? Well, just some simple division. So Python of calculator.py, let's do something like 2 divided by 3. And of course, I get 0.66666. And to Ethan's question a moment ago, it does seem to be finite. It's not rounding in a weird way here, but I only seem to see so many digits. That's an inevitability of using a float in this way. By contrast, just so you know, integers nowadays in Python can be as big as you want them to be. Unlike other languages, there is no upper bound on how big an int can be now in Python, but there is a bound on just how precise a floating point value can be. All right, now that I've got some simple division working here, let's go ahead and round this. It would be nice to round this really long number, 0.6666666, and so forth, to maybe just 2 decimal places. We've seen how to do this with round, though, at least in its documentation. Let's just round this, not to the nearest int, by passing in just x divided by y, which is 1 argument. Once the math is done inside of the parentheses, I don't want to pass in just 1 argument. I want to pass in 2 so that I can specify n digits, number of digits, which recall was the second parameter for round. Let me go ahead and run python of calculator.py. I'll do the same thing, 2 and then 3. 0.67. So here too we see a way of rounding now, not just to a nearest integer, but to a nearest number of digits. But there's another way to do this here. And in fact, this evokes our f string example again. Let me go ahead and change this. Suppose that you didn't remember the round function, or for some reason you didn't want to use it. You instead want to just use a format string. Well, let's go there. Let me do quote unquote z. But let me surround it with those curly braces. Let me add the f at the beginning. And again, this is not interesting yet. This is just going to print out z, but I'm adding a lot more complexity to turn it into an f string. But notice, I can do something else after my variable name, after the colon. If this were going to be a big integer, I might want to use a comma like before to separate each triple of numbers with commas. But I don't. I'm going to use a different sequence of characters. I'm going to say 0.2f. And this, too, is one of these very cryptic things I have to constantly look up because I forget if I don't use it that often. So don't be intimidated if this looks especially weird. But this is, according to the documentation, the way you specify using an f string how many digits you want to print. So let me run this version of the calculator, type in 2 and then 3. We get the exact same thing. But again, this is just consistent with my claim that in programming, we can so very often solve the same problem in multiple ways. This is just now the f string approach to that very same problem. All right, which one is better? It depends. In this case, they're pretty equivalent. You could imagine, though, it being useful to use a function sometimes so that you can pass in an argument like n digits as that second argument. Or you can imagine just deciding in advance that you want 0.2 and then writing it like this. Let's transition now from focusing on strings and on integers and on floats to focusing now on functions themselves. We began today by focusing on how you can use functions that come with Python. But wouldn't it be nice if you could invent your own functions, especially if, to our point earlier, you find yourself solving the same kind of problem again and again? It's nice that Python comes with the print function because it's really useful to be able to print things on the screen. But wouldn't it be nice if you could print specific things on the screen by just calling your own function? Well, let me propose that we do this. Let me go back to VS Code here, and let me propose that we go back to hello.py. I'm going to reopen hello.py where we left it before, and I'm going to go ahead now and propose that we consider how we can start improving this further by making our own function. I have written so many programs today that just say hello. And each time I'm using print, but wouldn't it have been nice if from the beginning of today we could just call a function called hello that just says hello for us? Now, the authors of Python years ago didn't think that we need a special function just to say hello, but I would like that to exist. I'm saying hello so many times, I just want to be able to call a function hello. So I'm going to start from scratch here. I'm going to delete all of my code from earlier, and I'm going to pretend for the moment that a function called hello exists. And I'm going to do just as I did before. I'm going to get the user's name with the input function, asking what's your name, question mark. And now I'm going to call a function hello, and then I'm going to print out the user's name. Now, I will admit hello doesn't exist, so bad things are about to happen. But let's see what. Let me go down to my terminal window. Let me run python of hello.py. I think the first line is going to be OK, because that worked before. And indeed, it's prompting me for my name. So let me type in David. The second line of code is apparently calling a function that looks like it's called hello, because why is it a function? It has a parenthesis and a closed parenthesis immediately after it. And that's what every function we've used has looked like but Python's not going to recognize this one. When I hit enter now, I get a name error. Name hello is not defined. Did you mean help? I didn't, although it's opportune. That's what I need at this point, is some help. But I am encountering this error because why? The function just doesn't exist. So how do I make this function exist? Well, I need to create it myself using this keyword, def. Def for define. So here too, just as str is short for string and int is short for integer, def is short for define. If and when you want to define, create, invent your own functions, you can do so using now this keyword in Python. So let me go back to my code here and let me propose that we define this perhaps in this way. At the very top of my file, I'm going to first take a moment to define a function called hello using def hello, open parenthesis, close parenthesis, colon. What this means now is that Python is going to treat every line of code that I indent underneath this one as the meaning of this new function hello. So def is important, as is the space. I get to choose the name of the function, and I'm choosing to call it hello. The parentheses with nothing inside means that this function at the moment is not going to take any inputs. No arguments there too. The colon means stay tuned for some indentation. Everything that's indented beneath this line of code is going to be part of this function. It's going to be a super short function. One line of code. It's just going to print out quote unquote hello. But now on lines 1 and 2, I have invented my own function hello. Notice these dots that have now magically appeared here. This is just a setting of my text editor, VS Code in this case, that's just making super explicit to me that I've hit the spacebar 4 times, or equivalently the tab key once, which is converted automatically to 4 spaces. Generally speaking, I'm going to need to make sure that all of my indented code lines up now so that Python knows that it's all part of the same thing. But it's easy in this case because it's just a single line. But now, thanks to lines 1 and 2, the function hello will absolutely exist when I'm ready to use it on line 6. So let me go down to my terminal window and run python of hello.py, enter. Here comes my name again. And now, when I hit enter, I now see hello, David. All right, we've kind of regressed though, right? This is not nearly as pretty as it once was. I think we can probably do better than this by improving things further. Why don't we consider, though, how we might, say, parameterize this same function? That is to say, can we customize hello to maybe take the user's name as input so that we can say not only hello, but the person's name all on one line, all in one breath? Well, I think we can do this. Let me propose that we do this as follows. Let me go ahead and up in my code, let me, inside of these parentheses, let me come up with my own parameter name. I have complete choice here. And I'm going to say that the name of my parameter will be the word to. Why? Because I want my function to sound like the verb it represents, hello. But who do you want to say hello to? Well, I'm going to call my parameter for this function to, just because in English it kind of sounds nice to me. Hello to. Who do you want to say hello to? That's why I'm calling this parameter to instead of something simpler like x or y or z. All right, well, what do I want to do with the word to? Well, I can do a couple of different things. We've seen like so many different ways to implement hello. Let me just add a comma there for grammar's sake. And then let me put the word to after that as the second argument to the function hello. There's other ways we can do this, and we've seen so many, but this one looks a little clear to me, I'll say. What's going to happen next? Well, I don't think I need this extra print line here. I think what I'm going to do is this. I'm going to go ahead here and print out not the person's name manually. I'm going to instead say hello parentheses name. So what am I now doing? On lines 1 and 2, I'm defining my very own function called hello. But this time, that function has been designed to take a parameter, a single parameter, as input. And I'm using the value of that parameter, which I called to plug into print so that I see not only hello, but also that person's name. What am I doing on line 5? Same as always. I'm just getting the user's name. Line 6, I'm not only calling hello, I'm passing as input the name variable as an argument so that that's what gets passed into hello. And what's happening here is essentially this. Even though the variable is called name here, when the function itself is called, the computer assumes that that same value is now called to. So name is essentially copied to another variable called to, so that in the context of hello, I can say hello to that variable instead. And we'll see in a moment what happens if we don't keep those straight. Let me go ahead and run Python of hello.py, enter. What's your name? And now I'm crossing my fingers, enter. There we go. We're back in business. But now I have my own custom function called hello that's allowing me to say hello to a specific person. And here's where now things can get really fancy. What if you wanted your hello function to say hello to someone specific, but you know what? If you don't know who you want to say hello to, you want to say hello to the whole world, you can give parameters default values. We've seen that. Recall that with print, there was a default value for sep, for the separator. There was a default value for end, the line ending. We can do that too. And here's the syntax. If you want the value of this parameter by default, if not provided by the programmer, to be equal to quote unquote world, you literally do that in the same line you're defining the function. And I'll admit it's starting to look more cryptic, but I'm still just defining a function called hello. It takes a parameter called to, but I'm assigning it with the equal sign a default value of quote unquote world just in case the programmer doesn't call hello with an argument. And we can see this here. Let me change my code to use hello in two ways. On line 5, I'm going to very simply call hello, no arguments. Then on line 6, I'm going to get the name. Line 7, I'm going to call hello with an argument. So you'll see hello now being used in two ways. Let me go ahead and run Python of hello.py. I'll type in my name. Oh, interesting. Notice I already see hello world, but that's expected because line 5 happens before line 6. But once I type my name, now the program's going to be a little more polite and say hello to me personally. So there too, we see with relatively simple but new syntax how you can implement functionality very similar in spirit to what the print function gave us automatically. Now you have control over doing that yourself. But let me now make this point too. One of the whole points of defining your own functions is, one, just to avoid having to repeat yourself again and again. You don't have to actually keep reinventing the wheel and keep using the print function again and again and again if you just want to say hello. Wouldn't it be nice now if I could kind of move this code that I wrote for defining the hello function, and just to be dramatic, I'm going to hit enter a whole lot of times, 50 lines down, and put my definition of hello way further down in this file. Why? Well, just in the spirit of out of sight, out of mind. Because if I now rewind to the start of my program, now you can sort of take for granted that, oh, hello is a function. Why? Because it's there on line 1 and it has an open parenthesis and a closed parenthesis, which up until now has meant call this function. And then on line 2, we're getting a variable from the user by typing in their name, and then we're calling hello, passing in that value. Well, at this point, I can just take for granted that hello exists, even if it's way down further in the file, or as we'll see in future weeks, even if it's in a different file altogether. But there's a problem here. And let me go ahead and run this version of hello.py. Notice that as soon as I run the interpreter, Python of hello.py, I see a name error. Name hello is not defined. Again, did you mean help? Well, again, fitting. I do need some help here, but I didn't mean to call the function help. The problem here, though, is that Python is just taking me literally. I have defined my function hello all the way down here, but I'm trying to use it way up here, and that's not allowed. Python's interpreter is going to take you literally, and if you use a function, it must already exist by the time you are calling it. So how do I fix this? Well, apparently I can't do that. I have to define any functions I want at the very top of my file. But that too could get me into a bit of trouble eventually, because if I constantly have to define a function above where I want to use it, you're kind of writing code in reverse. You're constantly writing functions up here, up here, up here, as opposed to like writing your code logically top to bottom. So let me fix this in a more standard way, which is to do this. Generally speaking, you do want to put the main part of your code at the top of your file. And in fact, I'm going to go so far as to define my function called main. It's not a requirement, but it's indeed a convention. And this just connotes to the reader that this is the main part of my program. I'm going to get rid of my empty hello call now and only pass in one version with hello name. And then down here, a couple lines further down, I'll actually define my hello function. Unfortunately, now that I've reordered the functions in this way, by putting the main part of my code at the top and hello at the bottom so that my logic kind of flows top to bottom, if I go ahead and run Python of hello.py, enter, nothing whatsoever happens. If I do it again, nothing whatsoever happens. Well, why in the world is this? Well, just because I've defined a function called main and I've defined a function called hello doesn't mean that I've actually called, that is, used either of them. Yes, I'm using hello inside of main, but no one is telling Python to actually use or call main. So in order to tidy this up, the last thing I need to do in this file, it seems, is actually call my main function. And in fact, by calling my main function in this way, it gets me out of trouble because now I'm defining main first, but I'm not calling hello yet. I'm defining hello next, but I'm not calling hello next. I only, at the very end of this file, call main, which has the effect of running this code up here, which has the effect of running this code down here, and it allows me, therefore, to organize my file and order my functions in any way I want, including main at the very top, and solving, ultimately, that problem of Python not knowing what's going on. Now, it's important to note that I defined my function hello as taking an argument, 2, and then I passed into that function the value of the variable that I wanted to say hello to, that is the variable called name. Because suppose I had done something a little bit differently. Suppose that I hadn't defined hello as taking an argument, so I just remove mention of 2 and its default value world, and I go back up to my main function and I just call hello itself without passing in any arguments. And now let me go ahead and make one more change, one more mistake technically. Let me go ahead and just try to naively print out the value of name in the hello function. So now to be clear, in my main function on line 2, I'm defining my variable called name and assigning it the return value of the input function from the user. I'm then just calling hello. In my hello function, which now no longer takes any arguments, I am calling print, passing in hello, comma, and then immediately passing in name, the variable into which I got the user's input. But the catch is that name exists now only in main. And so watch what happens when I try to run this version of the program with Python hello.py. I hit enter. I'm prompted for my name, D-A-V-I-D, enter, and a name error. Name, quote unquote, is not defined. So it turns out that this is actually an issue of what's called scope. Scope refers to a variable only existing in the context in which you defined it. So insofar as I define this variable name in my main function, I can only use that variable in my name function. I can't use it as I've tried to here in my hello function. It doesn't exist in that so-called scope. And so this is why now, if I rewind and undo all of those changes, you'll see that I'm deliberately passing main from my main function into my hello function. And now in the hello function, it technically has a different name. It's called 2 in that context, but that's fine. It's completely up to each individual function to name its own variables or name its own arguments. But this is a way now that I'm handing to the hello function the value of that variable so it can be printed by hello as well. And there's one final flourish we can add here. Now that we've implemented hello, you'll notice that hello only has a so-called side effect. It only prints out something to the screen. Well, what if I also want my function to not have a side effect per se, but actually hand me back a value? Recall that the input function returns a value, the string that the user typed in. Recall that the int function returns a value. The float function returns a value that was passed into it. Well, you can use one final keyword here, literally return, to return a value explicitly yourself. In fact, let me go back to VS Code here, and I think we'll return our attention to calculator.py and see if we can't implement one other version of calculator.py that actually has our own function that even returns a value. So I'm going to go ahead and open up calculator.py, and I think this time I'm going to throw everything away as before, and I'm just going to start practicing what we're preaching here. Define a function called main, which is now going to be the main part of my function. Let's go ahead and now declare a variable called x and assign it to the converted version of the user's input after asking them what's x. So again, a line of code quite like we've done before. And suppose now that what I want to do is square this value. I want to take the number that the user's typed in and raise it to the power of 2. So 2 squared would be 4. 3 squared would be 9. 4 squared would be 16, and so forth. Well, how do I go about implementing a function literally called square, which actually doesn't come with Python built in? Well, let me assume for the moment that it does exist, and let me say something like this. Let me go ahead and say that printing, how about x squared is comma square of x. So what have I done? I've defined a function called main, and I've implemented 2 lines. The first of these lines prompts the user for a value x and converts it to an int and stores it in a variable called x. On line 3, I then say x squared is, and then I pass a second argument to the print function, whatever the return value is of a square function. But square doesn't exist, and I'll show you this here. If I now call main at the bottom, and I run Python of calculator.py, I'll see that x is 2, and then I see a whole bunch of errors. A name error, name square is not defined. So this isn't a typo here. It's just the function doesn't exist, but I think I can make it exist here. Let me go ahead and define another function called square. This one's going to take in a number, and I'm going to call it generically n, as many a programmer would, just to represent any old number. And then what do I want to do in order to square n? Well, a number squared is really just itself times itself, so I'm going to do this, n times n. But it's not enough just to do the math yourself, n times n. You're going to have to return the actual value, n times n, and that's our new keyword here. When I now do this, watch what happens. Python of calculator.py, enter. X, say, shall be 2. X squared is 4. Let me go ahead now and say x is now 3. X squared is now 9. So I've implemented my very own function that returns the square of a value. And because I'm using the return keyword, that ensures that I can pass the return value of this, just like the return value of input or int or float, to another function, like print instead. And here, too, there's going to be so many ways to solve this same problem. I can actually raise n to the power of 2. We've not seen the syntax before, but if you use 2 asterisks like this, 2 stars, that raises the thing on the left to the power on the right. Or it turns out there is in Python a function called pow for raising something to the power that takes 2 arguments, the first of which is the number, the second of which is the exponent. So there, too, there's just so many ways to actually solve that same problem as well. So ultimately, what have we done here? We first introduced functions. These actions are verbs, many of which come built into Python that you can just use in your own code. We then introduced variables via which you could store those return values and then maybe do something more with it. At the end of the day, too, you now have the ability to create, to invent your own functions to solve simple problems like hello, or in the weeks to come, much more sophisticated, more challenging, more fun problems as well. All right, this is CS50's Introduction to Programming with Python. My name is David Malin, and this week we focus on conditionals. Conditionals, or conditional statements, in Python and in other languages, are this ability to ask questions and answer those questions in order to decide, do you want to execute this line of code, or this line of code, or this other line of code instead? They allow you to take the proverbial forks in the road within your own code logically. So how might we go about making some of these decisions? Well, it turns out that Python comes with a lot of built-in syntax. For instance, here are just some of the symbols you can use in Python to ask questions. Admittedly, mathematical questions, but we'll start there, if only to keep the example simple early on. This first symbol, as you might know from math, represents greater than. The second symbol might not look too familiar because we usually write it all as one thing on a piece of paper. But on a keyboard, if you want to say greater than or equal to, you'd use this symbol instead. This, of course, means less than. This means less than or equal to. And this one's a bit of a curiosity. We've seen in our look at functions and variables how we were able to assign values to variables using a single equal sign. But that equal sign didn't represent equality. It represented assignment from right to left. That's great because it solved that problem, but it kind of left us in a bit of a bind because how do we now compare two things left and right? Well, in Python and in many languages, you actually use 2 equal signs. So 2 equal signs represents equality, comparing the thing on the left and the right. 1 equal sign, as always, represents assignment, copying the thing from the right to the left. Lastly, this last symbol represents not equal to. So the exclamation point or bang followed by an equal sign means not equal to some value next to it. Well, to ask the questions using these symbols or any others, we're going to need another keyword in Python. And that keyword, quite simply, as in English, is if. You can ask questions in Python code along the lines of, if the answer to this question is true, then go ahead and execute this code for me. So let's go ahead and write some of these examples here. I'm going to go over to VS Code, and let's go ahead and create a program first called compare.py, the goal of which is simply to write code that compares values and makes decisions based on those values. Let's go ahead and type code of compare.py in order to create a brand new file called compare in which we'll start to express some of this logic. All right, well, what do we want to compare? Suppose we want to compare, for the sake of discussion, just a couple of integers, but we'd like those integers to come from the user so that we can make decisions based on numbers we don't know the values of in advance. Well, let's go ahead and do this. As we've done in the past, let's declare a variable like x. Let's assign it equal to the return value of the int function and pass to the int function the return value of the input function, asking the user a question like, what's x? Question mark, as we've done in the past. Let's do this one more time with y, asking the user for the value of y, and again, converting that ultimately to an int as well. So at this moment in the story, we have two variables, x and y, each of which has values. And ideally, we should be able to now compare these values. So suppose I want to make a decision based on the values of these variables. I'm going to use the keyword if, and I'm going to use some of those mathematical symbols to actually ask the question itself. So how about this? If x is less than y, then let's go ahead and just print as much out. Quote unquote, x is less than y. So this isn't a very interesting program yet. I'm literally just stating the obvious based on the math, but it's allowing me to now introduce some new syntax. And exactly what is this syntax? Well, it's this. Not just the keyword if, which I've added here at the start of line 4, but then I ask my question here. X less than y. X is one variable on the left, y is one variable on the right, and of course the less than sign is expressing the mathematical question I have. What I've highlighted here is technically called a Boolean expression. A Boolean expression named after a mathematician named Boole is simply a question that has a yes or no answer, or technically a true or false answer. And that's nice because if there's only two possible answers, it's very easy for me and in turn the computer to make a decision. Do this or don't do this thing. Now notice if you come from other languages, you might notice that I have not typed any parentheses. They are not in fact necessary, at least in this case in Python, but I have typed a colon at the end of the line. And even more importantly, at the next line, I have begun my line with some indentation, hitting the spacebar 4 times or just hitting tab once, which will automatically be converted to the same. That indentation is what tells Python that line 5 should only be executed if the answer to line 4's question is in fact true. So if x is less than y, that phrase will be printed thereafter. Well, let's add a few more lines of code. How about another question? If x is greater than y, then let's go ahead and print that. X is greater than y. And let's do one final question. If x equals y, then wait a minute. What have I done wrong here, right? A good I here. I don't want to assign y to x. If x equals y is how I express equality. Let's go ahead and print out x is equal to y. So I now have 3 conditions, if you will. One question asking x less than y, one asking x greater than y, one asking x equals y. Let's run the code. Well, down here in my terminal window, I'm going to run Python of compare.py and hit enter. What's x? Let's go with 1. What's y? Let's go with 2. This should, of course, execute that first line of code and tell me, indeed, that x is less than y, exactly as I would expect there. Well, what just happened, though, in code? Well, let's take a look, perhaps, at this same code visually, particularly if you're a more visual learner. This, I dare say, is what just happened. So what we're looking at here is a flow chart. It's a diagram of this program's logic. And more technically, it shows the program's control flow. That is, the ability of you in code to control the flow of a program, generally from top to bottom. In fact, let me go ahead and zoom in on the top of this flow chart. And you'll see an oval at the very top that says quite literally start. That is, irrespective of what shape or layout the diagram is where your your own thinking and logic should start when trying to wrap your mind around this program. Notice that there's an arrow from start to this diamond shape. And inside of that diamond is a question, a Boolean expression, x less than y. And this shape just means, based on the answer to that question, go left or go right. Specifically, go left if the answer is true, or go right if the answer is false. Well, the inputs I typed were 1 and 2 respectively for x and y. So of course, 1 is less than 2. So that's why my program printed out, quote unquote, x is less than y. But recall the code. The code then proceeded to ask 2 more questions. Is x greater than y? Is x equal to y? Well, the flowchart depicts those questions too. Notice that no matter whether the question had an answer of true or false, the arrows both converge back down to this second diamond shape here. And that second diamond shape asks the second question, x greater than y. That too has a true or false answer, so we go one way or the other. But if x is 1 and y is 2, then no, the answer is false. 1 is not greater than y. So logically, in the flowchart, you follow the false arrow this time. And notice, along that false arrow, you don't print anything this time. That's why we only saw 1 print out on the screen. Now, there was still a third question, and this flowchart captures that as well. The third diamond asks x equals y. Now, that too has a false answer in this case, because 1, of course, does not equal y. And so we again follow the third false branch here. And that leads us, of course, to stop. And stop just indicates that's it for the program. So I think that's correct. And that particular flowchart does happen to represent the actual code that I wrote. So it's correct. It does what it's supposed to do. It answered the question correctly by printing on the screen x less than y. But what is perhaps poorly designed about it? Let's make this first distinction. It's not enough necessarily for the code that you write to be correct and do what you intend. Longer term, especially as our programs get longer and more sophisticated, more complicated, we're going to want them to be well designed too. Thoughts on in what way this program is arguably not well designed, even though it's correct? Let's see here. Khalid, if I'm saying that right, your thoughts?
Too many ifs, I think, is getting repetitive. We can make our code more concise, maybe.
Yeah, it seems a little repetitive. I'm asking if this, if this, if this, and yet logically, I should know the answer to some of those later questions once I figure 1 out. And in short, if you look at this diagram here, notice that no matter whether I go left or I go right, I'm always asking 3 questions. No matter what, all of those arrows lead to the first, the second, and the third diamond. So I'm asking 3 questions no matter whether any of those answers are true or false. Well, how might I go about improving this? Well, let me propose that we introduce another keyword to our Python vocabulary, namely elif. And this too is kind of a succinct one. It's a conjunction of else if in English, which allows us to ask a question that takes into account whether or not a previous question had a true or false answer. Well, what do I mean by that? Well, let me go back to my code here, and let me propose that we now improve upon this here by asking ourselves, ultimately, how can we ask fewer questions? And let me go ahead here and propose that instead of asking if, let's make these conditions potentially mutually exclusive. That is to say, don't keep answering questions once we get back a true answer. So I'm going to change my code up here as follows. Instead of asking if, I'm going to say if x less than y, if x greater than y, if x equals y. So I'm going to implicitly, just like in English, take into account that I'm only going to keep asking myself these questions if I haven't yet gotten a true response. Think about the logic here, the English. If x is less than y, on line 4, print out x is less than y. Well, if that's the case, you're done logically. Because if the English is saying if x less than y, else if x greater than y, those are going to be mutually exclusive if the answer to the first question is true. You don't have to keep asking questions to which you already logically know the answer. So let me go ahead now and run this program. And I think the behavior is going to be the same. Python of compare.py, what's x? Let's do 1. What's y? Let's do 2. X is less than y. Now, honestly, I didn't really notice a difference when I ran the program. And honestly, my Mac, my PC, my phone nowadays are so darn fast that these kinds of improvements aren't going to necessarily feel any faster until we're writing bigger, faster programs. But it's laying the foundation for writing better code longer term. Now, what is the improvement I've just made? Well, if previously my diagram looked like this, which was problematic insofar as I was asking 3 questions, no matter what, even if I already figured out what I want to print on the screen, this new version of the program that has if, elif, might look a little something like this instead. Now, it got a little wider. That's just because we drew the arrows to be a bit wider here. But let's focus on just how many questions are getting asked. Let me zoom in at the top as before, and let me propose that we note that the start oval is at the very top, and it's asking us to ask one question first. X less than y. Is 1 less than 2? But notice here, let me zoom out. If 1 is indeed less than 2, we follow this longer arrow down marked true. We print out, quote unquote, x is less than y, but then we immediately follow this next arrow down to the icon that says stop. So that's what's implied by doing if, elif. If we get back a true answer right away to that first if, we're going to print out x is less than y and then stop. We're logically at the end of the program. So this picture is just representing graphically what the code is actually doing. But suppose I typed in something else. Suppose that my code actually ran and I typed in 2 for x and 1 for y. That is to say, the answer to the first question is now false, but the answer to the second question is now true. Because, of course, 2 is greater than 1. Well, let's go back to the diagram. Same as before. We start at the very top where it says start. The very first question up here now, x less than y, is an answer of false because no, 2 is not less than 1. So we follow this arrow to the next question, this diamond. Is x greater than y? Well, yes. 2 is greater than 1. So now we follow this left arrow, which is true. We print out, quote unquote, x is greater than y, and then stop. So what's the improvement? Well, in the first case, we got lucky and we only had to ask one question, and boom, we're done. This time, we had to ask 2 questions, but then boom, we're done. Only if x happens to equal y do we actually find ourselves logically getting all the way down to this final elif in my code. And pictorially, only if x is equal to y do we find ourselves going all the way down to the third diamond, the third question, asking is it equal to y or not. Now, hopefully the answer at that point is not false. We've included a false arrow just so that the program itself is well defined. But logically, we shouldn't actually be getting there anyway, because it's got to be less than or greater than or equal to in this case. Well, let me pause here to see if there's any questions now, either on the code version thereof here or on this diagramming of that very same logic. Questions here on this control flow?
Aren't we supposed to put an else at the end?
A good question. And yes, so that's going to be my third and final approach. And if you don't mind, let's pivot there right away. Identifying a third keyword that indeed exists in Python that allows us to be even better at expressing this logic, to design this program even better. And that's going to solve a particular problem. So if I take us back to our code here, notice that what I've highlighted earlier, elif x equals y, it's not wrong to ask that question. In fact, if you're trying to be especially thorough, it makes perfect sense to check if x is less than y, greater than y, or equal to y. But why don't I need to ask this third and final question?
We don't need to ask if x is equal to y anymore, because logically, if the 2 conditionals evaluate to false, there is only one conditional that will evaluate to true, and that is x is equal to y.
Exactly. If we're all pretty comfortable with math and comparisons here, of course, x is either going to be less than y, greater than y, or equal to y. But once you rule out the first 2 scenarios, logically, it's got to be the case that x must equal y if it wasn't the case that it's less than or greater than. So Hope proposed that we use this other keyword, else. And how do we use this? Well, exactly as we might in English. Let me go back to my code here. And instead of bothering to ask the third and final question, let's not ask a question at all. Let's just have this catch-all, so to speak, a final line of code that says else just assume that x is equal to y, therefore printing it as well. So what's the upside of that? My code is still going to work exactly the same. And again, my computer's so darn fast, I don't even notice that it's working even faster than it was before. But we would notice these kinds of things if we were doing a lot more work, a lot bigger programs here. But let me run Python of compare.py. Let's do, for instance, 1 and 2. It still works for that. Let's do 2 and 1. Still works for that. Let's do 1 and 1. And it indeed now works for that. But in these cases now, let's consider the path we just went down. Previously, our diagram, when we had if, elif in place, looked a little something like this. And notice that, again, we might have asked 1 question or 2, or worst case, 3 whole questions. But we can do better than that. Using else as Hope proposed, we can whittle this diagram now down to this. And even though it looks like the diagram's getting bigger, notice that it's having fewer building blocks inside of it. There's fewer arrows and there's fewer nodes in this picture. Let's start at the top now. Start leads us to the first question still. X less than y. If the answer is true, great. We can say as much, x is less than y, and we can stop. If it's not true, if it's false, we can ask the next question. X is greater than y, true or false? If it is, great. We can print x is greater than y and stop. Else, if it's not the case that x is greater than y, the answer is false, we can just immediately, logically say x is equal to y. We don't have to add the third question at all. We can just immediately conclude there. So what's the implication here? You can see with these pictures a relative decrease in the complexity of a program. The first one was very long and stringy with lots and lots of questions, unnecessarily ultimately. The next one got a little shorter, and this one's even shorter still. And again, the fewer lines of code you have, the less likely you are, arguably, to make any mistakes, the easier it is for other people to read. And so generally, this readability, this simplification, is indeed a good thing. Well, let's go ahead and add another piece of capability into Python, and that's this one here. Just like in English, where you can ask this question or this other question, you can say the same thing in Python using literally this word or. So let me go back to my Python code here. And let's propose how we might ask a couple of questions at once this time. Perhaps this time considering how we might ask not whether or not it's greater than or equal to and caring about the precise answer. Let's take a coarser approach here, and let's just try to determine, is x equal to y or not? Well, let me go ahead and delete some of this code and change the question we're asking. Let me do this. Well, if I care about whether it's equal or not, let's check the possible scenarios. If x is less than y or x is greater than y, let's go ahead and print out x is not equal to y. Now, why is that? No pun intended. If x is less than y, well, it's obviously not equal. If x is greater than y, it's obviously not equal. So we can conclude x is not equal to y. So if we instead want to make sure that it is equal to, we can just use Hope's else, using print, quote unquote, x is equal to y. And again, why is this? Well, if x is less than y or x is greater than y, they're obviously not equal. Otherwise, logically, they must be equal in fact. So let's run this. Let's go ahead and run Python of compare.py. What's x? 1. What's y? 2. OK, x is not equal to y. Let's do it again. But 2 for x, 1 for y, x is not equal to y. And one third time, how about x is 1 and y is 1, x is now equal to y. Now, if we want to compare that visually to, let me propose that the picture looks a little something like this. And again, this is the exact same thing logically, but it's a pictorial representation thereof. What's the first question? Well, if x is less than y, well, then we follow the true arrow and we say, quote unquote, x is not equal to y, and then we stop. But what if x is not less than y? What if it's greater than y? What if it's 2 and 1 respectively? Then the answer to x less than y's first question is false. So we go here. We ask the second question because of the or, and that asks, is x greater than y? If so, notice this. We can kind of reuse some of the same parts of this picture and just say x is not equal to y. We don't need to add arrows and add boxes unnecessarily. We can reuse lines of code, parts of the picture just as we have lines of code. And then we stop. Lastly, we have the following. If we know that x is not less than y, we know that x is not greater than y, it must be the case that x equals y. We don't need to ask a third question, another diamond. We can just immediately print as much and then say stop as well. Well, what could I do here? I bet I could improve this code slightly. And if we really want to be nitpicky, I would argue that this is now really just a minor refinement, but it's a good habit to get into thinking about, could my code be better? Could my code be simpler? Could I improve this code further? It's subtle, but could I improve the design? Could I ask fewer questions? Could I tighten it up, so to speak? What do folks think?
You can ask if x is just equal to y. Then it will print x is equal to y, else x is not equal to y.
Perfect. Recall one of the other symbols we saw in the available list earlier. We can check not just less than or greater than or equal to. We can literally ask the question, is it not equal to? Why are we wasting time asking if it's less than or if it's greater than? Well, if all you care about is it not equal, I think we can do exactly that. Let's just ask the one simple question we do care about. And so let me go back up here and let me just say, not both of these questions. Let's get rid of the or. Let's just say if x is not equal to y, then go ahead and print x is not equal to y. And that, too, I think is going to work exactly the same. But the picture now looks a little bit different. Notice that this was our flow chart earlier that represented that same logic. And there's a bit of complexity. You got to go left. You got to go right based on the answer to these couple of questions. If we now take into account what this version of the program looks like, it's even simpler, perhaps the simplest one we've seen yet. When we start off the program, we ask just one and only one question. Is x not equal to y? And if so, true, we go ahead and print out x not equal to y. If the answer is false, then of course it must be equal to y, so we say that instead. And if we really want, we could invert this. If I go back here to my code, and if for whatever reason you just prefer to think in terms of equal or not equal, as opposed to not equal or equal, it's really up to you. We could change this to be equals equals, but I'm going to have to change my print statements to be in the opposite order. So let me go ahead now and reverse these two here and move the second one first and the first one second. So now when I execute this code, I'm asking still just one question. So it's still just as good, just as succinct. But now the diagram, instead of looking like this, is going to change the not equal to equal equal. And we just need to make sure that we print out the right thing accordingly. And again, here too, just as the code is getting a little more compact with fewer and fewer characters, so are these diagrams, these flowcharts, capturing the relative simplification of each of those programs too. All right, let me go ahead and pause here to see if there's any questions now on any of these versions of code.
Yeah, I have a couple of questions. What if indentation is not used?
If indentation is not used, your program will not work. So Python is a little different from a lot of languages in that it enforces the indentation requirement. Some of you who have been programming for years might not necessarily be in the best habit of indenting your code properly. And one of the features, arguably, of Python is that it makes you indent your code or it will not just work. And I think, did you have one other question?
Is the colon necessary?
Is the colon necessary? Yes, the colon too is necessary. So with Python, what you see is what you get here. And indeed, it needs to be indented, and the colon is necessary. Python does not use in the same way by convention as C and C++, and Java curly braces to connote blocks instead. It relies indeed on this indentation. Well, let me propose that we introduce one other keyword here in Python to see exactly how we might combine additional thoughts. And that's going to be literally the word and, a conjunction of one or two or more questions that we might want to ask at once. And let me propose here that we explore this kind of logic by way of another program altogether in VS Code, whereby I'll go ahead now and create a new program, say, called grade.py. Let's consider exactly what grade a student should get based on their score on an exam or a test or a quiz or some other assignment like that. I'm going to go ahead and run code of grade.py to give myself a new file. And I'm going to go ahead and start by just getting the user's score, again, on some assignment or test or the like. And I'm going to store it in a variable called score equal the return value of the int function, which is going to convert whatever the user's input is when prompted for this score. So again, the user should just oblige by giving me a number like 0 or 1 or 2, or hopefully much higher than that, like 97, 98, 99, 100, assuming the test or assessment is out of 100%. percentage points. Now, how could I go about assigning a grade to the student's score? Well, in the US, it's very commonly the case that if you get between a 90 and 100, that's an A. And if it's between an 80 and an 89, it's a B. If it's 70 and 79, it's a C, and so forth, all the way down to F, which should be E, but we'll see that there's a bit of a jump. So how might I express this? Well, I can use conditionals, and I can ask a few questions and then print out the student's grade accordingly. So let me express it like this. If the student's score is greater than or equal to 90, and the student's score is less than or equal to 100, so it's in that range, let's go ahead and print out that their grade shall be an A, because they're in the 90s above grades range. If the score is greater than or equal to 80, and the score is less than or equal to, say, 89. But here I have some options. Logically, I can actually express myself in any number of ways. And maybe just to be a little cleaner, I'm going to say a score is less than 90. So I'm using less than instead of less than or equal to. So I'm making sure that their boundaries between these grades are correct. Then I'm going to go ahead and give the student a B, if it's in the 80s. If score is greater than or equal to 70 and the score is less than 80, I'm going to go ahead and give them a C. If the score is greater than or equal to 60 and the score is less than 70, I'm going to go ahead and give them a D. And here's where it's a little anomalous, at least in some schools here. Else, I'm going to go ahead and give them an F. So we're skipping E altogether, and we're going to give an F instead for the grade. So that's the catch-all. And I think logically I've gotten this correct, at least based on where I went to school growing up, such that it's going to give an A or a B or a C or a D. Else, it's going to assume that you got an F. Well, let's try just a few of these here. Let's run Python of grade.py. My score is, let's start strong, 100. All right, I got an A. Didn't do as well the next time. Maybe it's a 95. Still an A. Starting to slip further, so I got an 89 the next time. That's now, say, a B. And let's say I really had a bad week and it's now like a 71. That's now a C. Or I didn't even submit it at all. That's an F altogether. All right, so it seems to work. That's not really an exhaustive test, but at least based on some sampling there, my code seems to work as I expect. But let's see if we can't tighten this up. It's not wrong. It's correct. And indeed, according to my own specifications, I dare say this code is correct. But can we tighten it up? Can we reduce the probability of bugs now or down the line? Can we increase the readability of it? And can we increase the efficiency of it? Can we get the computer to have to answer fewer questions and still get the same result? Well, let's see what we might do. Let me just kind of switch things up, if only to demonstrate that we can use these symbols in different ways. I could say, as I've done, if score is greater than or equal to 90. But I can actually do this. I can flip it around. Instead of saying greater than or equal to, let's say 90 is less than or equal to score. And here, let's say if 80 is less than or equal to score. And here, 70 is less than or equal to score. And then lastly, 60 is less than or equal to score. So it's the same thing logically. I'm just kind of switching things around, just like you could do on paper pencil if you really wanted. But now notice this trick, and this is not possible for those of you who have programmed in C or C++ or Java or other languages. Notice what I can do here is actually combine these ranges. Notice that I'm asking two questions, two Boolean expressions. Is 90 less than or equal to score? And is score less than or equal to 100? Well, Python allows you to nest these things like this and chain them together. And just like you would on paper pencil in the real world, you can in code in Python do this, which is just a little cleaner, right? It's tightening up the code a little bit. It's fewer keystrokes. It's faster to type. It's easier to read moving forward. So that's arguably better as well. So that's one improvement. It's largely aesthetic in this case. It's still asking the same number of questions, but it's doing it a little more succinctly still. Well, what more could I do here next? Well, you know what? Each time I'm deciding these grades, I don't think I have to ask two questions. I don't have to ask, is it greater than 90 and less than 100? Is it greater than 80 and less than 90? If I kind of rethink my logic, I can maybe do this better still. Let me propose that we simplify this further. And just do this. If we know the input for the moment is going to be within 0 and 100, we can make some assumptions. We could say something like if the score is greater than or equal to 90, well, the student gets an A. If the score is greater than or equal to 80, the student gets a B. If score is greater than or equal to 70, they get a C. If the score is greater than or equal to 60, they get a D, else they get an F. So what have I done here? Well, instead of asking 2 questions every time, checking the lower bound and the upper bound of that range, I'm kind of being a little more clever here by asking if the score is greater than 90, well, they've obviously gotten an A or better. If your score is greater than 80, well, you either deserve an A if it's really strong or a B if it's just above 80. But because of the if logic, we've already checked, is the student's score greater than 90? And if it's not, then we're asking the question, well, is it greater than 80? So you implicitly know it's somewhere in the 80 to 89 range. Else, you know it's in the 70 to 79 range. Else, it's in the next range down. So it's a minor optimization that allows us to ask fewer questions. But again, it's making the code arguably a little more readable, certainly more succinct, and then hopefully more maintainable longer term. Any questions then on these types of changes and this type of logic with our code?
What if we don't use elif at all? What if we write the code in F?
Yeah, so that's a good question because it's actually going to have an unintended effect here. Let me get rid of the F temporarily and just focus on A through D. If we revert to where we began today's story with conditionals, saying if, now our cleverness here of using broader strokes and not using an upper and lower bound ranges is going to come back to be a downside. Let me go ahead and run Python of grade.py. And suppose my score is 95. I am so darn excited. I want my A. But nope, I just got an A, a B, a C, and a D. So logically, that's broken things. Because if you don't make these conditions mutually exclusive, every one of those questions is going to get asked and therefore answered. And even if your grade is above a 90, it's also logically above an 80, above a 70, above a 60. And if I'd kept it in there, I would have failed as well with an F. Really good question. Other questions here on this form of logic?
Like, would there be any, I guess, better way to kind of clean up even just this simple statement like we had before, the previous one that you had with the else if?
Oh, I like your enthusiasm for simplifying things further. I'm going to go out on a limb here and say this is about as good as it gets, at least using only conditional statements. I can, if my mind wanders, think of a slightly more clever way to do this, maybe with something called a loop or another programming construct. We don't have that yet in our vocabulary. But yes, there's absolutely other ways to do it. But I think not yet if we want to restrict ourselves to just words like if and or and else and elif and the like. Well, let me propose that we pivot now to use another approach here that uses one other symbol that up until now we've not really had occasion to use. Let me propose that we implement a program that we'll call parity. In mathematics, parity can refer to whether a number is even or odd. And that's kind of an interesting question. And it turns out it can be useful in other applications too. To just ask the question, is a given number even or odd? Maybe that the user typed in. And let me go ahead and write a new program called parity.py via code parity.py in my terminal. And let me propose that we use this as an opportunity to introduce the last of those arithmetic symbols, at least most of which we're familiar with: addition, subtraction, multiplication, division. But there's been on this list before, this last one here, a percent sign. And it doesn't mean percentage in this case when used as an operator in programming in Python. Rather, it represents the so-called modulo operator for modular arithmetic. Or at least in our case, we're going to use it to calculate the remainder when dividing one number by another. Well, what do I mean by that? Well, if you take a number like 1 divided by 3, 3 does not go into 1 cleanly, so you have a remainder of 1. 2 divided by 3 has a remainder of 2. 3 divided by 3 has a remainder of 0 because it divides cleanly. 4 divided by 3 has a remainder of 1 because you can divide it in once, but then that leaves 1, so it has a remainder of 1. And then lastly, something like 5 divided by 3 has a remainder, of course, of 2. So that's all we mean by remainder, how much is left over after dividing one number by another. Well, if I go back now to my code and I consider how I might implement the question, is this number even or odd? Let's consider how we might implement that, since it's perhaps not necessarily obvious how we can use this additional building block. But it turns out it's going to be very useful longer term. Well, let's first just get a number from the user in a variable called x. And I'm going to set that equal to the conversion to int of whatever the user inputs after asking them, what's x question mark? And we've done that before many times. How do I now determine if x is even or odd? Well, it turns out if I have access to a programmatic operator that tells me the remainder, I think I can do this. In fact, let me just ask the group, and this is just from grade school math perhaps, what does it mean for a number to be even? To be clear, a number like 0, 2, 4, 6, 8, 10, 12, 14, 16, those are all even numbers, but what does that really mean? Elena, if I'm saying that right?
Even numbers that can divide it exactly by 2. For example, 2, 4, 6, 8, and 10. And
Perfect. And we could go on all day long, literally. So there's an infinite number of those even numbers, but it's nice that you formulated it in terms of a question that we can ask very clearly. Is this number cleanly divided by 2? That is, can we divide it by 2 with no remainder, a remainder of 0? Well, that's perfect, because if we have this operator, this percent sign, that allows us to answer just that, what is the remainder, we can presumably check, is the remainder 0 or is it 1? Do we have nothing left over, or do we have 1 left over? Well, let's ask that. If x divided by 2 has a remainder of 0, as Elena proposes, let's go ahead and print out something like quote unquote even and just say as much to the user. Else, I think we can assume that if a number is not even, it's going to be odd if it's indeed an integer. So I'm going to go ahead and print out quote unquote odd instead. And let's go ahead and now run Python of parity.py in my prompt. What's x? Let's start with 2. 2 is in fact even. Let's start with 4. 4 is in fact even. Let's get interesting with 3. 3 is now odd. And I think we could do that all day long and hopefully get back indeed exactly that answer. But what more could we do here? How could we improve upon this? Well, recall that we have the ability to invent our own functions. And let me just propose for the sake of discussion that we're going to eventually find that it's useful to be able to determine if a number is even or odd. And so we'd like to have that functionality built in. And I don't think Python has a function for telling me just that, but I can invent it using code like just this. So let me go into my earlier version here, and let me propose that we do this. Let me go ahead and write a main function. I'm going to get back into that habit of defining a main function to represent the main part of my program. And I'm going to do what I did before. I'm going to get an integer from the user's input, asking them what's x, question mark. And then I'm going to ask this question. For the moment, I'm going to naively assume that the function already exists, but that's a useful problem-solving technique. Even if I have no idea yet where I'm going with this, how I'm going to invent a function that determines if a number is even, I'm just going to assume that there's a function called isEven. And I'm going to call it blindly like this. If isEven, passing in x, then go ahead and print quote unquote even. So if this magical function called isEven returns true as its return value, I am going to print out that it's even. Else, otherwise, I'm going to assume that it's, of course, odd. Now, the one problem with this program, even if I call main over here, is that isEven does not exist. And this program would break if I ran it right now. But that's OK. I have the ability, recall, to invent my own function. So let me define with def a function called isEven. I want this function to take an argument, and I'm going to call it n, just a number generically. I could call it x, but again, I don't want to confuse myself as to which x is which, so I'm going to give it a different name, and that's fine. I'm just going to call it more generically n for number. And then I'm going to do this. I'm going to say if n %2 equals 0, just like before, then, and here's the magic, you, the programmer, can actually return what are called Boolean values. We've seen in Python that Python has strs or strings, ints or integers, floats or floating point values, all of which are different types of data in Python. Python also has a fourth data type called bool for a Boolean value. And even though this is just adding to our list, the nice thing about bools is that they can only be true or false. An int can be any number of infinite possible values. A bool can only be true or false. And it must be capital T and capital F if you're writing itself. So if I go back now to my code and I consider exactly what I want to return here, well, if n %2 equals 0, that is, if n divided by 2 has a remainder of 0, well, I think it's even to, Elena, your definition, so let's return true, capital T. Else, If it doesn't have a remainder of 0, I'm pretty sure mathematically it's got to have a remainder of 1, but it doesn't matter. I know it's not even, so I'm going to return false. And we return false instead, capital F. And now that we've defined both main and is even, and I'm calling main at the bottom, I think I've got this right. Python of parity.py, enter. What's x? Let's try something simple like 2. And it's even. Let's do it again. What's x? How about 4? Even. Once more. What's x? How about 3? And it's odd. Now, what have I done here? I've just made the point that if I want to create my own function called isEven that answers this question for me, that I can now use in this program, and heck, maybe future programs that I write, I now have a function that no one gave me, I gave myself, that I can use and reuse. And I can even perhaps share it with others. I'm using that function now on line 3 just to make a decision. I'm using a conditional up there, and my Boolean expression, something that's true or false, is going to be not something explicit like x less than y or y greater than x or the like. It's going to be a function call. I'm using a function as my Boolean expression, but that's OK because I know, because I wrote it, that that function isEven returns true or it returns false. And that's all I need in a conditional to make a decision to print even or print odd. So let me pause here to see if there's any questions now on how I've implemented isEven using this bool.
Hello, hi David. First of all, thank you for this wonderful class. Day before yesterday and today itself. I have just one query, like basis on my background of Java. There, when we used to pass the arguments, we can also pass the address of the variables. So is there any sort of this concept in Python?
Short answer, no. Those who are unfamiliar with Java or other languages, or C or C++, there's generally ways to pass values in different mechanisms that allow you or disallow you to change them. In Python, no. Everything we're going to see is actually, in fact, an object, but more on that down the line. How about time for one more question here on these bools and these isEvens?
So I actually had a question about defining a function, if that's OK.
Sure.
So if you define one, are you, like within your code, like you made it up, are you allowed to use the dot operator like we did name.strip and use it like that?
Good question. If you've created your own function, can you use other functions like .strip or .title or .capitalize that we've seen in the past? You can use those on strings. Those functions come with strings. You can't necessarily use them on your own functions unless your function returns a string. For the examples you gave, I'm returning a bool. Bools have no notion of white space to the left or the right. You can't call strip. You can't call capitalize. But if you were writing a different function that returns a string, absolutely, you could use those functions as well. Well, let me turn our attention, if I may, back to this example here and consider, as we now frequently do, can we improve on the design of this code? Can I make this particular program better? And I can. There's a couple of ways here, and I'll show you something that's now generally known as something Pythonic. There's actually this term of art in the Python world where something is Pythonic if it's just the way you do things in Python. Which is to say, we've seen already there's so many different ways to solve certain problems. And in the Python community of programmers, there tend to be some ways that are smiled upon more than others. And they tend to relate to features that maybe only Python has, but not other languages. And here's some syntax that you might not have seen in languages like Java or C or C++ if you've programmed before. And if you've never programmed before, this too is going to be new. Instead of asking a question like this, if else, using 4 lines, in Python, you can actually collapse this into just one more elegant line, if you will. Instead of asking if n divided by 2 has a remainder of 0, return true, else return false, let me delete all of that and just say this. Return true if n divided by 2 has a remainder of 0, else return false. Now, those of you who do have prior programming experience might actually think this is kind of cool. You can condense from 4 lines into 1 line that very same thought. And one of the reasons why Python is popular is that it does tend to read rather like English. It's not quite as user-friendly as most English or most human languages, but notice now the line does rather say what you mean. Return true if n divided by 2 has a remainder of 0, else false. I mean, that's pretty darn close to something you might say logically in English, be it about even and odd, or really anything else. So that program is going to work exactly the same. Python of parity.py, let me type in 2, it's still even. Let me type in 3, it's still odd. But I can refine this even further. And again, consistent with this idea of not just writing correct code, but writing better and better code, but still keeping it readable, I can do one even better than this. Notice this value here is my Boolean expression, and it is going to evaluate to true or false. Is n divided by 2 having a remainder of 0 or not? Like, that is by definition a Boolean expression. It has a yes, no answer, a true, false answer. Well, if your Boolean expression itself has a true or false answer, why are you asking a question in the first place? Why ask if? Why say else? Just return the value of your own Boolean expression. And perhaps the tightest version, the most succinct and still readable version of this code would be to delete this whole line, Pythonic though it is, and just return n modulo 2 equals 0. If it helps, let me add parentheses temporarily, because what's going to happen in parentheses will happen first. N divided by 2 either does or does not have a remainder of 0. If it does, the answer is true. If it doesn't, the answer is false. So just return the question, if you will. You don't need to wrap it explicitly with an if and an else. And in fact, because of order of operations, you don't even need the parentheses. So now this is perhaps the most elegant way to implement this same idea. Now, which is better? This is pretty darn good. And it's hard to take fault with this because it's so very succinct. But it's perfectly OK and just as correct to have an if and then an else, even though it might be 4 total lines, if that helps you think about your code more clearly and it helps other people reason about it as well. So it turns out there's another syntax that you can use to implement the same idea of a conditional, whereby you do something optionally based on the answer to some Boolean expression. And the keyword that you can now use in recent versions of Python is called this, match. Match is a mechanism that, if you've programmed before, is similar in spirit to something called switch in other languages. For instance, let me go ahead here and close out parity.py, and let me go ahead and create a new file called house.py. And in house.py, I think what we're going to do is try to implement a program that prompts the user for their name and then just outputs what house they're known to be in the world of Harry Potter. So for instance, let me go ahead and do this. Let me give myself a variable called name, set it equal to the return value of the input function, and I'll say something like, what's your name, ? And then after that, I'm just going to use a traditional if else construct to decide what house this person is in. So let me say if name equals, say Harry, as in Harry Potter. Well, let's go ahead and print out Harry's house, which is Gryffindor in the world of Harry Potter. If the name is instead Hermione, then go ahead and print out also, quote unquote, Gryffindor, as she's in the same house too. If name equals Ron, let's go ahead and similarly print out Gryffindor, quote unquote. And let's make this a little more interesting now. If name equals, quote unquote, how about Draco Malfoy in the books? Let's go ahead and print out, quote unquote, Slytherin. And just in case someone else's name gets inputted for now, let's just suppose that we don't recognize them and say, by default, else print out, quote unquote, who? ? Just to convey that we don't actually have a hard-coded response to that particular name. Let me go ahead now and run this as Python of house.py, enter, and I'll go ahead and type in something like Harry. And voila, we see that Harry is indeed in Gryffindor. Let's run it one more time, Python of house.py. Let's type in Draco this time, Slytherin, and now let's type in an unrecognized name. Let's go ahead and rerun Python of house.py, and let's go ahead and type in Padma, enter. And who? Because we haven't actually hard-coded with an if condition in this case what house Padma is meant to be in. All right, well, it turns out there's other ways to implement this. Indeed, there's some redundancy here in that we're checking if Harry or Hermione or Ron are all in Gryffindor. I feel like we can at least tighten this code up a little bit using techniques we've seen already. So let me go ahead and do this. Let me go up here and instead do something like this. Let's get rid of these 2 blocks of ifs, leaving just Harry's for a moment. And let's use that or keyword again and say or name equals, quote unquote, Hermione. or name equals quote unquote Ron, thereby consolidating all three cases, if you will, into just one if statement. Then we still have a separate elif for Draco because he's not in fact in Gryffindor, and then the final else to catch anyone else. All right, let me go ahead now and run this version of the program, Python of house.py. I'll type in Hermione this time. She too is still in Gryffindor. Let me try it with Ron, and that too still seems to be correct. Well, it turns out there's another approach altogether that can perhaps make your code a little less verbose. You could imagine how complicated this code might get if we had not just Harry and Hermione and Ron, but a whole bunch of other names as well for Gryffindor, for Slytherin, and for all of the other Hogwarts houses. So you could imagine that code just getting pretty unwieldy pretty fast. Well, it turns out another technique you can use is indeed this keyword called match, which is very similar in spirit, but the syntax is different and allows you to express the same ideas a little more compactly. So let me go back to house.py and let me propose that I get rid of my current if, elif, else approach and instead do this. Literally use the keyword match and type the name of the variable or value that we want to match on. And then I'm going to go ahead and include a colon. And then underneath that, I'm going to include literally a keyword called case. And the first case I want to consider is going to be Harry. And I'm going to put Harry in quotes because it's a string or a stir. And I'm going to have another colon at the end of this line. And indented under that one, I'm going to go ahead and, for now, print out Gryffindor, which of course is Harry's house. Otherwise, I'm going to have another case for quote unquote Hermione. And similarly, I'm going to have under that indented print quote unquote Gryffindor, close quote. Now I'm going to have another case for Ron, also in quotes with a colon. Now print quote unquote Gryffindor. And now I'm going to have a other case for, let's say, Draco. This one gets a little more interesting because Draco, of course, now is in Slytherin. And then I'm going to go ahead and leave it as that for now. So let me go ahead and save this file and go back down to my terminal window running Python of house.py, enter, and let's go ahead and try Harry. And he seems still to be in Gryffindor. Let's run it again for Hermione. Enter. Gryffindor. Let's skip ahead to Draco and type in Draco's name. He's indeed in Slytherin. Now let's try another name that we haven't handled a case for, like Padma again. Enter. And we're just ignored. There's no output whatsoever because there wasn't a case for Padma. Now, we could, of course, go back in and explicitly add one for Padma. But what if we, similarly to the else construct, just want kind of a catch-all that handles anyone whose name is not explicitly specified? Well, it turns out the syntax for that, using this new match statement, is to still have another case, but then to use this single underscore character, which is used in other contexts in Python. But for here, it's meant to say whatever case has not yet been handled, go ahead and print out, as we did before, for instance, quote unquote, who, with a question mark at the end. Now let's go ahead and rerun this. Python of house.py. I'll type Padma's name again, and this time I think we're at least going to get an explicit response indicating who, whereas previously we did not have the equivalent of that. Now, I think we've regressed a little bit. We went from tightening things up by putting Harry and Hermione and Ron all on the same line in the same if statement. But here we have now three case statements again for all three of those. Well, we can tighten this code up as well, but the syntax is going to be a little bit different. I'm going to go ahead and delete these two middle cases for Hermione and Ron. And then up here next to Harry's name, before the colon, I'm going to go ahead and use a single vertical bar and then a quote unquote Hermione. Then another single bar and do quote unquote Ron. And this is how, using this relatively new match statement, you can say the equivalent of Harry or Hermione or Ron, but more concisely than you could using an if statement alone as we implemented it previously. So now one final run of the program with Python of house.py. Let's make sure that Harry's still in Gryffindor. Let's make sure that Hermione's still in Gryffindor. Let's make sure that Ron is still in Gryffindor. And indeed, all three of them are. Now, as always with Python and programming more generally, there's going to be different ways you can solve these problems. This is just another tool in your toolkit. Arguably, it has tightened things up. Arguably, it's perhaps a little more readable because there's a little less syntax going on, a little less duplication of equal signs and elif and elif and elif all over the place. But ultimately, this would be an equally correct approach to that same problem. But it turns out with the match statement, you can do even more powerful forms of matching as well. Here, we've used it simply to implement the same idea as that if, elif, else construct. And it's worth noting, if you've programmed in some other language, the syntax here is indeed correct. You do not need, for instance, a break statement, as has been peppered throughout. And you don't need something like default or something explicit. You indeed just use this underscore as your catch-all at the end of the match. So just by adding in some of these new keywords here, like if and elif and else, we have now the ability to ask questions about values. We have the ability to analyze input from users and ultimately make decisions about it. And these then were our conditionals. Lying ahead is going to be the ability for us to not only use functions and variables and also these conditionals, but also next loops, the ability to do something now again and again. All right, this is CS50's Introduction to Programming with Python. My name is David Malin, and this week we focus on loops, this ability in Python and a lot of other programming languages to do something again and again, a cycle of sorts. And let's see if we can't begin by motivating exactly why we have this ability to do things cyclically using these loops. I'm going to go ahead here and open up VS Code. And in my terminal window, let's go ahead and create via code cat.py, a Python program that meows like a cat. And I'm going to go ahead here in this code tab. Very simply, perhaps, I'm going to start by implementing this cat just by using print. We're going to have this cat not make audible sounds, but just print meow, meow, meow on the screen 3 times. Well, I think the simplest way I can do this is just to print meow once, and to print meow again, and to print meow one last time on the screen. And now let me go down to my terminal window. Let me run python of cat.py, enter, and meow, meow, meow. All right, so this program works. This program indeed works if my goal is to get the cat to meow 3 times. And let me propose, just to help us wrap our minds around what's going on inside of the computer, let me propose that we consider this flowchart. So as before, we have this flowchart that starts with a this oval, which just means start reading here. And then notice it goes via arrows to a meow, 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 and then it stops. It's perfectly correct, and honestly, it's wonderfully simple, but I dare say we can find fault with my code nonetheless. Why is my code arguably poorly designed? Now, the answer is going to be loops in some way, but let's see if we can identify in what way the code is actually poorly designed in some sense. Let's see. Any thoughts, Alex?
OK, so I mean, repeating the same action like 3 times or even more is not a good habit.
Yeah, I'm just repeating myself. And honestly, it's not that big a deal. If we go back to my code here, am I really doing such a bad thing by just printing meow, meow, meow 3 times? Not really, but let's consider the logical extension of this. Suppose I wanted to meow 4 times, or 5 times, or 50 times, or 500 times. Do you really think, even if you've never programmed before, is the solution to this problem really going to be to hit copy paste 50 times? Like, probably not. We can probably do better than that. And beyond it just being ugly at that point, having so many lines of identical code, just imagine if you wanted to change the code. Maybe I changed my mind and I don't want to make a cat, I want to make a dog. So now it has to say woof, woof, woof multiple times. Now I have to change that in like 50 different places. And yeah, sure, I could do find and replace, but come on. Like, we're programmers now. There's got to be a better way than just repeating ourselves. So I bet we can do better than that if we think about a little harder how we go about structuring this program. And we can do that if we augment our vocabulary just a little bit. It turns out in Python, and in other languages too, there's a keyword called while. And while is one way that we can express what's called a loop, a block of code that's going to do something again and again and again, 0 times, 1 time, 2 times, 50 times, as many times as we want. But while rather leaves to us the particulars of how we express ourselves to do something again and again. So let me go back over to VS Code here, and let me propose that I do this. While is a construct that allows me to ask a question again and again. And anytime we've seen a question, it's been in the form of a Boolean expression, a question to which the answer is true or false. Well, how could I do this? How could I print out meow 3 times and ask 3 times a question to which the answer is true or false? Well, what if I did some counting, right? Like literally on my fingers. And if I'm trying to count maybe down from 3, I want to meow 3 times. I can put 3 fingers up and I can meow and then I can put like one of the fingers down, and then meow, and I can put one of the fingers down, and I can meow, put one of the fingers down. And maybe the question I can ask every time I meow is, do I have any fingers up still? Do I have any fingers up still? Do I have any fingers up still? And if the answer is true, keep going. If the answer is false, stop. So how can I translate that to code? Well, once we've added this while keyword, I think we have all of the building blocks already. Let me propose that I do this. Let me propose that I give myself a variable. And I'll call it I for integer, but I could call it anything I want. And I'm going to initialize it to 3. Then I'm going to use this new feature of Python, while, and I'm going to ask a question, the answer to which must be true or false. And I'm going to say, while I does not equal 0. So I'm going to ask the question, while I does not equal 0, do the following. Notice the colon at the end of the line. Notice my indentation. And just like with functions, just like with conditionals, you indent the lines that you only want to execute as part of this other thing. What do I want to do while I does not equal 0? Well, I think I just want to meow. But it's not enough just to write this code. If I were to very dangerously run Python of cat.py and hit enter right now, what might happen on the screen, whether you've programmed before or not? Why is this a very bad thing potentially? It's not going to break things, but it might lose control of my computer somehow. Any thoughts? Yeah, Timo?
Hi, I think it's going to continue to print out mail since I is always equal to 3 and the while is always true.
Yeah, exactly. If I'm initializing I to 3, that is setting it equal to 3 on line 1, then I'm asking the question, while I does not equal 0, and that's going to be true. It does not equal 0. It obviously equals 3. Print meow. And the way a while loop works is that the Python interpreter just keeps going back and forth. It goes from line 1 to line 2, then to line 3, and then it goes back to line 2 to ask the question again. If the answer is still true, it goes to line 3. It then goes back to line 2. If the answer is still true, it goes back to line 3. And to Timu's point, if you're never actually changing the value of I, it's always 3, you're just going to be looping literally forever. And this is an accidental infinite loop. So we've got to be smarter than that. And I'm not going to hit enter because I don't want to lose control over my computer here such that it's printing out meow forever. Fortunately, if you ever do that and you find yourself in an accidental infinite loop, Control-C for cancel or interrupt is going to be your friend. If you ever seem to lose control, you don't need to like reboot or turn off the computer. You can just hit Control-C in your terminal window, and that will likely fix it. All right, well, what do I want to do then after meowing each time? I think what I'd like to do here is maybe something like this. Let me update I to equal whatever the current value is, minus 1 here. Whoops, sorry, minus 1. So if I, on each iteration, am updating I to be 1 less, 1 less, 1 less, it should eventually hit 0, at which point the answer to line 2's question will now be false. So let's see if this works. I'm going to go down to my terminal window and run Python of cat.py, and I indeed get 3 meows. Why? Because I've kind of wired this up, kind of like a machine in software, if you will. I've set I equal to 3, then I keep asking this question. But I keep turning the gears. I keep changing the value of the variable to make sure that ultimately it is actually being decremented, that is, decreased by 1 until we eventually hit 0. Now, for those of you who think a little more graphically, let me pull up one of our usual flowcharts. This is just a representation graphically of the exact same thing. Notice what's happening. I first start the program, and then I initialize I to 3. And then I ask the first of my questions. Again, the diamonds always represent questions. And the answer is going to be true or false. Does I not equal 0? Well, it doesn't. It equals 3. So if I follow the true line, I meow. And then I follow this arrow. And I update I to equal I minus 1. At this point in the story, I presumably equals 2 mathematically. I follow the arrow. And there's the loop. This is why it's nice to see this graphically, perhaps, because you can literally see the loop back and forth. Now I ask the question again. Does 2 not equal 0? Well, it does not equal 0. It's 2. So we meow again. We change I from 2 to 1. Well, does 1 not equal 0? Well, obviously, if 1 is not 0, so we meow again. We decrement I again. I is now 0. Does 0 not equal 0? No, it equals 0. So the answer is false, and we stop. So there, perhaps more so than any of our flowcharts before, do you really see the structure of what's happening inside of the program? And you don't have to get into the habit of making these charts or creating these charts, but just as a first pass at what's going on inside of the computer, that's indeed one way to visualize it instead. Well, let me propose that, like always, there's many different ways to solve this problem. And suppose you just like to think a little differently. Maybe you don't like starting at 3 and then counting down to 0y. Maybe your just brain doesn't work that way and you prefer to count up instead of down. Totally fine. Let me go ahead and change my code here to set I equal to 1 instead of 3. And here, let me just change my logic. Rather than checking for not equal to 0, like maybe you don't like thinking in terms of not because it's a little confusing, and it might be, let's just check that I is less than or equal to 3. So we'll be a little more explicit. We'll count from 1 up through 3, each time printing meow, but I'm going to need to change this line here. Let me see if we can't call on someone to change line 4 for me. How do I want to change line 4? To be consistent with counting from 1 up to and through 3.
I would be +1 every time you meow.
Yeah, exactly. In this case, we want to add 1, not subtract 1. And in fact, if you think about this, this too could end very poorly, right? If you start counting at 1 and you keep subtracting 1, subtracting 1, subtracting 1, I think we're going to find ourselves with the same problem, which is that we're never going to stop because we're going to keep getting more and more negative as opposed to ever getting up to the number 3. So I think you're right. I need to change this to be I equals I plus 1. And now notice, just for clarity too, the equal sign is, again, our assignment operator from right to left. Logically, this might otherwise strike you as strange. Like, how can I equal itself plus 1? Well, it doesn't until you execute this code from right to left. You add 1 to I, or you subtract 1 from I, and then you update the value of I on the left. The assignment copies the value from the right to the left. Well, how else might I do this? Well, I will say that most programmers, computer scientists more generally, tend to start counting from 0. It's a convention, and it actually has upsides even in Python and other languages where, generally speaking, it's a good thing to start counting from 0 instead of counting like we might in the real world from 1. Let's go ahead and adopt that convention now. Let me set I equal to 0, and I need to make a change now. Notice, if I don't change my logic, this program just became buggy. The cat has a bug. It's now meowing 4 times if I run it as is. But the easiest fix here would be to change my inequality to be this, less than, instead of less than or equal to. Now, I'm starting at 0, but I'm going up 2, but not through 3. And even though this might, of all the things we've seen thus far, seem maybe the least familiar, most of us might start at 1, 2, then 3. It's a good habit to get into now. Start at 0 and go up 2, but not through the value that you care about ultimately, 3 in this case here. Well, let me tighten things up a bit here. Not only will this now fix my counting problem, it now meows 3 times as expected, there's a more succinct way to express I equals I plus 1. And this is because it's such a popular thing to do in code. You can instead just say I plus equals 1. And that's it. You don't need to put everything on the right-hand side. This is a special syntax that says the exact same thing, increment I, but it does it with a fewer keystrokes. It's just a little more pleasant to type. It's a little faster to read. It's just a convention. Those of you who have programmed in C, C++, Python, not Python, C, C++, Java, JavaScript might have seen plus plus before or minus minus. Sorry, Python doesn't have it. So you cannot use that. This is as succinct as your line of code might get. All right, let me pause here to see then if there's any questions about these implementations of while loops.
Can we use stuff like for loops, which have a certain I value initialized to it at the start, and it runs from the particular condition you put into the thing and increment it as you go along?
Short answer, no. You cannot do what you're describing, but there is another type of for loop that we will soon see. But let's come to that in just a moment. Other questions on loops using while here.
So I had a question about the flowcharts.
Okay.
There were certain symbols for the certain kind of the statements. Sir, are they certainly used for that kind of statement that they are put there?
They are. So I
Or you can use anyone.
I deliberately use certain types of symbols, certain shapes here, whereby an oval is conventional for start and stop. I used rectangles for any statement of code, like an assignment or a printing and so forth. And I used diamonds to represent questions that you might ask, conditions, as we've seen. If you're doing this for yourself, if you're just trying to make sense of your code and writing it down, you certainly don't need to use these formal symbols. But I tried to be consistent with some best practices. And in fact, let me come back to this same picture, because this was the first version of our picture, but we've since modified our code a couple of times. This, recall, was the version where the question we were asking was I not equal to 0. Let me go ahead and just change this code now to represent the next version we did, which, recall, changed our logic to start counting from 1. It changed our question to check is I less than or equal to 3. But then everything else was the same except for the counting, which is now plus instead of minus. And then we refined it a little bit further by counting now from 0 up to, but not through 3. And we tightened up this code here by just incrementing 1 by using the slightly more succinct syntax. So at this point, these flowcharts might become less and less useful for us, because once you've wrapped your mind around the concept, and hopefully the picture helps bring that concept to life, it's certainly fine to focus entirely on the code and only think about or even draw something like this if you need to wrap your mind around something more complicated than you're used to. Well, let me go ahead, if I may, and propose that we transition to another approach of types of loops using another keyword here, namely a for loop. And this is a word that does exist in other languages, but doesn't necessarily have as many features as other languages might use it for. But there is a different type of loop, not a while loop, but a for loop. And a for loop is going to allow us to express ourselves a little differently. But to do so, I'd propose that the easiest way is if we introduce one other idea in Python, which is that of a list. And here, too, no pun intended, we're adding to the list of data types that Python supports. We've seen strs or strings, ints or integers, floats or floating point values, bools or Boolean expressions. Python also has lists, which is another type of data. But wonderfully, this one's probably pretty familiar. A list of things in the real world is a list of things in Python. It's a way of containing multiple values all in the same place, all in the same variable. So what do I mean by this? Well, let me propose that we go back to our VS Code here, and let me kind of start fresh with my code here and not use a while loop at all, but let me use this new keyword for. The way the for loop works is that it allows you to iterate over a list of items. So what does this look like? It might look like this. For I in the following list of items, 0, 1, 2. This is my starting point, and on each iteration of this loop, that is, on each execution of this loop, again and again, I want to print out meow. Now, I'll admit, I kind of like the look of this code already, even though there's some new syntax here, because it's just shorter than the while loop, right? The while loop had multiple lines a moment ago, and it was entirely up to me to decide what I is. I have to check a condition. I have to increment or decrement I. Like, I was doing a lot of work, relatively speaking, to make that thing turn, to make that loop go and go. It was very mechanical in a sense. You can kind of, in your mind's eye, maybe see the gears turning as all of these variables are changing and these questions are being asked. A for loop kind of simplifies all of that. And it just says if you want a variable, like I, a number, and you know in advance how many times you want this loop to execute, 3 times, we'll just kind of specify what it is you want I to take on as values explicitly. In this loop, I will be automatically initialized by Python to be 0. Then meow will be printed. Then Python will automatically update I to equal 1. Then meow will be printed. Then Python will automatically update I to be 2, and meow will be printed. And because that's it for the values in that list, Python will stop, and it will only meow a total of 3 times. What is the list? The list in this program is exactly that, 0, 1, 2, and notice the square brackets. Those aren't parentheses. Those are square brackets that represent a list. That's how you know visually as the programmer. That's how Python knows as the language that you intend for that to be a list. So let me go ahead and run this, Python of cat.py, and it works just the same. But it's only 2 lines. It's pretty readable once you have familiarity with that construct. But to my constant point about correctness not necessarily being the same as design, in what sense is this program perhaps poorly designed? It seems to work. It meows 3 times. But why might this not be the best way to solve this problem? Even if you've never programmed before, again, think about corner cases, things that may or may not happen. Think about extreme cases that really test the quality of this code.
Okay, I think that because like we are saying 0, 1, 2 3 times, and then like if you want to print a million, you say 1, 2, 3.
Yeah, exactly. And that's what I mean about thinking about the extreme cases. If you're trying to decide for yourself if your own code is good or someone else's code is good, it might look so at first glance, but think about the extreme. Well, what if it's not 3 things? It's a million things. I mean, are you really going to write out 0 through a million or 0 through 999,999? Like, no, you're not going to write that many numbers on the screen. There's got to be a better way. So let's do the better way from the get-go rather than set the stage for doing something poorly. And the one way we can solve this problem to improve the design is don't just manually specify the list of values. Use a function. Someone else's function that comes with Python that gives you the list you want. And the easiest way to do that in Python is to use a function called range that returns to you a range of values. It expects as input at least 1 argument, and that number is going to be the number of values you want back. Those values are going to start at 0 and go to 1 to 2 and so forth, but they will go up to but not through the number you specify. So by specifying range 3, you're essentially being handed back 1, 2, 3 values. And by default, those values are 0, 1, and 2, and that's it. But what's brilliant about this is that now, to Hope's point, if I do want to meow a million times, I mean, that is an angry cat, I can now do a million by just typing a million. I don't have to literally type 0, 1, 2, 3, 4, all the way up to 999,999. I just do this. So that's got to be a better way long term. So that's indeed one improvement we can indeed make here, still using a for loop, but now using this range function. And just to show you something else that's Pythonic, this is not strictly necessary, but it's commonly done. There's a minor improvement we can make here, even if we're just meowing 3 times. And notice that even though I'm defining a variable I, I'm not ever using it. And it's kind of necessary logically, because Python presumably has to use something for counting, right? It has to know what it's iterating over. But there's this convention in Python where if you need a variable just because the programming feature requires it to do some kind of counting or automatic updating, but you, the human, don't care about its value, a Pythonic improvement here would be to name that variable a single underscore, just because. It's not required. It doesn't change the correctness of the program, but it signals to yourself later, it signals to colleagues or teachers that are looking at your code too, that yes, it's a variable, but you don't care about its name because you're not using it later. It's just necessary in order to use this feature, this loop in this case here. So just a minor improvement or change there. But to really get you intrigued by what's possible in Python, let's take this one step further. So if we really want to be Pythonic, this one, if you've programmed before, is kind of going to blow your mind, so to speak, whereby if I want the cat to meow 3 times, what if I actually do this? Print, open parenthesis, quote unquote, meow times 3. All right, you have to be kind of a geek to think this is cool, but this is kind of cool. So you can literally just print what you want, multiply it by the number of times that you want it, and you will get back exactly that result. Now, I've kind of made a mistake here, so let's see what this does. It's not quite as beautiful as this code might look to you, to some of you, to me. Let me run Python of cat.py, enter. OK, it's a really like hungry cat or something. It's meowing really fast. But I can fix this, I bet. Let's think about now some of the basic building blocks we've discussed. The problem is clearly that literally meow, meow, meow is being repeated 3 times, but it's not as pretty as I want it. I want it to be meow, meow, meow on separate lines. What might be a possible solution here while still using this multiplication operator? And think back, we've used plus to concatenate strings. You can apparently use multiplication to concatenate strings, but more than once, again and again and again. How could I clean this up without reverting to my for loop or my while loop and still use multiplication in this way?
We can use the escape sequence, which should be \n.
Amazing. Yes, think back to \n, which is the way you as the programmer can express a new line in code. And I think if I take your advice, I put a \n there inside of my quotes so that at the end of every MEOW, there's a new line. Let's see how this looks. Let me clear my screen and run python of cat.py. OK, so close. I like this. Let me call on someone else. The only thing I don't like, and I know I'm being really nitpicky now, is that it's meow, meow, meow on separate lines, but there's kind of this extra blank line, which I'm just not loving aesthetically.
I think we can make end equal to colon, not \n.
Yeah, so here too, like all of these things we've seen in past weeks are kind of coming together, right? Recall that the print function lets you control what the line ending is. By default, it's \n itself, which is why at the very end of this print, the cursor is being moved again to the next line. Well, we need to just override that. So let me go into my code here. And let me change this to comma end equals quote unquote so that it's no longer the default \n. It's instead now going to be nothing whatsoever. That should eliminate then hopefully that additional blank line. So let me run this one last time here, python of cat.py, enter, and there we have it. So now, you know, at least as programming goes, it's kind of cool that I can distill this into a short line and express myself all at once. Now, to be fair, it's a little less readable. Like now I've got \n, I've got ×3, I've got end equals quote unquote. So you don't have to do things this way. My previous approach with a for loop, totally fine. My previous approach with a while loop, totally fine, and in some sense, perfectly well designed. But this is just yet another way to do it, but it's not a good thing if you or your teacher, your colleague, your friend are going to struggle to read your own code. But this is a feature of Python that some languages do not, in fact, have. All right, well, let me propose that things get more interesting still if we're not just meowing 3 times only, but we're meowing some variable number of times. Let's ask the user how many times this cat should meow. So let me clear the screen here, and let me figure out, well, how do I get a number from the user? The catch here is that if I want the user to give me a number, I'm not doing math per se, I'm meowing. And therefore, the user has to give me a positive value. The user has to give me a positive value. So how can I insist on this? Well, if I just do this, n equals int of input, what's n, question mark. Well, I want to check, like I could say if n is less than 0, like if it's negative, well, I could do this. Well, then ask again, int input what's n question mark. OK, well, what if the user still doesn't give me a positive number? What if they're being really difficult, they're not paying attention, and they typed in 2 negative numbers? Well, if n is less than 0, well, let's do it again. N equals, right, this does not end well. You can't infinitely many times keep checking, is it negative, is it negative, is it negative, right? The program would never be done written. So we can do this, I think, better maybe with a loop. So let me propose this, a very common paradigm in Python when you want to get user input that matches a certain expectation you have, that it's all positive, that it's all negative, or just something like that. You just immediately say while true. You deliberately, and a little dangerously, but very conventionally, induce an infinite loop. Now, what is an infinite loop? It's just one that goes forever. And we've seen how that can happen accidentally, mathematically. It's absolutely going to happen when you say while true. Why? Well, the answer to the true question is always true. So this is a way of deliberately inducing a loop that by default is going to go forever. So we're going to need a way of breaking out of this loop when we have the number we want. The convention, though, inside of this otherwise an infinite loop is to ask the question you care about, like give me an int by prompting the user for input, like what's n question mark, and then just ask your question. So if n is less than 0, then I think we want Python to just continue to prompt the user again. That is, we want the code to stay in the loop, recall the input function, and hope that the user gives us a better answer if this time around it's less than 0. So let's just literally use Python's keyword continue, which says just that. Continue to stay within this loop. Else, if it's not less than 0, let's go ahead and just break out of the loop altogether using another keyword in Python, break. Break will break you out of the most recently begun loop. In this case, if it's not the case that n is less than 0. So this will work, and it will allow us to get a value that's 0 or greater from the user. But I think we can tighten it up further so as to not bother having an if and an else. Why don't we instead just say, if n is greater than 0, go ahead and break. In fact, it's not that interesting a program if we even allow the user to type in 0. So let's wait until they give us an integer that is greater than 0 and then break out of this loop. And what can I now do down here? For I in range of whatever that value n is, print meow. And honestly, I don't need I here. So let me come back to that principle before. And let me just change it to an underscore just to be Pythonic, if you will. So what's going on? Lines 1 through 4 deliberately implement an infinite loop that otherwise by default is going to go forever. But I'm asking a question inside of that loop. After getting an int from the user on line 2, I'm then checking, is it greater than 0? Or is it 0? Is it negative? None of which makes sense for a meowing cat. Like I want the cat to meow at least one time. So if it is greater than 0, break. And this break statement, even though it's indented twice, has the effect of breaking out of the most recently begun while loop. So once the user gives you a positive value, then we get to line 6, at which point we meow that many times because of line 6 and 7. So if I run this now, Python of cat.py, enter, well, what's n? Let's start with 3, where we began, meow, meow, meow. Well, this time, let me go ahead and increase the size of my terminal window just temporarily. Let me run Python of cat.py. Let me do it 10 times. Meow 10 times now appears on the screen. And the takeaways here are not just that we can meow 10 times or do something again and again, but this is a very common paradigm in Python when you want to do something again and again and again, but only until the user actually gives you a value that you care about here. And let me propose, actually, now that we practice a little more what we've been preaching, especially when it comes to, say, writing your own functions. You know, now that I'm doing all this meowing, it might be nice to actually have a meow function that the inventors of Python didn't envision. So let me do this. Let me actually get rid of all this code, and let me go ahead and do this. Let me go ahead and say define a main function, as I've done before, and let me just blindly call meow3. Meow doesn't exist yet, but when it does, that'll be great. So let me go ahead now and define meow. So my meow function should take as input a parameter called n or anything I want. And this part's pretty easy now. How do you meow n times? Well, for underscore in the range of n, go ahead and just print meow. So same code as before, nothing new here. I'm just putting that logic inside of a meow function that's going to have this side effect of printing meow. And now, as before, let me go down here and let me make sure I call main. And if I now run this code, Python of cat.py, meow, meow, meow. It's always going to do 3 because I've hard-coded the 3. Well, let's make one improvement here. Let me go ahead now and maybe do this. Let me ask the user for a number. So let's say something like this. Number equals get number. All right, unfortunately, there is no function in Python called getNumber that gets a positive number from the user. But I can invent that. So define getNumber, open paren, close paren. And then inside of this function, let me do this. While true, go ahead and get a number from the user, converting it to an int, asking them what's n, question mark. And then if n is what I want, it's a greater than 0 value, a positive number. I don't want to break this time necessarily. Although I could, I instead want to return the value so I can actually do this instead. And this, too, is a feature of Python, this ability not to just break out of a block of code, but also to return a value in code. To actually return a value gives you the ability, ultimately, to return explicitly a value so that your function has not just a side effect necessarily, but it actually hands back, just like input does, just like int does, just like float does, an actual value to the user. Now, to be clear, I don't have to return n here. I can still break out of the loop as I've done in the past with code like this. But then after the loop, I still have to return n. And so what's happening here is that if you use break to get out of the loop, but you need to hand back a value from a function, you still have to use the return keyword now explicitly, either in the loop as I did, or now outside of the loop, but still inside of the function. The last thing I'm going to do here now is change that 3, which we hard-coded earlier, to actually be the value of the variable we've gotten from the user, so that now down here, if I run python of cat.py, enter, what's n? I can type in 3. I get my 3 meows. Or if I only want 1, I now get 1 meow instead. All right, so if we now have this ability to do things again and again in these loops, let's see if we can't solve some other problems via which to express ourselves cyclically, but get back some interesting answers as well. Let me propose, for instance, that we look a little more closely at these lists. It turns out that in Python, and really in programs in general, it's useful to have a list of values because we're going to be able to work with more and more data, larger and larger data sets. So let me propose that we come back to VS Code here, and let's do something that's perhaps a little familiar to some folks, the world of Hogwarts. And let me go ahead and code up a file called Hogwarts. And let's see if we can't have a list of students at Hogwarts here. So I have a new tab called hogwarts.py. And let me go ahead and propose that I just define in this program a list of students whose names I know in advance. So I'm not going to get user input for now. I'm just going to know from the get-go that the 3 students I want to consider are these. A variable is going to be called students. It's going to equal, as I've done in the past, a square bracket, which means, hey, here comes a list. And those values are going to be Hermione, in quotes, because it's a string. Harry, in quotes, because it's a string. And then Ron, in quotes, because it's a string as well. So this is a list of length 3. It's similar in spirit to my list of length 3 earlier, but that had 3 ints, 0, 1, 2. Now I have a list of 3 strings instead. And this isn't very useful at the moment, but let me just do something as a check for myself. Let me print out each of these students. Well, wait a minute. How do I print the contents of a list? Well, in the past, when we've printed a variable, we've just printed out the name of the variable. But I don't want to print out all of Hermione and Harry and Ron all at once. Maybe I want to print out Hermione first, then Harry, then Ron. So I need a way to express more precisely which value do I want from this list. And the way you do this in Python is you use square brackets in another way. If you have a variable, in this case called students, and you want to go inside of that variable and get a specific value, that is to say you want to index into the list, you use square brackets this way using numbers inside of the square brackets. And here's where we see that it is useful to think and count in terms of 0 on up instead of 1 on up. These lists in Python are, shall we say, 0 indexed. The first item in a list is at location 0. The second item in a Python list is at location 1, and the third is at location 2. So you're always kind of off by 1 mentally, but you get used to it if you've never programmed before over time. So let me print out all 3 students. So let me print out students bracket 0, then students bracket 1. Then lastly, let me print students bracket 2. And this is my third and final line. And of course, if I run this code, it probably does what you would guess. If I run python of hogwarts.py, there's Hermione, Harry, and Rob, each on their own lines there. But there's got to be a better way, right? Especially if I don't know in advance who's going to be in this list. If next year there's some new students at Hogwarts, we can use a loop to do something automatically without having to manually type out 0 and then 1 and 2. Well, here's another feature of Python. You can use a for loop, not just to count from 0 to 1 to 2. You can use Python to just iterate over anything, not just numbers, but strings. So I could actually do this. For student in students, colon, and then indented underneath that, I can say print student. Now, it doesn't matter if I have 3 students or 4 or 400. This 2 lines of code, this loop, will print all of those students for me one at a time. So if I now run python of hogwarts.py, there's the same list, but I don't need to know in advance how long that actual list is. Now, notice I made a conscious decision here. I didn't call this variable underscore, because this time I'm using the variable. And while I could do this, now, no. Your code is getting way too cryptic if you're naming the variable underscore and you're using the variable underscore. Now you're helping no one. Now you're confusing the reader yourself down the line. You should call your variables what they are. So a very appropriate name, though I'm sure you could come up with others, would be student. And here you would say student as well. If you'd prefer to be more succinct, it's not unreasonable to do something succinct in a loop like this. For s in students, using maybe the same letter that the list itself begins with. But again, why bother? Python is meant to be more readable. If you have a list of students, iterate over them one student at a time. Well, let me pause here to see if there's now questions about lists, as I've now defined them, a list of strings in this case, or using a for loop now to iterate over and print each of those names.
Yeah, so is it not necessary to initiate student in this case, or we can just declare a variable in the loop?
Good question. You do not need to manually initialize it. Python takes care of initializing the student variable to Hermione first, then Harry second, then Ron third. Unlike other languages, you don't need to initialize it to something yourself. It just exists and it will work. Other questions on loops and lists in this way?
Since you described break, so is there any concept of continue so that we can skip a particular case in loops?
Yes, you can continue using another syntax as well. We haven't shown that. For now, we focused only on break.
Okay, sure. Can this for loop work with either hash tables or different kind of iterables or arrays?
Indeed. So we're getting ahead of ourselves there, but there are yet other types of data in Python. And indeed, you can use a for loop to iterate over those as well. Anything that is iterable, so to speak, is a piece of data that can be used with a loop like this. But more on those soon. In fact, let me transition here to show just another way of solving this same problem, because up until now, when we've used loops, we really have relied on numbers, and that's fine if you prefer to sort of stay in that space. Suppose I did want to iterate using numbers like I and 0, 1, 2, and so forth. Let me propose that we could change this code as follows. If you would prefer to think about, or if the program you're trying to implement requires that you use numbers like this, you might do this. For I in, well, I don't want to just say students, because then I is not going to be a number. I is going to be literally Hermione, then Harry, then Rob. I need to iterate from 0 to 1 to 2, right? If I know a list with 3 elements, has these locations, 0, 1, 2, I need to create a loop somehow that starts at 0 and ends at 2. Previously, when I wanted to do that, I needed range, but this 2 is not going to work. I can't just say in the range of students, because students is not a number. It's not an integer, so you can't pass it to range. Range expects an integer. But there is a solution here. It turns out that there is a function in Python called length, or len, L-E-N, that will tell you the length of a list and other things down the line too. And now I think I can assemble these building blocks in a way that can allow me to use numbers in this way. So range doesn't take a list of strings. It takes a number. And ideally, that number is going to be 3. So I get a range of values, 0, 1, and 2. So I think I can nest my functions like this. If I first get the length of the student's list, that's going to be 3. Then I pass that return value as the argument to range. That's going to give me back a range of values, 0, then 1, then 2. And what that's going to allow me to do then in code, if I want, is not just this. I could do print now students bracket I. And this is now where the syntax we're seeing is getting very expressive, new, and perhaps unfamiliar. But if I can do open bracket 0, close bracket, or open bracket 1, close bracket, or open bracket 2, close bracket, turns out I can actually put a variable in there. And I can express any number inside of those brackets so as to print these all out dynamically in a loop. Let me do this. Python of Hogwarts.py, enter. There's Hermione, Harry, and Ron. And now if I'm just curious, if I just want to poke around, or maybe I want to do a ranking, like who are the top 3 students in the school or in Gryffindor, well, I can print multiple things at a time, we've seen. Let me print out not just the students at location I, but rather let's print I first and then the student at location I. So 2 things to print, and we know that print can take 2 arguments. We've seen that before. They'll be separated by a space. Let me go ahead and rerun this. Now I see that, OK, Hermione is the top student, but she's in 0th place. That's a little weird. Like, we don't need to show the human using my program that we started counting at 0. I can clean this up. I can just add 1 to the I up here. And now we see sort of a top 3 list of students. Hermione's number 1, Harry's number 2, and of course, Ron is number 3. So we can get access to all of those same values as well. All right, any questions now on these lists? Any questions now on these lists? This length, these ranges, or otherwise?
My question is, for I in range, can you explain this once more?
Sure.
Still looks cryptic.
So let me rewind in time. We started off doing this. For I in 0, 1, 2, and then we printed out meow 3 times in that way. The way that the for loop works is that it creates for you a variable that I've called I, but I could call it anything I want. It then assigns I initially to the first thing in the list. It then automatically assigns I to the next thing in the list. And then it assigns I to the third thing in the list. And each time, it does all of the indented code underneath. We realize, though, that this is not going to scale well if I want to do something like 1,000,000 times. So we introduced range instead. That has the effect of doing the same thing. It returns to me a range of values, a list of 3 things, really. So the behavior is exactly the same. If we now fast forward to this Hogwarts example now, though, what I'm doing is just combining these smaller ideas. I'm still creating a for loop. I'm still creating a variable called I. I want to do it over a range of values, but how many values? Well, if I use the length function and pass to the length function the list of values, length's purpose in life is to tell me how long is this list, and it's 3. So that's almost as though before I had just done something like this, but I don't want to hard code 3. I want to dynamically figure out how many students are at Hogwarts. So I'm just composing, or nesting all of these various ideas. All right, if I may, let me transition now to in Hogwarts still to introduce one final type of data before we combine everything with a few final programs. It turns out in Python, there's not just strings, not just ints, not just floating point values, not just bools, not just lists. There are also what are called dictionaries, or dicts, which are a data structure that allows you to associate one value with another. Literally a dictionary, like in the human world. If you were to open a dictionary, be it in English or any other human language, what's inside of a dictionary? Well, it's a bunch of words and definitions. A computer scientist, though, and a programmer would describe those more generically as keys and values. Something associated with something else. That's all a dictionary is. It allows you to associate something with something else. And notice, this is already more powerful, more interesting than a list. A list is just a set of multiple values. But a dictionary is sort of 2-dimensional, if you will. Just like a human dictionary, a book, it associates something with something else, like words with their definitions. Now, what does this actually mean in practice? Well, suppose that we wanted to keep track of who is in what house at Hogwarts. Well, I could do it using lists alone. Let me go back to VS Code here, and let me just temporarily, but in a way that I'm not going to like ultimately, let me create another variable called houses, set it equal to Gryffindor, corresponding to Hermione's house, Gryffindor corresponding to Harry's house, and Gryffindor corresponding to Ron's house. And let's add Draco in there. So we now have 4 instead of 3 students, just so we have a little variety. And he was in Slytherin. So now we have 2 lists. And we could just agree amongst ourselves that whoever is first in the students variable lives in the first value in houses. Whoever is second in students lives in the second house. Who's ever third in students lives in the third house. We could do that. But honestly, that is going to break down quickly when we have a lot of students, when we have a lot of houses. And what if we want to keep track of more things than that? What if we want to keep track of every student's house and the Patronus, this image that they conjure up magically? Well, then we need a third list. Like, this is just going to get messy quickly if we're just on the honor system using multiple lists where everything lines up logically. It doesn't end up well when your code gets more complicated. But I do want to implement this idea. I want to associate something with something. a student with a house, a student with a house, a student with a house, and so forth. So how can I go about doing this? Well, let me go back to my code here. And let me propose that we do this using a Python dictionary. And this is the last of the new syntax, really, that we'll see. Here's the new syntax. Instead of using square brackets, we're going to use curly braces for dictionaries as well. We've seen curly braces in the context of F strings, completely unrelated. Sometimes you run out of keys on the keyboard and the authors of a language need to start reusing symbols in different ways. That's what's about to happen. We're using curly braces in a different way now. So let me create a variable called students, and let me go ahead and set it equal to open curly brace and close curly brace. This is an empty dictionary at the moment. And here's how a dictionary works. It allows you to associate something with something else. And you do that like this. Hermione, quote unquote, colon, and then the value thereof. What do you want to associate with Hermione? Well, Gryffindor. What do I want to associate Harry with? Well, I want to associate him with Gryffindor. What do I want to associate Ron with? Well, I want to associate him with Gryffindor. Well, this is actually not going to, this is going to get very ugly quickly. Once we add in Draco and Slytherin, my code is going to get too long. It's going to start wrapping. So this is purely aesthetic. It is perfectly acceptable in Python and other languages to format your code a little more readily and just add new lines if it makes it more readable. And one way of doing this might be as follows. I still have my curly brace up here. I still have my curly brace down here. But notice it's a little more readable now in that I have my keys on the left, my somethings, and my values on the right, my other somethings. It's just a little easier to skim top to bottom. You could format it differently as well. But I'm going to go ahead and add in now Draco, who lives, of course, in Slytherin. So now I have each of these keys on the left and values on the right, which is really, again, just a code implementation of this idea, a little chart that you might write up with paper pencil when associating something with something else. So how do I now use this code in an interesting way? The syntax is almost the same. If I want to print out the very first student, Hermione's house, I could do this. Print out the name of the variable, but I need to go inside of the variable. I need to index into it. And what's neat about dictionaries is that whereas lists have locations that are numeric, 0, 1, 2, Hermione, Harry, Ron, respectively, dictionaries allow you to use actual words as your indices, so to speak, your indexes, to get inside of them. So if you want to print out Hermione's house, the key you care about is, quote unquote, Hermione. And what this syntax here will do, notice it's not a number 0 or 1 or 2. It's literally Hermione's name. This is like going to the chart earlier and saying, all right, give me Hermione is my key, Gryffindor is the value. That's what we're doing here syntactically. We're looking up Hermione and getting the value thereof. So if I go back to my code, that should print out Gryffindor. And if I do this a few times, students bracket, quote unquote, Harry should give me Harry's house. Print students, open bracket, Ron. That should give me Ron's house. And then lastly, if I do this with students, bracket, Draco, that should give me Draco's house. Now, it's a little manual still. I bet we can improve this, but let me run Python on Hogwarts.py, and we should see Gryffindor, 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 Slytherin, which is exactly what we'd expect. Now, all we've done, again, is we've just now moved from having just a simple list of names to, again, sort of 2 dimensions, associating, like we would on paper pencil, something with something else, keys with values respectively. Allow me, if you will, even though I realize this is getting a little fancy, allow me to escalate things slightly here and transition from looking at just, for instance, that pattern there, just hard coding those values there, to actually printing these out more dynamically. Let me go ahead and use our loop. And this question came up earlier as well. Let me go ahead and say for each student in students, go ahead and print out, for instance, the student's variable at, well, let's just say student first. Let's keep it simple. So this is not going to be that interesting yet, but when I run Python of Hogwarts.py and hit enter, notice, what should I see? Let me take a question here to see, what am I going to see when I hit enter now, when I'm doing for student in students?
Yeah, I think we will only see keys.
Perfect. So good intuition. It could have gone both ways. Could have been values, the houses. But when you use a for loop in Python to iterate over a dictionary, by design, it iterates over all of the keys. So we should see, I think, Hermione, Harry, Ron, and Draco. Let me hit enter now. Enter. And indeed, you're exactly right. We see just the keys. But that's not really that useful if what I really care about is who lives where. Can I print out both? Well, I think I can. Let me go ahead and do this. Let me print out not just the student's name, the key, but let me use the key, their name, to index into the dictionary, right? If I know the word in the dictionary, let me look up its definition. If I know the student's name, let me look up their house. And the syntax for this, just like a list, is students, bracket, and just like in the past we used I, when I was a number, we can also, with a dictionary, use a string. So if the student's name is the key, then this syntax, students, open bracket, student, close bracket, will go to Hermione's location and get back her house. We'll go to Harry's location and get back his house, and so forth. So if I do Python of Hogwarts.py, enter, now I see Hermione Gryffindor, Harry Gryffindor, Ron Gryffindor, Draco Slytherin. Now it looks like I've given them all new last names, but I can clean that up. This is just a print thing. Let's go ahead and change our separator from the default space to maybe a space, comma. And just using print features now, let me run the same program again, enter. Now I've just got some nice pretty commas in there to make clear that Hermione's last name is not, in fact, Gryffindor. But that's just a print detail. Any questions then on these dictionaries and what I've just done? Questions on these dictionaries and this looping over them here?
I just can't get my head around the for student in students. Does if I'm just correct me if I'm right, does that mean it imports the list of students and uses the indexes, or in other words, Hermione, Harry, and Ron, as the indexes in the actual the list of students?
Correct. So this is just a feature of Python. When you use a for loop with a dictionary, what happens is this. If this is the dictionary here with the keys on top and the values on bottom, you get to choose what the variable is called. I called my variable student just because it makes sense, because I want one student at a time. And what the for loop does, just like it did with numbers before, the 0, the 1, and the 2, it allows me to, for instance, set student equal initially to Hermione's name. And then the next iteration of the loop, the next cycle, sets student equal to Harry's name, then Ron, then Draco. It just kind of happens automatically. Like that is what the Python interpreter does for you when it sees a for loop like that. So it's very similar in spirit to iterating with a for loop over a list, but rather than iterate over the numeric location 0, 1, 2, it iterates over the bold-faced keys in this representation here graphically. And allow me to give us one other example on Hogwarts before we look at one other familiar domain. At the risk of things escalating a little bit, let me propose that we continue the story with one final Hogwarts example like this. What if we have more information about each of our students? And this is kind of inevitable, right? If you're implementing a program that's a database with people or customers or employees or anything else, you can imagine having a lot of data about anything you're representing in your program here. For the sake of discussion, suppose that every student at Hogwarts, of course, has a name. They have already a house, but they also have a Patronus. For those unfamiliar, this is the animal or entity that comes out of the end of their wand when they make a certain magical spell. The point here being is that we want to associate not just one thing with the student, but multiple things as well. Their name, their house, and their Patronus in this case. Well, what might code like this look like? Well, let me go back to Hogwarts.py, and let me start fresh for just a moment, and let me propose that I enhance this with a bit more data. And this data is going to look as follows. My students variable now, I'm going to propose we think of it as a list. What if we have a list of dictionaries as follows? Indeed, I want to literally implement this picture here. So notice that my previous picture just represented a single dictionary. But suppose I wanted to compose a list of dictionaries. That is, 4 students, so a list of 4 students. And suppose that each of those students is itself a dictionary, a collection of key value pairs, keys and values, something and something else. Well, here's one other way we can do this in code. Let me go back to VS Code here, and let me define a variable called students that is equal to a list. And I'm going to preemptively move my cursor onto separate lines because I know this is going to be long, and I want to fit all of the elements of this list inside of it. I'm now going to create a dictionary, one dictionary per student. And how do I create a dictionary? I just use those curly braces. But it's up to me to define what those keys are. And let me propose that one key this time won't be the student's name explicitly. It will literally be the word name. And they're going to have the name Hermione. This same student is going to have another key called house, and the value is going to be Gryffindor. And this same student's going to have a third key called Patronus, and the value of that is going to be, I had to look it up, an otter, according to the book. Now I'm going to create a second dictionary inside of this list. And again, a dictionary is literally like the human dictionary of words. It's a book that contains keys and values, words and definitions. What are the 3 words I'm storing in each of my dictionaries? Name, house, and Patronus. What are the definitions of those words for Hermione? Hermione, Gryffindor, and otter, respectively. For Harry, the definitions are going to be different in this new dictionary. Let me give myself another pair of curly braces and say this. Name, quote unquote, colon, Harry. House here is again going to be Gryffindor. And this one I knew, his Patronus is going to be, in this case, a stag. All right, next, a third dictionary. The name here will be Ron. And I'm going to go ahead and do that just like this. Next, I have the house, and he too was Gryffindor. Lastly, had to look this one up, Ron's Patronus was a Jack Russell Terrier. Lastly is Draco in a fourth dictionary now, so another pair of curly braces. The name of this student is, of course, Draco. The house of this student is Slytherin. And Draco, interestingly enough, at least according to the internet, has no Patronus, was never revealed in the books or the movies. So it turns out, this is actually a wonderful teachable moment, there is a special keyword in Python that is literally none, N-O-N-E, with the first letter capitalized. This represents officially the absence of a value. So I could a little sloppily do something like quote unquote, but does that mean I didn't get around to typing it or not? It's a little clearer semantically to say literally none, a special keyword in Python to make clear that I know Draco has no Patronus. It's not just an oversight on my part. Now that I have this, what do I have in the computer's memory? I have a list. How do I know it's a list? Because I see a square bracket at the beginning and another square bracket at the end. That's just my visual clue. OK, I don't know necessarily what else is going on here, but there's a list of something. What is in that list? Well, here too, the syntax is our clue. Because this line 2 starts with a curly brace and ends with a curly brace, I just know that is a dictionary, a collection of key value pairs. Now, this all fit on my screen perfectly, so I didn't bother moving all of the key value pairs onto new lines. It would have made it really tall, so I kept it all together here this time. But how many keys does this first dictionary have? Put another way, in Hermione's physical dictionary, how many words are in that dictionary? 3. The words are name, house, and Patronus. What are the 3 definitions or values of those words in Hermione's dictionary? Hermione, Gryffindor, and otter, respectively. And the same story goes for Harry, then for Ron, then for Draco. I have, by design, chosen to give them dictionaries that have all the same keys, all the same names, but they all have unique values. And that's my design. That's my prerogative as a programmer. So why is this useful at the end of the day? Now I have access to a whole collection of interesting data about all of these students. And I can still do a loop. I can say for student and students, that's going to allow me to iterate over this list of students. And let me go ahead and print out just one thing at a time. Let me print out the current student's name. So as complicated as the dictionary is, this should be pretty comfortable. For student and students is just going to iterate over every student in the list. 1, 2, 3, 4 total. The next line is just going to print out the value of the name key. It's like opening a physical dictionary, looking up the word name, and giving us Hermione, Harry, Ron, and Draco, respectively, from each dictionary. So if I run this version of Hogwarts and hit enter, there, I get all 3 of their names. But what if I want more information than that? I want both their names and their houses. Well, just add to print's arguments, student, open bracket, house, close bracket. All right, let's go ahead and run this. Python of Hogwarts.py and hit enter. So I now see Hermione Gryffindor, Harry Gryffindor, and so forth. Well, we can aesthetically clean this up a little bit by adding a separator with print, like a comma and a space, just so that when I run this again, I now see some commas separating these values. But recall that students have not just a name, not just a house, but also that Patronus. So if we want to print out that too, we now have the syntax via which to go into that same dictionary for each student and output their Patronus as well as their house and their name. So if I run this program one final time, now I see all of the data in this here dictionary. So this is a lot to absorb all at once, I'm sure. It's the last of our new data types. On top of lists, we have these dictionaries. But again, a dictionary at the end of the day is just a collection of values similar to these values here that allow you to associate keys with values. And the first version of this program associated literally the students' names with their houses. But then I realized in my next version, wait a minute, what if every student has not just a name and a house, but a Patronus? Let's actually standardize the names of our keys to be name, house, and Patronus, and then the values of those keys can actually be the data, like Hermione, Gryffindor, Otter, and so forth. Questions now on these dictionaries and iteration thereof?
I just was wondering if suppose the dictionary is very huge, and if I want to look up for a specific student, so how do I know where to look that student from? Like, can we sort it out in alphabetical order or numeric order or anything like that?
In short answer, yes. One of the features of Python is that it makes these dictionaries very highly performant for you. That is, even if they're very large, as they will be in future weeks when we manipulate more data, Python will find the data you care about quickly for you. And in fact, that is a feature of the language. That is a feature of a dictionary to get you the data quickly. And there are functions that you can use. You can sort the data. You can sift through it. You can do very performant operations, as we eventually will. Allow me then to propose, as we wrap up these loops, that we solve just a few final problems that will perhaps evoke fond memories of yesteryear, at least for me, wherein one of my favorite games growing up was this one here on the original Nintendo. And this is a two-dimensional world where the characters move up, down, and right, not so much to the left, in jumping over pyramids and obstructions like these. And allow me to propose that we use this just for inspiration, not to do something that's quite as colorful or graphical as this, but just to focus on, for instance, this barrier in the middle of the world here that Mario or Luigi had to jump over. And so this here seems to be like 3 bricks stacked on top of one another. And we won't do things quite graphically, but let's just implement a very simple Python-based version of this textually using maybe just hashes for bricks. Because there's a pattern here, one on top of the other. And I bet we can solve this in any number of ways. Well, let me switch back over to VS Code here. And let me propose that we create a program called Mario.py using code in the terminal window. And then up here, let me start by implementing that same picture as simply as I can, printing out just literally the hash, and then the hash, and then a third final hash. This is going to be a very textual approximation of it, but I think if I run Python Mario.py, I've got a very simple version of that same column of bricks, so to speak. But you can imagine that certainly in a game where maybe these the columns get higher or lower, it would be nice to write code that's actually a little more dynamic than that and doesn't just use print, 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 which is literally copy and paste, it would seem. So let me at least adopt some of today's lessons learned and instead do something like this. For underscore in range of 3, let's now print out just one of these at a time. But the fact that I've now used a 3 to range means if I want to change it to something bigger or smaller, I change it in one place, not in 3 or more places. And this code too, of course, if I got it right, is just going to print out the exact same thing. So we're iterating here. But let's see if we can't now integrate our discussion of writing functions of our own to begin writing something a little more dynamic and solving more complicated problems ultimately. One of the nice things about functions is that they allow us to not just write code that we can use and reuse. They allow us to create abstractions, if you will. An abstraction is a simplification of a potentially more complicated idea. And we've seen this a few times over the course of the weeks. For instance, we had a function called hello, which granted didn't do all that much. It just printed hello, but it allowed me to think about the function as exactly what it does. Not generically printing something, but literally saying hello. I've been able to get a number using something similar by defining my own function like getNumber. Well, let me go ahead and, for instance, assume for the moment that I've had the forethought to, in my function main, use a function called printColumn. That seems as good a name as any to use a function that prints a column of bricks. Well, how can I go about now implementing this abstraction, this simple idea, printColumn, with actual code? Well, we've seen before with def, we can do just that. Let me define a function called printColumn. Let me accept as its input, generically speaking, a parameter called height. I could call it n or h, but I'll be a little more explicit now with height, just so I remind myself what it's doing. And now I think I can just borrow some of that same code from before. For underscore in range of height, go ahead and print out a single hash. And then at the end of this whole program, let's just call main. So I've kind of complicated the code. It doesn't do anything more just yet, but it's setting me up for solving what I think are going to be more sophisticated problems. If I run Python of Mario.py, we're back where we began. But I now have a function, an abstraction, printColumn, that's going to allow me to think about printing some chunk of the world of Mario at a time. And I can do this in different ways too. Notice that if I really want, I could do something like this. I could re-implement now printColumn in different ways, especially if I'm using printColumn all over my code, or maybe still a colleague of mine, a friend, someone else on the internet is using my printColumn function. What's also nice about functions you've written is you can change the underlying implementation details of them, but so long as you don't change the name of the function or its parameters or what it returns, if anything, no one else knows the difference. You can change the internal implementation as much as you want if you want to improve it or make fixes over time. So for instance, another way we could implement printColumn, recall, would be something like this. A bit clever with one hash and then a new line. And then maybe we could do multiplication of strings and then end this line with quote unquote. Again, it's OK if you're not comfortable with this syntax. This was a more clever approach we saw in the past. But if I run Python of Mario.py here, I'll still see a column of 3. But what's important here is that main does not need to know that the underlying implementation of printColumn has changed. Well, let's transition to a different dimension, if you will. And rather than print out just these vertical bricks, let's fast forward in the game to this part of the world here. At some part, Mario encounters these bricks in the sky that if he jumps up underneath, they become coins. And so he gains to his score. But let's go ahead and focus only on those coins. And let me propose that we print out, just these 4 question marks here. And let me go back to VS Code here. And let me propose that within VS Code here, just like before, we try to abstract this away. So let me go ahead and get rid of this version, because we're now going horizontal instead of vertical with our output. And let me just say, well, print row 4 times. Let me just abstract away the problem at hand. I don't know yet how I'm going to print those 4 question marks, but let's call it print row 4, and I'll assume I'll now solve this problem. Let's now go down that rabbit hole of solving the problem. Define a function called print row. It's going to take a width instead of a height, because it's horizontal instead of vertical. And how can I do this? Well, now we have an opportunity to do string multiplication even more elegantly. I can say quote unquote question mark times width. And this is a very pretty Pythonic way of printing what could otherwise be a loop, and that's fine. But this is going to go ahead and print those question marks for me. Let's do Python of Mario.py, enter. And now I've got 4 question marks. It's not nearly as pretty as the more graphical version, but it is at least a building block toward having now a reusable function like print row. And why am I doing all this? Like, why are we over-engineering the solution to these problems by having printColumn and print row? Well, it's a useful problem-solving technique as soon as your world does not look one-dimensional like this, or with the column version. But what about this? Later in Super Mario Brothers, does Mario have to jump down into this world where there's a lot of these underworld barriers? And this one here, for instance, looks like a square. It's 2-dimensional. There's a height and a width to it. And that is to say, there's a bunch of different ways we could implement this thing if maybe for discussion it's like a 3x3 grid, a 3x3 square of sorts. Well, how can we go about solving this here problem? Well, let me propose we come back to VS Code, and let me propose that we think about this in a couple of different ways. I could do this like this. If I know where I'm going, you know, maybe I'm a seasoned programmer, let me go ahead and do this. Let me print out a square, the width and the height of which is 3. That's an abstraction. I'm just taking for granted for a moment that there is already a function called print square that's going to be width 3 and height 3 as well. But someone's got to implement this. And at the moment, there's only me at the keyboard. So let's go ahead and implement that square. Let me go ahead and define a function called print square that takes in a specific size, both for height and for width. And here's where we have an opportunity to use some of those loops. And we can use those loops in a way we haven't yet. If I want to print out all of these rows, but also all of these columns, I now have to think not just cyclically, like a loop allows, but I need to think two-dimensionally. And if you're familiar with like an old school typewriter or even a printer nowadays, it generally prints from top to bottom. So even if you have multiple columns, you print out one line at a time. And while you're on that line, the printer or the typewriter prints from left to right. And that's kind of the mental model to have with your black and white terminal window. All of the output for every example thus far starts at the top and goes down to the bottom. From top to bottom, left to right. So we have to generate our output, our square, in that same way. So let me propose that we do this. Let me propose that we know we need to iterate this many times, 3 or more generally size. So let me do this. For I in the range of size, what do I need to do 3 times? Well, I want to print out what? 1, 2, 3 rows of bricks. But within each row of bricks, what do I want to print? 1, 2, 3 bricks specifically. So if we go back to our diagram here, and I stipulate that it's indeed meant to be a 3x3 square, 3 wide and 3 tall, what do I want to do to print the first row? I want to print brick, 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 brick. What do I want to print on the second row? Brick, brick, brick. And the third row, brick, brick, brick. So I'm doing 3 things 3 times. There's a lot of printing that must happen. So let me go back to my code here and let me propose now that we think of this outer loop that I've just started as representing each of our rows. For I in range of size is going to ensure, no matter what I do next, that I can print out 1, 2, 3 rows. Or more generally, size, where size could be 3, but it could be smaller or larger. What do I want to do on each of the rows? Well, just like an old school typewriter or printer, on each row, I want to print out brick, 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 brick. Well, that sounds like a cycle, some kind of loop. So maybe I can have inside of one loop another loop. I don't want to use I again because I don't want to use the same variable and mess up my counting. So I'm going to, by convention, use j. Very common to use I and then j, maybe k. But after that, you shouldn't keep nesting inside of each other. Let me go ahead and say for j in range of size 2, because it's a square, and then each of these rows, let me print out a single hash, but no new line. But after each row, let me print only a new line. So there's a lot going on here, especially if you've never touched Python, let alone loops. But notice what I've done here too, and I'll add some comments for clarity. For each row in square, for each brick in row, print brick. And here is where comments, and more generally pseudocode, can really help explain to yourself and to others what your lines of code are doing. On line 8, I'm iterating from I equals 0 on up to size. So 0, 1, 2. On line 11, I'm doing the exact same thing, but using j from 0, 1, 2. But that's good, because I represents now each of my rows. And while I'm on each of those rows inside of this outer loop, I'm going to do brick, brick, brick. 1, 2, 3, 1, 2, 3, 1, 2, 3. But I don't want my cursor to keep moving to the next line while I'm on a row, so I'm just overriding that line ending. But let me ask a question of the group now. Why on line 16 do I have a print here all by itself? Why do I have a print all by itself? Notice that it's below the inner loop, but inside of the outer loop, so to speak. What is that loop on line 16 doing ultimately?
Every time you finish a line, you have to add a new line at the end of it. So it prints a new line.
Perfect. I don't want a new line after every brick. I only want to do that at the end of the row, and that's why my comments now are perhaps enlightening. Notice that this loop here is just iterating for each brick in the row. Once I'm done with that inner loop, so to speak, once I'm done with these highlighted lines here, to Evelyn's point, I need to print out one blank new line. And we've not done this before, but when you call print with no arguments, all you get is that automatic line ending, the \n, where the cursor moves to the next line. So if I now go back to my terminal window and run mario.py, I think I should get a 3x3 square. And it doesn't quite look like a square on my screen because these hashes are a little taller than they are wide, but it is in fact 3x3. But let me propose, as we've always done here, how we might tighten up this code further. Just for clarity's sake, let me get rid of my comments for a moment, just so we can see how many lines of code we have total. And let me propose that we maybe do this. Let me propose that, you know what, this inner loop, especially if you're having trouble wrapping your mind around one loop inside of another loop, you don't strictly need it. What if we do this trick again? What if we print out inside of the outer and only loop each of those hashes times the number of times we want them? Right? We draw inspiration from an earlier approach, and we run Python now of mario.py, same result, but now print square is really nice and compact. It has one explicit loop, and it's still printing out using string multiplication all of the hashes at once on that row. If you like abstraction and you'd like to wrap your mind more around what the code is doing, well, let's do this. If you're not quite clear on what's going on, let's propose that you implement a function called print row, passing in size. And let me propose that this print row function, it simply take in that width and print out the individual hash times that many times. In other words, here's an opportunity for abstraction, whereby, well, what does it mean to print a row? Well, when you're implementing print square, I don't really care what it means to print a row. I just need to know that someone's taking care of printing the row. You can kind of pass the buck to another function altogether. And how does print row work? Well, it could use a for loop. It could use this string multiplication trick. This is a way to take a larger program, and this is probably the most complicated one we've looked at thus far, and to decompose it into these smaller components that, once assembled, achieve your final idea. Seeing no questions, that's the end of our look at loops in Python, this ability to do things cyclically again and again. And when we combine those with conditionals, this ability to ask and answer questions and combine them with our functions and variables, we really now have most of the building blocks we need to solve much larger, much more interesting, much more personal questions. So in the weeks to come, we'll start to see exactly what could go wrong, though, when we do so. But we'll introduce you to all the more tools via which you can troubleshoot those same problems. All right, this is CS50's Introduction to Programming with Python. My name is David Malin, and this is our week on exceptions. Exceptions in Python, as well as in other programming languages, refer to problems in your code. Indeed, when something is exceptional in your program, it actually doesn't mean it's a good thing. It means something has gone wrong that ideally you will somehow solve. So what are some of the things that can go wrong? So I'm going to go ahead and open up VS Code on my computer here. And in the terminal window, I'm going to go ahead and run code of hello.py. That's going to, of course, open up a brand new tab for me, hello.py, in which I can write my code. And let me go ahead and write some very simple code just to say hello to the world. Let's go ahead and say print, quote, hello, comma, world. And then let me go ahead and I'm forgetting to close that quote. So a mistake that you yourself might have already made or might surely in the future make. And it's a little subtle because you might not necessarily notice that you've just missed that one character. Well, let me go ahead and somewhat optimistically go down to my terminal window now and run python of hello.py and hit enter. And that's the first of my errors. My gosh, I've only written one line of code, and I seem to have more lines of errors on the screen. But the salient point is this bottommost thing here. Notice where it says syntax error. A syntax error is a problem with the code that you have typed, your syntax. Just like English and other human languages have syntax associated with them, so does my code. And it's not quite correct. Something is awry. I didn't follow the instructions properly. And it does elaborate for me. Unterminated string literal. Now that's a bit arcane. That is a bit of a confusing error message, but unterminated would generally mean that I started something but didn't stop it. I didn't terminate it. String, of course, is a sequence of text like we discussed before, or str in Python. And literal generally refers to something that you literally typed. It's not a variable. It's something like quote unquote, or just quote, hello world. So the fix here, of course, is going to be to go ahead and terminate that string and actually close the quote. And if I now go back down into my terminal window and rerun Python of hello.py, now I'm saying hello to the world. So the catch with syntax errors here is that syntax errors are entirely on you to solve. A syntax error is a problem that you've got to go back into your code and fix from the get-go. You can't just kind of hope that it's going to resolve itself or expect that other parts of your code will catch it for you. Syntax errors just must be fixed. But there's a lot of other types of errors in Python that might be described as runtime errors that happen while your code is running. And it's really up to you to write some additional code defensively to detect when those errors happen, because you don't necessarily know, for instance, what input humans are going to type into your program. And so you better be ready defensively to accommodate things that they type or even mistype. So for instance, let's go back over here to VS Code, and let me propose that we take a look at a new file altogether. I'm going to close hello.py, and I'm going to write code of, say, number.py. So let's play around with some numbers in Python. And the first thing I'm going to go ahead here and do with number.py after opening this new tab is I think I'm going to go ahead and type up a relatively simple program that maybe prompts the user for an integer like x and then just prints out what x is. So we're going to start super simple. But again, in starting simple, we'll be able to really see where I've done something wrong. Well, here we go. I'm going to go ahead and say a variable called x is going to get assigned the value of the return value of input, quote unquote, what's x question mark. And I'm going to include a space to move the cursor over a little bit. And then ultimately, I'm going to go ahead and, oh, wait a minute, if I'm wanting to get an int from the user, recall that I need to do something proactively. I need to actually convert that input to an integer using the int function in Python. So now I'm passing the return value of input as the argument to int, and that will store in x ultimately an integer, not a string that looks like an integer. All right, let me go ahead now and just quite simply print out what this is. I'm going to go ahead and print out, quote unquote, x is x. But I don't want to literally say x is x. I want to plug in the value of x. So maybe the easiest way to do that is to surround it with curly braces. And then if I'm using these curly braces and I want Python to interpolate the value of that variable, that is, substitute what x actually is in between those curly braces, recall that I need to use a format string or an f string by prefixing this whole thing with an f. Now that I've done that, let's go ahead and see what happens. I'm going to go ahead in my terminal window and run Python of number.py. I hit enter, and so far so good. All is well. I'm being prompted for x. Let me go ahead and type in a number like 50. All right, that seems to work. Program seems to be correct. Or is it? What could go wrong in this program, even though nothing did just go wrong? But if I run it and run it and run it again, during the running of my program, what could still go wrong, especially if I'm not the human interacting with it, but some other human instead? Any volunteers here for this one? What could go wrong? And in what way is this program not really correct, even though at first glance it seems so?
What is an interpreter? So, when we code in a integrated IDE, we can't code in an interpreter.
So I'm not calling an integer. I'm still having trouble hearing you, but what I think I heard is that if what the user types in is not in fact an integer, I can't just blindly convert it to an int. if I'm not putting too many words into your mouth, I think what I should perhaps do here is be a little defensive, and let me see if I can't simulate exactly the problem that could go wrong here. Let me go ahead and run, again, Python of number.py. Let me try another number. In fact, when testing your code, generally it's a good idea to test corner cases, maybe numbers that aren't quite as plain as 50 or 49 or 51. Let's choose some numbers that might be a little more interesting, if only mathematically, like 0. All right, 0 seems to work. My code still prints out that x is 0. What might be another corner case to consider? Well, let me go ahead and try a negative number. That, too, is pretty different in spirit from 50. -1. OK, that works, too. Well, let me try it one more time. I've tried positive numbers, negative numbers, 0. Let me try something like a cat. So literally, C-A-T, typing in a string that doesn't even look like a number. And yet, let's see now what happens when I hit enter. All right. We'll see now we've got another kind of error. It's not a syntax error because I didn't make a typographical mistake. I didn't forget some piece of syntax. I actually now have an error with one of my values. And it's in a value I didn't even anticipate. The human, me in this case, typed it in long after I wrote the code. So what does this refer to? A value error. Well, let's see what the explanation is. Invalid literal for int with base 10, quote unquote, cat. Now, this too is a bit of a mouthful. And unfortunately, in Python and a lot of programming languages, the error messages are written for pretty comfortable programmers. And of course, when you're learning programming for the first time, you might not be so comfortable with the programming language, let alone the error messages. But let's see if we can't glean some insight. So invalid literal. Well, again, a literal is just something that's been typed in, it would seem. For int, what is int exactly? Well, int is the function I'm using to convert the user's input to a corresponding integer. Base 10, that refers to the decimal system, which is the default that Python's using. And it looks like, at the end of the day, what Python really doesn't like is that I passed cat, quote unquote, to the int function. So how do I go about actually fixing this problem? Well, I could just add instructions in my program. Maybe I could add a line of print telling the user more explicitly, be sure to type an integer. Or please don't type cat. Please don't type strings. Of course, the user might still not oblige. They might not be reading the instructions. So that, too, is probably not an effective strategy. What we really want to do is write our code with error handling in mind. We want to write lines of code that not only accomplish the problems we care about, but that also handle errors that might unexpectedly happen. And in general, when programming defensively, assume that the users aren't going to be paying attention, or worse, they're malicious. They're trying to crash your program, so we want to handle as many errors as we can. Now, how do we go about doing that in Python? Well, it turns out whether you want to catch a value error or other types of errors as well, though not syntax error, Python actually has this keyword called try. And it's sort of aptly named. If you want to try to do something in Python, you can literally use this keyword, and you can check whether or not something exceptional, something erroneous has happened. So using both try and this other keyword except, can I go and try to do something, except if something goes wrong, I can do something else instead. So let's consider, how can I go about trying to convert the user's input to an int, except if something goes wrong? Well, let me go back to my code here. And let me propose that I now modify this example as follows. Let me go ahead and above my first line of code, I literally write try and a colon, telling Python, try to do the following. I'm going to go ahead and indent my existing lines of codes here by the same number of spaces, 4 in this case. And then I'm going to add one more new line down here that literally says except value error. And notice it's important that I've capitalized the V and I've capitalized the E. These symbols are case sensitive. And this is now an opportunity, after this colon, to tell Python what I want to do in exceptional cases, when the number or the input from the user is not, in fact, a number. And I'm going to say something plain like print, quote unquote, x is not an integer. I'm at least going to tell the user roughly what the problem actually is. So notice another detail. The indentation is important. Because I have try on line 1 and I've indented lines 2 and 3, those are the 2 lines of code that I'm trying. Except if I see a value error, line 5, because it's indented, is what is going to get executed in cases of those errors. Let me go ahead now back to my terminal window and run Python of number.py, enter, and let's go ahead and type in 50 again. Still seems to work. And of course, I'm trying and succeeding. Let me go ahead and try once more, this time, though, with the word cat, or really anything that's not a decimal number. And now you'll see much more cleanly x is not an integer. I'm not seeing some scary error message that I, as a user, am going to have no idea how to handle. Now you, the programmer, have anticipated that something exceptional can happen, and you've gone about actually handling the error for the user, giving them an appropriate error message instead. Let me pause here and see, are there any questions now on what we've just done by introducing try and except to handle this value error?
Is value error the only type of error you can get? Or are there other types?
Is value error the only thing you can catch? There are other errors as well, and we'll see a few of them today. And there's many, many more, honestly, that if you continue programming in Python, you're going to see a lot of them over the weeks, the months, the years to come. But the technique for handling them is going to be largely the same. Other questions on try, except, or these exceptions more generally?
Yes. Sir, actually, to use the except block, you need to know the type of error, right? Like here, you knew it was a value error. What if you can't anticipate this particular type of the error?
A really good question. So I'm being very good about catching, so to speak, the very error that I know might happen. I don't know when it might happen, because it's going to depend on the user, but I know what kind of error will happen from the int function. There is a way in Python where you can say except if anything goes wrong, and you can literally omit value error and just catch everything. The problem with that is that it sometimes hides other bugs in your code because you don't necessarily know what's going wrong. And if you don't necessarily know what's going wrong, how can you possibly handle it correctly? So bad practice. And put another way, it's lazy to do that, to just say catch everything and I'll deal with it here. So a much better practice would be to figure out what kind of errors could happen and include mention of them explicitly as I've done. Now, with that said, if you read Python's official documentation, as you'll eventually invariably do, it is not great about telling you proactively what kinds of errors can be raised in this way. So it's a bit of contradictory advice. You should do it this way, but it's not always obvious what you should be checking for. But you get better at it with practice. And some of the times the documentation does spell out what could go wrong. Let me turn our attention now back to this and point out that even though this is better code, it is more correct in the sense that I'm not just leaving it to the user to see some really ugly default Python error message that most people are going to have no idea what to do with. I'm at least handling it more elegantly, and I'm printing out x is not an integer. So it's at least more instructive. But this isn't necessarily the best way to implement this code. Why? Well, here too, I'm actually still being a little lazy. So notice that I'm trying to do not one line of code, but 2 lines of code. And this isn't a huge deal because we're only talking about 2 lines of code. But in the interest of preaching best practices, you should really only be trying to do the one or very few lines of code that can actually raise an exception, that can actually fail in some way. I am pretty sure that calling print here is not going to raise a value error. Whether x is an int or a string or a float or anything else, the format string feature of Python is going to handle printing it just fine. So really, what I'm going to do is this. I'm going to move this line 3 down to the bottom of my code. I no longer need to indent it. I'm just going to execute it at the bottom of my file here. Unfortunately, by doing this, I've done a good thing by now only trying to do the minimal amount of work necessary that might raise the exception, a value error. But I fear I've introduced a new mistake. Well, let's see. What is now incorrect? Let me go ahead and again run Python of number.py, enter. Let me go ahead and do it correctly with 50. And all seems to be well. But again, let's try those corner cases, the zeros, the negative numbers, or in this case, the cat. Let me go ahead and type in CAT again, enter. Now I have a name error. So now it's yet another type of error in my code that I've introduced here. And what does this name error mean? Well, just as a value error refers to that, the value of some variable, the value that someone has typed in is incorrect, name error tends to refer to your code, like you're doing something with the name of a variable that you shouldn't. And why might that be? Well, let me turn our attention back to the code here and consider, what is it complaining about? Well, the name error is what I see down here. And it's telling me name, quote unquote, x is not defined. And notice if I look further here, it is mentioning line 6. So I know the problem is with my code on line 6. And that worked a moment ago. And I'm defining x on line 2. But let me ask the group here, why does x not, in fact, exist on line 6? Why is it not defined, even though I'm pretty sure I was intending to define it on line 2?
maybe the scope of the variable is between the try block.
So good terminology. Scope refers to the portion of code in which a variable exists. That too, though, isn't quite right in Python. That would be true in C, C++, and Java, where indentation or curly braces tend to define the scope of a variable. But again, here in general, and this worked a moment ago, x exists once it's defined on line 2, because remember, I printed out x is 50 a little bit ago. Let's try one more hypothesis here. One more hand. Why is x somehow still not defined?
Yeah, so is it because it's local variable, meaning that like it doesn't define outside of the scope? Because like what people have mentioned, it prompts the input in try, right? But outside of it, it's undefined.
So still good instincts and good terminology too. There's this notion of local variables, which tend to exist inside of functions, for instance. Global variables, which tend to exist in entire files. In this case too, though, that's not quite the case. What's happening here boils down to order of operations. Let me come back to the code here and recall that anytime we've discussed the assignment operator, the single equal sign, that copies a value from the right to the left. But consider for a moment at what point something is going wrong. Well, the input function is probably working just fine, because we've used that a lot now to get users' input. It always returns a string or a str in Python. But what could be going wrong? Well, if I'm passing that string to the int function as its argument, it's probably the int function that's erroring. And indeed, if you think back earlier when we had the value error, it was in fact the int function that did not like quote unquote cat as input. So this is all to say that this portion of my code, highlighted now to the right of the equal sign, that's the code that's creating a problem. That's the code that was creating a value error. And in this case, we're catching the value error. But because the value error is happening on the right of the equal sign, there's no value being copied to the left. The error is interrupting that whole process. So even though we see x equals ... on line 2, the portion of that line to the left of the equal sign isn't getting evaluated ultimately, because the value error is happening too soon. And so when we finally get down to line 6, even though it looked like I was defining on line 2, and I would have defined x on line 2 if all had gone well, we didn't get to the part where the value is copied from right to left because the value error happened first. So this code is just incorrect now. So how do I go about solving something like this? Well, it turns out that there's another feature of the try and except syntax that Python supports, which is that it also supports the keyword else. Now, we've seen else before. If you think back to our discussion of conditionals, we saw if, we saw elif, we saw else, which was kind of this catch-all, what you should do in the event that nothing else is relevant. That's kind of the same intuition here for the try except feature of Python. What you can do is this. You can try to do the following, as I've done, except if this goes wrong. But if nothing goes wrong, else go ahead and do this. So this is one way I can solve this same problem now. No matter what now, Python is going to try to execute line 2. If something goes wrong, it's going to execute lines 3 and 4 to handle that value error. However, if you try and this code succeeds, then there is no exception to handle, so you're then going to execute this line here. So it's a little confusing perhaps in that we're now using else both for conditionals, if, elif, elif, else, and we're also using else with these try except blocks, but that's OK. That's part of the language. That's one of the features. So now if I rerun this code in my terminal window, Python of number.py, let's do something correct like 50, I see that x is 50. So line 1 is executed. We're trying to do the following. Line 2 is executed because the conversion happened successfully and the number 50 gets copied from right to left. The exception does not happen. So we ignore lines 3 and 4. We jump immediately to line 5 and 6, which prints out the result. By contrast, though, let's do this one last time. Python of number.py, let's type in cat or, again, any other word and hit enter now. We don't see what x is. Rather, we see, quote unquote, x is not an integer, which is what's being handled in my except clause. All right, let me pause here, because that's a lot of new syntax, and see here if there's any questions on try, on except, on else, name error, or value error.
Can you please repeat try function?
Repeat the name error. What's the problem with the name error?
Yes.
Yeah, so let's let's just rewind a couple of lines here before I fix this problem by now getting rid of the else. A moment ago, we had code that looked like this, whereby I was getting a name error, Python of number.py, enter, typing in cat, that looked like this, where name x is not defined, and the problem was on line 6, according to this output in Python. Well, let's think about this now deductively. Let's try a different approach. On line 6, I'm seeing an error that name x is not defined. OK, Python's already telling me x does not exist at that point. So how could that possibly be? Well, where should x be defined? Well, presumably x is defined on line 2 up here. So what could go wrong? Well, if the user has inputted something that doesn't look like a number, like the word cat, passing cat, the return value of input, as the argument to int to convert the word to an int makes no sense. You can't convert a cat, C-A-T, to an integer at all. So the int function is raising a value error at that point, and the error is being handled with this code here. But notice, this line 6 is not indented. It's left aligned with the rest of my code, which means no matter what, line 6 is going to execute. It's going to execute whether I typed in 50 or I typed in cat. But if I typed in cat, again, x never gets a value, so it's not defined here on line 6. So when I introduced finally the else statement, that makes sure that these things are mutually exclusive. I only execute the else if I tried and succeeded up above. Well, let me propose that we refine this just a little bit further as well and consider how we might improve this example a little bit more. It's a little unfriendly of me to be rejecting the user's input after they fail to provide an integer and just quitting the program, really. Right? It'd be more user-friendly if I just prompt or reprompt the user again and again. And in the chat, if you could, what's the feature of Python that you can use if you want to do something again and again and again until such time as the user cooperates and gives you what you're looking for, like a number? So yeah, loop, loop, loop. So a loop is something that happens again and again and again. And maybe we can use that same mechanism, a loop, in order to prompt the user for x. And if they don't give us a number, prompt them again. And if they don't, prompt them again and again and again. We don't need to just quit out of the program so quickly. So let me propose this. Let me propose here that I improve this code by deliberately doing this. Let me induce a infinite loop at the very top of my code with while true. Recall that the while keyword induces a loop, a cycle that behaves like this, and it asks a question, a Boolean expression that needs to evaluate either to true or false. Well, if I want this thing to loop forever, at least initially, we'll just say while true, because true is true. So this has the effect of doing something no matter what forever, unless we break out of it early. Now I'm going to go ahead and do this. I'm going to go ahead and move my try except code indented underneath this loop so that I'm trying to get an x. If I have a value error instead, I print out x is not an integer. But this time, what do I want to do if the user does try and succeed in giving me a number? Well, I can do this. I can just break out of my code here. And down here now, I can use that same line of code from before, an f string that says x is, and then in curly braces, x again. So what's going on here? I think this code now, because I've added the loop, is going to have the effect of trying at least once, maybe a second time, maybe a third time, maybe 500 times until the user finally gives me what I want, which is an integer. And once they do, once there's no value error happening, then I break out of the loop, and line 9 executes as I would hope. So let me go ahead and try executing this version. Python of number.py, enter. What's x? Let me go ahead and type in the easy thing first, 50. X is 50. What just happened in terms of the control flow of this program, the flow of my logic? Well, I first found myself on line 1 inside of a loop. Hopefully, I'll get out of this loop. What did I then do? On lines 2 and 3, I tried to get input from the user and convert it to an int. Well, I was a nice guy this time, and I typed in 50, which looks like and is a number. So the int function converted it just fine and stored it from right to left in x. Except value error, there is no value error, because if I typed in a number, there's nothing exceptional happening. This is a boring, good execution of my program. So what happens? I break out of the loop. So again, the else clause is associated with the try, not with the except. And once I'm out of the loop, of course, I'm just printing out what x is. Well, let's try the other scenario that might happen. Python of number.py enter. What's x? Let's try cat or any other word. Enter. This is now a new feature. I'm being informed what I did wrong. X is not an integer, so I'm getting some useful user feedback. But notice again, I'm prompted, what's x? Well, let me try typing in dog. X is not an integer. What's x? Let me try bird. Enter. X is not an integer. What's x? And suffice it to say, this will happen now forever if I'm in an infinite loop until I try and succeed, at which point I break out. So let's try again. 50, enter. Now I'm out of the loop, and I'm printing out what x actually is. All right, let me pause here and see if there are any questions. The logic is almost the same, but what is different now is I'm in a loop, and I'm using the keyword break in Python to deliberately break out of the loop when I'm ready to, once the user has cooperated.
Do we really need to break? Can't we just print? Or what keeps us from just printing?
Good question. So let me try that. Couldn't I just print? Well, let's see what happens if I do that. Let me move this print line at the end into my loop here, thereby shortening the program. And in general, that's been a good thing. Python of number.py enter. Let me go ahead and type in 50. OK, x is 50. What's x? OK, maybe it's 49. X is 49. OK, maybe 48. Unfortunately, I think you're laughing. You see it. I never break out of the loop, which maybe that's a feature. Maybe you want this to be your program, but I didn't. I'd eventually like this game to stop. So I need to break out in that way. But I can do it a little differently. And let me propose that we modify this a little bit. But first, any other questions on this syntax here? Let me rewind to the prior version.
Hi, can I use break or in exception except in else? For example, in another print, when you use print in the else, you can use print together with break or something like this?
So you can use break inside of loops to break out of loops. And you can use it inside of a conditional, like an if, an elif, or an else. You can do it inside of a try, except, else statement too. Anytime you're in a loop that you want to break out of, you can use this keyword break. I'm using it in the context of exceptions, but it's not restricted to that. And let me show you too, it doesn't even have to be in the else. If I wanted to, I could actually do this. I could get rid of my else, and I could go back to line 3, add another line that's indented, line 4, and break out here. Now, why is this logically OK? Well, consider what I'm now trying to do. I'm trying to execute line 3 and converting the user's input to an int. And I'm trying to store the result from right to left in x. If something goes wrong, the code we've already seen is immediately going to jump to line 5 and then 6 to handle the exception. But if nothing goes wrong, my code presumably should just keep on executing line by line. So I could technically, logically put the break here and watch what happens when I run this version. Python of number.py 50 enter. It worked. I broke out of the loop. Now, which way is better? Honestly, I think it could go either way at this point. This program's so relatively short that even though I'm trying to do two things now, one of which, the break, is not going to fail. Like you either break or you don't. There's no piece of data from the user that's going to influence that. We don't strictly need to have those 2 lines of code there, but it's only 2 lines, so I think it's OK. And if you recall our discussion in the past, not just of correctness, does the code work as it should, but design, I think you could argue it either way. If you prefer the readability of this and the fact that you don't have an else, that's fine. If, though, you prefer to minimize just how many lines of code you're trying to execute in case something goes wrong, the else is a reasonable approach too. Well, allow me to propose too now that we refine this further. I think we're at the point where it's pretty darn correct. But suppose now that I find myself today and tomorrow trying to get numbers from the user quite a bit. It would be nice, as we've seen, to maybe just invent my own function, getInt, to get an integer from the user both today and tomorrow and beyond. And heck, maybe I can even share that function with other people if they want to write programs that get integers from users. So how might I go about doing this? Well, let me go ahead and propose that we do this. Let me get rid of the print line, but keep most of my loop here. Let me define a function called getInt that takes no arguments for now. And I'm going to go ahead and indent all of the code I already wrote underneath getInt. So now I have a function called getInt that tries to do the following. Try to get an int from the user. If something goes wrong and there's a value error, yell at them with x is not an integer. Else, break. But it's not just breaking that I want to do here. Now that I'm in a function, recall our discussion of return values. If you're inventing your own function whose purpose in life isn't just to print something on the screen like a side effect, but is to hand back a value, to hand you back a value, like on that same post-it note from our discussion of functions, well, you need to return x explicitly. How do I now use this function? Well, as soon as we start making our own functions, it tends to be convenient to define our own main function as well. That's the main part of our program. And I'm going to keep this simple. I'm now going to say x equals getInt. And then on the next line, I'm going to do that print from before, quote unquote, x is, in curly braces, x. And at the very bottom of my program, recall, I'm going to call main, so that no matter what, I'm invoking my main function after everything's been defined. Well, let's see how this works. Let me go ahead and run Python of number.py, enter. Let's type in 50, and it seems to work as before. Let's go ahead and run it again, typing in cat, C-A-T this time. X is not an integer, and I'm being prompted. Dog, and I'm being prompted. Bird, and I'm being prompted. Fine, 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 50. That's an int, and so it is printed. So what's worth noting here? Well, I'm manifesting a couple of good properties here. One, I've kind of abstracted away this notion of getting an integer. And even though I just artificially hit enter a whole bunch of times just to hide that function for now, it needs to be there, but we don't need to see it at this point. Notice that now this entire program really boils down to just these 3 lines of code now. Why? Because I've abstracted away that whole process of getting an int from the user into this new function of my own called getInt. But can I improve upon this? Well, let me go ahead and undo all of those blank lines and pull this up just so we can see more on the screen at once. Can I tighten up my implementation of getInt? It is correct. I claim this is correct. It's handling errors and it's returning x, but I don't, strictly speaking, need to write the code as long. What else could I do? Well, let me propose that if all you're doing on this line 13 is breaking, and then immediately after that, per the indentation, you're executing return x on line 14, why are you wasting everyone's time? Once you know you're ready to return the value, you could just return x. And so in my else, I could break out and return a value. So here too, return is used to return values from functions. Break is used to break out of loops. But it turns out that return is sort of stronger than break. It will not only break you out of a loop, it will also return a value for you. So it's doing 2 things for once, if you will. But can I make this even more compact? If my goal is to just tighten the code up, even though it's already correct, can anyone think of a further refinement, whether you've programmed in Python before or not? Can I shorten this implementation further, just a little bit, if only to decrease the probability that I've made a mistake by having fewer lines, and just make it a little easier to read because it's shorter? Any suggestions for tightening up my implementation of getInt?
You can just return the value on the try function when you're trying. You take the input x and then return x.
Good. We can just return x a little higher up. And let me correct folks as we go. It's not a try function. It would be a try statement, technically. A function typically has a parenthesis and another one. In this case, it's just a statement. But we can do exactly that. I don't technically need the else. If I really want, I could do this. Right after line 9, I could return x here. Or recall our discussion of defining variables unnecessarily sometimes. Like, why define a variable here if you're immediately going to use it here and then never again? So we could avoid a new line here. And I could avoid even defining x explicitly. I could just say something like this. I could return int input, quote unquote, what's x. I can do it all at once. Now, which is better? I don't know. I mean, again, this is where reasonable people might disagree. I'd argue that on the one hand, we're tightening up the code. We're using fewer lines. It's easier to read, lower probability that I've made a mistake. On the other hand, it's a little more complicated to understand, perhaps. It's a little less obvious where I'm returning from. So I think arguments can be made either way. At the end of the day, what's important is that you've done this consciously. You've made a decision to do it this way or this way, and you can justify it in your mind, not that your answer is, it worked, so I left it alone. Like, have a good reason. Come up with a good reason, and that will come with experience and practice. Well, let me propose, too, that we make one other refinement here. Suppose that you're finding your programs to be a little noisy, and it's a little obnoxious that you keep telling the user x is not an integer, x is not an integer, x is not an integer. What if you want to make things a little gentler and just prompt the user again with the same words, what's x, what is x, what's x, again and again? Well, you can do that as well. And it turns out that if you want to handle an exception in Python, but you want to pass on doing anything with it, so you want to catch it, but you essentially want to ignore it. You don't want to print anything. You don't want to quit the program. You just want to silently ignore it, like if you're talking in a room full of people and it's your turn to talk and you're just like, pass. They're still calling on you, but you're not doing or saying anything more. Well, we can add this keyword to our code here. Let me go back to my program here. And instead of printing out again and again, x is not an integer, I could just do this. I could pass on handling the error further. I'm still catching it. So the user is not going to see a scary message even mentioning value error. My code is catching it, but I'm passing on saying anything about it. I'm going to stay in the loop. I'm going to stay in the loop and keep prompting and reprompting the user. So now the effect looks a little something like this. Python of number.py. Let's type in cat. What's x again? Let's type in dog. What's x again? Type in bird. So it's just a little maybe more user-friendly in that you're just reminding the user what you want. Maybe it's worse. Maybe it would be helpful to tell the user why you're prompting them again and again. It's not obvious, so it could go both ways. But again, it's just another mechanism now for handling these errors. We use the except keyword to catch a specific error, but we don't have to handle it more than that. We can just pass on doing something further. Let me pause here and see if there's any questions now on try, except, else, or pass?
Okay, yeah, no, I was just kind of curious, I guess, about the idea of when you were indenting with the getInt function, for example. Because I'm noticing, you know, obviously going through it with the whole logic and breakdown of the entire function, you know, while true, do this. But I'm just kind of curious on elaborating with the indentations for the code more.
Yeah, so the indentation is deliberate logically. Some languages don't require as rigorous indentation. You can use curly braces or other symbology to make clear what is associated with what. In general, anytime you indent something in Python on this line, anytime you write a line of code in Python that's here, and the lines below it are somehow indented, that means that those lines are somehow associated with that first line. And presumably, those indented lines should only be executed if the first line told the computer to do so. So concretely, what does this mean? On line 6 here, we're defining a function called getInt that takes no arguments, colon. Everything that's indented by at least 4 spaces hereafter is part of that function. Why? That's just the design of the Python language. Frankly, I think the designers got tired of seeing really ugly code in languages like C and C++ and Java that don't necessarily enforce indentation to this extent. So now it's baked into the language. And my chronology might be a little off there, but there's been many languages that are looser than Python when it comes to indentation. The indentation is meaningful on line 7 too. Notice that because the while true is indented by 4 spaces, that just means it's part of the getInt function. But notice below the while true statement, there's 8, there's 12, there's 8, there's 12 spaces here. And I'm just quickly counting the dots. That means that all of the lines I've just highlighted are inside of that while loop. While true means to execute lines 8 through 11 potentially again and again and again. And now lastly, on line 8, because we have try and indented below it is line 9, that just means that what you should try is what's on line 9. And similarly, on line 10, below it, we have indented line 11. You should only pass when there is an exception of a value error. So the indentation just means what is associated with what. And once you get comfortable with that, you'll see that it helps, the indentation alone helps explain the logic of your program. And it has a wonderful side effect that for yourself the next morning, for your colleagues, your family, your friends, your teachers, your code is much more readable as a result. It's not one big mess of a blob of text. Other questions now on try, except, else, or pass?
Yeah, thanks. Two questions. Question one, once you say pass, can the caller still learn anything about this error through a system variable or whatever? And question two, problem set 0 referenced some string methods, including is numeric. Is it any different to go via is numeric here?
A good question. So on the first question, if I'm handling the error in this way, the caller is not going to know anything about it. That's the point of my handling it, so that main or other callers don't know that anything technically went wrong. On the second question, isNumeric is another function that you can call that can look at a string and determine, is this in fact a number? I could use a mechanism like that. I could use a conditional. If this looks like a number, then pass it to the int function and go ahead and convert it to an integer. That's totally fine. I would generally say that the Pythonic way of doing things is often, for better or for worse, to try things, hope they work, but if they don't, handle the exception. So other languages are more in favor of checking if, elif, else, and all of these conditionals. Python tends to be a little more of the mindset, try it, but just make sure you're handling the error. So this would be the Pythonic way of doing it. Your way, though, checking with a conditional, is it a number first, is totally reasonable too, if you want to go that way. Well, let me propose some final refinements to this program that really just kind of tighten things up one additional step to improve the implementation of this getInt function. Let me propose that we not hard code, so to speak, that is, type manually x all over the place. Let's make this function getInt a little more reusable. Right now, notice that I'm just kind of using the honor system that, well, main is defining a variable called x, and getInt is asking for a variable called x. But it would be nice if the caller, main, doesn't have to know what the callee is naming its variables, and vice versa. So caller, to call a function, means to use it. The caller is the function that's using it. The callee is just the function being called. It would be nice if I'm not just hoping that x is the same in both places. So let me propose this. Let me propose that we actually add a parameter to getInt like this. What's x? That is to say, if main wants to use the getInt function, well, then main should probably tell the getInt function what prompt to show the user. Just like the input function, recall, that comes with Python, it's up to you to pass in a prompt that the user then sees when the human is asked for input. So how do I make this work here? I can go down to my definition of getInt, and I can say, all right, getInt is going to take a parameter now called prompt. I could call it anything I want, but prompt in English is pretty self-explanatory. It means what do you want, the message the user will see. And now down here, when I actually use input, I don't have to presumptuously say what's x, because what if the program, the caller, wants to ask for y or z or some other variable? I can just pass to input whatever prompt the caller has provided. So now I'm making more reusable code. It still works just the same. I haven't changed the functionality per se, but now it's a little more dynamic, because now getInt doesn't have to know or care what variable is being asked for, what's being asked for. It just needs to know what prompt it should show to the user. So if I now run this program down here again, prompt number.py, enter, what's x? 50. Still seems to work. Let's run it again. Let's type in cat. It still seems to work. And if I type in cat, dog, bird, or anything else, it will keep prompting me with that same prompt, making this code, therefore, all the more usable. Now, it turns out, too, you can even raise exceptions yourself using Python's raise keyword, but more on that another time. So in the coming days, the coming weeks, the coming months, as you write more code in Python, you'll see that errors are inevitable. Sometimes there's syntax errors, which you got to just fix if you even want to run your program at all. But they could be name errors, for instance, variables that you meant to define but somehow didn't. Value errors, where maybe the user didn't cooperate and provided you with something that you weren't expecting, or a whole list of other possible errors or exceptions. But now, hopefully, you know how you can handle these errors and respond to them in any way you like. This, then, was our look at exceptions, and we'll see you next time. All right, this is CS50's Introduction to Programming with Python. My name is David Malin, and this is our week on libraries. So libraries are generally files of code that other people have written that you can use in your own programs, or a library is code that you've written that you can use in your own program, but maybe not just this program, but another and another as well. So Python supports exactly this idea, this ability to share code with others, share code across your own projects, and it does so by way of what it calls module. A module in Python is just a library that typically has one or more functions or other features built into it. Generally, the purpose of a library, or a module specifically, is to encourage reusability of code. If you find yourself using the same types of functions again and again, the same functionality, if you find yourself copying and pasting from an old project into your new project, odds are there's an opportunity there to factor out that code that you keep copying and pasting, that you keep reusing, and put it into a library that you can then load into your programs moving forward, so as to not just copy and paste it and have all these different copies all over. So what are some of the modules or libraries that Python comes with? Well, Python comes with a random library, literally, which is to say that when you install the Python interpreter on your Mac or PC or somewhere in the cloud, not only do you get Python, you get a whole bunch of modules as well. Now, these modules provide you with functions that you don't have access to just by default, like you do print and input. Print and input and other such functions just work in Python. But sometimes functions are tucked away in these modules, so you have to be more deliberate about loading them into the computer's memory. So somewhere on the computer's hard drive, once you've installed Python, there is also, it turns out, a file probably called random.py that someone else wrote, probably long ago, but that you have access to. And in that random.py file, there's probably one or more functions that you yourself can use in order to do things randomly. That is to say, how could you flip a coin in a program in Python? How could you pick a random number between 1 and 10 in Python? Well, you need a bit of randomness. And while you could figure out mathematically how to write functions like that yourself, it's a lot easier to stand on the shoulders of others who've already solved that problem for you, so you can focus on the problem that you yourself want to solve. So for documentation on most any Python module, you go to the official Python docs, and you go to a URL like this where the documentation for that specific module lives. And within the documentation, you'll see a list of the functions or other functionality that some module provides. But how do you go about loading a module into your own program so that you can use the functions in that module? Well, we need a new keyword in Python, and namely, it's import. The import keyword in Python allows you to import the contents of, the functions from, some module in Python. Well, how might I go about using this in practice? Well, let me propose that there exists in that random module this function, among others. So I have copied and pasted from the documentation this summary of a function called choice. Now, the function exists in the random module, so to speak, not a random module, the random module. And so generally, the documentation describes it fully like this. Random.choice is how you would technically call this function, though we'll see alternatives to that. In parentheses, there is a parameter called seq for sequence. And sequence generally means a list or something that is list-like, if you have a list of numbers or strings or anything else. And the documentation elaborates. Well, how can I go about using this function to solve perhaps a familiar problem? Well, let me go ahead and open up VS Code here. And let me propose that we implement a program that simulates flipping a coin that in the US heads heads or tails, the idea of which is to pick a decision with 50-50 probability, 50% probability of heads, 50% probability of tails, or you can use some other mechanism like that. Well, let me go ahead and open a program with code called generate.py, because I want to start generating a whole bunch of random information, the first of which is just going to be a coin toss. Now, how do I go about using that function? Well, I first have to import the random library. So literally, the first or among the first lines of my file should be import random. And that just gives me access to all of the functions in that specific module. Now suppose I want to flip a coin. Well, I can do random.choice per the documentation a moment ago. And that again takes a sequence. What's a sequence? It's a list or something that's list-like. And we know about lists. We've used lists to iterate over numbers. We've used lists to iterate over students at Hogwarts. Let's go ahead now and iterate over just a list of two sides of a coin. Heads, quote unquote, or tails. Now I could call these anything I want. These are my strings. I just want to simulate a tossing a coin, so I'm just going to say in all lowercase heads and tails. But notice the syntax. I have heads and tails in double quotes. That's because they're strings. I could also use single quotes so long as I'm consistent. There's a comma between them, which means the list has 2 elements. There's square brackets to the right and the left, which indicates that this is indeed a list. That's the syntax, recall, for defining a list in Python. And then lastly, there's something more familiar. There's the parentheses outside of those square brackets, but those are just the parentheses that belong to the choice function and specify where its parameter gets passed in. But again, unlike past functions, I have to specify what module this function is in, at least for now. And so I do random.choice to call this specific function. All right, well, it's one thing to flip a coin, picking between those with 50% probability. And that's what random.choice does. It takes in a list, and it returns to you one of those values randomly with equal probability. Because I've passed in 2 items, I've got a 50-50 chance. If I passed in 3 items, it'd be a 33% chance for each of those items, and so forth. Python does the math for you. But I want to store the value of this in a variable. So let's define a variable called coin equals whatever the return value is. So this is indeed like flipping a coin. I'm going to store in a variable called coin whatever that value is, heads or tails. And now, just so I can see what's going on, let's go ahead and print out the value of that string coin. All right, let me go ahead now and run this program in my terminal window. Python of generate.py, enter, and it looks like the first coin toss was the heads. Let's go ahead and run it again, and it looks like it was heads again. Maybe you want to chime into the chat here. If I run it a 3rd time, what's it going to be this time? If you want to type your thoughts in the chat. You might think there's a bug here, but this is probability in action. If I go ahead and hit enter a 3rd time, there, it's actually now tails. And again, 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 heads. Now, if we did this an infinite number of times, it would indeed work out to be 50-50. If we only do it a few times, it might not work out as cleanly. But that's how probabilities indeed work. All right, so I've got that now working. Could I have implemented this in a different way? Well, let me show you an alternative to actually using the import keyword alone. And let me introduce the keyword from in Python. So from is a keyword in Python that you can use when importing functions from a module, but it allows you to be a little more specific than import alone. So if I go back to my code here, it's worth noting that what technically I'm doing here by importing random is I'm technically importing everything that's in that module. So not just the function called random.choice, but a few other functions as well. So instead of using this line of code at the top of my file, import random, which will technically give me access to all of the contents therein, a downside of that is that I have to type in random.choice, random.this, random.that, because all of the functions I'm calling have to be associated with the scope of that module. Well, suppose that I just want to call the function as its name, choice. I can do that as well. Let me replace this first line here with from random import choice. And what this does effectively is it loads the function's name, choice, into my current namespace, into the scope of the file I'm working in. What that means is that I now no longer have to specify which choice function I mean. I can just say choice. And so it loads it into the local namespace, that is, into my local vocabulary, if you will, so I can just now say choice. This might be advantageous in what cases, do you think? When might you want to import the name of the function explicitly like this, as opposed to just saying random.choice throughout your code when calling a function? Any instincts here for this alternative import using from?
Hello, I'm Mohammed Omar from Egypt. Maybe if we have a variable that its name is basically like choice, if I have a variable called the choice, so I need to differentiate which choice I choose. So I'm going to choose random.choice.
Yeah, really good instincts. By using the first approach, by just importing random, you're making sure that all of its contents are associated with, are scoped to the random module so that you can have your own choice function. You can have your own choice variable. You can use the same names as all of the functions or variables that are stored inside of that file without them colliding, so to speak. And this is a good thing. In older languages, it was the case that if you imported someone's library, you better hope that you're not using the same functions or variables as as they are because you might, in fact, have some kind of conflict. Python and certain other languages allow you to scope the names of those functions and variables to the file or the module that they come from, so that's a good thing. But honestly, this is such a short program. Or, equivalently, maybe I'm using the choice function in so many places, calling random.choice, random.choice, random.choice. It's just making my code longer and longer and longer. Marginally so, but it's just getting ugly and annoying. I can simply import choice and now tighten up my code a little bit. So as with so many decisions in the past, there's not necessarily one right approach or another. It depends. But I think for those very reasons, sometimes it's better to do what we did the first time, which is only import the module so as to retain the scope therein. Well, let me propose that we transition to another function that comes with Python's random module. And that's this here from the documentation, randint. It's a bit hard to say, but it implies get back a random int. And if you read the documentation, it's a random int that's between a and b inclusive. So if you were to pass in 1 for a and 10 for b, you would get back a number between 1 and 10 inclusive, including the 1 and including the 10 potentially, each with a 10% probability. So how might I go about using a program like this? Well, let me come back to my generate.py file. And why don't we go ahead and try generating a random number between 1 and 10? You might do this frequently in the real world when you just want someone to pick a random number. You tell them as much and the human responds. Let's get the computer to do the same here. Let me go ahead and delete my 2 lines of code at the bottom, but keep my import random. And let's go ahead and define a variable, this time called number. Set it equal to the return value of random.randint. And now pass in a value of 1, and b, a value of 10. And now let's go ahead and print the number. I'm going to go ahead in my terminal window and run Python of generate.py and hit enter. 4. Python of generate.py and hit enter. 8. Again. 9. Again. 7. Again. 10. Again. 2. Again. And we can do this all day long. And if we add all of those up, they should end up being with 10% probability each. Now, how might you use this information? Well, maybe we're playing a guessing game. Or maybe we're trying to randomize the behavior of some character in the game. You can imagine using very simple building blocks like this, just kind of spicing up your program by getting it to do things a little less predictably because you're choosing these values seemingly randomly. And you're deferring to Python to actually do the generation of these numbers using its own algorithms and its own math. Well, what more could we do here? Let me propose that we introduce another function that comes from this random library, yet another that you yourself don't have to implement, shuffle. If you read the documentation for shuffle in the same random module, you'll see that it takes in a list, for instance, of values and just shuffles them up. It randomizes them. Like a deck of cards here, you might shuffle them so as to put them into seemingly random order. Well, how do I use this based on this function's name? Well, let me propose that we go back to VS Code here, and let me go ahead and this time do the following. Because I need to shuffle something like a deck of cards, let me go ahead and not just import random, but let me give myself a variable called cards that's going to be of type list. And just so I have something to shuffle, I don't need all 52 cards in a typical deck. I'm just going to shuffle 3 cards, a jack, a queen, and a king. I could call those strings anything I want, but I just wanted a list of some values so as to shuffle them up. That is, randomize the order therein. Well, how does this now work? If you read the documentation for random.shuffle, you'll see that it shuffles the argument in place. That is, unlike many of the functions we've seen, it doesn't return to you a value that contains the shuffled cards in this case. It actually shuffles the list it's given itself. So what this means for my code is that I need to do something like this. Random.shuffle and pass in the variable containing those cards. And then on a final line here, how might I go about printing the cards? Well, I could do this, and I could say print cards. But if I do that, I'm actually going to see Python syntax for lists. And it's just going to format in its own way using commas and the like. I want to print these cards out one at a time just because I think it'll look a little better. So we can use some of our syntax from loops and say something like this. For card in cards, go ahead and print out the current card. So what's now happening here? Line 3, I'm defining a list of 3 cards in this order, jack, queen, king. I'm then shuffling those same cards on line 4. And then on line 5, I'm using a for loop. For each of the cards in that list, print it out one at a time. And because I'm using print, one line at a time. Well, let's see the results. Down here in my terminal window, I'm going to run Python of generate.py and hit enter. Queen, king, jack. Seemingly shuffled because that's not the order I defined earlier. Let's do it again. queen, king, jack. Okay, that happens to be the same, but let's see. This could just be bad chance. There we go. Jack, queen, king. Doesn't look like it's shuffled, but at least we're getting back different orderings now. Again, jack, queen, king. Not so good. Jack, queen, king, not so good. This is someone you probably want to play against with cards. Queen, jack, king, there we go. But of course, we only have 3 cards here, so there's not that many permutations we might see. And if we do this over time, we will see all of them. But if we had, of course, 13 or 52 cards, we'd see a lot more permutations instead. So we have now these 3 ways to generate random information. One is simple coin toss if you want to start some kind of athletic event. One, pick a number between 1 and 10 if you want to decide something based on that. And now using shuffle, we can even take in a list of things and shuffle them about so that we get some kind of random behavior. Well, let me pause here and see if there's any questions yet on random, on modules, or any of these 3 functions.
Yeah, can we increase or decrease the probability of cards if we want to? For example, there is a 33% chance of probability. So is there any chance to increase or decrease the probability?
Can you set these probabilities, not using these same functions? Can you set the probabilities? But you can absolutely implement some of your own functions or use more sophisticated functions that do exist in this library and others to exercise more control. These are meant to be very user-friendly and simple functions, certainly the ones we looked at that give you equal probability for all of those. But absolutely, you could skew things, though hopefully if you're implementing a gambling game or the like, you're not actually making some cards more probable than others. Allow me to turn back now to our implementation here of this randomness and consider how we might leverage other types of functionality that aren't necessarily in this specific library here. Well, it turns out that Python also comes with a statistics library, and this contains all sorts of functions for doing things more statistical in nature, namely calculating means or medians or modes or other aspects of a data set that you might want to analyze. So how might we use the statistics module in Python? Well, we might first just take a look at its documentation like any other module in Python, and we'll see within that library that there's a whole bunch of functions. And one of those functions is one that's quite simple. It's average, a function that allows you to calculate the average of some numbers that you've passed in. Let me go ahead and in VS Code in my terminal window, open up a new file called average.py. And at the top of this file, I'm going to import a different library this time, namely the statistics module in Python. And now I'm going to go ahead and call a function that I know comes in that module, namely mean, for the average of some values. And I'm going to call statistics.mean. And I'm going to pass into this function mean a list of some values. And let's suppose that I'm quickly trying to calculate what my current grade average is in school, and I did really well on my first test and I got 100%, and on my second I did well but not as well and I got a 90. And ironically, I'm not very good with math, so I'd like to figure out what my average now is between those 2 tests. So let me go ahead now and in this list type in the number 100, 90, thereby passing in a list of 2 values, 2 ints, 100 and 90, and outside of those are the parentheses because, of course, this is now the argument I'm passing to the function called mean, and this function mean is in the module called statistics. Well, it's not that interesting to just calculate the mean if I don't actually see what it is. So let me additionally pass the return value of that mean function to the print function as usual. Let me now in my terminal window in VS Code type in Python of average.py and hit enter, and voila, as you might expect, my average is 95%. So the difference here is that I'm just using a different module that still comes with Python, but I need to import it instead of, for instance, the random module instead. And this time I know from the documentation that there exists a function called mean. Well, it turns out there's even more functionality that comes with Python and that comes with other modules in Python. And there's this feature generally known as command line arguments. This is a feature not just of Python, but of languages more generally that allow you to provide input not when prompted inside of a program, as happens whenever we call the Python function input, but rather there's this feature, command line arguments of programs, that allows you to provide arguments, that is input to the program, just when you're executing it at the command line. So up until now, for instance, recall that we've generally run Python of something.py. For instance, Python of hello.py. And I've never once really executed any words or phrases after the name of the file. But I could. In fact, when you're running programs in a command-line environment like we are, you can provide any number of words or numbers or phrases after the command that you're typing, and all of those will somehow be passed in as inputs to the program itself. You don't have to prompt the user for one thing at a time by manually calling that input function. So what does this mean in real terms? Well, let me go ahead back into VS Code here, and let me propose that we consider how we might leverage a certain module. I'm going to go ahead and create a file called name.py. And I'd like to use a new module this time that's going to give me access to values that have been typed at that command line. But what's this module going to be? Well, this one's going to be called sys. And sys, short for system, contains a whole lot of functionality that's specific to the system itself and the commands that you and I are typing. The documentation for this module is at this URL here, and it lists all of the various functions and variables and the like that come with that module. But we're going to focus on something a little more specific, namely this thing here. It turns out in the sys module in Python, there is a variable that just magically exists for you called argv. It stands for argument vector, which is a fancy way of describing the list of all of the words that the human typed in at their prompt before they hit enter. All of those are seemingly magically provided to you via Python in a variable called sys.argv. This variable is a list, which means that the first element's going to be the first word that you typed, the second element's going to be the second word that you typed, and so forth. And by way of this list, then, can you figure out what words did the human actually type at the prompt and maybe use that to influence the behavior of your own program? So what does this mean now in real terms? Well, in this new tab called name.py, let me go ahead and import sys. Within that sys module is going to give me access to sys.argv, but how might I want to use it? Well, let's do this. Instead of writing a hello world program that all of these times has just looked for the return value of input to figure out what the user wants me to print, let's go ahead and just expect the user to tell us when they run the Python program itself what their name is. And suppose this time I'd like to generate a whole bunch of name tags, initially just one. And in the US here, it's very common to wear a sticker on your lapel that says, hello, my name is David. So I want to print out some text that resembles that. The idea being maybe I could enhance this program someday to even send that text straight to the printer and dynamically generate those name tags. Well, let me go ahead now and do this. Let me go ahead and print out, as always, hello, but I'll say a little something more this time to make things more interesting. Hello, my name is, quote unquote. And then after that, I normally have been in the habit of calling input, storing the return value in a variable, and passing in the name of that variable here. But I'm going to instead jump right to this, sys.argv bracket 1. And that's it. I'm going to have a program here that says, hello, my name is, followed by whatever is in sys.argv bracket 1. And notice sys.argv again is a list. And recall from our discussion of loops and intern lists, we use this square bracket notation to get at the various elements inside of a list. All right, let me go down now into my terminal window and run python of name.py. But this time, rather than just hit enter and wait for the program to prompt me for my name, let me proactively just tell this program what my name is at the so-called command line. Here we go, david separated with a space from the name of the file, so that now when I execute python name.py David, I see on the screen, voila, hello, my name is David. So based on this demonstration alone, I think we can infer exactly what's going on in sys.argv, even though it sounds certainly, at first glance, rather complicated here. Let's look up. At sys.argv, I'm going to bracket 1 here. So clearly, sys.argv bracket 1 is storing david, but it's 1. In the past, when we looked at loops, recall that we said that they were 0 indexed. That is, the first element is 0. The next element is 1. The next element is 2, and so forth. And yet here I am treating it as though my name is at the start of the list 1. Well, let me ask this question. What is probably in sys.argv of 0? What is probably in sys.argv of 0? The very first element actually in that list.
Oh, yeah. I think it's like in C, the name of program.
Indeed, it's indeed, like in C and other languages, the name of the program. Well, if we consider what it was I typed, I certainly typed Python, because that's the name of my interpreter. And we don't really need to know that because we're using Python itself. But after that, I did type two things. I typed name.py, as I've done so many times, anytime I want Python to interpret a program I've written. And it turns out by convention, what Python does is it stores in sys.argv the name of the file that you're executing or interpreting, followed by any number of other words that you typed. So all this time, we could have been accessing the name of the program, which frankly isn't all that interesting, but we can also now access words that are typed after that prompt as well. But of course, if I don't type anything in, what might happen here? This might be naive of me to assume that there's always going to be something at location 1 in sys.argv. Let me go ahead and try this. Python, name.py. And no, I'm not giving you my name, because at this point I might not even know that you want my name to be typed. So let me hit enter now. And uh-oh, we see now an error. A so-called exception in Python. This one's a new one. This one's an index error that elaborates list index out of range. And turns out this is actually one of the most common mistakes in programming, whether using a list in Python or arrays or vectors in other languages, is to try to access some element that does not exist. You try to go too far to the left, or you try to go too far to the right in this object that is just a list of some values. So of course, the mistake here is that I'm assuming there's going to be something at location 1 when really it's location 0 that's the only one that has a value. But fixing this is not going to amount to doing bracket 0, because now if I go ahead and rerun this program with no other words after name.py, it says, hello, my name is name.py, which is fine if we're making a name tag for the program, but that's not, of course, what my goal here is instead. So if the fix is not just to change the 1 to a 0, how else might I handle this error? How else might I handle this error? This index error that happens if the user just doesn't remember to or doesn't know to type their actual name at the prompt.
We could always put an exception into the program saying if there's nothing at location 1, we just come out to say, well, OK, we haven't got a parameter or something. But if there is, you continue along with the program.
Perfect. So if I might simplify, we can try to execute this line of code, except if there's an error, we'll deal with it in some other way. Now, ideally, and once I'm a strong enough programmer, I would have anticipated this and written the following code from the get-go. But when you're learning, it's certainly reasonable to see an error. Oh, I didn't realize I should detect that, and then go back and improve your code. But of course, if you read the documentation, you ingrain some of the lessons learned from the past, you'll get into the habit of trying and checking for some of these exceptions yourself. So let me solve this in one possible way, as you proposed here. Let's try to handle this exception as follows. Let me go ahead now, and instead of just blindly calling this print line, let me try to print out, hello, my name is such and such, except if there is an issue, specifically an index error, then what do I want to go ahead and do? I'm going to say something like too few arguments. I could be more explanatory than that, but for now, I'm just going to explain to the user that they gave me too few arguments, too few words at the prompt. So now, it's still not going to work in quite the way I want. I'm still not going to be able to generate their name tag, but at least they're not going to see some cryptic error message and think that they themselves broke the program. Let me go ahead now and run python of name.py, enter, and too few arguments. OK, let me go ahead now and do python of name.py and type in my name, David, and now we're back in business. And I see that my name is on the screen too. But strictly speaking, I don't have to try to do this. I could actually be a little more defensive in writing this code. And maybe I could check whether or not the user has indeed provided a name or multiple names at the prompt so as to give them more refined error messages as well. So how might I do this? Well, let me go and undo the exception handling I've added. And why don't I instead more modestly try to do this? Let me go ahead and introduce a conditional here. If the length of sys.argv is less than 2, or equivalently equal to just one value, but I'll just stick with less than 2 for now, then go ahead and print out too few arguments. So I want ultimately 2 arguments. I want the name of the program at location 0, and I want the name of the human at location 1. So that's a total of 2 arguments. So if I have fewer than 2 arguments, let's tell the user with this print line, if the length of sys.argv is, say, greater than 2, like they typed in too many words at the prompt, well, let's tell them print, quote unquote, too many arguments. Else, if they did get it right and they gave me exactly 2 arguments, else let's go ahead and print what I actually care about. All right, let me go down to my terminal window here and run python of name.py, and voila, a completely different type of error. This one, a syntax error, which we've seen in the past. Now, a syntax error, recall, is mea culpa, like I messed up here and I wrote invalid syntax, and so no amount of conditionals or exception handling is really going to catch this one. I need to go back and just get my program to work because it's not running at all. Well, let me go up here and see. Line 4 is the issue, and indeed, it looks like I have an unterminated string here. I need to go ahead and now add this double quote. So let me go ahead now, and with that red herring gone, let me rerun python of name.py and hit enter, and now we see too few arguments. OK, maybe it wants my full name. Let me go ahead now and run python of name.py, David Malin, typing in both words after the name of the file and hit enter. And now, of course, it's too many arguments. Fine, now I'll oblige and do python of name.py and just David, and there we have it, my name tag printed on the screen. So strictly speaking, we don't have to handle exceptions if we can be a little smarter about it and just check for the things that we're worried about, especially if we want to give the user more refined advice. We don't want to just tell them, no, something went wrong, or we don't want to pass. We want to tell them, no, that's too few. Or no, that's too many. We have conditionals in our vocabulary already via which we can now express that. Well, let me pause here and see if there's any questions now on how we handled the error before with the index error, or how now we're just proactively avoiding all index errors altogether by just checking first, is it too few, is it too many, or is it exactly what we want?
Hiya, thank you. So I was wondering, you touched upon kind of using your full name. Could we then, is there a way going forwards that perhaps we have people that want their full names and want just their first name, that we separate that into like, oh, this person has full name, this person has just the one name?
Absolutely, and allow me to propose we come back to that support for multiple names. But indeed, we could do that. And I should note, too, though, we can support full names right now if I do this. Instead of typing in David space Malin, which is problematic because, again, by definition of how argv works, each word ends up in a specific location in the list. But if I add quotes, single quotes or double quotes at the command line, now Python will view this as 2 total things, the name of the file and this full name. And now when I hit enter, I don't see the quotes. The whole thing is passed in as my full name. And if I want to adapt this further for multiple people, we'll be able to do that as well. Other questions now on this version with if, elif, else, or on except before?
Hi, sir. I want to ask you, can we use multiple else statements?
Can you use multiple else's statements? No. Else is the last catch-all statement that you can have. You can have multiple elif statements in the middle, but not multiple else's. All right. All right, well, let's turn our attention back now to this code and see if we can't refine it a bit more by adding in some additional functionality that we get with modules like the sys module. One of the things I don't love about this version of the code, even though arguably it is now correct, is that the essence of my program, which is just to print out the name tag, is kind of relegated to this else clause. And that's fine. Logically, it's correct. But generally speaking, there's something nice about keeping all of your error handling separate from the code that you really care about. Having all of these ifs, elifs, perhaps at the top of your code that are checking to make sure that all of the data is as expected. But then it would be nice, if only for design's sake, not to sort of hide in this else statement the actual code that you care about. I would prefer, for instance, to do something logically like this. I could check for errors up top, and then down here, print the name tags. It would be nice if those are sort of distinct blocks of code, all of which are here left aligned. But there's a problem with what I've just done here. Logically, what bug did I just introduce by getting rid of the else and introducing line 10 on its own with no indentation outside of the conditional? What bug have I just introduced? What mistake, to be clear?
Name error.
Ironically, it's a name error, but not a name error exception. It's an error with my name, but I think you're frozen for me. It's going to raise an exception because even though I'm checking the length of sys.argv up top, and even though I'm checking it again for being greater than 2, not just less than 2, but greater, I'm still then blindly and incorrectly assuming it's now going to exist. So just to be clear, if I run python of name.py and I don't type any arguments, I've got too few, I think I'm going to see that I have too few, but I'm also going to see that same exception. At the very top of my terminal window's output, there's my error message, too few arguments. But again, on line 10, I blindly proceed to still index into my list at location 1, which does not exist. So it turns out there's a better way to handle errors like this, especially if you're writing a program in Python that's just meant to run briefly and then exit anyway. But maybe we could start to exit prematurely if the program itself just can't proceed. If the user has not given us the data we want, perhaps we should just exit the program earlier than we might otherwise. So let me go ahead and do this. Let me go ahead and remove my comments so as to focus only on the code here. And let me propose that instead of just printing quote unquote too few arguments, I'm going to use one other function that comes with the sys module. I'm going to go ahead and call sys.exit. And as the name suggests, it's going to do exactly that. With the system's help, it's going to exit my program then and there on line 4. Why is that OK? Well, if you gave me too few arguments, I have nothing more to say to you, the user. I might as well exit a bit prematurely. And I can do this as well on line 6. Let's go ahead and not just print that, but sys.exit, quote unquote, too many arguments. Print out that message and just exit right there. Now I can trust that by the time I get to line 8, every error condition has been checked for, and so it's safe for me to assume that there is, in fact, an item at location 1 in sys.argv. So let me go ahead now and run this. Python of name.py, enter, too few arguments. But I'm back at my prompt. Nothing more has happened. Let me run it again. Python of name.py, David Malin with no quotes, enter. Too many arguments is now printed here. Finally, Python of name.py, just David, enter. Hello, my name is David. So we have then in sys 2 forms of functionality now. We have access to this variable, sys.argv, this argument vector that gives me all of the words that were typed at the prompt, including the program's own file name. And it turns out, if we read further in the documentation, there's an exit function that can take different types of inputs. But if I pass it a string like this, it will indeed print that string for me and then exit from my program then and there. Questions now on exiting from programs like this. To be clear, all of this time, once Python gets to the bottom of your file, it's going to exit anyway. So I'm using sys.exit now just to make sure that I exit earlier than otherwise.
My question is about the sys.argv. So is that capable of accepting or taking multiple elements at once? Let's say, for example, Python name.py, David Malin, I'm a male, 20 years old. And if, let's say, I only want to access your name, which is at the first index, and then your age is, say, at the 6th index, can I say sys.rv1 and another one for 6 to access what I just want? Is that possible for sys.rv?
Short answer, yes, I think, if I understand your question correctly, whereby you're proposing to have many words at the end of the command, and you want to access those individual words. Absolutely. At some point, it gets a little fragile, I would say, if you're typing so many words at the prompt that the order really matters. And so it turns out there's a lot of programs, and there's functionality in Python that can allow you to provide those values, like name or age or any number of other fields, in any order you want, but pass in a bit more information textually that tells the program how you want to use it. So in short, what you're describing is possible. And let me do a small incarnation of it as follows. Let me propose that we go back to my code here. And let's propose that we actually now want to support multiple values at the prompt. So there's going to be no such thing as too many arguments. Suppose that I want to generate name tags, not just for David, but for David, for Carter, for Rongshin, for others in the group who all want their name tags as well. So I'm going to go ahead and do this. I'm going to get rid of my elif condition because I don't want to limit the maximum number of words that are typed at the prompt anymore. I instead want to iterate over every name at the prompt. So I'm going to say this. For arg in sys.argv, go ahead and print out, this time, arg. So what am I doing here? Well, even though the syntax is a little different, the idea is the same as before when we've had loops. I'm using a for loop to iterate over a list. The list in question here is sys.argv. Arg is a variable that I'm creating on the fly. The for loop is going to make sure that the first time through this loop, arg is set to the first word on the command line. The second time through the loop, Python's going to make sure that arg is now set to the second thing on the command line, and so forth. That's just how a for loop works. It updates the variable for us. I don't have to call it arg. I could call it name, so long as I change it to name in both places. But arg is reasonable if I'm iterating over arguments more generally. If I now run this program, though, unfortunately, there's a little bit of a bug. Even if I type in David and Carter and Rongshin, I'm not going to get just 3 name tags. In your mind, does anyone see the bug I'm about to trip over? It's not a huge deal if I've got enough name tags to go around, but I'm going to be wasting one because this is going to print not 3 but 4 name tags, whereby the first contains the name of the program itself. Maybe not a big deal. Maybe that's the sticker we don't bother handing out, but it's wasteful and it does look wrong. So how could we get access to not all 4 elements of argv, but just a slice of argv? And this is actually a technical term. In Python and some other languages, to take a slice of a list means to take a subset of it. Maybe from the beginning, maybe the middle, maybe the end. But a slice is a subset of a data structure like a list. Well, how do I actually do this in code? Well, in Python, it's actually very easy to take a slice of a list, that is a subset thereof. You can simply do this. At the end of the list name, sys.argv in this case, you can use square brackets. And then in those square brackets, you can specify the start and the end of the list that you want to retain. I want to start at element 1, not 0. I want to start at element 1, and I want to just go to the end. So I'm actually going to omit a second number altogether. It's not necessary to have a second number, but I do need that colon because this is going to give me a slice of the list. It's going to give me a slice of the list that starts at location 1, not 0, and the colon and then a blank just means it's going to give me everything else. So this is equivalently going to slice off the first element of the list and give me a new list that contains just those 3 human names, not the name of the file itself. Let me try running this again. I'm going to run Python of name.py, David, Carter, Rongshin. This time, hopefully, I'm going to get 3 and only 3 name tags. Hitting enter, and indeed, I've done now just this. So again, using some relatively simple syntax in Python, we can use square brackets not just to go to specific elements like bracket 0 or bracket 1. We can also get subsets of the list, slices of the list, by doing bracket something colon something, where each of those somethings is a number, the beginning or the end, and they're optional, depending on whether you want all of them or just some. Any questions now on this version, which adds the loop and these slices with that new syntax?
Can we slice starting from the end of the argument vector?
You can. You can slice something from the end of the argument vector, and this might blow one's mind a little bit. Let me go ahead and do this. Let's see. Let me go ahead and do -1 at the end, using a negative number here and running the same command. We've just uninvited Rongshin from receiving a name tag here. So if you use a negative number, it has the effect of counting to the in the other direction from the end of the list. A good question there. Other questions now on slices, on looping over sys.argv.
Hi. So I remember very early on when we were talking about only having 2 decimal places in float value. Does this is that in the same vein? Like because we use the colon point to f. So is that the same thing then? Why would the f be included then in the point to f as opposed to here when you just have the numbers?
A really good question, and it's just the short answer is that context matters. So there's only so many keys on our keyboard, and so we sometimes use the same symbols for different things. So what you're alluding to is the format code in F-string for actually formatting a number, using a colon, using a period, using a number, using the letter F, and so forth. And that is very specific to the F-string feature of Python. This case has nothing to do with any of that syntax per se. This is just using a colon in a different context to solve this problem, to implement a slice. The authors of Python could have chosen another symbol, but honestly, looking down at my keyboard here, we don't have that many to choose from that are easy to type, so sometimes they have different meanings. A good question as well. Allow me to propose now that we take things further and move away from using only those modules, those libraries that Python comes with, to talk about more generally packages that exist. One of the reasons that Python is so popular and powerful these days is that there's a lot of third-party libraries out there as well, otherwise known as packages. Strictly speaking, Python itself has a term of art called a package, which is a module, essentially, that's implemented in a folder. Not just a file, but a folder. But more generally, a package is a third-party library that I can install on our own Mac or PC or our cloud server and gain access to even more functionality that other people have implemented for us. Now, one of the locations you can get all of these packages is called the PyPI website, the Python Package Index, which lives at this URL here. And this is a website that is searchable via the command line as well as via the web that allows you to download and install all sorts of packages. Even CS50 has some of its own packages in services like these. Now, there's a fun one out there that's a throwback to a command that's been around for years in command line environments called cow_say. Cow_say is a package in Python that allows you to have a cow say something on your screen. If curious to read up on it, its own documentation is on pypi.org, specifically at this URL here. But how do you actually get the package into your system? Well, technically, you could figure out how to download the file and maybe unzip it and put it into the right location on your Mac or PC. But nowadays, a lot of languages, Python among them, has what's called its own package manager. This one here called pip, which is just one. So pip is a program that generally comes with Python itself nowadays that allows you to install packages onto your own Macs or PCs or cloud environment by just running a command. And then voila, you have access to a whole new library in Python that didn't come with Python itself, but now it's available on your system for you. Let's go back to VS Code here. And in my terminal window, I'm going to go ahead and type pip install cow_say. Now, what's going on here? Pip is the command, the package manager, and I want to install what package? The package called cow_say. I'm going to go ahead and hit enter here, and after a little bit of output, it has successfully installed cow_say. Now, what does that mean? That means I can now go about importing this into my own code. Well, let's go ahead and see what this means. Let me go ahead and create a new file with code called say.py, because I want something to be said on the screen. And in my new tab here, I'm going to go ahead and import cow_say, which presumably is now installed. I'm now going to import sys as well, because I'd like to use some command line arguments in this program just so that I can run it quickly. And without using the input function, I can get the user's name immediately from the prompt. And let me go ahead and do this. I'm going to do a bit of error checking proactively this time. And rather than use less than or greater than, I'm this time going to say if the length of sys.argv does equal 2. So if the human is provided just the name of the program and their own first name, we're good to go. I'm going to do the following. I'm going to call a function called cow in the package called cow_say, and I'm going to pass in a string, hello, comma, and then, as in the past, I'm going to pass in just one string, because according to its documentation, it's not like print. I can't pass in comma this, comma that. I can only pass in one string, so I'm going to concatenate the contents of sys.argv bracket 1. So long as then I type in my name, David, after the name of this program, it should end up in sys.argv1, in which case this line 5 of code should concatenate hello with my name, with a space in between, and apparently a cow is going to say it. So let's see what happens here. Let me go ahead and clear my screen and increase the size of my terminal window. Let me go ahead and run python of say.py and type my name, David, and enter. There is the program called cow_say. It literally has a cow say something on the screen. And this is a throwback to a program from yesteryear that tended to come with a lot of systems. This is otherwise known as ASCII art. It's a textual way using just keys on your keyboard to print pictures of sorts on the screen. Now, we can really go down the rabbit hole here, and there's questionable academic value of doing so, so I'll do so just once. Turns out the cow_say package comes with other functions as well. One of those functions, for instance, is trex. And if I now increase the size of my terminal window, we'll perhaps see where we're going with this. Let me now run again, python of say.py. This time, let me not provide my name just to see if it's broken. It's still OK, because we have that if condition. If the length of sys.argv equals 2, and only if it equals 2 do we do anything. That's why we're not seeing anything here. Let me go ahead and cooperate now. Say.py space David. And it's no longer a cow, but if I zoom out on my screen, a T-Rex. Why? Just because. These are the things you can do once you know how to program. You can even package them up and make them freely available to others as open source software. For us, it's demonstrative of a feature more generally here, namely being able to install these third-party packages and how you might do so in Python. Now, I'll leave this up on the screen for a moment and see if there's any questions about cows or Tyrannosaurus rexes or packages more generally. I'm really qualified to speak to just one of those.
Hi, I've got two questions. It's a bit earlier than what's supposed to be. So the first question is, the packages that you're calling to use in the program, are they the same as, let's say, because I'm doing Java, the same as calling a class of a Java file in order to use its functions? And my second question is, what's the actual purpose of using command line arguments as you use? Because it's not really the best way to, as you say, be user friendly, where, as in, let's say the person who's using the program doesn't know what they want, what the program's asking them.
Really good questions. The first question about the comparison with Java. Python packages are similar to Java packages, where you have something dot something dot something at the top of your program that gives you access to a class or something else. Python itself supports classes, more on those down the road, and you can do very similar things in Python as you can do with Java. But the analog really is Python packages to Java packages here. As for command line arguments, you ask a good question. Why do we use them, especially if they're a little less user-friendly? They're a little less user-friendly to people who aren't in this Zoom, to be honest. You and I, as we learn more and more about programming and more about command line arguments, I dare say will become more comfortable with and tend to prefer the ability to customize commands using these command line arguments. Why? Productivity. It tends to make you faster because you get into the habit of knowing exactly how you can configure your software without having to manually answer questions. And case in point, all of this time have we been running python of something.py. You could imagine not doing that. You could imagine typing only Python, hitting enter, and then you're prompted for the name of the file you want to run. So you type in something.py, and then it runs. Not a big deal, but I would argue that over time, you're going to get a little tired of that tedium, and you would much prefer to just automate the command again and again and again, especially with little conveniences like being able to hit up and down in your keyboard history so as to rerun those same commands. Automation is big too. If you emerge from a class like this and start using Python to automate processes at work or for personal projects or the like, the ability to specify all of your inputs on the one line just means you can get work done more quickly. So hands down, absolutely, using command line arguments is a more arcane feature of systems that most of us are no longer as familiar with because of Windows and Mac OS and other operating systems that have buttons and GUIs and menus. But the more comfortable you get with programming, I dare say the more you will tend to prefer these capabilities because they allow you to do things more quickly. With that said, allow me to propose that we take a turn toward yet another package that's particularly popular and just as easy to install, all toward an end of using APIs. Now, APIs are not something that's Python specific. More generally, an API is an application programming interface, and it can refer to Python files and functions, but often APIs really refer to third-party services that you and I can write code that talk to. Many APIs, but not all, live on the internet these days, so that so long as you have a browser or so long as you have some experience with Python programming or programming in any language, you can write code that in effect pretends to be a browser, connects to that third-party API on a server, and downloads download some data that you can then incorporate into your own program. Now, how do you do this? Well, Python has a very popular package that you can install via pip called requests. The requests library allows you to make web requests, internet requests, using Python code, essentially as though you were a browser yourself. You can automate, therefore, the retrieval of URLs that start with HTTP or HTTPS. The documentation for this library is that a URL like this, but it too can be installed at the command line. And even though it's third party, it's one of the most popular and commonly used packages out there in Python. And this too is one of the reasons, again, that Python is so popular. There's just so many solutions to problems that you and I have or are invariably going to have when we write projects of our own. There's just a really vibrant ecosystem, a really vibrant community of open source software that's that easy for us to install. Let me go back to my terminal window now and run pip install requests in order to install this package on my own system. And after some lines of output, I'll see that it's successfully installed. Now let's go ahead and create a new file here. For instance, iTunes.py. It turns out that Apple has its own API for their iTunes service, the software that provides you with the ability to download and search for music and songs and other information as well. And it turns out that, let me go back over to my computer here and open up a browser like Chrome. And let me go ahead and visit this URL here, https://itunes.apple.com/search, !entity equals song, ampersand, limit equals 1, ampersand, term equals Weezer. Now, I constructed this URL manually by reading the documentation for Apple's API, Application Programming Interface for iTunes. And what they told me is that if I want to search for information about songs in their database, I should specify entity equals song, so that it's songs and not albums or artists or something like that. If I just want to get back information on one song, I'm going to provide limit equals 1. And if the band I want to search for, the artist, is Weezer, I should specify term equals Weezer. So with this, if I go ahead and hit enter and visit this URL, I actually end up with a text file in my downloads folder on my Mac. If I go ahead and open that text file that my browser just downloaded, we'll see all of this text here, which at first glance might look a bit cryptic, but it actually follows a pattern. Notice this curly brace at the start, and notice this closed curly brace at the end. Notice this open square bracket here, and notice this closed square bracket here. And in between those pieces of syntax are a whole bunch of strings and values. In fact, a whole bunch of key value pairs. What we're looking at here is a standard text format known as JSON, JavaScript Object Notation, which, yes, is technically related to yet another programming language called JavaScript, but JSON itself is typically used nowadays as a language agnostic format for exchanging data between computers. By language agnostic, I mean you don't have to use JavaScript. You can use Python or any other language to read JSON or write it as well. And it's a completely text-based format, which means that if I visit that URL with my browser, what gets downloaded is just a bunch of text, but that text is formatted in a standard way using curly braces and square brackets, using quotes and some colons that ultimately contains all of the information in Apple's database on Weezer's song, at least the first one, because I limited it to one, in their database. And that's an API, an application programming interface, a mechanism whereby I can access data on someone else's server and somehow integrate it into my own program. Now, of course, my browser, Chrome, is not something I wrote. I should actually write some Python code that perhaps pretends to be a browser to grab this same data. So let's do that. Let me go back to VS Code here, and let me write a program with code itunes.py. And we're going to write some code via which I can then use the iTunes API and in turn Python to get information about any band that I might want. I'm going to go here and import first the requests library, which I installed earlier in order to make those HTTP requests. I'm going to go ahead and import the sys library, via which I'll have the ability to use command line arguments like specification of the band that I want to search for, if not Weezer. And then down here, I'm going to go ahead and insert some error checking to say if the length of sys.argv does not equal 2, so if the user does not provide me with the name of the file they want to run and the name of a band, and that's it, you know what, let's just go ahead and exit for now. I could provide a more explanatory message, but for now I'm going to keep things simple and just exit the program prematurely so that I can trust hereafter that sys.argv has what I want. And now I have the opportunity to use the requests library to write some Python code that effectively is pretending to be a web browser so as to connect to that same HTTPS URL on Apple's own server. So now that I've guaranteed that the user has typed in not just the name of the file, but also the name of a band at the prompt, giving me a length of 2 for sys.argv, let's go ahead and execute requests.get, which is a function inside of the requests package that will literally get some response from a server. And the URL that I want to get is exactly the same as before, https://itunes.apple.com/search, entity equals song, ampersand, limit equals 1, ampersand, term equals previously Weezer. But let's make this program a little interactive and actually allow the human to specify at the command line what artist they'd like to search for. So I'm going to go ahead and close my quote early and just append, using the concatenation operator as in the past, sys.argv bracket 1. And now it'd actually be nice to store the response from the server in a variable. So I'm going to go ahead and say response equals, and to store all of the response that comes back from the server in a variable called response. Down here now, I'd like to just understand what the server is returning to me to make sure I know how next to proceed. So this isn't going to be very pretty yet, but I'm going to go ahead and print out response.json, which ensures that the data I'm getting back is formatted on my screen as exactly that, JSON, the same text format as we saw on my screen. It's not a useful program yet. I'm really just learning along the way. But let me go ahead now and increase the size of my terminal window and run Python of itunes.py and type in the name of a band like Weezer and hit enter. And what we see on the screen, formatted almost the same as before, is exactly that same text. But what you'll see here is that this has been standardized now as a Python dictionary. What indeed Apple's returning is technically a JSON response, JavaScript object notation. But Python, the requests library, is converting it to a Python dictionary, which happens to use, wonderfully coincidentally, almost the same syntax. It uses curly braces to represent the dictionary here, and a closed curly brace to represent the end of it here. For any lists therein, it uses a square bracket here and a closed square bracket down here. It uses quotes, single quotes in this case, or equivalently double quotes to represent the keys in that dictionary. And after a colon, it stores the value of that key. And so you'll see that indeed we have a result count key whose value is 1, but then a more interesting result key called results, whose value is this entire list of data. Now, honestly, this is such a big blob of text that it's going to take me forever to wrap my mind around what I'm seeing. So let me propose temporarily we use another library in Python that will allow me to format my data a little more cleanly. It turns out that Python also comes with a special library called JSON that allows you to manipulate JSON data and even just print it. That is, format it in a way that's going to be way easier for you and I to understand. So let me go back to my code here. Let me shrink my terminal window. And let me propose that just temporarily, again, we do this. Let me import this additional library, JSON, which comes with Python. So I don't need to install it manually with pip. And let me go ahead now and not just print out response.json, which was that big blob of hard to understand text. Let me go ahead and use one other function here called json.dumps for dump string, and pass to that function that response.json return value. So again, I'm just introducing another function who I claim it has a purpose in life of pretty printing, nicely formatting on the screen the exact same information. And I know this from the documentation, having done this before. But I'd like things to be nicely indented. And according to the documentation, if I pass in a named parameter of indent equals 2, that's going to indent everything at least 2 spaces. I could do 4 or something else, but it's going to be enough to help me wrap my mind around what the data is I'm getting back. Because again, I'm just learning along with you. So let me increase the size of my terminal window again. Let me run Python of itunes.py. And again, let's search for Weezer and hit enter. And now notice it's still a little bit cryptic because there's a lot going on here. But my gosh, I can totally read this more easily now. Notice now that I still see the first curly brace, which means, hey, this is a dictionary in Python, a collection of keys and values. The first key is called result count. It happens to be displayed in double quotes now, but that's just an issue of formatting. It could be double or single so long as we're consistent. The value of that key is 1. Why? Well, I told the URL to only limit the responses to 1 Weezer song, so I've gotten a result set of 1. If I increase that limit, I could probably get more. Then the interesting part of this response is really the data itself. Notice in the results key here, there's a really big value. The value is a Python list as implied by this square bracket. What does this list contain? Well, I know from skimming it earlier that this contains one dictionary, and that's why we see another curly brace here. So again, if this gets a little more complicated, keep in mind that a dictionary is just a collection of key value pairs, and Python uses curly braces to indicate as much. It is perfectly reasonable for a dictionary to be inside of another dictionary if the value of some key itself is another dictionary. So this is a common paradigm, and even though it might seem a bit cryptic, it's just something that allows us to associate more keys with more values. Now, most of this information I probably don't care about. For instance, according to Apple, the unique identifier for Weezer is apparently 115,234. That might be useful if I'm making my own database and I want this to be searchable, but for today's purposes, all I care about is the name of the track, otherwise called track name as key. And the first song, and only song, because we limited it to one, that we got back from iTunes here is the song that you might know by Weezer called Say It Ain't So. So now I have a bit of a clue. If my goal here is to implement a program called itunes.py that doesn't just dump the response from the server, which is admittedly very cryptic, but to print out all of the songs that iTunes has for the band called Weezer, maybe I can iterate over this somehow. So let me backtrack. Here's the key called track name. It is inside of a dictionary that is the value of results here. So how can I go about getting this? Well, let me go ahead and try this. Let me go ahead and shrink my terminal window back down. And let me propose now for one final flourish, we don't just lazily print out the contents of that response, because that's not interesting or pretty for anyone. Let's do this. Let me go ahead and create a new variable, just for the sake of discussion, called O for object. And I'm going to go ahead and call O equals response.json, just to store that JSON response specifically in a variable called O, but I could name it anything I want. And now I'm going to do this. For each result in that object's key called results, go ahead and print out that result's track name. And notice I have used exactly the same capitalization. Track name has a capital N. Results is all lowercase. And let me rewind before we run the actual program. In line 8, we are making an HTTP request using Python to the server, just like you and I as humans type URLs into a browser and hit enter. This is the Python equivalent thereof. I am then on line 10 just grabbing from that variable that contains the server's response the JSON object that I care about, the thing between those curly braces at the very top and the bottom. But because we've poked around and because I read the documentation earlier, I know that that object has a key called results. And that results key, again, is a list. Now, at the moment, that list contains only one song, Say It Ain't So, because I limited my response to one. But even so, my loop will work. It's just going to iterate once. And each time through that loop, it's going to print the current results track name. If I want to make this even more interesting, let me change this limit now from 1 to 50, so I'll at least get back 50 track names instead. Let me go ahead now and increase the size of my terminal once more and go ahead now and run Python of itunes.py, searching again for a band like Weezer. And here we go. And voila, there are 50 songs that iTunes has for Weezer. And if we scroll back up to the top here, we'll see that the very first one there is indeed Say It Ain't So, but now we got Undone, the Sweater Song, Buddy Holly, apparently another rendition of Say It Ain't So, perhaps from another album, another Buddy Holly, Undone, My Name is Jonas, and so forth. Questions now on this program, which integrates Python with a real-world third-party API.
Yeah, hi. Can we use break instead of system.exit?
Good question, but no. Break, again, is used to break out of things like loops, like we saw earlier. Sys.exit is used to break out of the whole program itself. Use break for loops for now, and use sys.exit to terminate the whole program. Good question. Other questions now on this program or others?
From where we bring the name of the key results.
From where do we get the name of the key?
Results itself. يعني can we change the results name
You cannot. So we could in our program. So the keys that come back in that JSON response, to be clear, come from itunes.apple.com. Some engineer, some team of engineers decided for us what all of those keys would be called, including track name, results, result count, and everything else. You and I can absolutely store those same values in variables, just like I'm doing here with O, just like I'm doing here with result. You can rename those keys anything you want using Python variables, but the JSON response is coming from that third-party server. Other questions?
Yes, sir. So I have a question related to cowsay package. So like, yes. So sir, what sort of ASCII graphics is it capable of outputting?
The cowsay package. I would refer you to the URL in the slides earlier, if only because it's more thorough. They have not just cows, but Tyrannosaurus rexes and several other animals as well. I should emphasize that this is not a package I suspect you will use much in the real world. It's really just meant to be representative of the types of packages you can install. But allow me to refer to the documentation for what more is there. But ASCII art is all we had before there were emojis, let alone GIFs and JPEGs and pings. But it's what is immortalized in cowsay. Well, allow me to transition us back now to one final capability of Python, which is that you yourselves have the ability to make your own libraries. Up until now, we've been writing all of our functions in our one file, hello Py and everything since. And now that we've introduced modules in Python, like random and statistics, we can import those that come with Python, but that's other people's code as well. And we've now used pip, this package manager, to install third-party packages as well in the system, and using other people's code still. But to come full circle, what if you yourself find yourself implementing the same kinds of functions again and again? Or you find yourself opening up old programs, copying and pasting code you wrote into new programs because you have the same problem yet again. A good practice would be to somehow bundle up that code you keep reusing and make your own Python module or package. You can keep it local on your own Mac or PC or cloud server, or you can go through the steps of actually bundling it up, making it free and open source, and putting it on something like PyPI for others to use as well. OK, I'm going to go ahead and run code of sayings.py to create a brand new file called sayings.py, which is going to be my own sayings module. And I'm going to define a couple of simple functions in there. I'm going to define a hello function that's going to take a name parameter as input. And that function is simply going to print out an f string that contains hello, comma, and then in curly braces, whatever that person's name actually is. Then I'm going to go ahead and define one other function, a goodbye function, that has def goodbye, also takes a name as its input, and then that prints out by contrast an f string that says goodbye, comma, and then in curly braces, name. And now, just for good measure, just so I can be sure that these functions are working as expected, I'm going to go ahead and define a main function in here too, just for the purposes of testing. And I'm going to go ahead and define a main function that simply does a couple of tests. For instance, it calls hello of quote unquote worlds, shall we say. And then it's going to call goodbye of quote unquote world as well. And hopefully what I'll see on the screen then is hello world and goodbye world when I run this program. Of course, as always, I need to explicitly tell Python to call that function. So I'm going to call main at the very bottom of this file. All right, let's try it out. Python of sayings.py, enter. And indeed, I see hello world and goodbye world. And so I think it's reasonable for me to assume that these functions, albeit simple, are pretty correct at this point. But now suppose that I want to use these functions as though I've indeed created my own library, my own Python module that makes available a hello function for me or anyone else who wants to use it, or a goodbye function as well. Well, let me go ahead and open up, again, say.py, but start fresh. And rather than have the cow say anything, let me go ahead and have my own library do the talking. So I'm going to go ahead and, as before, import sys so that I have access to command line arguments. And from my own module called sayings, I'm going to import hello. So because I created a file called sayings.py, I can say from sayings, and it's inferred by Python that I mean sayings.py, at least in this current directory. But I specifically am going to import just one of the functions for now, namely hello. And now I can do something like this. If the user obliges by giving me 2 command line arguments, which I can check by just checking the length of sys.argv, I'm going to then go ahead and call this new hello function, passing as its input sys.argv bracket 1, which should hopefully be the person's name, which I'm going to expect them to type at the prompt. So here we go. I'm going to go down to my terminal window, run python of say.py, and my own name, because I want my own name to end up in the command line arguments and therefore be part of the hello. So when I hit enter in just a moment, I should hopefully see hello, comma, David. So here we go. Enter. And I see hello world, goodbye world, and then I see hello David. So why is this happening? Well, it turns out, even though I've done everything according to our own past practice, it's not really the right way to go about calling main after all. If I'm blindly calling main here at the bottom of my file, that means whenever this file is loaded by Python, main is going to get called. And unfortunately, that's true even if I'm importing this file or just a function from this file, as I am here in my say.py program. This is to say on line 3 here, when I say from sayings import hello, this effectively tells Python to go find that module, sayings.py, read it from top to bottom, left to right, and then import specifically the hello function. Unfortunately, by the time Python has read the file from top to bottom, left to right, that last line of code recall is to call main. Main gets called no matter what. So really, the right way to go about using a main function, which does solve that problem of ensuring that we can order our functions however we want, and all the functions will be defined at the time they're invoked, I shouldn't be unconditionally calling main at the bottom of this or really any of my programs. I should instead use this technique. I should say if underscore underscore name underscore underscore equals equals quote unquote underscore underscore main underscore underscore close quote, then and only then should you actually call main. Well, it turns out that this variable is a special symbol in Python, underscore underscore name underscore underscore. And notice that VS Code, because of its font, isn't quite showing those two underscores, but they're indeed there to the left and the right. This is a special variable whose value is automatically set by Python to be quote unquote main when you run a file from the command line, as by running python of sayings.py. So watch what happens now with this additional conditional in sayings.py. If I run python of sayings.py, it still works as before, because name will be automatically set to underscore underscore main underscore underscore when I run this file using python of sayings.py. But notice this. Name is not going to be set to quote unquote main. It's going to be set to something else, technically the name of the module, when I instead import the file like I do here. So this highlighted line of code, even though it will cause Python to go find sayings.py, read it from top to bottom, left to right, it's going to ignore the call to main this time because it's wrapped in that conditional. In this case, when I'm importing a file and not running it directly at the command line, main will not get called by definition of that name's value. So let me go ahead and try this. Instead of running python of sayings.py, which is the module which contains that conditional main, let me go ahead here and run python of say.py, which is the program here before me that imports hello from sayings. But because of that conditional, it's not going to say hello to anyone else except me in this case. All right, we're here at the end of our week. It's only appropriate, I think, to import something other than hello. Why don't I go ahead and import not hello, but goodbye from here? Let me go ahead and call goodbye instead of hello. And this time when I run python of say.py, I'm not going to type my own name. Allow me, if I may, to type in the whole world so that our final sentiment today is goodbye world. Indeed, that's it for this week. We will see you next time. All right, this is CS50's Introduction to Programming with Python. My name is David Malin, and this is our week on unit tests. Up until now, we've been writing a lot of code, and you might have been testing your code by running your program and passing in some sample inputs, and running it again and passing in some sample inputs, or you might have been waiting for us to test your code instead. But it's actually much better practice to get into the habit sooner rather than later of testing your own code using code of your own. In fact, whether you're writing a personal project or working in industry, industry, it's very common nowadays to not only write code to solve the problems that you want to solve, but also to write a little extra code to test the code that you wrote. And that's what we're going to focus on today, writing our own tests so as to be all the more confident, all the more certain that the problems we have been trying to solve are in fact solved correctly. So let's rewind a few weeks now to a program we wrote a while back, namely to calculate numbers. And specifically, we left off with this calculator on trying to compute the power of a number, like x squared, or where x might be 2 or 3 or some other number as well. Well, let me go ahead and resurrect that file by going into my terminal window here and running again code of calculator.py. And let me go ahead and pick up where we left off way back when by defining a main function here. And then in my main function, I did something like this. I said x equals int of input, and I asked the user, what's x, question mark. And then I immediately went ahead and printed out something like x squared is, and then I passed in as a second argument to print the result of calling a function called square, passing in that value x. Now, of course, I haven't yet implemented the square function, so let's define that as well. Let me go down a couple of lines and define square. And it takes an argument, recall, a parameter that at the time I called n for number. So I'll do that again, though I could technically choose any name for this variable. And I recall did this. I returned n times n. And there were multiple ways to do this. The squaring a number is multiplying it by itself. So I could also use other syntax here, but this is what we ultimately settled on. And then recall that I ultimately called main in order to kick off the process of running this program. So just as a test manually, let me go ahead and run Python of calculator.py and hit enter. What's x? Let's start with 2. All right, x squared is 4. I think that's correct. So let's run it again just for good measure. Python of calculator.py. Let's type in 3 for x this time. X squared is 9. And I think that's correct. And I might be feeling pretty good at this point, and I go off and submit my code to a course, or I post it on the internet for others to use. But I haven't really methodically tested this code. And it's not necessarily the case that it works entirely. In fact, I haven't really considered a number of corner cases. I went with some pretty obvious numbers like 2 and 3. But what about 0? What about negative numbers? What about any number of other infinite numbers? Well, we're not going to test an infinite number of inputs to this because the program would never halt. But we should test some representative inputs ultimately. But before we do that, let's get into the habit of making sure that main isn't always called. Let's adopt this habit again of doing if underscore underscore name underscore underscore equals equals quote unquote underscore underscore main underscore underscore. Only then should we execute main. And I'm doing this now proactively because I want to make sure that when I import my square function, perhaps from another library, from another file, treating it as though it's a library, I want to make sure that main is not just automatically called itself. Now, what do I want to do from here? Now that I've modified this program as follows, well, let's go ahead and write a completely different program whose sole purpose in life is to now test this program. So I've got my actual calculator in calculator.py. I've readied myself to call main conditionally so that I can safely import one or more things from this file in another file. Well, what should that other file be? Well, by convention, I'm going to create a file that's called test underscore. And then because the thing I'm testing is the calculator itself, let's call this file testcalculator.py. That's going to give me a new tab in which I can write a brand new program whose purpose in life is now specifically to test that program, but really that program's specific functionality. Built into that program is the square function. Let's focus on testing that function. All right, so how do I access that function in this program? Well, recall that I can import a function from another file as though it's a library of my own, a so-called module. So I'm going to do this. From calculator, import square. I could go ahead and just import square itself, but then I would have to prefix my use of square, recall, by saying calculator dot everywhere. And it's just a little cleaner to just import the one function. And now let me go ahead and do this. Let me go ahead and define a function called test square. This, too, is a convention. If you want to test a function called square, your function for testing should be called test underscore square. Or alternatively, you could do square underscore test, but I'll adopt this convention here. Now, what kind of tests can we do? Well, I don't dislike the tests I ran earlier, testing x equals 2 and x equals 3. But every time I want to test my program previously, I would have to do that manually. And that's going to get tedious. It's not going to be easy for someone else to test it. And if I'm actually working in the real world, it would be nice if I could automatically have my program tested again and again by having some automated process run my own code. So let's do that and take the human ultimately out of the equation. So how might I go about testing the square function that I've now imported per line 1? Well, in my test square function, why don't I do this? If the result of calling square of 2 does not equal 4, why don't we go ahead and print an error message? Because I know that in the real world, 2 squared should equal 4. So if square of 2 does not equal 4, there's a bug in my program. There's a bug in my function. I've made a mistake. So let me go ahead and print something like that so I or someone else knows 2 squared was not 4, for instance. So I could print out anything here. What should I maybe next test? Well, let's do more than one test. Let's say if the square of 3 does not equal 3 squared 9, then let's go ahead and print out that 3 squared was not 9. So I haven't done any more testing than I did earlier, but I've baked those two tests, x equals 2 and x equals 3, into my own code here, so I can now run those tests automatically, if you will. Now, it's not enough to just define a function called test square. I actually, if I want to run this function, need to call it somehow. And our convention for doing that is the same as always. In this function here, in this file too, let me define main. And main's sole purpose in life is going to be to test square. And now at the bottom of this file, as before, let me go ahead and adopt my convention of if underscore underscore name underscore underscore equals equals quote unquote underscore underscore main underscore underscore, then go ahead and call main. So a lot of this is just boilerplate. Like we've seen this before, defining a main function and calling a function to kick off some process. Now adding the conditional at the bottom of the file to make sure I'm only conditionally calling main just in case I import anything from this file elsewhere. So let's see. Let's go ahead and test my code now. Let me go ahead and run test calculator with Python and hit enter, and nothing outputs. Nothing outputs. But I think it's OK. I think no output is good because look at my test square function. I'm not printing anything if all seems well. So let's demonstrate as much by going back to my calculator and let me break it. Let me introduce a bug. Maybe I didn't even get it right the first time. Maybe my code originally looked like this. I wasn't thinking. I forgot my squares. And so I thought that the square of a number is n plus n instead of n times n. So a reasonable mistake to make, perhaps arithmetically. Let me now go back to my test calculator, which I'm not going to change, but I am going to rerun it. Python of testcalculator.py. I'm going to cross my fingers here, but for naught, I'm going to see immediately that 3 squared was not 9. Now, what is it? Well, let's see. When your tests fail, how can we put our finger on what's wrong? Well, it's a little interesting that I completely broke my square function, and yet only one of these tests is failing. It looks like this test, lines 9 and 10, is fine because I'm not seeing that output. But of course, these two lines, this test is failing because 3 squared is not 9 when I'm using plus. So just to be clear here, why is my function only partially broken? Just to be clear, why am I seeing only one error instead of 2, even though the square function is now mathematically broken?
Because 2 plus 2 is 4. No.
Yeah, I mean, it's as simple as that. I just got lucky that 2 plus 2 is the same thing as 2 times 2. So this is one of those corner cases. And this is why it's good to be in the habit of not just testing one thing, but test several and make sure you're covering your bases, so to speak. So I got lucky here, and that explains why I'm seeing only one error, even though the function itself is flawed. But let me propose that there's another way we could do this, because honestly, if I extrapolate from this simple example running not just 2 tests, but 3 or 4 or 10 or 20 tests, you can imagine that, my God, the code is going to get so much more complicated than the function itself. I mean, already, look, in calculator.py, the function in question is 2 lines long. And yet in test calculator, the code in question is 5 lines long. Like, I've written more code to test my code than I actually wrote original code. So the fewer lines of code we can write when testing code, I think the more likely you and I are to do it, because it's going to be literally a little less work and just fewer opportunities for mistakes. So what's another approach I can take here? Well, it turns out in Python, there is another keyword that we haven't yet used, which is this here, assert. Assert is a keyword in Python and some other languages as well that allow you to do exactly that as in English, to assert that something is true, to sort of boldly claim that something is true. And if it is, nothing's going to happen. No errors are going to appear on the screen. But if you assert something in Python and it is not true, that is, the thing you're asserting, a Boolean expression, is false, you're actually going to see some kind of error on the screen. So let's go ahead and try this new keyword as follows. Let me go back to my code here. And just to make it a little simpler, let me propose that I use this new keyword as follows. Let me simply assert that the square of 2 should equal 4. So I've changed my logic. Instead of checking for not equals, I'm now asserting very loudly that it should equal 4. And then on one additional line, let me do the other test, assert that the square of 3 equals 9. And that's it. No if, no indented print. I'm just going to assert more simply these two things that I want to be true. Well, let me go ahead now with calculator.py still broken. I'm still using plus accidentally instead of multiplication. Let me go ahead now and run Python of testcalculator.py. Crossing my fingers as always, but it's not going to go well this time. A whole lot of errors seem to appear on the screen. And if I scroll up here for this traceback, we'll see that the thing that failed was this line here. Assert square of 3 equals 9. Now, unfortunately, when you're using the assert keyword, it's not terribly user-friendly. It shows you the files and the line numbers involved, but it does show you the specific line of code that failed, the assertion that failed, so to speak. It's now kind of up to you and me to infer from this, well, wait a minute, why is the square of 3 not equal to 9? So it's not super user-friendly, but honestly, it was like half as much code for me to write. It's just 2 lines instead of those previous 4. But notice this. Little remnant down here, this was an assertion error. And we have seen errors before. We've seen errors before when we've made other mistakes in our code. And in the past, what was our solution for catching those errors? How do we catch errors that seem to resemble this, even though we've not seen this one before?
Try and accept.
Yeah, in Python, we can use the try and accept keywords to try to do something optimistically, except if something goes wrong, do something else instead. So this is a step forward in that I can at least catch this error, but it's going to be perhaps a step backward in that I'm going to end up writing, I'll admit in advance, a little more code instead. So let me go ahead and try this. Let me go back into my code here, and instead of just asserting blindly, let me go ahead as Tolu proposed and try to do this first assertion, except if there is an assertion error, like we saw a moment ago, then go ahead and print out something more user-friendly that explains what actually failed. 2 squared was not 4. And let me go ahead similarly and try to assert that the square of 3 equals 9, except if there's an assertion error there, in which case I'm going to print out more user-friendly. 3 squared was not 9. So I've taken a step forward, but also a step back, because now I have more code, but I have at least introduced assertions and exceptions in a manner consistent with how we've seen in the past. When something goes wrong, you actually see an exception raised. Well, let me go ahead and run this version of the program now instead. Python of testcalculator.py, crossing my fingers. All right. It still failed because I'm seeing output, but we're back to at least user-friendly output. So that's at least progress in some way here. But it's, again, more code than might have been ideal. And in fact, if we continue this further, what if we actually want to add additional test cases here as well? Well, it seems like we might end up writing way more code than would be ideal. For instance, I'm testing 2 and 3 now. I should probably test some negative numbers as well. So why don't I go ahead and add in, for instance, let me go ahead and copy and paste this. Let me try to assert that the square of -2 equals 4, which should be the case mathematically. And if not, let me go ahead and change this to say -2 squared was not 4. And you know what? Let me go ahead and copy paste this again, test another negative number just for good measure. Let's test the square of -3, which should equal 9. But if it doesn't, let's go ahead and say that -3 squared was not 9. And just to think aloud here, what might be another good value to test? I've tried 2, I've tried 3, I've tried -2, I've tried -3. I can't try in infinite numbers, but there's at least something that's a little different in between those values. Let's try 0. 0 is an interesting case too, just in case something might be wrong. And why 0? I'm just going with instincts here, right? Odds are positive numbers are generally going to behave the same. Negative numbers might generally behave the same. 0 might be a little anomalous. There's no science to it necessarily, but rather considering for yourself based on your own experience, like what are the potential corner cases based on the function you're trying to test. I'm trying to test something mathematical, so I want to test representative values. So let me go ahead and paste in one more try except block. Let's assert that the square of 0 should equal 0. And if not, I'll say something explanatory like 0 squared was not 0. Now if I go ahead and run this, Python of testcalculator.py, and hit enter, now I see multiple errors. And this is interesting. It's a bit of a clue because notice that some, but not all of these assertions are failing. The one for 2 squared is apparently OK, as we noted earlier. Recall that 2 squared happens to be 2 plus 2, so that bug doesn't really throw off our test. But it's a good thing we tested for 3. It's a good thing we tested for -2 and -3 because all of those tests caught this error. The 0 test did not notice because 0 squared is, of course, 0, but 0 plus 0 is 0. So we're getting lucky or unlucky there, depending on how you view the glass as half full or half empty here. We, at least by way of having multiple tests, caught this mistake somehow. So it would be nice, though, if we weren't writing so much darn code here, right? Because notice what I've done. I have try, except. I have all of these assertions. I have a main function. I have this if conditional at the bottom of my file. I mean, honestly, who's going to want to write 31 lines of code now just to test a 2-line function, right? No one's going to write test code like this if we're all writing so much more code to do the actual testing. So people have solved this problem. If you are in the habit of testing your code a lot or wanting to, if I'm in the habit of wanting to test my code a lot, if everyone else in the real world is in this habit of wanting to test their code, why don't we create tools that make it a little easier to do so? And in fact, there is a mechanism for doing this whereby we can use a tool that's popularly called PyTest. So PyTest is a third-party program that you can download and install that will automate the testing of your code so long as you write the tests. But what's nice about this library and others like it is that it adopts some conventions so that you don't have to write as many lines of code yourself manually. They do some of that automatically for you. Now, this is a third-party library. There's other libraries for unit tests, so to speak, that is testing units of your code. Some of them come with Python itself. We're proposing that we look at PyTest today because it's actually a little simpler than the unit testing frameworks that come with Python itself. And what do we mean by unit testing? Unit testing is just a formal way of describing testing individual units of your program. What are those individual units? They're typically functions. So unit tests are typically tests for functions that you have written. Now, what does this mean in practice here? Well, let me go back to my VS Code here, and let me propose that we simplify my test calculator significantly. I'm going to go ahead and delete all of these tests, which were accumulating to like 31 lines of code. And let's see if we can distill the tests to their essence using PyTest. From my same calculator program, let me still import square. So I do still need that line of code so that I can test that specific function. Now I'm going to go ahead and define a function just like I did before as follows. I'm going to define a function called test square, again by convention, test underscore, and the name of the function you want to test, though it doesn't have to be that way. And now I'm going to go ahead and make a few assertions. I'm going to assert that the square of 2 should equal 4. I'm going to assert that the square of 3 should equal 9. I'm going to assert that the square of -2 should equal 4. And I'm going to insert that the square of -3 should equal 9. And lastly, for now, I'm going to assert that the square of 0 should equal 0. So I'm still using the assert keyword, as I introduced earlier. And even though it was a little tedious to type those, I mean, it's only 8 lines of code now, and they're so easy to type. It's not try and accept and all of this. Wouldn't it be nice if something else, someone else, handled the try, the accept, the printing, all of the standardization of actually running these tests? And that's where, indeed, PyTest comes into play. Per the documentation for PyTest, which can itself be installed with pip install PyTest, which we've used to install other libraries in the past, you can look at the documentation here for all of its formal usage. But fortunately, PyTest is pretty user-friendly as testing frameworks go, and it actually allows us to dive right in by just running PyTest on the code that we've written. So if I go back to VS Code here and look at my testcalculator.py, which notice has no main function anymore, it has no conditional, it has no tries, it has no accepts, it has no prints, it just has my few assertions, PyTest and other libraries like it are going to automate the process of running these tests for me and informing me on the screen whether or not any of those tests failed. So let me go ahead and do this. I'm going to go ahead and increase the size of my terminal window for a moment just so we can see more on the screen. And I'm going to run not Python as I've been doing. I'm going to run PyTest, which again is this third-party tool for running tests in your code. I'm going to run PyTest of test_calculator. So that same file, I'm going to cross my fingers as always and hit enter. And we'll see that, something has failed. Now, admittedly, even though I do think you'll find that PyTest is relatively simple to use, its output, at least at first glance, is not necessarily super user-friendly. So what are we seeing here? Well, notice at the very top of my window is the command that I ran after my prompt. Right below that is a single F in red, which means fail. So not very encouraging. I tried really hard here, but fail is my grade on this program. But let's see exactly what happened. Well, if I look at this excerpt here, under failures, you'll see that test square is the function that failed. All right, that makes sense because that's the only one I wrote. And you'll see here somewhat arcane output describing what the error was. So what you're seeing here is the first line of output equals 4, which is fine. There's no red error message below that, so that one's OK. But this line of code here, assert that square of 3 equals 9, PyTest did not like that assertion because it didn't end up being true. In fact, per the red E at the start of this line, you'll see that I'm effectively trying to assert that 6 equals 9. Now, where did the 6 come from? OK, wait a minute. If my test involves this, notice that where 6 equals square of 3, this is saying that because I've called square, passing in a value of 3, it turns out its return value is 6. And of course, mathematically, 6 does not equal 9. So that's why this is failing. Now, PyTest is not as user-friendly as telling you exactly why the bug is there or how to fix it. This is really just a clue to you what must be wrong. What you're seeing here is a clue that the first test passed because there's no red error below that line of code, but this test failed. Somehow or other, your square function is returning 6 when passed in 3 instead of 9. So at this point, you sort of put your detective hat on, you go back to your actual code, and you think about in calculator.py, how in the world is line 7 of my square function returning 6 instead of 9? And at this point, odds are the light bulb would go off above your head proverbially, and you would see, oh, I'm using addition instead of multiplication. But what PyTest has done for us is automate the process of at least pointing out that error for us. And if I now go in and fix this, let me go ahead and the light bulb has gone off. I changed the plus to a multiply. Now I'm going to go ahead and after clearing my screen, I'm going to run not Python, but PyTest of testcalculator.py. Crossing my fingers again, and now it's green, and I see just a dot, which indicates that my one and only test passed. I'm good. 100% success with my test now after fixing that bug. All right, let me pause here and see if there's any questions.
So my question is, what if a user, instead of, because we are taking input from the user, what if the user is somewhat malicious and types in a string instead of an integer? Or maybe he types in a float or some other data type.
Yeah, so what if the user, like we've seen in past examples, types in cat instead of a number when we're expecting an integer? How do we test for something like that? At the moment, I'm admittedly not testing user input. If I go back to my code here, notice that my calculator function, of course, has the square function that we keep testing and retesting. But notice that all of the user input is currently relegated to my main function. And admittedly, as of now, I am not testing my main function. So there could be one of those bugs. And in fact, there would be, because if the user types in a string like cat instead of an integer like 2 or 3, then line 2, recall, would actually raise a value error exception. So we've seen that before. So when it comes to testing your code, this is actually a good reason for having multiple functions in your program. Rather than putting all of your logic in just the file itself, rather than putting all of the logic in just main, it's actually really good, really helpful practice to break your ideas up into smaller, bite-sized functions that themselves are testable. And what do I mean here? Square is perfectly testable. Why? Because it takes as input a parameter called n, and it returns as output an integer, which is going to be the square thereof, hopefully. It has a well-defined input and a well-defined output. It is therefore completely within your control in your test program to pass in those values. Now, I will say, if you want to test whether square behaves properly when passed something like a string, like quote unquote cat, we could absolutely do something like this. Assert that the square of quote unquote cat, it's not going to equal something. You can actually, using different syntax, assert that a specific exception will be raised. So if we were actually going to go back into our square function, improve it, and deliberately raise an exception, we could test for that too. But for now, I'm deliberately only testing the square function. I'm not testing for specific user input. But that's another problem to be solved. Other questions now on unit tests.
Do you use the unit test to test code for the CS50 check?
So check50 is similar in spirit. Check50 is a tool that we, CS50, wrote that is essentially doing something like PyTest for the evaluation of students' code. It is similar in spirit, but think of check50 as being an alternative to PyTest, if you will. But it works a little bit differently. But same idea. PyTest and unit testing more generally is a technique that is independent of CS50 and is something that you can and should be doing on your own code, both in or outside of this class. How about one other question here on our unit tests?
My question is, instead of writing 4 times like assert square of 2 is equal to 4, instead of that, can we write if I is equals to, in square brackets, the numbers we want, instead of writing 4 lines?
A really good question. Absolutely. Right now, if I go back to testcalculator.py, it's indeed pretty manual. I mean, it took me a while to say and to type out those several lines. And you could imagine writing some kind of loop to just assert in a loop that this equals that this equals that, and so forth, using a list or using maybe a list or a dictionary or some structure like that. So yes, you can absolutely automate some of these tests by not just doing the same thing again and again. You can still use all of the syntax of Python to do loops. But generally speaking, your tests should be pretty simple. And in fact, let me propose that we improve upon even this design further, because at the moment, what's not really ideal when I run all of this, when I run all of these tests, when my function is buggy, is notice the output that I got. Let me reintroduce that same bug by changing my multiplication back to addition. Let me increase the size of my terminal window again, and let me run PyTest again of testcalculator.py. So this is the version of my code now that has the bug again. So I'm going to see that big, massive failure where this failure has been displayed to me. But this is not as helpful as it could be, right? Because I have all of those other tests in my code. Recall that I had, what, 1, 2, 3, 4, 5 separate tests, and I'm only seeing the output of the first. Now, why is that? Well, if we go back to my code here, you'll see that the first assertion that's failing, namely this one here, that assert of square of 3 equals 9, the other tests aren't even getting run. And that's not a big deal in the sense that my code is buggy, so one or more of them are probably going to fail anyway. But wouldn't it be nice to know which of them are going to fail? And in fact, it's ideal to run as many tests all at once as possible to give you as many clues as possible to finding your bug. So let me propose that we improve the design of my testing code now, still using PyTest as follows. Instead of having one big function called test square that tests the entire function itself with so many different inputs, let's break down my tests into different categories. And here, too, there's no one right way to do this, but my mind is thinking that I should maybe test positive numbers separately, test negative numbers separately, and test 0 separately. I could think of other ways. I could test even numbers. I could test odd numbers, or maybe some other pattern altogether. But separating this big test into multiple tests is probably going to yield more clues for me when something goes wrong. So let me do this. Let me go ahead and rename this function to test positive initially, and let me include in that function only those first 2 tests. Let me then create another function here called test negative, and in this function, let me test only -2 and -3. Then down here, let me do one more def of test 0, and I'll just run one test in there. So I have the same assertions, the same 5, but I've now divided them up among 3 separate functions. What's nice about PyTest and other unit testing frameworks is that all 3 of these test functions will be run automatically. Even if one of them fails, the others will be attempted. That means that if 1 or 2 or 3 of them fail, I'll have 1 or 2 or 3 clues now for helping me find that mistake. So let me go ahead and again increase the size of my terminal window, just so we can see more on the screen. My calculator calculator still has the bug using addition instead of multiplication, let me go ahead and run not Python, but again, PyTest of testcalculator.py, crossing my fingers as always. And now, oh my God, there's even more errors on the screen. But this in itself is more helpful. Let's work through them from top to bottom. So under failures here, in all caps, which I know is not very encouraging to see failure when you're just trying to solve a problem, but that's what these frameworks do. Under failures, the first function that failed is test positive. But here, too, we see the same clue as before. The first one, 2, the square of 2 equals 4. That one's fine. It's not erroring with any red errors. But the next one is failing. So I know that square is broken when I pass in 3. All right, what about down here? It looks like, unfortunately, my test negative function is failing too. Why? Well, when I pass in, oh, this is interesting. Here now, negative 2 doesn't even work. So I got lucky with positive 2, but negative 2 isn't working. So that's a bit of a clue. But in total, only 2 tests failed. So notice at the very bottom, this summary, 2 failed and 1 passed. What's the other one? What was the third one? Test 0. So test 0 is passing. These 2 are failing. And so that kind of leads me logically, mathematically, if you will, to the source of the bug. And just to be clear, too, if you have a lot of tests, this little one-line output is helpful, even though also a bit discouraging. Fail, fail, and dot means pass. So there are the 3 tests just depicted graphically a little bit differently. Well, let me rewind now and go back into calculator.py. Let's fix that bug, because let's suppose that I've deduced, OK, I'm using addition. I should have been using multiplication all this time. Let me now, after fixing the bug yet again, let me go back to my big terminal. Let me run PyTest of testcalculator.py, hitting Enter, crossing my fingers now. And dot, dot, dot means all is well. 100% of my tests passed, all 3 of them. So now I'm good. It doesn't necessarily mean that my code is 100% correct, but it does mean that it has passed 100% of my current tests. And so it would probably behoove us to think a little harder about maybe we should test bigger numbers, maybe we should test even smaller numbers, maybe we should test strings or something else. The onus is ultimately on you to decide what you're going to test. But in the real world, you're going to be very unhappy with yourself or someone else. Maybe your boss is going to be very unhappy with you if you did not catch a bug in your code, which you could have caught had you just written a test to try that kind of input. All right, let me pause again and see if there's any questions now on unit testings with PyTest.
So if you wanted to test, like someone suggested before, user input as well as testing your function, do you do that within the same file, or do you make separate files for different types of tests?
Really good question. You could absolutely make separate files to test different types of things. Or if you don't have that many, you can keep them all in the same file. At the moment, I've been storing all of my tests in one file for convenience, and there's not terribly many of them. But we'll take a look in a bit at an example that allows me to put them into a folder and even run PyTest on a whole folder of tests as well. So that's possible. Other questions on unit testing?
So I've got 2 questions. A couple of while ago, you just used an exception called assertion. I'm not sure what it was. Oh yeah, assertion error. What exactly does that particular error catch? And my second question is, does the assert keyword stand out to the compiler and exactly tell them to assert this particular line of code?
Indeed. The assert keyword we're seeing and the assertion error we saw earlier are intertwined. So when you use assert and the assertion fails, because whatever Boolean expression you're using is not true, it's false, an assertion error, by definition of Python, will be raised. So those 2 work in conjunction. Those errors, those assertion errors, are still being raised by my code here when any of these lines of code fail. However, PyTest, this third-party library, is handling the process of catching those exceptions automatically for me so as to give me this standard output. So we started today's story by really implementing unit testing myself. I wrote all of the code myself. I wrote main. I did my conditional. I did try and except. Honestly, it's going to get incredibly painful to write tests long term if you and I have to write that much code every time, especially when our function is this small. So PyTest and unit testing frameworks like it just automate so much of that. Essentially, PyTest adds the try, the except, the if, the prints for you, so you can just focus on the essence of the tests, which really are these inputs and outputs. How about time for one other question here on unit testing as well?
Sir, when we enter -6 or -5, the
square or square root of that number comes up. But when we put 6.6 or 5.6, something like that integer, then line shows error. So what's happening there?
So if I'm deliberately testing integers right now, in large part because I only want POW to operate on integers. And that might be conveyed in Python's documentation or my own documentation for that function. If we were to pass in something else like a float, it turns out that floating point values in Python and other languages are actually very hard, if not impossible, to represent 100% precisely. And so if you are trying to compare it against some other value, they might be slight rounding errors as a result. I'm just inferring from what you've described, but I'm very deliberately now testing this function with only the inputs that I would expect. It might indeed throw other errors if other inputs are passed. All right, allow me to propose that we consider what should happen if square isn't actually passed a number. For instance, if I go back to calculator.py and suppose that I, or perhaps someone else using my square function, simply forgets to convert the return value of input from a str to an int, as by modifying line 2 here. Well, now something's definitely going to go wrong if I type in a str instead of what appears to be an int. For instance, if I clear my terminal here, run Python of calculator.py and hit enter, let's type in cat as our value for x. And of course, this raises now a type error. Why? Can't multiply sequence by non-int of type str. What does that mean? Well, you can't do cat times cat because indeed square is expecting that n will be some number. But that doesn't necessarily mean that square itself is buggy, but this does mean that if I expect a type error to be raised, let's test for that too so that I know the behavior indeed works as expected. So let me go back to testcalculator.py and let me go and add a fourth test down here. How about define test underscore, and I'll call this test str because I'm going to specifically and deliberately pass in a str for testing. And I want to, in spirit, assert that passing in something like cat to square will raise a type error, but we don't use the assert keyword for that. Rather, we need this. Let me go to the top of this file, and let me additionally import the PyTest library itself, because it turns out there's a function in that library called raises that allows me to express that I expect an exception to be raised. And I can express that as follows: with pytest.raises, and then in parentheses, I can pass in the type of exception I expect, which is going to be a type error in this case. And now when do I expect that type error to be raised? Whenever I do something like calling square and passing in not a number, but something like cat. So now if I go back to my terminal window, run pytest of testcalculator.py, this time having 4 tests, I should see that all 4 now are successful. All right, let's now consider how we could test code that doesn't just expect numbers as input, but actually strings. And let me rewind us in time here in VS Code to that very first program we wrote a few different versions of in hello.py that ultimately looked a little something like this. I had a main function that prompted the user for the value of a variable by asking them, what's your name, ? And then we went ahead and did something like hello, open paren name, passing that user's name into a function called hello. Now that function hello, recall, ultimately looked like this. We defined hello as taking a parameter called 2, the default value of which was world, and that function very simply printed hello followed by a comma, and then whatever the name that had been passed in. And then we ultimately called main, but for now onward, I'm going to always add this if conditional, if name equals underscore main, then and only then do I want to call main. So that's essentially what this program looked like in its last incarnation. How do we go about testing it? Well, here again, too, I'm not going to test the user's input per se in main. I'm going to focus really on the module of code here that's of interest, which is the hello function itself. How can I go about testing the hello function? Well, unfortunately, even if I start by doing something like code of testhello.py, let me go about and start writing a test program. I could import from my hello program a function called hello. So a bit strange to see from hello import hello. But notice that on this line here, I'm importing from the module, that is the file called hello.py, the function called hello. And how do I go about testing this? Well, if I have a function like define test argument like this, well, let me do this. So if I were to define a function like define test hello, what could I do? Well, I could call hello with quote unquote, say, David, and then check if it equals what? Hello, comma, David? So would this work, this approach here? If I've written a test called test hello that calls hello with an argument of David and then tests its return value, just like we've done for our calculator, would this work as written? And let me go back to, in just a moment, the version of hello that we're testing so you can see that function hello. Here's the test. Here's the actual code. Would this test now work? Any thoughts?
I think the problem is that in the first version in hello.py, you're using the to argument that you first declare when you declare the function instead of using the name.
OK, that is actually not a bug here. So let me stipulate that in hello.py, this code actually does work as intended. And let me go ahead and test it manually just to demonstrate as much. Let me run Python of hello.py, typing in as my name David, and I see, in fact, that it says hello, David. If, though, I were to change this program and get rid of the name argument, get rid of the name variable, and just call hello, again running Python of hello.py, this time I'm not even prompted because I got rid of my input call, but it does behave as I expect. It does say hello world. So let me stipulate that this code in its current form is actually correct, but my test is not going to work as I'd hoped. And there's a subtle difference between hello versus my pow function that there's a subtle difference between my hello function and my square function that explains. Why might this test not work as intended?
Because it's not returning a value.
Yeah, exactly. Recall our discussion early on about functions. Functions can either return a value, like my square function hands you back the square of some value, or they can have side effects, sort of visual artifacts that might happen on the screen, like printing something out on the screen. And by definition, that's how print works. Notice that hello, it is short, but it's implemented ultimately using the print function, which does not return a value as I'm using it here. It instead has this side effect of printing something onto the screen. So it is not correct in my test function to check if the return value of hello equals hello, David, because again, hello is not returning anything. It's printing something with that side effect, but notice literally it has no return keyword, unlike my square function, which did. So here's an opportunity, too, to perhaps change how I go about implementing my actual functions. It turns out that as your programs get more and more sophisticated, more and more complicated, it tends to be best practice not to have side effects if you can avoid it, especially if you want your code to be testable. And in fact, I'm going to propose that we change my hello program to now work as follows. Let me go ahead and change this function to not print hello and then that name. Let me go ahead and literally return maybe an f string, which will clean this up a little bit, hello, comma, 2, close quote at the end. So my syntax here is just the familiar f string or format string. It's going to return hello world or hello David or hello whoever's name is passed in as that argument. But I'm returning it now. I'm not printing it out. So what needs to change up here? Well, I could do something like this. I could say something like output equals hello, and then print output in my main function. Or I can simplify that because I don't really need that variable. I could instead just do this. I could still call hello, but I could immediately print out the result. And this version of my hello program now is actually more testable. Why? Because these assert statements that we're using, and we've seen thus far for our tests, are really designed to test arguments into functions and return values therefrom, not testing side effects. So if you're doing equals equals, you're looking for a return value, something that's handed back from the function. So that's fine. If I modify the design of my program now, not to just print hello, but to return the string, the sentence, the phrase that I want to construct, I can leave it to the caller, that is the function who's using this hello function, to handle the actual printing. Now what does this mean in my code? Well, it means now if my hello.py looks like this, and hello is indeed returning a value, in my test hello function, I can test it exactly like this. So let me go ahead and run pytest of test hello.py, crossing my fingers as always, and voila, one passed. So I passed this test because apparently the return value of hello does indeed equal hello, comma, David. Well, let's test the other scenario. What if I call hello without any arguments? Let's assert that calling hello with nothing in those parentheses similarly equals hello, comma, but world, the default value. Let me now go ahead and run PyTest of test_hello.py, and that too passes entirely. But there too, suppose that I had made some mistakes, suppose that there were a bug in my code, it might not be best practice to combine multiple tests in this one function, so let's make it more clear what might pass or fail. Let's call the first function test the default to this function, and let's only include this first line of code. And then let's go ahead and define another function like test argument to test this other line of code here. So now I have two different tests, each of which is testing something a little fundamentally different. So now when I run my code, it's still not broken. If I run PyTest of test_hello.py, enter, I've now passed two tests. And that's just as good as before. But if I did have a bug, having two tests instead of one would indeed give me perhaps a bit more of a hint as to what's wrong. Questions now on this testing of return values when these return values are now strings instead of integers, and why we've done this.
So my question is about a function inside the function. Can we test that too? Or recursion we have in C?
If you have a recursive function, which we've not discussed in this class, yes, you can absolutely test those too by simply calling them exactly in this way. Recursion does not affect this process. All right, how about one more question here on unit tests before we look at one final example?
When testing our arguments, like can we use something like loops or inside of asserts or for the values?
Absolutely. You can absolutely use a loop to test multiple values. In this case, for instance, I could do something like this. I could say for name in the following list of Hermione, say Harry, and Ron, I could then within this loop assert that hello of that given name equals, say, the format string of hello, comma, name, and then run all of these here at once by running, again, PyTest of test_hello.py. It's still going to be just one test within that function. But if there's something interesting about those several strings that makes it compelling to test all of them, you can absolutely automate the tests in that way. With that said, each of your tests should ideally be pretty simple and pretty small. Why? Because you don't want to write so much code, so much complicated code that your tests might be flawed. What we don't want to have to do is write tests for our tests and tests for our tests for our tests, because it would never end. So keeping tests nice and simple is really the goal, so that a reasonable human, yourself included, can eyeball them and just claim, yeah, that is correct. We don't need tests for our tests. All right, how about one other feature? Suppose that we don't have just one test, but many different tests instead, and we want to start to organize those tests into multiple files and even a folder. Well, PyTest and other frameworks support that paradigm as well. In fact, let me go ahead and test hello.py using a folder of tests with technically just one test, but it would be representative of having even more in that folder. I'm going to go ahead and create a new folder called tests using makedir at my command line, and then within that file, within that folder, I'm going to go ahead and create a file called test_hello.py. Within this file, meanwhile, I'm going to test the same things. I'm going to go ahead and from hello, import hello. And I'm going to go ahead and define a function like test default that simply tests the scenario where hello with no arguments returns hello, comma, world. And I'm going to have that other function where I test that an argument is passed. And in this case, I'll choose an argument like asserting that hello, quote unquote, David, equals indeed hello, comma, not world, but David. So in this case, I've just recreated the same test as earlier, but they're in a file now in a folder called test. Well, PyTest allows me to run these here too, but to do so, I actually need to create one other file. Within my test directory, I need to create a file called __init__.py, which has the effect, even if this file is empty, of telling Python to treat that folder as not just a module, but a package, so to speak. A package is a Python module or multiple modules that are organized inside of a folder. And this file, underscore underscore init underscore underscore py, is just a visual indicator to Python that indeed it should treat that folder as a package. If I had more code in this folder, I could do even more things with this file. But for now, it's just a clue that it's indeed meant to be a package and not just a module or file alone. What I can now do in closing is run pytest, not even on that specific file, but on a whole folder of tests. So if I run pytest of test, where the test is the name of that folder, pytest will automatically search through that folder looking for all possible tests. Granted, there's just those 2 in this one file, but when I run it now with enter, I'll still pass those tests. I'll still get 100%. And I now have a mechanism, ultimately, for testing my own code. So whether you're writing functions that return integers or something else, functions that have side effects that could be rewritten as functions that return values, you now have a mechanism to not just wait for someone like us to test your code, and not just test your code manually again and again, which might get tedious, and you might make mistakes by not including some possible inputs. We now have an automated mechanism for testing one's own code that's going to be even more powerful when you start collaborating with others, so that you can write tests that ensure that if they make a change to the same code, they haven't broken the code that you've written. All right, that's it for this week. We'll see you next time. All right, this is CS50's Introduction to Programming with Python. My name is David Malin, and this is our week on file I/O, input and output of files. So up until now, most every program we've written just stores all the information that it collects in memory, that is, in variables or inside of the program itself, a downside of which is that as soon as the program exits, anything you typed in, anything that you did with that program is lost. Now with files, of course, on your Mac or PC, you can hang on to information long term. And file I/O within the context of programming is all about writing code that can read from, that is load information from, or write to, that is save information to, files themselves. So let's see if we can't transition then from only using memory and variables and the like to actually writing code that saves some files for us and therefore data persistently. Well, to do this, let me propose that we first consider a familiar data structure, a familiar type of variable that we've seen before, that of a list. And using lists, we've been able to store more than one piece of information in the past. Using one variable, we typically store one value. But if that variable is a list, we can store multiple values. Unfortunately, lists are stored in the computer's memory, and so once your program exits, even the contents of those disappear. But let's at least give ourselves a starting point. So I'm over here in VS Code, and I'm going to go ahead and create a simple program using code of names.py, a program that just collects people's names, students' names, if you will. And I'm going to do it super simply initially in a manner consistent with what we've done in the past to get user input and print it back out. I'm going to say something like this. Name equals input, quote unquote, what's your name? Thereby storing in a variable called name the return value of input, as always. And as always, I'm going to go ahead and very simply print out a nice F string that says hello, comma, and then in curly braces name to print out hello David, hello world, however happens to be using the program. Let me go ahead and run this just to remind myself what I should expect. And if I run python of names.py and hit enter, type in my name like David, of course, I now see hello, comma, David. Suppose, though, that we wanted to add support not just for one name, but multiple names, maybe 3 names for the sake of discussion, so that we can begin to accumulate some amount of information in the program such that it's really going to be a downside if we keep throwing it away once the program exits. Well, let me go back into names.py up here at top. Let me proactively give myself a variable, this time called names plural, and set it equal to an empty list. Recall that the square bracket notation, especially if nothing's inside of it, just means give me an empty list that we can add things to over time. Well, what do we want to add to it? Well, let's add 3 names, each from the user. And let me say something like this. For underscore in range of 3, let me go ahead and prompt the user with the input function and getting their name in this variable. And then using list syntax, I can say names.append name to that list. And now I have in that list that given name. 1, 2, 3 of them. Other points to note is I could use a variable here like I, which is conventional. But if I'm not actually using I explicitly on any subsequent lines, I might as well just use underscore, which is a Pythonic convention. And actually, if I want to clean this up a little bit right now, notice that my name variable doesn't really need to exist because I'm assigning it a value and then immediately appending it. Well, I could tighten this up further by just getting rid of that variable altogether and just appending immediately the return value of input. I think we could go both ways in terms of design here. On the one hand, it's a pretty short line and it's readable. On the other hand, if I were to eventually change this phrase to be not what's your name, but something longer, we might want to break it out again into 2 lines. But for now, I think it's pretty readable. Now, later in the program, let's just go ahead and print out those same names, but let's sort them alphabetically so that it makes sense to be gathering them all together, then sorting them and printing them. So how can I do that? Well, in Python, the simplest way to sort a list in a loop is probably to do something like this. For name in names, but wait, let's sort the names first. Recall that there's a function called sorted, which will return a sorted version of that list. Now let's go ahead and print out an f string that says, again, hello, bracket name, close quotes. All right, let me go ahead and run this. So Python of names.py. And let me go ahead and type in a few names this time. How about Hermione? How about Harry? How about Ron? And notice that they're not quite in alphabetical order. But when I hit enter and that loop kicks in, it's going to print out hello Harry, hello Hermione, hello Ron in sorted order. But of course now, if I run this program again, all of the names are lost. And if this is a bigger program than this, that might actually be pretty painful to have to re-input the same information again and again and again. Wouldn't it be nice, like most any program today on a phone or a laptop or desktop or cloud, to be able to save this information somehow instead? And that's where file I/O comes in, and that's where files come in. They are a way of storing information persistently on your own phone or Mac or PC or some cloud server's disk so that they're there when you come back and run the program again. So how can we go about saving all 3 of these names in a file as opposed to having to type them again and again? Let me go ahead and simplify this file and again give myself just a single variable called name and set the return value of input equal to that variable. So what's your name as before, quote unquote. And now let me go ahead and let me do something more with this value. Instead of just adding it to a list or printing it immediately out, let's save the value of the person's name that's just been typed in to a file. Well, how do we go about doing that? Well, in Python, there's this function called open, whose purpose in life is to do just that, to open a file. But to open it up programmatically so that you, the programmer, can actually read information from it or write information to it. So open is like the programmer's equivalent of like double-clicking on an icon on your Mac or PC. But it's a programmer's technique because it's going to allow you to specify exactly what you want to read from or write to that file. Formally, its documentation is here, and you'll see that its usage is relatively straightforward. It minimally just requires the name of the file that we want to open and optionally how we want to open it. So let me go back to VS Code here, and let me propose now that I do this. I'm going to go ahead and call this function called open, passing in an argument for names.txt, which is the name of the file I would like to store all of these names in. I could call it anything I want, but because it's going to be just text, it's conventional to call it something.txt. But I'm also going to tell the open function that I plan to write to this file. So as a second argument to open, I'm going to put literally quote unquote W for write, and that's going to tell open to open the file in a way that's going to allow me to change the contents. And better yet, if it doesn't even exist yet, it's going to create the file for me. Now, open returns what's called a file handle, a special value that allows me to access that file subsequently. So I'm going to go ahead and assign it equal to a variable like file. And now I'm going to go ahead and quite simply write this person's name to that file. So I'm going to literally type file, which is the variable linking to that file, .write, which is a function, otherwise known as a method that comes with open files that allows me to write that name to the file. And then lastly, I'm going to quite simply go ahead and say file.close, which will close and effectively save the file. So these 3 lines of code here are essentially the programmer's equivalent to like double-clicking an icon on your Mac or PC, making some changes in Microsoft Word or some other program, and going to file save. We're doing that all in code with just these 3 lines here. Well, let's see now how this works. Let me go ahead now and run Python of names.py and enter. Let's type in a name. I'll type in Hermione. Enter. All right. Where did she end up? Well, let me go ahead now and type code of names.txt, which is a file that happens now to exist because I opened it in write mode. And if I open this in a tab, we'll see there's Hermione. Well, let's go ahead and run names.py once more. I'm going to go ahead and run Python of names.py, enter, and this time I'll type in Harry. Let me go ahead and run it one more time, and this time I'll type in Ron. And now let me go up to names.txt, where hopefully I'll see all three of them here. But no, I've just actually seen Ron. What might explain what happened to Hermione and Harry, even though I'm pretty sure I ran the program 3 times and I definitely wrote the code that writes their name to that file? What's going on here, do you think?
I think because we are not appending them, we should append the names. Since we are writing directly, it is erasing the old content and it is replacing with the last set of characters that we mentioned.
Exactly. Unfortunately, quote unquote W is a little dangerous. Not only will it create the file for you, it will also recreate the file for you every time you open the file in that mode. So if you open the file once and write Hermione, that worked just fine as we saw. But if you do it again for Harry, if you do it again for Ron, the code is working, but each time it's opening the file and recreating it with brand new contents. So we had one version with Hermione, one version with Harry, and one final version with Ron. But ideally, I think we probably want to be appending, as Vishal says, each of those names to the file, not just clobbering, that is overwriting the file each time. So how can I do this? It's actually a relatively easy fix. Let me go ahead and do this as follows. I'm going to first remove the old version of names.txt, and now I'm going to change my code to do this. I'm going to change the W, quote unquote, to just A, quote unquote, A for append, which means to add to the bottom, to the bottom, to the bottom again and again. Now let me go ahead and rerun Python of names.py, enter. I'll again start from scratch with Hermione, because I'm creating the file new. Notice that if I now do code of names.txt, enter, we do see that Hermione is back. So after removing the file, it did get recreated, even though I'm using append, which is good. But now let's see what happens when I go back to my terminal. And this time I run Python of names.py again, this time typing in Harry. And let me run it one more time, this time typing in Ron. So hopefully this time, in that second tab, names.txt, I should now see all three of them. But, this doesn't look ideal. What have I clearly done wrong? Something tells me, even though all three names are there, it's not going to be easy to read those back unless you know where each name ends and begins.
The English format is not correct. The English format is not correct. It's incorrect. It's concatenating them.
It is. Well, it appears to be concatenating, but technically speaking, it's just appending to the file. First Hermione, then Harry, then Ron. It has the effect of combining them back to back, but it's not concatenating per se. It really is just appending. Let's go to another hand here. What really have I done wrong? Or equivalently, how might I fix? It would be nice if there were some kind of gaps between each of the names so we could read them more cleanly.
Hello. We should add a new line before we write new name.
Good. We want to add a new line ourselves. So whereas print by default, recall, always outputs automatically a line ending of \n unless we override it with the named parameter called end, write does not do that. Write takes you literally. And if you say write Hermione, that's it. You're getting the H through the E. If you say write Harry, you get the H through the Y. You don't get any extra new lines automatically. So if you want to have a new line at the end of each of these names, we've got to do that manually. So let me again close names.txt, and let me remove the current file. And let me go back up to my code here. And I can fix this in any number of ways, but I'm just going to go ahead and do this. I'm going to write out an F string that contains name and \n at the end. We could do this in different ways. We could manually print just the new line or some other technique. But I'm going to go ahead and use my F strings, as I'm in the habit of doing, and just print the name and the new line all at once. I'm going to go ahead now and down to my terminal window, run Python of names.py again, enter. We'll type in Hermione. I'm going to run it again, type in Harry. I'm going to type it again, and this time Ron. Now I'm going to run code of names.txt and open that file. And now it looks like the file is a bit cleaner. Indeed, I have each of the name on its own line, as well as a line ending, which ensures that we can separate one from the other. Now, if I were writing code, I bet I could parse, that is, read the previous file by looking at differences between lowercase and uppercase letters, but that's going to get messy quickly. Generally speaking, when storing data long term in a file, you should probably do it somehow cleanly, like doing one name at a time. Well, let's now go back, and I'll propose that this code is now working correctly, but we can design it a little bit better. It turns out that it's all too easy when writing code to sometimes forget to close files. And sometimes this isn't necessarily a big deal, but sometimes it can create problems. Files could get corrupted or accidentally deleted or the like, depending on what happens in your code. So it turns out that you don't strictly need to call close on the file yourself if you take another approach instead. More Pythonic when manipulating files is to do this, to introduce this other keyword called, quite simply, with, that allows you to specify that in this context, I want you to open and automatically close some file. So how do we use with? It simply looks like this. Let me go back to my code here. I've gotten rid of the close line, and I'm now just going to say this instead. Instead of saying file equals open, I'm going to say with open, then the same arguments as before, and somewhat curiously, I'm going to put the variable at the end of the line. Why? That's just the way this is done. You say with, you call the function in question, and then you say as, and specify the name of the variable that should be assigned the return value of open. Then I'm going to go ahead and indent the line underneath so that the line of code that's writing the name is now in the context of this with statement, which just ensures that automatically, if I had more code in this file down below, no longer indented, the file would be automatically closed as soon as line 4 is done executing. So it doesn't change what has just happened, but it does automate the process of at least closing things for us, just to ensure I don't forget and so that something doesn't go wrong. But suppose now that I wanted to read these names from the file. All I've done thus far is write code that writes names to the file. But let's assume now that we have all of these names in the file. And heck, let's go ahead and add one more. Let me go ahead and run this one more time, Python of names.py. And let's add in Draco to the mix. So now that we have all 4 of these names here, how might we want to read them back? Well, let me propose that we go into names.py now, or we could create another program altogether, but I'm going to keep reusing the same name just to keep us focused on this. And now I'm going to write code that reads an existing file with Hermione, Harry, Ron, and Draco together. And how do I do this? Well, it's similar in spirit. I'm going to start this time with open. And then the first argument is going to be the name of the file that I want to open, as before. And I'm going to go open it this time in read mode, quote unquote R. And to read a file just means to load it, not to save it. And I'm going to name the return value file. And now I'm going to do this. And there's a number of ways I can do this. But one way to read all of the lines from the file at once would be this. Let me declare a variable called lines. Let me access that file and call a function or a method that comes with it called readLines. So if you read the documentation on file IO in Python, you'll see that open files come with a special method whose purpose in life is to read all of the lines from the file and return them to me as a list. So what this line 2 is doing is it's reading all of the lines from that file, storing them in a variable called lines. Now suppose I want to iterate over all of those lines and print out each of those names. For line in lines, this is just a standard for loop in Python. Lines is a list. Line is the variable that will be automatically be set to each of those lines. Let me go ahead and print out something like, oh, hello, comma, and then I'll print out the line itself. All right, so let me go to my terminal window, run Python of names.py now. I have not deleted names.txt, so it still contains all 4 of those names, and hit enter. And OK, it's not bad, but it's a little ugly here. What's going on? When I ran names.py, it's saying hello to Hermione, to Harry, to Ron, to Draco, but there's these gaps now between the lines. What explains that symptom? If nothing else, it just looks ugly.
It happens because in the text file, we have new line symbols in between those names. And the print always adds another new line at the end. So you use the same symbol twice.
Perfect. And here's a good example of a bug, a mistake in a program. But if you just think about those first principles, like how do each of the lines of code work that I'm using, you should be able to reason exactly as Rafal did there to say that, all right, well, one of those new lines is coming from the file after each name. And then, of course, print all of these weeks later is still giving us for free that extra new line. So there's a couple of possible solutions. I could certainly do this, which we've done in the past, and pass in a named argument to print, like end equals quote unquote. And that's fine. I would argue a little better than that might actually be to do this, to strip off of the end of the line the actual new line itself, so that print is handling the printing of everything, the person's name as well as the new line. But you're just stripping off what is really just an implementation detail in the file. We chose to use new lines in my text file to separate one name from another. So arguably, it should be a little cleaner in terms of design to strip that off and then let print out what is really just now a name. But that's ultimately a design decision. The effect is going to be exactly the same. Well, if I'm going to open this file and read all the lines and then iterate over all of those lines and print them each out, I could actually combine this into one thing. Because right now, I'm doing twice as much work. I'm reading all of the lines, then I'm iterating over all of the lines just to print out each of them. Well, in Python with files, you can actually do this. I'm going to erase almost all of these lines now, keeping only the with statement at top. And inside of this with statement, I'm going to say this. For line in file, go ahead and print out, quote unquote, hello, comma, and then line.rstrip. So I'm going to take the approach of stripping off the end of the line. But notice how elegant this is, so to speak. I've opened the file in line 1. And if I want to iterate over every line in the file, I don't have to very explicitly read all the lines, then iterate over all of the lines. I can combine this into one thought. In Python, you can simply say for line in file. And that's going to have the effect of giving you a for loop that iterates over every line in the file one at a time. And on each iteration, updating the value of this variable line to be Hermione, then Harry, then Ron, then Draco. So this, again, is one of the appealing aspects of Python, is that it reads rather like English. For line in file, print this. It's a little more compact when written this way. Well, what if, though, I don't want quite this behavior? Because notice now, if I run python of names.py, it's correct. I'm seeing each of the names and each of the hellos, and there's no extra spaces in between. But just to be difficult, I'd really like us to be sorting these hellos. Really, I'd like to see Draco first, then Harry, then Hermione, then Ron, no matter what order they appear in the file. So I could go in, of course, to the file and manually change the file. But if that file is changing over time based on who is typing their name into the program, that's not really a good solution. In code, I should be able to load the file no matter what it looks like and just sort it all at once. Now, here is a reason to not do what I've just done. I can't iterate over each line in the file and print it out, but sort everything in advance, right? Logically, if I'm looking at each line one at a time and printing it out, it's too late to sort. I really need to read all of the lines first without printing them, sort them, then print them. So we have to take a step back in order to add now this new feature. So how can I do this? Well, let me combine some ideas from before. Let me go ahead and start fresh with this. Let me give myself a list called names and assign it an empty list, just so I have a variable in which to accumulate all of these lines. And now let me open the file with open, quote unquote, names.txt. And it turns out, I can tighten this up a little bit. It turns out if you're opening a file to read it, you don't need to specify quote unquote r. That is the implicit default. So you can tighten things up by just saying open names.txt, and you'll be able to read the file, but not write it. I'm going to give myself a variable called file, as before. I am going to iterate over the file in the same way for line in file, but instead of printing each line, I'm going to do this. I'm going to take my names list and append to it, and this is appending to a list in memory, not appending to the file itself. I'm going to go ahead and append the current line, but I'm going to strip off the new line at the end so that all I'm adding to this list is each of the students' names. Now I can use that familiar technique from before. Let me go outside of this with statement, because now I've read the entire file, presumably. So by the time I'm done with lines 4 and 5, again and again and again for each line in the file, I'm done with the file. It can close. I now have all of the students' names in this list variable. Let me do this. For name in, not just names, but the sorted names using our Python function sorted, which does just that, and do print quote unquote with an f string, hello, comma, and now I'll plug in bracket name. So now what have I done? I'm creating a list at the beginning just so I have a place to gather my data. I then, on lines 3 through 5, iterate over the file from top to bottom, reading in each line one at a time, stripping off the new line, and adding just the student's name to this list. And the reason I'm doing that is so that on line 7, I can sort all of those names now that they're all in memory and print them in order. I need to load them all into memory before I can sort them. Otherwise, I'd be printing them out prematurely, and Draco would end up last instead of first. So let me go ahead in my terminal window and run Python of names.py now and hit Enter. And there we go. The same list of 4 hellos, but now they're sorted. And this is a very common technique when dealing with files and information more generally. If you want to change that data in some way, like sorting it, creating some kind of variable at the top of your program like a list, adding or appending information to it just to collect it in one place, and then do something interesting with that collection, that list, is exactly what I've done here. Now, I should note that if we just want to sort the file, we can actually do this even more simply in Python, particularly by not bothering with this names list, nor the second for loop. And let me go ahead and instead just do more simply this. Let me go ahead and tell Python that we want the file itself to be sorted using that same sorted function, but this time on the file itself. And then inside of that for loop, let's just go ahead and print right away our hello, comma, followed by the line itself, but still stripping off of the end of it any white space therein. If we go ahead and run this same program now with Python of names.py and hit Enter, we get the same result, but of course it's a lot more compact. But for the sake of discussion, let's assume that we do actually want to potentially make some changes to the data as we iterate over it. So let me undo those changes, leave things as is, whereby now we'll continue to accumulate all of the names first into a list, maybe do something to them, maybe forcing them to uppercase or lowercase or the like, and then sort and print out each item. Let me pause and see if there's any questions now on file I/O, reading or writing, or now accumulating all of these values in some list.
Hi, is there a way to sort the files, but instead if you want it from alphabetically from A to Z, is there a way to reverse it from Z to A? Is there like a little extension that you can add to the end to do that, or would you have to create a new function?
If you wanted to reverse the contents of the file?
Yeah, so if you, instead of sorting them from A to Z in ascending order, if you wanted them in descending order, is there an extension for that?
There is indeed. And as always, the documentation is your friend. So if the goal is to sort them, not in alphabetical order, which is the default, but maybe reverse alphabetical order, you can take a look, for instance, at the formal Python documentation there. And what you'll see is this summary. You'll see that the sorted function takes a first argument, generally known as an iterable. And something that's iterable means that you can iterate over it. That is, you can loop over it, one thing at a time. What the rest of this line here means is that you can specify a key, like how you want to sort it, but more on that later. But this last named parameter here is reverse. And by default, per the documentation, it's false. It will not be reversed by default. But if we change that to true, I bet we can do that. So let me go back to VS Code here and do just that. Let me go ahead and pass in a second argument to sorted in addition to this iterable, which is my names list. Iterable again in the sense that it can be looped over. And let me pass in reverse equals true, thereby overriding the default of false. Let me now run Python of names.py, and now Ron's at the top and Draco's at the bottom. So there too, whenever you have a question like that moving forward, consider what does the documentation say and see if there's a germ of an idea there, because odds are if you have some problem, odds are some programmer before you has had the same question. Other thoughts?
Can we limit numbers of names? And the second question, can we find specific name in list?
Really good question. Can we limit the number of the names in the file, and can we find a specific one? We absolutely could. If we were to write code, we could, for instance, open the file first, count how many lines are already there, and then if there's too many already, we could just exit with sys.exit or some other message to indicate to the user that, sorry, the class is full. As for finding someone specifically, absolutely. You could imagine opening the file, iterating over it with a for loop again and again, and then adding a conditional. Like if the current line equals Harry, then we found the chosen run. And you can print something like that. So you can absolutely combine these ideas with previous ideas like conditionals to ask those same questions. How about one other question on file I/O?
So I just thought about this function like read all lines, and it looks like it's like separate all the lines by this special character \n, but it looks like we don't need it character, and we always strip it, and it looks like some bad design of function. Why wouldn't we just strip it inside this function?
A really good question. So we are, in my examples thus far, using rstrip to reverse, strip from the end of the line all of this white space. You might not want to do that. In this case, I am stripping it away because I know that each of those lines isn't some generic line of text. Each line really represents a name that I have put there myself. I'm using the new line just to separate one value from another. In other scenarios, you might very well want to keep that line ending because it's a very long series of text or a paragraph or something like that where you want to keep it distinct from the others. But it's just a convention. We have to use something, presumably, to separate one chunk of text from another. There are other functions in Python that will, in fact, handle the removal of that white space for you. Readlines, though, does literally that, though. It reads all of the lines as is. Well, allow me to turn our attention back to where we left off here, which is just names, to propose that with names.txt, we have an ability, it seems, to store each of these names pretty straightforwardly. But what if we wanted to keep track of other information as well? Suppose that we wanted to store information including a student's name and their house at Hogwarts, be it Gryffindor or Slytherin or something else. Well, where do we go about putting that? You know, Hermione lives in Gryffindor, so we could do something like this in our text file. Harry lives in Gryffindor, so we could do that. Ron lives in Gryffindor, so we could do that. And Draco lives in Slytherin, so we could do that. But I worry here. But I worry now that we're mixing apples and oranges, so to speak. Like some lines are names, some lines are houses. So this probably isn't the best design, if only because it's confusing or it's ambiguous. So maybe what we could do is adopt a convention. And indeed, this is in fact what a lot of programmers do. They change this file not to be names.txt, but instead, let me create a new file called names.csv. CSV stands for comma separated values, and it's a very common convention to store multiple pieces of information that are related in the same file. And so to do this, I'm going to separate each of these types of data not with another new line, but simply with a comma. I'm going to keep each student on their own line, but I'm going to separate the information about each student using a comma instead. And so now we sort of have a two-dimensional file, if you will. Row by row, we have our students. But if you think of these commas as representing a column, even though it's not perfectly straight because of the lengths of these names, it's a little jagged, you can think of these commas as representing a column. And it turns out these CSV files are very commonly used when you use something like Microsoft Excel, Apple Numbers, or Google Spreadsheets, and you want to export the data to share with someone else as a CSV file. Or conversely, if you want to import a CSV file into your preferred spreadsheet software like Excel or Numbers or Google Spreadsheets, you can do that as well. So CSV is a very common, very simple text format that just separates values with commas and different types of values ultimately with new lines as well. Let me go ahead and run code of students.csv to create a brand new file that's initially empty, and we'll add to it those same names, but also some other information as well. So if I now have this new file, students.csv, inside of which is one column of names, so to speak, and one column of houses, how do I go about changing my code to read not just those names, but also those names and houses so that they're not all on one line? We somehow have access to both type of value separately. Well, let me go ahead and create a new program here called students.py. And in this program, let's go about reading, not a text file per se, but a specific type of text file, a CSV, a comma separated values file. And to do this, I'm going to use similar code as before. I'm going to say with open, quote unquote, students.csv. I'm not going to bother specifying quote unquote r, because again, that's the default. But I'm going to give myself a variable name of file. And then in this file, I'm going to go ahead and do this. For line in file, as before. And now I have to be a bit clever here. Let me go back to students.csv, looking at this file, and it seems that on my loop, on each iteration, I'm going to get access to the whole line of text. I'm not going to automatically get access to just Hermione or just Gryffindor. recall that the loop is going to give me each full line of text. So logically, what would you propose that we do inside of a for loop that's reading a whole line of text at once, but we now want to get access to the individual values, like Hermione and Gryffindor, Harry and Gryffindor? How do we go about taking one line of text and gaining access to those individual values, do you think? Just instinctively, even if you're not sure what the name of the functions would be.
You can access it as you would as if you were using a dictionary, like using a key and value.
So ideally, we would access it using a key and value. But at this point in the story, all we have is this loop. And this loop is giving me one line of text at a time. I'm the programmer now. I have to solve this. There is no dictionary yet in question. How about another suggestion here?
So you can somehow split the two words based on the comma.
Yeah, even if you're not quite sure what function is going to do this, intuitively you want to take this whole line of text, Hermione, comma, Gryffindor, Harry, comma, Gryffindor, and so forth, and split that line into two pieces, if you will. And it turns out wonderfully the function we'll use is actually called split, that can split on any characters, but you can tell it what character to use. So I'm going to go back into students.py, and inside of this loop, I'm going to go ahead and do this. I'm going to take the current line. I'm going to remove the white space at the end, as always, using rstrip here. And then whatever the result of that is, I'm going to now call split and quote unquote comma. So the split function or method comes with strings, strs in Python. Any str has this method built in. And if you pass in an argument like a comma, what this split function will do is split that current string into 1, 2, 3, maybe more pieces by looking for that character again and again. Ultimately, split is going to return to us a list of all of the individual parts to the left and to the right of those commas. So I can give myself a variable called row here. And this is a common paradigm. When you know you're iterating over a file, specifically a CSV, it's common to think of each line of it as being a row. And each of the values therein separated by commas as columns, so to speak. So I'm going to deliberately name my variable row just to be consistent with that convention. And now what do I want to print? Well, I'm going to go ahead and say this. Print, how about the following? An f string that starts with curly braces. Well, how do I get access to the first thing in that row? Well, the row is going to have how many parts? 2. Because if I'm splitting on commas, and there's 1 comma per line, that's going to give me a left part and a right part, like Hermione and Gryffindor, Harry and Gryffindor. When I have a list like row, how do I get access to individual values? Well, I can do this. I can say row bracket 0. And that's going to go to the first element of the list, which should hopefully be the student's name. Then after that, I'm going to say is in, and I'm going to have another curly brace here for row bracket 1. And then I'm going to close my whole quote. So it looks a little cryptic at first glance, but most of this is just f-string syntax with curly braces to plug in values. And what values am I plugging in? Well, row, again, is a list, and it has 2 elements, presumably. Hermione in one and Gryffindor in the other, and so forth. So bracket 0 is the first element, because remember, we start indexing at 0 in Python, and 1 is going to be the second element. So let me go ahead and run this now and see what happens. Python of students.py, enter, and we see Hermione's in Gryffindor, Harry's in Gryffindor, Ron is in Gryffindor, and Draco is in Slytherin. So we have now implemented our own code from scratch that actually parses, that is, reads and interprets a CSV file ultimately here. Now let me pause to see if there's any questions, but we'll make this even easier to read in just a moment. Any questions on what we've just done here by splitting by comma?
So my question is, can we edit any line of code anytime we want, or the only option that we have is to append the lines? Or let's say if we want to, let's say, change Harry's house to, let's say, Slytherin or some other house.
Yeah, a really good question. What if you want to, in Python, change a line in the file and not just append to the end? You would have to implement that logic yourself. So for instance, you could imagine now opening the file and reading all of the contents in, then maybe iterating over each of those lines. And as soon as you see that the current name equals Harry, you could maybe change his house to Slytherin. And then it would be up to you, though, to write all of those changes back to the file. So in that case, you might want to, in simplest form, read the file once and let it close, then open it again, but open for writing and change the whole file. It's not really possible or easy to go in and change just part of the file, though you can do it. It's easier to actually read the whole file, make your changes in memory, then write the whole file out. But for larger files where that might be quite slow, you can be more clever than that. Well, let me propose now that we clean this up a little bit, because I actually think this is a little cryptic to read row bracket 0, row bracket 1. It's not that well written at the moment, I would say. But it turns out that when you have a variable that's a list, like row, you don't have to throw all of those variables into a list. You can actually unpack that whole sequence at once. That is to say, if you know that a function like split returns a list, but you know in advance that it's going to return 2 values in a list, the first and the second, you don't have to throw them all into a variable that itself is a list. You can actually unpack them simultaneously into 2 variables, doing name, comma, house. So this is a nice Python technique to not only create but assign automatically in parallel 2 variables at once, rather than just 1. So this will have the effect of putting the name in the left, Hermione, and it will have the effect of putting Gryffindor, the house, in the right variable. And we now no longer have a row. We can now make our code a little more readable by now literally just saying name down here and, for instance, house down here. So just a little more readable, even though functionally the code now is exactly the same. All right, so this now works, and I'll confirm as much by just running it once more. Python of students.py, enter, and we see that the text is as intended. But suppose for the sake of discussion that I'd like to sort this list of output. I'd like to say hello again to Draco first, then hello to Harry, then Hermione, then Ron. How can I go about doing this? Well, let's take some inspiration from the previous example where we were only dealing with names, and instead do it with these full phrases. So-and-so is in house. Well, let me go ahead and do this. I'm going to go ahead and start scratch and give myself a list called students, equal to an empty list initially. And then with open students.csv as file, I'm going to go ahead and say this. For line in file. And then below this, I'm going to do exactly as before. Name, comma, house equals the current line, stripping off the white space at the end, splitting it on a comma. So that's exact same as before. But this time, before I go about printing the sentence, I'm going to store it temporarily in a list so that I can accumulate all of these sentences and then sort them later. So let me go ahead and do this. Students, which is my list, dot append. Let me append the actual sentence I want to show on the screen. So another F string. So name is in house, just as before. But notice I'm not printing that sentence. I'm appending it to my list. Not a file, but to my list. Why am I doing this? Well, just because, as before, I want to do this. For student in the sorted students, I want to go ahead and print out student, like this. Well, let me go ahead and run Python of students.py and hit enter now, and I think we'll see, indeed, Draco is now first, Harry is second, Hermione is third, and Ron is fourth. But this is arguably a little sloppy, right? It seems a little hackish that I'm constructing these sentences, and even though I'm technically want to sort by name, I'm technically sorting by these whole English sentences. So it's not wrong, it's achieving the intended result, but it's not really well designed because I'm just kind of getting lucky that English is reading from left to right, and therefore when I print this out, it's sorting properly. It would be better really to come up with a technique for sorting by the students' names, not by some English sentence that I've constructed here on line 6. So to achieve this, I'm going to need to make my life more complicated for a moment, and I'm going to need to collect information about each student before I bother assembling that sentence. So let me propose that we do this. Let me go ahead and undo these last few lines of code so that we currently have 2 variables, name and house, each of which has name and the student's house respectively, and we still have our global variable students. But let me do this. Recall that Python supports dictionaries, and dictionaries are just collections of keys and values, so you can associate something with something else, like a name with Hermione, like a house with Gryffindor. That really is a dictionary. So let me do this. Let me temporarily create a dictionary that stores this association of name with house. Let me go ahead and do this. Let me say that the student here is going to be represented initially by an empty dictionary. And just like you can create an empty list with square brackets, you can create an empty dictionary with curly braces. So give me an empty dictionary that will soon have two keys, name and house. How do I do that? Well, I could do it this way. Student, open bracket, name, equals the student's name that we got from the line. Student bracket house equals the house that we got from the line. And now I'm going to append to the students list, plural, that particular student. Now, why have I done this? I've admittedly made my code more complicated. It's more lines of code. But I've now collected all of the information I have about students while still keeping track. What's a name? What's a house? The list, meanwhile, has all of the students' names and houses together. Now, why have I done this? Well, let me, for the moment, just do something simple. Let me do for student in students. And let me very simply now say, print the following f string. The current student with this name is in this current student's house. And now notice one detail. Inside of this f string, I'm using my curly braces as always. I'm using inside of those curly braces the name of a variable as always. But then I'm using not bracket 0 or 1, because these are dictionaries now, not list. But why am I using single quotes to surround house and to surround name? Why single quotes inside of this f string to access those keys?
Yes, because you have double quotes in that line 12, and so you have to tell Python to differentiate.
Exactly, because I'm already using double quotes outside of the f string. If I want to put quotes around any strings on the inside, which I do need to do for dictionaries, because recall, when you index into a dictionary, you don't use numbers like lists, 0, 1, 2, onward. You instead use strings, which need to be quoted. But if you're already using double quotes, it's easiest to then use single quotes on the inside so Python doesn't get confused about what lines up with what. So at the moment, when I run this program, it's going to print out those hellos, but they're not yet sorted. In fact, what I now have is a list of dictionaries. Nothing is yet sorted, but let me tighten up the code too to point out that it doesn't need to be quite as verbose. If you're in the habit of creating an empty dictionary, like this on line 6, and then immediately putting in two keys, name and house, each with two values, name and house respectively, you can actually do this all at once. So let me show you a slightly different syntax. I can do this. Give me a variable called student. And let me use curly braces on the right-hand side here. But instead of leaving them empty, let's just define those keys and those values now. Quote unquote name will be name. And quote unquote house will be house. This achieves the exact same effect in one line instead of 3. It creates a new non-empty dictionary containing a name key, the value of which is the student's name, and a house key, the value of which is the student's house. Nothing else needs to change. That will still just work. So that if I again run Python of students.py, I'm still seeing those greetings, but they're still not quite actually sorted. Well, what might I go about doing here in order to, what could I do to improve upon this further? Well, we need some mechanism now of sorting those students. But unfortunately, you can't do this. We can't sort all of the students now because those students are not names like they were before. They aren't sentences like they were before. Each of the students is a dictionary. And it's non-obvious how you would sort a dictionary inside of a list. So ideally, what do we want to do? If at the moment we hit line 9, we have a list of all of these students. And inside of that list is one dictionary per student. And each of those dictionaries has two keys, name and house. Wouldn't it be nice if there were a way in code to tell Python, sort this list by looking at this key in each dictionary? Because that would give us the ability to sort either by name or even by house or even by any other field that we add to that file. So it turns out we can do this. We can tell the sorted function not just to reverse things or not. It takes another named parameter called key, where you can specify what key should be used in order to sort some list of dictionaries. And I'm going to propose that we do this. I'm going to first define a function temporarily for now called getName. And this function's purpose in life, given a student, is to quite simply return the student's name. from that particular dictionary. So if student is a dictionary, this is going to return literally the student's name. And that's it. That's the sole purpose of this function in life. What do I now want to do? Well, now that I have a function that, given a student, will return to me the student's name, I can do this. I can change sorted to say, use a key that's equal to whatever the return value of getName is. And this now is a feature of Python. Python allows you to pass functions as arguments in two other functions. So getName is a function, sorted is a function, and I'm passing in getName to sorted as the value of that key parameter. Now, why am I doing that? Well, if you think of the getName function as just a block of code that will get the name of a student, that's handy because that's the capability that sorted needs. When given a list of students, each of which is a dictionary, sorted needs to know, how do I get the name of the student in order to do alphabetical sorting for you? The authors of Python didn't know that we were going to be creating students here in this class, so they couldn't have anticipated writing code in advance that specifically sorts on a field called student, let alone called name, let alone house. So what did they do? They instead built into the sorted function this named parameter key that allows us all these years later to tell their function sorted how to sort this list of dictionaries. So now watch what happens. If I run Python of students.py and hit enter, I now have a sorted list of output. Why? Because now that list of dictionaries has all been sorted by the student's name. I can further do this. If, as before, we want to reverse the whole thing by saying reverse equals true, we can do that too. Let me rerun Python of students.py and hit enter. Now it's reversed. Now it's Ron, then Hermione, Harry, and Draco. But we can do something different as well. What if I want to sort, for instance, by house name reversed? I could do this. I could change this function from getName to getHouse. I could change the implementation up here to be getHouse, and I can return not the student's name, but the student's house. And so now notice, if I run Python of students.py, enter, notice now it is sorted by house in reverse order. Slytherin is first, and then Gryffindor. If I get rid of the reverse, but keep the getHouse, and rerun this program, now it's sorted by house. Gryffindor is first, and Slytherin is last. And the upside now of this is because I'm using this list of dictionaries and keeping the students' data together until the last minute when I'm finally doing the printing, I now have full control over the information itself, and I can sort by this or that. I don't have to construct those sentences in advance like I rather hackishly did the first time. All right, that was a lot. Let me pause here to see if there are questions.
So when we're sorting the files, every time should we use the loops, or like a dictionary or any kind of list? Can we sort by just sorting, not looping or any kind of stuff?
A good question. And the short answer with Python alone, you're the programmer, you need to do the sorting. With libraries and other techniques, absolutely. You can do more of this automatically because someone else has written that code. What we're doing at the moment is doing everything from scratch ourselves. But absolutely, with other functions or libraries, some of this could be made more easily done. Some of this could be made easier. Other questions on this technique here?
It equal to the returned value of the function. Can it be equal to just a variable or a value?
Well, yes, it should equal a value. So I'm specific, and I should clarify actually, since this was not obvious. So when you pass in a function like getName or getHouse to the sorted function as the value of key, that function is automatically called by the sorted function for you on each of the dictionaries in the list. And it uses the return value of getName or getHouse to decide what strings to actually use to compare in order to decide which is alphabetically correct. So this function, which you pass just by name, you do not pass in parentheses at the end, is called by the sorted function in order to figure out for you how to compare these same values.
How can we use nested dictionaries? I have read about nested dictionaries. What is the difference between nested dictionaries and dictionary inside a list? I think it is.
Sure. So we are using a list of dictionaries. Why? Because each of those dictionaries represents a student. And a student has a name and a house. And we want to, I claim, maintain that association. And it's a list of students because we've got multiple students, 4 in this case. You could create a structure that is a dictionary of dictionaries. But I would argue it just doesn't solve a problem. I don't need a dictionary of dictionary. I need a list of key value pairs right now. That's all. So let me propose if we go back to students.py here and we revert back to the approach where we have getName as the function, both used and defined here, and that function returns the student's name. What happens to be clear is that the sorted function will use the value of key, getName in this case, calling that function on every dictionary in the list that it's supposed to sort. And that function getName returns the string that sorted will actually use to decide whether things go in this order, left, right, or in this order, right, left. It alphabetizes things based on that return value. So notice that I'm not calling the function getName here with parentheses. I'm passing it in only by its name so that the sorted function can call that getName function for me. Now, it turns out, as always, if you're defining something, be it a variable or in this case a function, and then immediately using it, but never once again needing the name of that function like getName, we can actually tighten this code up further. I can actually do this. I can get rid of the getName function altogether, just like I could get rid of a variable that isn't strictly necessary. And instead of passing key, the name of a function, I can actually pass key what's called a lambda function, which is an anonymous function, a function that just has no name. Why? Because you don't need to give it a name if you're only going to call it in one place. And the syntax for this in Python is a little weird, but if I do key equals literally the word lambda, then something like student, which is the name of the parameter I expect this function to take, and then I don't even type the return key. I instead just say student bracket name. So what am I doing here with my code? This code here that I've highlighted is equivalent to the getName function I implemented a moment ago. The syntax is admittedly a little different. I don't use def. I didn't even give it a name like getName. I instead am using this other keyword in Python called lambda, which says, hey, Python, here comes a function, but it has no name. It's anonymous. That function takes a parameter. I could call it anything I want. I'm calling it student. Why? Because this function that's passed in as key is called on every one of the students in that list, every one of the dictionaries in that list. What do I want this anonymous function to return? Well, given a student, I want to index into that dictionary and access their name so that the string Hermione and Harry and Ron and Draco is ultimately returned. And that's what the sorted function uses to decide how to sort these bigger dictionaries that have other keys like house as well. So if I now go back to my terminal window and run Python of students.py, it still seems to work the same, but it's arguably a little better designed because I didn't waste lines of code by defining some other function, calling it in one and only one place. I've done it all sort of in one breath, if you will. All right, let me pause here to see if there's any questions specifically about lambda or anonymous functions and this tightening up of the code.
And I have one question, like whether we could define lambda twice.
You can use lambda twice. You can create as many anonymous functions as you'd like, and you generally use them in contexts like this where you want to pass to some other function a function that itself does not need a name. So you can absolutely use it in more than one place. I just have only one use case for it. How about one other question on lambda or anonymous functions specifically?
What if our lambda would take more than one line, for example?
Sure, if your lambda function takes multiple parameters, that is fine. You can simply specify commas followed by the names of those parameters, maybe x and y or so forth, after the name student. So here too, lambda looks a little different from def in that you don't have parentheses, you don't have the keyword def, you don't have a function name, but ultimately they achieve that same effect. They create a function anonymously and allow you to pass it in, for instance, as some value here. So let's now change students.csv to contain not students' houses at Hogwarts, but their homes where they grew up. So Draco, for instance, grew up in Malfoy Manor. Ron grew up in the Burrow. Harry grew up in number 4 Privet Drive. And according to the internet, no one knows where Hermione grew up. The movies apparently took certain liberties with where she grew up. So for this purpose, we're actually going to remove Hermione because it is unknown exactly where she was born. So we still have some 3 students. But if anyone can spot the potential problem now, how might this be a bad thing? Well, let's go and try and run our own code here. Let me go back to students.py here, and let me propose that I just change my semantics because I'm now not thinking about Hogwarts houses, but the student's own home. So I'm just going to change some variables. I'm going to change this house to a home, this house to a home, as well as this one here. I'm still going to sort the students by name, but I'm going to say that they're not in a house, but rather from a home. So I've just changed the names of my variables in my grammar in English here ultimately to print out that, for instance, Harry is from number 4 Privet Drive, and so forth. But let's see what happens here when I run Python of this version of students.py, having changed students.csv to contain those homes and not houses. Enter. Our first value error. Like the program just doesn't work. What might explain this value error, the explanation of which rather cryptically is too many values to unpack, and the line in question is this one involving split. How did all of a sudden, after all of these successful runs of this program, did line 5 suddenly now break?
In the line in students.csv, you have 3 values. There's a line that you have 3 values and students.
Yeah, I spent a lot of time trying to figure out where every student should be from so that we could create this problem for us. And wonderfully, like the first sentence of the book is number 4 Privet Drive. And so the fact that that address has a comma in it is problematic. Why? Because you and I decided some time ago to just standardize on commas, CSV, comma, separated values, to denote the we standardized on commas in order to delineate one value from another. And if we have commas grammatically in the student's home, we're clearly confusing it as this special symbol. And the split function is now, for just Harry, trying to split it into 3 values, not just 2. And that's why there's too many values to unpack, because we're only trying to assign 2 variables, name and house. Now, what could we do here? Well, we could just change our approach, for instance. Like one paradigm that is not uncommon is to use something a little less common, like a vertical bar. So I could go in and change all of my commas to vertical bars. That too could eventually come back to bite us in that if my file eventually has vertical bars somewhere, it might still break. So maybe that's not the best approach. I could maybe do something like this. I could escape the data, as I've done in the past, and maybe I could put quotes around any English string that itself contains a comma. And that's fine. I could do that, but then my code, students.py, is going to have to change too, because I can't just naively split on a comma now. I'm going to have to be smarter about it. I'm going to have to take into account split only on the commas that are not inside of quotes, and it's getting complicated fast. And at this point, you need to take a step back and consider, you know what, if we're having this problem, odds are many other people before us have had this same problem. It is incredibly common to store data in files. It is incredibly common to use CSV files specifically. And so you know what? Why don't we see if there's a library in Python that exists to read and or write CSV files. Rather than reinvent a wheel, so to speak, let's see if we can write better code by standing on the shoulders of others who have come before us, programmers past, and actually use their code to do the reading and writing of CSVs so we can focus on the part of our problem that you and I care about. So let's propose that we go back to our code here and see how we might use the CSV library. Indeed, within Python, there is a module called CSV. The documentation for it is at this URL here in Python's official documentation, but there's a few functions that are pretty readily accessible if we just dive right in. And let me propose that we do this. Let me go back to my code here, and instead of reinventing this wheel and reading the file line by line and splitting on commas and dealing now with quotes and privet drives and so forth, let's do this instead. At the start of my program, let me go up and import the CSV module. Let's use this library that someone else has written that's dealing with all of these corner cases, if you will. I'm still going to give myself a list, initially empty, in which to store all these students, but I'm going to change my approach here now just a little bit. When I open this file with width, let me go in here and change this a little bit. I'm going to go in here now and say this. Reader equals csv.reader, passing in file as input. So it turns out, if you read the documentation for the CSV module, it comes with a function called reader, whose purpose in life is to read a CSV file for you and figure out where are the commas, where are the quotes, where are all the potential corner cases, and just deal with them for you. You can override certain defaults or assumptions in case you're using not a comma, but a pipe or something else. But by default, I think it's just going to work. Now, how do I iterate over a reader and not the raw file itself? It's almost the same. The library allows you still to do this for each row in the reader. So you're not iterating over the file directly now. You're iterating over the reader, which is, again, going to handle all of the parsing of commas and new lines and more. For each row in the reader, what am I going to do? Well, at the moment, I'm going to do this. I'm going to append to my students list the following dictionary. A dictionary that has a name whose value is the current row's first column and whose house, or rather home now, is the row's second column. Now, it's worth noting that the reader for each line in the file indeed returns to me a row, but it returns to me a row that's a list, which is to say that the first element of that list is going to be the student's name, as before. The second element of that list is going to be the student's home, as now before. But if I want to access each of those elements, remember that lists are 0 indexed. We start counting at 0 and then 1, rather than 1 and then 2. So if I want to get at the student's name, I use row bracket 0. And if I want to get at the student's home, I use row bracket 1. But in my for loop, we can do that same unpacking as before. If I know this CSV is only going to have 2 columns, I could even do this. For name home in reader, and now I don't need to use list notation. I can unpack things all at once and say name here and home here. The rest of my code can stay exactly the same, because what am I doing now on line 8? I'm still constructing the same dictionary as before, albeit for homes instead of houses. And I'm grabbing those values now, not from the file itself and my use of split, but the reader. And again, what the reader is going to do is figure out where are those commas, where are the quotes, and just solve that problem for you. So let me go now down to my terminal window and run python of students.py and hit enter. And now we see successfully, sorted no less, that Draco is from Malfoy Manor, Harry is from number 4, comma, Privet Drive, and Ron is from the Borough. Questions now on this technique of using CSV reader from that CSV module, which again is just getting us out of the business of reading each line ourselves and reading each of those commas and splitting.
So my questions are related to something a bit in the past. I recognize that you are reading a file every time we're assuming that we have the CSV file to hand already in this case. Is it possible to make a file readable and writable? So in case if you want, you could write some stuff to the file, but then at the same time you could have another function that reads through the file and does changes to it as you go along.
A really good question, and the short answer is yes. However, historically, the mental model for a file is that of a cassette tape. Years ago, not really in use anymore, but cassette tapes are sequential, whereby they start at the beginning, and if you want to get to the end, you kind of have to unwind the tape to get to that point. The closest analog nowadays would be something like Netflix or any streaming service where there's a scrubber that you have to go left to right. You can't just jump there or jump there. You don't have random access. So the problem with files, if you want to read and write them, you or some library needs to keep track of where you are in the file, so that if you're reading from the top and then you write at the bottom and you want to start reading again, you seek back to the beginning. So it's not something we'll do here in class. It's more involved, but it's absolutely doable. For our purposes, we'll generally recommend read the file, and then if you want to change it, write it back out rather than trying to make more piecemeal changes, which is good if, though, the file is massive and it would just be very expensive time-wise to change the whole thing. Other questions on this CSV reader?
Is possible to write a paragraph in that file?
Absolutely. Right now I'm writing very small strings, just names or houses as I did before, but you can absolutely write as much text as you want. Indeed. Other questions on CSV reader?
Can a user choose himself a key, like input key will be a name or home?
So short answer, yes, we could absolutely write a program that prompts the user for a name and a home, and we could write out those values. And in a moment, we'll see how you can write to a CSV file. For now, I'm assuming as the programmer who created students.csv that I know what the columns are going to be, and therefore I'm naming my variables accordingly. However, this is a good segue to one final feature of reading CSVs, which is that you don't have to rely on either getting a row as a list and using bracket 0 or bracket 1, and you don't have to unpack things manually in this way. We could actually be smarter and start storing the names of these columns in the CSV file itself. And in fact, if any of you have ever opened a spreadsheet file before, be it in Excel, Apple Numbers, Google Spreadsheets, or the like, odds are you've noticed that the first row very frequently is a little different. It actually is boldface sometimes, or it actually contains the names of those columns, the names of those attributes below. And we can do this here in students.csv. I don't have to just keep assuming that the student's name is first and that the student's home is second. I can explicitly bake that information into the file just to reduce the probability of mistakes down the road. I can literally use the first row of this file and say name, comma, home. So notice that name is not literally someone's name, and home is not literally someone's home. It is literally the words name and home separated by a comma. And if I now go back into students.py and don't use CSV reader, but instead I use a dictionary reader, I can actually treat my CSV file even more flexibly, not just for this, but for other examples too. Let me do this. Instead of using a CSV reader, let me use a CSV dict reader, which will now iterate over the file, top to bottom, loading in each line of text not as a list of columns, but as a dictionary of columns. What's nice about this is that it's going to give me automatic access now to those columns' names. I'm going to revert to just saying for row in reader, and now I'm going to append a name and a home. But how am I going to get access to the current row's name and the current row's home? Well, earlier I used bracket 0 for the first and bracket 1 for the second when I was using a reader. A reader returns lists. A dict reader or dictionary reader returns dictionaries, one at a time. And so if I want to access the current row's name, I can say row quote unquote name. I can say here for home, row quote unquote home, and I now have access to those same values. The only change I had to make, to be clear, was in my CSV file, I had to include on the very first row little hints as to what these columns are. And if I now run this code, I think it should behave pretty much the same, Python of students.py, and indeed, we get the same sentences, but now my code is more robust against changes in this data. If I were to open this CSV file in Excel or Google Spreadsheets or Apple Numbers and for whatever reason change the columns around, maybe this is a file that you're sharing with someone else, and just because they decide to sort things differently left to right by moving the columns around, previously my code would have broken because I was assuming that name is always first and home is always second. But if I did this, be it manually in one of those programs or here, home comma name, and suppose I reversed all of this. The home comes first, followed by Harry. The borough, then by Ron. And then lastly, Malfoy Manor, then Draco. Notice that my file is now completely flipped. The first column's now the second, and the second's the first, but I took care to update the header of that file, the first row. Notice my Python code, I'm not going to touch it at all. I'm going to rerun Python of students.py and hit enter, and it still just works. And this, too, is an example of like coding defensively. Like, what if someone changes your CSV file, your data file? Ideally, that won't happen. But even if it does now, because I'm using a dictionary reader that's going to infer from that first row for me what the columns are called, my code just keeps working. And so it keeps getting, if you will, better and better. Any questions now on this approach?
Yeah, what is the importance of new line in CSV file?
What's the importance of the new line in the CSV file? It's partly a convention. In the world of text files, we humans have just been for decades in the habit of storing data line by line. It's visually convenient. It's just easy to extract from the file because you just look for the new lines. So the new line just separates some data from some other data. We could use any other symbol on the keyboard, but it's just common to hit enter to just move the data to the next line. Just a convention. Other questions?
It seems to be working fine
if you just have name and home. I'm wondering what will happen if you want to put in more data. Say you wanted to add a house to both the name and the home.
Sure, if you wanted to add the house back. So if I go in here and add house last, and I go here and say Gryffindor for Harry, Gryffindor for Ron, and Slytherin for Draco. Now I have 3 columns, effectively, if you will. Home on the left, name in the middle, house on the right, each separated by commas with weird things like number 4, comma, privet drive, still quoted. Notice if I go back to students.py and I don't change the code at all and run Python of students.py, it still just works. And this is what's so powerful about a dictionary reader. It can change over time. It can have more and more columns. Your existing code is not going to break. Your code would break, would be much more fragile, so to speak, if you were making assumptions like the first column's always going to be name. The second column's always going to be house. Things will break fast if those assumptions break down. So not a problem in this case. Well, let me propose that besides reading CSVs, let's at least take a peek at how we might write a CSV too. If you're writing a program in which you want to store not just students' names, but maybe their homes as well in a file, how can we keep adding to this file? Let me go ahead and delete the contents of students.csv and just re-add a single simple row, name, comma, home, so as to anticipate inserting more names and homes into this file. And then let me go to students.py and let me just start fresh so as to write out data this time. I'm still going to go ahead and import CSV. I'm going to go ahead now and prompt the user for their name. So input, quote unquote, what's your name, question mark. And I'm going to go ahead and prompt the user for their home. So home equals input, quote unquote, where's your home, question mark. Now I'm going to go ahead and open the file, but this time for writing instead of reading as follows. With open, quote unquote, students.csv. I'm going to open it in append mode so that I keep adding more and more students and homes to the file rather than just overwriting the entire file itself. And I'm going to use a variable name of file. I'm then going to go ahead and give myself a variable called writer. And I'm going to set it equal to the return value of another function in the CSV module called csv.writer. And that writer function takes as its sole argument the file variable there. Now I'm going to go ahead and just do this. I'm going to say writer.writeRow, and I'm going to pass into writeRow the line that I want to write to the file, specifically as a list. So I'm going to give this a list of name, comma, home, which of course are the contents of those variables. Now I'm going to go ahead and save the file. I'm going to go ahead and rerun Python of students.py, hit enter, and what's your name? Well, let me go ahead and type in Harry as my name, and number 4, comma, privet drive. Enter. Now notice that input itself did have a comma, and so if I go to my CSV file now, notice that it's automatically been quoted for me so that subsequent reads from this file don't confuse that comma with the actual comma between Harry and his home. Well, let me go ahead and run it a couple of more times. Let me go ahead and rerun Python of students.py. Let me go ahead and input this time Ron and his home as the borough. Let's go back to students.csv to see what it looks like. Now we see Ron, comma, the borough has been added automatically to the file. And let's do one more. Python of students.py, enter. Let's go ahead and give Draco's name and his home, which would be Malfoy Manor. Enter. And if we go back to students.csv, now we see that Draco is in the file itself. And the library took care of not only writing each of those rows per the function's name, it also handled the escaping, so to speak, of any strings that themselves contained a comma, like Harry's own home. Well, it turns out there's yet another way we could implement this same program without having to worry about precisely that order again and again and just passing in a list. It turns out if we're keeping track of what's the name and what's the home, we could use something like a dictionary to associate those keys with those values. So let me go ahead and back up and remove these students from the file, leaving only the header row again, name, comma, home. And let me go over to students.py. And this time, instead of using CSV writer, I'm going to go ahead and use csv.dictWriter, which is a dictionary writer that's going to open the file in much the same way, but rather than write a row as this list of name, comma, home, what I'm now going to do is follows. I'm going to first output an actual dictionary, the first key of which is name, colon, and then the value thereof is going to be the name that was typed in. And I'm going to pass in a key of home, quote unquote, the value of which, of course, is the home that was typed in. But with dict writer, I do need to give it a hint as to the order in which those columns are when writing it out, so that subsequently they could be read even if those orderings change. Let me go ahead and pass in field names, which is a second argument to dict writer, equals, and then a list of the actual columns that I know are in this file, which of course are name, comma, home. Those times in quotes, because that's indeed the string names of the columns, so to speak, that I intend to write to in that file. All right, now let me go ahead and go to my terminal window, run Python of students.py this time. I'll type in Harry's name again. I'll again type in number 4, comma, privet drive, enter. Let's now go back to students.csv, and voila, Harry's back in the file, and it's properly escaped or quoted. I'm sure then if we do this again with Ron and the burrow, and let's go ahead and run it one third time with Draco and Malfoy Manor, enter. Let's go back to students.csv, and via this dictionary writer, we now have all 3 of those students as well. So whereas with CSV writer, the onus is on us to pass in a list of all of the values we want to put from left to right. With a dictionary writer, technically they could be in any order in the dictionary. In fact, I could just have correctly done this, passing in home followed by name, but it's a dictionary. And so the ordering in this case does not matter so long as the key is there and the value is there. And because I have passed in field names as the second argument to dict writer, it ensures that the library knows exactly which column contains name or home, respectively. Are there any questions now on dictionary reading, dictionary writing, or CSVs more generally?
Is there any specific situation for me to use single quotation or double quotation? Because after the print, we use single quotation to represent the key of the dictionary. But after the reading or writing, we use the double quotation.
It's a good question. In Python, you can generally use double quotes or you can use single quotes, and it doesn't matter. You should just be self-consistent so that stylistically your code looks the same all throughout. Sometimes, though, it is necessary to alternate if you're already using double quotes, as I was earlier for a long F string. But inside that F string, I was interpolating the values of some variables using curly braces, and those variables were dictionaries. And in order to index into a dictionary, you use square brackets and then quotes. But if you're already using double quotes out here, you should generally use single quotes here or vice versa. But otherwise, I'm in the habit of using double quotes everywhere. Others are in the habit of using single quotes everywhere. It only matters sometimes if one might be confused for the other. Other questions on dictionary writing or reading?
Yeah, David. My question is, can we use multiple CSV files in any program?
Absolutely. You can use as many CSV files as you want, and it's just one of the formats that you can use to save data. Other questions on CSVs or file I/O?
Thanks for taking my question. So when you're reading from the file, you had the as a dictionary, you had the fields called. Couldn't you just call when you're reading? Couldn't you just call the row? In the previous version of the students .py file, when you're reading each row, you were splitting out the fields by name. Yeah. So when you're appending to the students list, can you just call for row in reader students.append row rather than naming each of the fields?
Oh, very clever. Short answer, yes. Insofar as dict reader returns one dictionary at a time, when you loop over it, row is already going to be a dictionary. So yes, you could actually get away with doing this, and the effect would really be the same in this case. Good observation. How about one more question on CSVs?
Yeah, when reading in CSVs from my past work with data, a lot of things can go wrong. I don't know if it's a fair question that you can answer in a few sentences, but are there any best practices to double check that sort of no mistakes occurred?
It's a really good question. And I would say in general, if you're using code to generate the CSVs and to read the CSVs, and you're using a good library, theoretically, nothing should go wrong. It should be 100% correct if the libraries are 100% correct. You and I tend to be the problem. Like when you let a human touch the CSV, or when Excel or Apple Numbers or some other tools involved that might not be aligned with your code's expectations, things then, yes, can break. The goal really, sometimes, honestly, the solution is manual fixes. You go in and fix the CSV, or you have a lot of error checking, or you have a lot of try except just to tolerate mistakes in the data. But generally, I would say if you're using CSV or any file format internally to a program to both read and write it, you shouldn't have concerns there. You and I, the humans, are the problem, generally speaking, and not the programmers, the users of those files instead. All right, allow me to propose that we leave CSVs behind, but to note that they're not the only file format you can use in order to read or write data. In fact, they're a popular format, as is just raw text files, .txt files, but you can store data really any way that you want. We've just picked CSVs because it's representative of how you might read and write from a file, and do so in a structured way, where you can somehow have multiple keys, multiple values, all in the same file, without having to resort to what would be otherwise known as a binary file. So a binary file is a file that's really just zeros and ones, and they can be laid out in any pattern you might want, particularly if you want to store not textual information, but maybe graphical or audio or video information as well. So it turns out that Python is really good when it comes to having libraries for really everything. And in fact, there's a popular library called Pillow that allows you to navigate image files as well, and to perform operations on image files. You can apply filters a la Instagram. You can animate them as well. And so what I thought we'd do is leave behind text files for now and tackle one more demonstration, this time focusing on this particular library and image files instead. So let me propose that we go over here to VS Code and create a program ultimately that creates an animated GIF. These things are everywhere nowadays in the form of memes and animations and stickers and the like. And an animated GIF is really just an image file that has multiple images inside of it. And your computer or your phone shows you those images one after another, sometimes on an endless loop, again and again. And so long as there's enough images, it creates the illusion of animation, because your mind and mine kind of fills in the gaps visually and just assumes that if something is moving, even though you're only seeing 1 frame per second or some sequence thereof, it looks like an animation. So it's like a simplistic version of a video file. Well, let me propose that we start with maybe a couple of costumes from another popular programming language. And let me go ahead and open up my first costume here, number 1. So suppose here that this is a costume, or really just a static image here, costume1.gif. And it's just a static picture of a cat, no movement at all. Let me go ahead now and open up a second one, costume2.gif, that looks a little bit different. Notice, and I'll go back and forth, this cat's legs are a little bit aligned differently, so that this was version 1. And this was version 2. Now, these cats come from a programming language from MIT called Scratch that allows you very graphically to animate all this and more. But we'll use just these 2 static images, costume 1 and costume 2, to create our own animated GIF that after this you could text to a friend or message them, much like any meme online. Well, let me propose that we create this animated GIF, not by just using some off-the-shelf program that we downloaded, but by writing our own code. Let me go ahead and run code of costumes.py and create our very own program that's going to take as input 2 or even more image files and then generate an animated GIF from them by essentially creating this animated GIF by toggling back and forth endlessly between those 2 images. Well, how am I going to do this? Well, let's assume that this will be a program called costumes.py that expects 2 command line arguments, the names of the files, the individual costumes that we want to animate back and forth. So to do that, I'm going to import sys so that we ultimately have access to sys.argv. I'm then, from this Pillow library, going to import support for images specifically. So from PIL, import image, capital I, as per the library's documentation. Now I'm going to give myself an empty list called images, just so I have a list in which to store 1 or 2 or more of these images. And now let me do this. For each argument in sys.argv, I'm going to go ahead and create a new image variable, set it equal to this image dot open function passing in arg. Now, what is this doing? I'm proposing that eventually I want to be able to run Python of costumes.py, and then as command line arguments specify costume1.gif space costume2.gif. So I want to take in those file names from the command line as my arguments. So what am I doing here? Well, I'm iterating over sys.argv, all of the words in my command line arguments. I'm creating a variable called image, and I'm passing to this function image.open from the pillow library that specific argument. And that library is essentially going to open that image in a way that gives me a lot of functionality for manipulating it, like animating. Now I'm going to go ahead and append to my images list that particular image. And that's it. So this loop's purpose in life is just to iterate over the command line arguments and open those images using this library. The last line is pretty straightforward. I'm going to say this. I'm going to grab the first of those images, which is going to be in my list at location 0, and I'm going to save it to disk. That is, I'm going to save this file. Now, in the past, when we use CSVs or text files, I had to do the file opening. I had to do the file writing, maybe even the closing. I don't need to do that with this library. The Pillow library takes care of the opening, the closing, and the saving for me by just calling save. I'm going to call this save function, and just to leave space, because I have a number of arguments to pass, I'm going to move to another line so it fits. I'm going to pass in the name of the file that I want to create, costume.gif. That will be the name of my animated GIF. I'm going to tell this library to save all of the frames that I pass to it. So the first costume, the second costume, and even more if I gave them. I'm going to then append to this first image, the image is 0, the following images equals this list of images. And this is a bit clever, but I'm going to do this. I want to append the next image there, images 1. And now I want to specify a duration of 200 milliseconds for each of these frames, and I want this to loop forever. And if you specify loop equals 0, that is time 0, it means it's just not going to loop a finite number of times, but an infinite number of times instead. And I need to do one other thing. Recall that sys.argv contains not just the words I typed after my program's name, but what else does sys.argv contain? If you think back to our discussion of command line arguments, what else is in sys.argv besides the words I'm about to type, like costume1.gif and costume2?
Yeah, so we'll actually get in the original name of the program we want to run, the costumes.py.
Indeed, we'll get the original name of the program, costumes.py in this case, which is not a GIF, obviously. So remember that using slices in Python, we can do this. If sys.argv is a list, and we want to get a slice of that list, everything after the first element, we can do 1:, which says start at location 1, not 0, and take a slice all the way to the end. So give me everything except the first thing in that list, which, to Mackenzie's point, is the name of the program. Now, if I haven't made any mistakes, let's see what happens. I'm going to run Python of costumes.py, and now I'm going to specify the two images that I want to animate. So costume1.gif and costume2.gif. What is the code now going to do? Well, to recap, we're using the sys library to access those command line arguments. We're using the pillow library to treat those files as images and with all the functionality that comes with that library. I'm using this images list just to accumulate all of these images one at a time from the command line. And in lines 7 through 9, I'm just using a loop to iterate over all of them and just add them to this list after opening them with the library. And the last step, which is really just one line of code broken onto 3 so that it all fits, I'm going to save the first image, but I'm asking the library to append this other image to it as well. Not bracket 0, but bracket 1. And if I had more, I could express those as well. I want to save all of these files together. I want to pause 200 milliseconds, a fifth of a second, in between each frame. And I want it to loop infinitely many times. So now, if I cross my fingers as always, hit Enter, nothing bad happened, and that's almost always a good thing. Let me now run code of costumes.gif to open up in VS Code the final image. And what I think I should see is a very happy cat And indeed. So now we've seen not only that we can read and write files, be it textually, we can read and now write files that are binary, zeros and ones. We've just scratched the surface. This is using the library called Pillow. But ultimately, this is going to give us the ability to read and write files however we want. So we've now seen that via file I/O, we can manipulate not just textual files, be it TXT files or CSVs, but even binary files as well. In this case, they happen to be images, but if we dived in deeper, we could explore audio and video and so much more, all by way of these simple primitives, this ability somehow to read and write files. That's it for now. We'll see you next time. All right, this is CS50's Introduction to Programming with Python. My name is David Malin, and this is our week on regular expressions. So a regular expression, otherwise known as a regex, is really just a pattern. And indeed, it's quite common in programming to want to use patterns to match on some kind of data, often user input. For instance, if the user types in an email address, whether to your program or a website or an app on your phone, you might ideally want to be able to validate that they did indeed type in an email address and not something completely different. So using regular expressions, we're going to have the newfound capability to define patterns in our code to compare them against data that we're receiving from someone else, whether it's just to validate it, or heck, even if we want to clean up a whole lot of data that itself might be messy because it too came from us humans. Before, though, we use these regular expressions, let me propose that we solve a few problems using just some simpler syntax and see what kind of limitations we run up against. Let me propose that I open up VS Code here, and let me create a file called validate.py. The goal at hand being to validate, how about just that, a user's email address. They've come to your app, they've come to your website, they type in their email address, and we want to say, yes or no, this email address looks valid. All right, let me go ahead and type code of validate.py to create a new tab here. And then within this tab, let me go ahead and start writing some code. How about that keeps things simple initially? First, let me go ahead and prompt the user for their email address, and I'll store the return value of input in a variable called email, asking them, what's your email, ? I'm going to go ahead and preemptively at least clean up the user's input a little bit by minimally just calling strip at the end of my call to input, because recall that input returns a string or a stir. Strs come with some built-in methods or functions, one of which is strip, which has the effect of stripping off any leading white space to the left or any trailing white space to the right. So that's just going to go ahead and at least avoid the human having accidentally typed in a space character. We're going to throw it away just in case. Now I'm going to do something simple. For a user's input to be an email address, I think we can all agree that it's got to minimally have an @ sign somewhere in it. So let's start simple. If the user has typed in something with an @ sign, let's very generously just say, OK, valid. It looks like an email address. And if we're missing that @ sign, let's say invalid, because clearly it's not an email address. It's not going to be the best version of my code yet, but we'll start simple. So I'm going to ask the question, if there is an @ symbol in the user's email address, go ahead and print out, for instance, quote unquote valid. Else, if there's not, now I'm pretty confident that the email address is in fact invalid. Now, what is this code doing? Well, if @ sign in email is a Pythonic way of asking, is this string, quote unquote @ in this other string, email, no matter where it is, at the beginning, the middle, or the end, it's going to automatically search through the entire string for you automatically. I could do this more verbosely, and I could use a for loop or a while loop and look at every character in the user's email address, looking to see if it's an @ sign. But this is one of the things that's nice about Python. You can do more with less. So just by saying if @ quote unquote in email, we're achieving that same result. We're going to get back true if it's somewhere in there, thus valid, or false if it is not. Well, let me go ahead now and run this program in my terminal window with Python of validate.py. And I'm going to go ahead and give it my email address, malin@harvard.edu, enter. And indeed, it's valid. Looks valid, is valid. But of course, this program's technically broken. It's buggy. What would be an example input, if someone might like to volunteer an answer here, that would be considered valid, but you and I know it really isn't valid?
Yeah, thank you. Well, for instance, you can type just do science, and that's it, and it still be valid. Still be valid according to your program, but the same.
Exactly. We've set a very low bar here. In fact, if I go ahead and rerun python of validate.py, and I'll just type in one @, that's it. No username, no domain name. This doesn't really look like an email address, but unfortunately, my code thinks it in fact is, because it's obviously just looking for an @ alone. Well, how could we improve this? Well, minimally, an email address, I think, tends to have, though this is not actually a requirement, tends to have an @ and a single dot at least, maybe somewhere in the domain name. So malin@harvard.edu. So let's check for that dot as well, though again, strictly speaking, doesn't even have to be that case. But I'm going for my own email address, at least for now, as our test case. So let me go ahead and change my code now and say not only if @ is an email, but also dot is in email as well. So I'm asking now two questions. I have two Boolean expressions, if @ in email, and I'm anding them together logically. This is a logical and, so to speak. So if it's the case that @ is in email and dot is in email, OK, now I'm going to go ahead and say valid. All right, this would still seem to work for my email address. Let me go ahead and run python of validate.py, malin@harvard.edu, enter. And that, of course, is valid as expected. But here, too, we can be a little adversarial and type in something nonsensical like @dot. And unfortunately, that, too, is going to be mistaken as valid, even though there's still no username, domain name, or anything like that. So I think we need to be a little more methodical here. In fact, notice that if I do this like this, the @ can be anywhere, and the dot can be anywhere. But if I'm assuming the user is going to have a traditional domain name like harvard.edu or gmail.com, I really want to look for the dot in the domain name only, not necessarily just the username. So let me go ahead and do this. Let me go ahead and introduce a bit more logic here, and instead do this. Let me go ahead and do email.split of quote unquote @. So email again is a string or a stir. Strs come with methods not just strip, but also another one called split that, as the name implies, will split one stir into multiple ones if you give it a character or more to split on. So this is hopefully going to return to me two parts from a traditional email address, the username and the domain name. And it turns out I can unpack that sequence of responses by doing this. Username, comma, domain equals this. I could store it in a list or some other structure, but if I already know in advance what kinds of values I'm expecting, a username and hopefully a domain, I'm going to go ahead and do it like this instead and just define two variables at once on one line of code. And now I'm going to be a little more precise. If username, then I'm going to go ahead and say print valid. Else, I'm going to go ahead and say print invalid. Now, this isn't good enough, but I'm at least checking for the presence of a username now. And you might not have seen this before, but if you simply ask a question like if username, and username is a string, well, if username is going to give me a true answer if username is anything except none or quote unquote nothing. So there's a truthy value here, whereby if username has at least one character, that's going to be considered true. But if username has no characters, it's going to be considered a false value effectively. But this isn't good enough. I don't want to just check for username. I want to also check that it's the case that dot is in the domain name as well. So notice here there's a bit of potential confusion with the English language. Here I seem to be saying if username and dot in domain, as though I'm asking the question if the username and the dot are in the domain, but that's not what this means. These are two separate Boolean expressions. If username, and separately, if dot in domain. And if I parenthesize this, we could make that even more clear by putting parentheses there, parentheses here. So just to be clear, it's really two Boolean expressions that we're anding together, not one longer English-like sentence. Now, if I go ahead and run this, python of validate.py, enter, I'll do my own email address again, malin@harvard.edu, and that's valid. And it looks like I could tolerate something like this. If I do malin at just say Harvard, I think at the moment this is going to be invalid. Now, maybe the top-level domain Harvard exists, but at the moment it looks like we're looking for something more. We're looking for a top-level domain too, like .edu. So for now, we'll just consider this to be invalid. But it's not just that we want to do It's not just that we want to check for the presence of a username and the presence of a dot. Let's be more specific. Let's start to now narrow the scope of this program, not just to be about generic emails more generally, but about edu addresses. So specifically for someone in a US university, for instance, whose email address tends to end with .edu. I can be a little more precise, and you might recall this function already. Instead of just saying, is there a dot somewhere in domain, let me instead say, and the domain ends with, quote unquote, .edu. So now we're being even more precise. We want there to be minimally a username that's not empty. It's not just quote unquote nothing. And we want the domain name to actually end with .edu. Let me go ahead and run python of validate.py. And just to make sure I haven't made things even worse, let me at least test my own email address, which does seem to be valid. Now, it seems that I minimally need to provide a username, because we definitely do have that check in place. So I'm going to go ahead and say Malin. And now I'm going to go ahead and say @ and it looks like I could be a little malicious here, just say Malin @ .edu, as though minimally meeting the requirements of this pattern. And that, of course, is considered valid, but I'm pretty sure there's no one at Malin @ .edu. We need to have some domain name in there, so we're still not being quite as generous. Now, we could absolutely continue to iterate on this program, and we could add some more Boolean expressions. We could maybe use some other Python methods for checking more precisely. Is there something to the left of the dot, to the right of the dot? We could use split multiple times, but honestly, this just escalates quickly. Like, you end up having to write a lot of code just to express something that's relatively simple in spirit. Just format this like an email address. So how can we go about improving this? Well, it turns out in Python, there's a library for regular expressions. It's called succinctly RE. And in the RE library, you have a lot of capabilities to define and check for and even replace patterns. Again, a regular expression is a pattern, and this library, the RE library in Python, is going to let us to define some of these patterns, like a pattern for an email address, and then use some built-in functions to actually validate a user's input against that pattern, or even use these patterns to change the user's input or extract partial information therefrom. We'll see examples of all this and more. So what can and should I do with this library? Well, first and foremost, it comes with a lot of functionality. Here's the URL, for instance, to the official documentation. And let me propose that we focus on using one of the most versatile functions in the library, namely this, search. re.search is the name of the function in the RE module that allows you to pass in a few arguments. The first is going to be a pattern that you want to search for in, for instance, a string that came from a user. The string argument here is going to be the actual string that you want to search for that pattern. And then there's a third argument, optionally, that's a whole bunch of flags. A flag in general is like a parameter you can pass in to modify the behavior of the function. But initially, we're not even going to use this. We're just going to pass in a couple of arguments instead. So let me go ahead and employ this RE library, this regular expression library, and just improve on this design incrementally. So we're not going to solve this problem all at once, but we'll take some incremental steps. I'm going to go back to VS Code here, and I'm going to go ahead now and get rid of most of this code, but I'm going to go into the top of my file and first of all import this RE library. So import RE gives me access to that function and more. Now, after I've gotten the user's input in the same way as before, stripping off any leading or trailing white space, I'm just going to use this function super trivially for now, even though this isn't really a big step forward. I'm going to say if re.search contains quote unquote @ in the email address, then let's go ahead and print valid. Else, let's go ahead and print invalid. At the moment, this is really no better than my very first version, where I was just asking Python if @ in the email address. But now, I'm at least beginning to use this library by using its own re.search function, which for now you can assume returns a true value effectively if indeed the @ is in email. Just to make sure that this version does work as I expect, let me go ahead and run python of validate.py and enter. I'll type in my actual email address, and we're back in business. But of course, this is not great, because if I similarly run this version of the program and just type in an @, not an email address, and yet my code, of course, thinks it is valid. So how can I do better than this? Well, we need a bit more vocabulary in the realm of regular expressions in order to be able to express ourselves a little more precisely. Really, the pattern I want to ultimately define is going to be something like, I want there to be something to the left, then an @, then something to the right, and that something to the right should end with .edu, but should also have something before the .edu, like Harvard or Yale or any other school in the US as well. Well, how can I go about doing this? Well, it turns out that in the world of regular expressions, whether in Python or a lot of other languages as well, there are certain symbols that you can use to define patterns. At the moment, I've just used literal raw text. If I go back to my code here, this technically qualifies as a regular expression. I've passed in a quoted string inside of which is an @ sign. Now, that's not a very interesting pattern. It's just an @ sign. But it turns out that once you have access to regular expressions or a library that offers that feature, you can more powerfully express yourself as follows. Let me reveal that the pattern that you pass to re.search can take a whole bunch of special symbols. And here's just some of them. In the examples we're about to see, in the patterns we're about to define, here are the special symbols. You can use a single period, a dot, to just represent any character except a new line, a blank line. So that is to say, if I don't really care what letters of the alphabet are in the user's username, I just want there to be one or more characters in the user's name, dot allows me to express A through Z, uppercase and lowercase, and a bunch of other letters as well. Star is going to mean, in single asterisk, 0 or more repetitions. So if I say something star, that means that I'm willing to accept either 0 repetitions, that is nothing at all, or more repetitions, 1 or 2 or 3 or 300. If you see a plus in my patterns, that's going to mean 1 or more repetitions. That is to say, there's got to be at least one character there, one symbol, and then there's optionally more after that. And then you can say 0 or 1 repetition. You can use a single question mark after a symbol, and that will say I want 0 of this character or 1, but that's all I'll expect. And then lastly, there's going to be a way to specify a specific number of symbols. If you use these curly braces and a number, represented here symbolically as m, you can specify that you want m repetitions, be it 1 or 2 or 3 or 300. You can specify the number of repetitions yourself. And if you want a range of repetitions, like you want this few characters or this many characters, you can use curly braces and 2 numbers inside, called here m and n, which would be a range of m through n repetitions. Now, what does all of this mean? Well, let me go back to VS Code here, and let me propose that we iterate on this solution further. It's not sufficient to just check for the @ sign. We know that already. We minimally want something to the left and to the right. So how can I represent that? I don't really care what the user's username is or what letters of the alphabet are in it, be it Malin or anyone else's. So what I'm going to do to the left of this equal sign is I'm going to use a single period, the dot that again indicates any character except for a new line. But I don't just want a single character. Otherwise, the person's username could only be A at such and such or B at such and such. I want it to be multiple such characters, so I'm going to initially use a star. So dot star means give me something to the left, and I'm going to do another one, dot star something to the right. Now, this isn't perfect, but it's at least a step forward, because now what I'm going to go ahead and do is this. I'm going to rerun python to validate.py. I'm going to keep testing my own email address just to make sure I haven't made things worse, and that's now OK. I'm now going to go ahead and type in some other input, like how about just Malin @ with no domain name whatsoever. And you would think this is going to be invalid, but it's still considered valid. But why is that? If I go back to this chart, why is Malin @ with no domain now considered valid? What's my mistake here? By having used dot star at dot star as my regular expression or regex.
Because you're using the star instead of the plus sign?
Exactly. The star, again, means 0 or more repetitions. So re.search is perfectly happy to accept nothing after the @ sign, because that would be 0 repetitions. So I think I minimally need to evolve this and go back to my code here. And let me go ahead and change this from dot star to dot plus. And let me change the ending from dot star to dot plus, so that now when I run my code here, let me go ahead and run python of validate.py. I'm going to test my email address as always. Still working. Now let me go ahead and type in that same thing from before that was accidentally considered valid. Now I hit enter. Finally, it's invalid. So now we're making some progress on being a little more precise as to what it is we're doing. Now I'll note here, like with almost everything in programming, Python included, there's often multiple ways to solve the same problem. And does anyone see a way in my code here that I could make a slight tweak if I forgot that the plus operator exists and go back to using a star? If I allowed you only to use dots and only stars, could you recreate the notion of plus
Yes, use another dot. Dot star.
Yeah, because if a dot means any character, we'll just use a dot. And then when you want to say or more, use another dot and then the star. So equivalent to dot plus would have been dot dot star, because the first dot means any character, and the second pair of characters, dot star, means 0 or more other characters. And to be clear, it does not have to be the same character. Just by doing dot or dot star does not mean your whole username needs to be A or AA or AAA or AAAA. It can vary with each symbol. It just means 0 or more of any character back to back. So I could do this on both the left and the right. Which one is better? You know, it depends. I think an argument could be made that this is even more clear because it's obvious now that there's a dot, which means any character, and then there's the dot star. But if you're in the habit of doing this frequently, one of the reasons things like the plus exist is just to consolidate your code into something a little more succinct. And if you're familiar with seeing the plus, now maybe this is more readable to you. So again, just like with Python more generally, you're going to often see different ways to express the same patterns, and reasonable people might agree or disagree as to which way is better than another. Well, let me propose, too, that we can think about both of these models a little more graphically. If this looks a little cryptic to you, let me go ahead and rewind to the previous incarnation of this regular expression, which was just a single dot star. This regular expression, dot star at dot star, means what again? It means 0 or more characters, followed by a literal @ sign, followed by 0 or more other characters. Now, when you pass this pattern in as an argument to re.search, it's going to read it from left to right and then use it to try to match against the input, email in this case, that the user typed in. Now, how is the computer, how is re.search going to keep track of whether or not the user's email matches this pattern? Well, it turns out that it's going to be using a machine of sorts, implemented in software known as a finite state machine, or more formally, a non-deterministic finite automaton. And the way it works, if we depict this graphically, is as follows. The re.search function starts over here in a so-called start state. That's the sort of condition in which it begins. And then it's going to read the user's email address from left to right, and it's going to decide whether or not to stay in this first state or transition to the next state. So for instance, in this first state, as the user's reading my email address, malin@harvard.edu, it's going to follow this curved edge up and around to itself, a reflexive edge. And it's labeled dot because dot, again, just means any character. So as the function is reading my email address, malin@harvard.edu, from left to right, it's going to follow these transitions as follows. M, A, L, A, N. And then it's hopefully going to follow this transition to this second state, because there's a literal @ sign both in this machine as well as in my email address. Then it's going to try to read the rest of my address. HARVARD.edu, and that's it. And then the computer is going to check, did it end up in an accept state, a final state that's actually depicted here pictorially a little differently with double circles, one inside of the other. And that just means that if the computer finds itself in that second accept state, after having read all of the user's input, it is indeed a valid email address. If by some chance the machine somehow ended up stuck in that first state, which does not have double circles and it is therefore not an accept state, the computer would conclude this is an invalid email address instead. By contrast, if we go back to my other version of the code where I instead had dot plus on both the left and the right, recall that re.search is going to use one of these state machines in order to decide from left to right whether or not to accept the user's input, like malin@harvard.edu. Can we get from the start state, so to speak, to an accept state to decide, yep, this was, in fact, meeting the pattern? Well, let's propose that this non-deterministic finite automaton looked like this instead. We're going to start as before in the leftmost start state, and we're going to necessarily consume one character per this first edge, which is labeled with a dot to indicate that we can consume any one character, like the M in malin@harvard.edu. Then we can spend some time consuming more characters before the @ sign, so the A, L, A, N. Then we can consume the @ sign. Then we can consume at least one more character, because recall that the regex has dot plus this time. And then we can consume even more characters if we want. So if we first consume the H in harvard.edu, that then leaves the A, R, V, A, R, D, and then .edu. And now here too, we're at the end of the story, but we're in an except state because that circle at the end has 2 circles total, which means that if the computer, if this function finds itself in that except state after reading the entirety of the user's input, it is too, in fact, a valid email address. If by contrast, we had gotten stuck in one of those other states, unable to follow a transition, one of those edges, and therefore unable to make progress in the user's input from left to right, then we would have to conclude that that email address is in fact invalid. Well, how can we go upon improving this code further? Let me propose now that we check not only for a username, and also something after the username, like a domain name, but minimally required that the string ends with .edu as well. Well, I think I could do this fairly straightforward. Not only do I want there to be something after the @ sign, like the domain, like Harvard, I want the whole thing to end with .edu. But there's a little bit of danger here. What have I done wrong by implementing my regular expression now in this way by using @plus, @plus, .edu? What could go wrong with this version?
The dot means something else in this context where it means 0 or more repetitions of a character, which is why it will interpret it differently.
Exactly. Even though I mean for it to mean literally .edu, a period, and then .edu, unfortunately in the world of regular expressions, dot means any character, which means that this string could technically end in AEDU, or BEDU, or CEDU, and so forth, but that's not, in fact, that I want. So any instincts now as to how I could fix this problem, and let me demonstrate the problem more clearly. Let me go ahead and run this code here. Let me go ahead and type in mailin@harvard.edu. And as always, this does in fact work. But watch what happens here. Let me go ahead and do mailin@harvard, and then mailin@harvard (edu), enter. That too is valid. So I could put any character there, and it's still going to be accepted, but I don't want (edu). I want .edu literally. Any instincts then for how we can solve this problem here? How can I get this new function, re.search, and a regular expression more generally to literally mean a dot, might you think?
You can use the escape character, the \.
Indeed, the so-called escape character, which we've seen before outside of the context of regular expressions when we talked about new lines. \n was a way of telling the computer, I want a new line, but without actually literally hitting enter and moving the cursor yourself. And you don't want a literal n on the screen. So \n was a way to escape n and convey that you want a new line. It turns out regular expressions use a similar technique to solve this problem here. In fact, let me go into my regular expression. And before that final dot, let me put a single \. In the world of regular expressions, this is a so-called special sequence. And it indicates, per this \, and a single dot, that I literally want to match on a dot. It's not that I want to match on any character and then edu. I want to match on a dot or a period edu. But we don't want Python to misinterpret this \, as beginning an escape sequence, something special like \n, which even though we as the programmer might type 2 characters \n, it really is interpreted by Python as a single new line. We don't want any kind of misinterpretation like that here. So it turns out there's one other thing we should do for regular expressions like this that have a \, used in this way. I want to specify to Python that I want this string, this regular expression in double quotes, to be treated as a raw string, literally putting an R at the beginning of the string to indicate to Python that you should not try to interpret any \s in the usual way. I want to literally pass the \, and the dot, and the edu into this particular function search in this case. So it's similar in spirit to using that f at the beginning of a format string, which of course tells Python to format the string in a certain way, plugging in variables that might be between curly braces. But in this case, R indicates a raw string that I want passed in exactly as is. Now, it's only strictly necessary if you are in fact using \s to indicate that you want some special sequence like \dot. But in general, it's probably a good habit to get into to just use raw strings for all of your regular expressions so that if you eventually go back in, make a change, make an addition, you don't accidentally introduce a \, and then forget that that might have some special or misinterpreted meaning. Well, let me go ahead and try this new regular expression. I'll clear my terminal window, run python of validate, run python of validate.py, And then I'll type in my email address correctly, mailin@harvard.edu, and that's fortunately still valid. Let me clear my screen and run it one more time, python of validate.py. And this time, let's mistype it as mailin@harvard?edu, whereby there's obviously not a dot there, but there is some other single character that last time was misinterpreted as valid. But this time, now that I've improved my regular expression, it's discovered as indeed invalid. Any questions now on this technique for matching something to the left of the @ sign, something to the right, and now ending with .edu explicitly?
What happens when a user enters multiple @ signs?
A good question, and you kind of called me out here. Well, when in doubt, let's try. Let me go ahead and do python of validate.py, mailin @ harvard.edu, which also is incorrect. Unfortunately, my code thinks it's valid. So another problem to solve, but a shortcoming for now. Other questions on these regular expressions thus far?
Can you use curly brackets M instead of backslash?
Can you use curly brackets instead of backslash? Not in this case. If you want a literal dot, backslash dot is the way to do it literally. How about one other question on regular expressions?
Is this the same thing that Google Forms uses in order to categorize data? In, let's say, if you've got multiple people sending in requests about some feedback, do they categorize the data that they get using this particular regular expression thing?
Indeed, if you've ever used Google Forms to not just submit it, but to create a Google form, one of the menu options is for response validation, in English at least. And what that allows you to do is specify that the user has to input an email address or a URL or a string of some length. But there's an even more powerful feature that some of you may not have ever noticed. And indeed, if you'd like to open up Google Forms, create a new form temporarily, and poke around, you will actually see, in English at least, quote unquote regular expression mentioned as one of the mechanisms you can use to validate your user's input into your Google Forms. So in fact, after today, you can start avoiding the specific dropdowns of like email address or URL or the like, and you can express your own patterns precisely as well. Regular expressions can even be used in VS Code itself. If you go and find or do a find and replace in VS Code, you can, of course, just type in words like you could into Microsoft Word or Google Docs. You can also type, if you check the right box, regular expressions and start searching for patterns, not literally specific values. Well, let me propose that we now enhance this implementation further by introducing a few other symbols, because right now with my code, I keep saying that I want my email address to end with .edu and start with a username, but I'm being a little too generous. This does in fact work as expected for my own email address, mailin@harvard.edu. But what if I type in a sentence like, my email address is mailin@harvard.edu, and suppose I've typed that into the program, or I've typed that into a Google form, is this going to be considered valid or invalid? Well, let's consider. It's got the @ sign, so we're good there. It's got one or more characters to the left of the @ sign. It's got one or more characters to the right of the @ sign. It's got a literal .edu somewhere in there to the right of the @ sign. And granted, there's more stuff to the right. There's literally this period at the end of my English sentence. But that's OK, because at the moment, my regular expression is not so precise as to say the pattern must start with the username and end with the .edu. Technically, it's left unsaid what more can be to the left and what more can be to the right. So when I hit enter now, you'll see that that whole sentence in English is valid. And that's obviously not what you want. In fact, consider the case of using Google Forms or Office 365 to collect data from users. If you don't validate your input, your users might very well type in a full sentence or something else with a typographical error, not an actual email. So if you're just trying to copy all of the results that have been typed into your form so you can paste them into Gmail or some email program, it's going to break because you're going to accidentally paste something like a whole English sentence into the program instead of just an email address, which is what your mailer expects. So how can I be more precise? Well, let me propose we introduce a few more symbols as well. It turns out, in the context of a regular expression, one of these patterns, you can use the caret symbol, the little triangular mark, to represent that you want this pattern to match the start of the string specifically. Not anywhere, but the start of the user string. By contrast, you can use a $sign in your regular expression to say that you want to match the end of the string, or technically just before the new line at the end of the string. But for all intents and purposes, think of caret as meaning start of the string and $sign as meaning end of the string. It is a weird thing that one is a caret and one is a $sign. These are not really things that I think of as opposites, like a parenthesis or something like that. But those are the symbols the world chose many years ago. So let me go back to VS Code now, and let me add this feature to my code here. Let me specify that, yes, I do want to search for this pattern, but I want the user's input to start with this pattern and end with this pattern. So even though it's going to start looking even more cryptic, I put a caret symbol here at the beginning, and I put a $sign here at the end. That does not mean I want the user to type a caret symbol or a $sign. This is special symbology that indicates to re.search that it should only look for now an exact match against this pattern. So if I now go back to my terminal window, and I'll leave the previous result on the screen, let me type the exact same thing. My email address is malin@harvard.edu, enter, period. And now I'm going to go ahead and hit enter. Now that's considered invalid. But let me clear the screen, and just to make sure I didn't break things, let me type in just my email address, and that too is valid. Any questions now on this version of my regular expression, which note goes further to specify even more precisely that I want it to match at the start and the end? Any questions on this one here?
Okay, you have slash and .edu, and then the $sign. But the dot is like one of the regular expression, right?
It normally is, but this backslash that I deliberately put before this period here is an escape character. It is a way of telling re.search that I don't want any character there. I literally want a period there. And it's the only way you can distinguish one from the other. If I got rid of that slash, this would mean that the email address just has to end with any character, then an E, then a D, then a U. I don't want that. I want literally a period, then the E, then the D, then the U. This is actually common convention in programming and technology in general. If you and I decide on a convention whereby we're using some character on the keyboard to mean something special, invariably we create a future problem for ourselves when we want to literally use that same character. And so the solution in general to that problem is to somehow escape the character so that it's clear to the computer that it's not that special symbol, it's literally the symbol it sees.
So we don't need another slash before the $sign?
No, because in this case, $sign means something special. Per this chart here, $sign by itself does not mean US dollars or currency. It literally means match the end of the string. If, however, I wanted the user to literally type in a $sign at the end of their input, the solution would be the same. I would put a backslash before the $sign, which means my email address would have to be something like malin@harvard.edu $sign, which is obviously not correct too. So backslashes just allow you to tell the computer to not treat those symbols specially, like meaning something special, but to treat them literally instead. How about one other question here on regular expressions?
You said one represents to make it one plus, then you said one was to make it one with nothing.
Sure.
So
let me rewind in time. I think what you're referring to was one of our earlier versions that initially looked like this, which just meant 0 or more characters, then an @sign, then 0 or more other characters. We then evolved that to be this, .+ on both sides, which means 1 or more characters on the left, then an @sign, then 1 or more characters on the right. And if I'm interpreting your question correctly, one of the points I made earlier was that if you didn't use plus or forgot that it exists, you could equivalently achieve the exact same result with 2 dots and a star. Because the first dot means any character. It's got to be there. The second dot star means 0 or more other characters. And same on the right. So it's just another way of expressing the same idea. 1 or more can be represented like this with ... star. Or you can just use the handier syntax of .+, which means the same thing. All right, so I dare say there's still some problems with the regular expression in this current form, because even though now we're starting to look for the username at the beginning of the string from the user, and we're looking for the .edu literally at the end of the string from the user, those dots are a little too encompassing right now. I am allowed to type in more than the single @sign. Why? because at is a character and dot means any character. So honestly, I can have as many at signs as this thing at the moment as I want. For instance, if I run python of validate.py, mailin at harvard.edu still works as expected. But if I also run python of validate.py and incorrectly do mailin at harvard.edu, that should be invalid, but it's considered valid instead. So I think we need to be a little more restrictive when it comes to that dot. And we can't just say, oh, any old character there is fine. We need to be more specific. Well, it turns out that regular expressions also support this syntax. You can use square brackets inside of your pattern. And inside of those square brackets, include one or more characters that you want to look for specifically. Alternatively, you can, inside of those square brackets, put a caret symbol, which unfortunately in this context means something completely different from match the start of the string. But this would be the complement operator inside of these square brackets, which means you cannot match any of these characters. So things are about to look even more cryptic now, but that's why we're focusing on regular expressions on their own here. If I don't want to allow any character, which is what a dot is, let me go ahead and I could just say, well, I only want to support A or B's or C's or D's or E's or F's or G's. I could type in the whole alphabet here, plus some numbers to actually include all of the letters that I do want to allow. But honestly, a little simpler would be this. I could use a caret symbol and then an at sign, which has the effect of saying, this is the set of characters that has everything except an at sign. And I can do the same thing over here. Instead of a dot, to the right of the at sign, I can do open bracket, caret, at sign. And I admit, things are starting to escalate quickly here. But let's start from the left and go to the right. This caret outside of the square brackets at the very start of my string, as before, means match from the start of the string. And let's jump ahead. The dollar sign all the way at the end of the regular expression means match at the end of the string. So if we can mentally tick those off as straightforward, let's now focus on everything else in the middle. Well, to the left here, we have new syntax, a square bracket, another caret, an at sign, and a closed square bracket, and then a plus. The plus means the same thing as always. It means one or more of the things to the left. What is the thing to the left? Well, this is the new syntax. Inside of square brackets here, I have a caret symbol and then an at sign. That just means any character except an at sign. It's a weird syntax, but this is how we can express that simple idea. Any character on the keyboard except for an at sign. And heck, even other characters that aren't physically on your keyboard, but that nonetheless exist. Then we have a literal at sign. Then we have another one of these same things. Square bracket, caret, at, close bracket, which means any character except an at sign, then one or more of those things, followed by literally a period edu. So now let me go ahead and do this again. Let me rerun python of validate.py and test my own email address to make sure I've not made things worse, and we're good. Now let me go ahead and clear my screen and run python of validate.py again and do mailin at harvard.edu, crossing my fingers this time, and finally, this now is invalid. Why? I'm allowing myself to have one at sign in the middle of the user's input, but everything to the left, per this new syntax, cannot be an at sign. It can be anything but one or more times. And everything to the right of the at sign can be anything but an at sign one or more times, followed by, lastly, a literal .edu. So again, the new syntax is quite simply this. Square brackets allow you to specify a set of characters that you literally type out at your keyboard, A, B, C, D, E, F, or the complement, the opposite, the caret symbol, which means not, and then the one or more symbols you want to exclude. Questions now on this syntax here?
So right after add sign, can we use the curly brackets M1 so that we can only have one repetition of the add symbol?
Absolutely. So we could do this. Let me go ahead and pull up VS Code and let me delete the current form of a regular expression and go back to where we began, which was just .star at and .star. I could absolutely do something like this and require that I want at least one of any character here. And then I could do something more to have any more as well. So the curly brace syntax, which we saw on the slide earlier but didn't yet use, absolutely can be used to specify a specific number of characters. But honestly, this is more verbose than is necessary. The best solution, arguably, or the simplest at least ultimately, is just to say dot plus. But there too, another example of how you can solve the same problem multiple ways. Let me go back to where the regular expression just was and take other questions as well. Questions on these sets of characters or complementing that set?
So can you use that same syntax to say that you don't want a certain character throughout the whole string?
You could. It's going to be, you could absolutely use the same character to exclude you could absolutely use this syntax to exclude a certain character from the entire string, but it would be a little harder right now because we're still requiring .edu at the end. But yes, absolutely. Other questions?
What happens if the user inputs .edu in the beginning of the string?
A good question. What happens if the user types in .edu at the beginning of the screen? Well, let me go back to VS Code here, and let's try to solve this in two different ways. First, let's look at the regular expression and see if we can infer if that's going to be tolerated. Well, according to the current cryptic regular expression, I'm saying that you can have any character except the @ sign. So that would work. I could have the dot for the .edu, but then I have to have an @ sign. So that wouldn't really work, because if I'm just typing in .edu, we're not going to pass that constraint. So now let me try this by running the program. Let me type in just literally .edu. That doesn't work. But, I could do this, .edu @ .edu. That too is invalid. But let me do this, .edu at something .edu. That passes. So it's starting to get a little weird now. Maybe it's valid, maybe it's not, but I think we'll eventually be more precise too. How about one more question on this regular expression and these complementing of sets?
Can we use another domain name as the string input?
Can you use another domain name? Absolutely. I'm using my own just for the sake of demonstration, but you could absolutely use any domain or top-level domain. And I'm using .edu, which is very US-centric, but this would absolutely work exactly the same for any top-level domain. All right, let me go ahead now and propose that we improve this regular expression further, because if I pull it up again in VS Code here, you'll see that I'm being a little too tolerant still. It turns out that there are certain requirements for someone's username and domain name in an email address. There is an official standard in the world for what an email address can be and what characters can be in it. And this is way too accommodating of all of the characters in the world except for the @ symbol. So let's actually narrow the definition of what we're going to tolerate in usernames, and companies like Gmail could certainly do this as well. Suppose that it's not just that I want to exclude @ signs. Suppose that I only want to allow for, say, characters that normally appear in words, like letters of the alphabet A through Z, be it uppercase or lowercase, maybe some numbers, and heck, maybe even an underscore could be allowed too. Well, we can use this same square bracket syntax to specify a set of characters as follows. I could do A, B, C, D, E, F, G, H, I, J. Oh my God, this is going to take forever. I'm going to have to type out all 26 letters of the alphabet, both lowercase and uppercase. So let me stop doing that. There's a better way already. If you want to specify within these square brackets a range of letters, you can actually just do a hyphen. If you literally do A-Z in these square brackets, the computer is going to know you mean A through Z. You do not need to type 26 letters of the alphabet. If you want to include uppercase letters as well, you just do the same. No spaces, no commas. You literally just keep typing A through capital Z. So I have little a hyphen little z, big A hyphen big Z. No spaces, no commas, no separators. You just keep specifying those ranges. If I additionally want numbers, I could do 0, 1, 2, 3, 4. Nope, you don't need to type in all 10 decimal digits. You can just say 0 through 9 using a hyphen as well. And if you now want to support underscores as well, which is pretty common in usernames for email addresses, you can literally just type an underscore at the end. Notice that all of these characters are inside of square brackets, which just again means here is a set of characters that I want to allow. I have not used a caret symbol at the beginning of this whole thing because I don't want to complement it with an E, not complement it with an I. Don't want to complement it by making it the opposite. I literally want to accept only these characters. I'm going to go ahead and do the same thing on the right. If I want to require that the domain names similarly come from this set of characters, which admittedly is a little too narrow, but it's familiar for now, so we'll keep it simple. I'm going to go ahead and paste that exact same set of characters over there to the right. And so now it's much more restrictive. Now I'm going to go ahead and run python of validate.py. I'm going to test my own email address, and we're still good. I'm going to clear my screen and run it once more. This time trying to break it, let me go ahead and do something like, how about David_Malin at harvard.edu, enter. But that too is going to be valid. But if I do something completely wrong again, like Malin at harvard.edu, that's still going to be invalid. Why? Because my regular expression currently only allows for a single at in the middle, because everything to the left must be alphanumeric, alphabetical or numeric, or an underscore, the same thing to the right, followed by the .edu. Now, honestly, this is a regular expression that you might be in the habit of typing in the real world, as cryptic as this might look. This is the world of regular expressions, so you'll get more comfortable with this syntax over time. But thankfully, some of these patterns are so common that there are built-in shortcuts for representing some of the same information. That is to say, you don't have to constantly type out all of the symbols that you want to include, because odds are some other programmer has had the same problem. So built into regular expressions themselves are some additional patterns you can use. And in fact, I can go ahead and get rid of this entire set, A through Z lowercase, A through Z uppercase, 0 through 9, and an underscore, and just replace it with a single \W. \W in this case represents a word character, which is commonly known as a alphanumeric symbol or the underscore as well. I'm going to do the same thing over here. I'm going to highlight the entire set of square brackets, delete it, and replace it with a single \W. And now I feel like we're making progress, because even though it's cryptic, and would have looked way cryptic a little bit ago, and even though it would have looked even more cryptic a little bit ago, now it's at least starting to read a little more friendly. The caret on the left means start matching at the beginning of the string. \W means any word character. The plus means one or more. At symbol literally. Then another word character, one or more. Then a literal dot. Then literally edu, and then match at the very end of the string, and that's it. So there's more of these too, and we won't use them all here, but here is a partial list of the patterns you can use within a regular expression. One, you have \D for any decimal digit. Decimal digit meaning 0 through 9. Commonly done here too is if you want to do the opposite of that, the complement, so to speak, you can do \D, which is anything that's not a decimal digit. So it might be letters and punctuation and other symbols as well. Meanwhile, \S means white space characters, like a single hit of the space, or maybe hitting tab on the keyboard. That's white space. \S is the opposite or complement of that, anything that's not a white space character. \W we've seen, a word character, as well as numbers and the underscore. And if you want the complement or opposite of that, you can use \W to give you everything but a word character. Again, these are just common patterns that so many people were presumably using in yesteryear that it's now baked into the regular expression syntax so that you can more succinctly express your same ideas. Any questions then on this approach here, where we're now using \W to represent my word character?
So what I want to ask about was the actually the previous approach, like the square bracket approach. Could we accept like lists in there?
Yes, we'll see this before long. But suppose you wanted to tolerate not just .edu, but maybe .edu or .com. You could do this. You could introduce parentheses, and then you can OR those together. I could say com or edu. I could also add in something like, in the US, or gov, or net, or anything else, or org, or the like. And each of the vertical bars here means something special. It means or, and the parentheses simply group things together. Formally, you have this syntax here. A or B, A or vertical bar B means A has to match or B has to match, where A and B can be any other patterns you want. In parentheses, you can group those things together. So just like math, you can combine ideas into one phrase and do this thing or the other. And there's other syntax as well that we'll soon see. Other questions on these regular expressions and this syntax here?
What if we put spaces in the expression?
Sure. So if you want spaces in there, you can't use \w alone, because that is only a word character, which is alphabetical, numerical, or the underscore. But you could do this. You could go back to this approach whereby you use square brackets, and you could say A through Z, or A through Z, or 0 through 9, or underscore, or I'm going to hit the space bar, a single space. You can put a literal space inside of the square brackets, which will allow you then to detect a space. Alternatively, I could still use \w, but I could combine it as follows. I could say, give me a \w or a \s, because recall that \s is white space, so it's even more than a single space. It could be a tab, but by putting those things in parentheses, now you can match either the thing on the left or the thing on the right one or more times. How about one other question on these regular expressions?
Perfect. So I was going to ask, does the \w include a dot? Because no.
Nope,
Okay.
it only includes letters, numbers, and underscore. That is it.
And I was wondering, you gave an example at the beginning that had spaces, like this is my email, so and so. I don't think our current version, even quite a long while ago, stopped accepting it. Was that because of the caret, or because of something else?
No, the reason I was handling spaces and other English words when I typed out my email address as mailin@harvard.edu was because we were using initially .* or .+, which is any character. And even after that, we said anything except the @sign, which includes spaces. Only once I started using square brackets and A through Z and 0 through 9 and underscore did we finally get to the point where we would reject white space. And in fact, I can run this here. Let me go into the current version of my code in VS Code, which is using, again, the \w's for word characters. Let me run python validate.py and incorrectly type in something like, my email address is mailin@harvard.edu, period, which has spaces to the left of my username, and that is now invalid because space is not a word character. Yorgo notes, too, that technically I'm not allowing dots, and some of you might be thinking, wait a minute, my Gmail address has a dot in it. That's something we're going to still have to fix. A \w is not the end all here. It's just allowing us to express our previous solution a little more succinctly. Now, one thing we're still not handling quite properly is uppercase versus lowercase. The \w technically does handle lowercase letters and uppercase because it's the exact same thing as that set from before, which had little a through little z and big A through big Z. But watch this. Let me go ahead in my current form, run python validate.py, and just because my caps lock key is down, mailin@harvard.edu, shouting my email address, it's going to be OK in terms of the mailin. It's going to be OK in terms of the Harvard because those are matching the \w, which does include lowercase and uppercase, but I'm about to see invalid. Why? Why is mailin@harvard.edu invalid when it's in all caps here, even though I'm using \w?
Yeah, so you are asking for the domain.edu in lowercase, and you're typing it in uppercase.
Exactly. I'm typing in my email address in all uppercase, but I'm looking for literally .edu. And as I see you with AirPods and so many of you with headphones, I apologize for yelling into my microphone just now to make this point. But let's see if we can't fix that. Well, if my pattern on line 5 is expecting it to be lowercase, there's actually a few ways I can solve this. One would be something we've seen before. I could just force the user's input to all lowercase. And I could put onto the end of my first line .lower and actually force it all to lowercase. Alternatively, I could do that a little later. Instead of passing in email, I could pass in the lowercase version of email because email addresses should, in fact, be case insensitive. So that would work too. But there's another mechanism here which is worth seeing. It turns out that that function before, called re.search supports, recall, a third argument as well, these so-called flags. And flags are configuration options, typically to a function, that allow you to configure it a little differently. And how might I go about configuring this call to re.search a little bit differently insofar as I'm currently only passing in 2 arguments? Well, it turns out that some of the flags you can pass into this function are these. It turns out that the regular expression library in Python, aka RE, comes with a few built-in variables, so to speak, things that you can think of as constants that have meaning to re.search, and they do so as follows. If you pass in as a flag re.ignore case, what re.search is going to do is ignore the case of the user's input. It can be uppercase, lowercase, a combination thereof. The case is going to be ignored. It will be treated case insensitively. And you can do other things too that we won't do here, but if you want to handle the user's input that maybe spans multiple lines, maybe they didn't just type in an email address, but an entire paragraph of text, and you want to match different lines of that text, that is multiple lines, another flag is for re.multi-line for just that, or re.all, whereby you can configure the dot to recognize not just any character except new lines, but any character plus new lines as well. But for now, let me go ahead and just make use of this first one. Let me pass in a third argument to re.search, which is re.ignore case. Let me now rerun the program without clearing my screen, python of validate.py. Let me type in again in all caps, effectively shouting, maylin@harvard.edu, enter, and now it's considered valid because I'm telling re.search specifically to ignore the case of the input, and that too here is fine. And why might I do this approach rather than call .lower in one of those other locations? If I don't actually want to change the user's input for whatever reason, I can still treat it case insensitively without actually changing the value of that variable itself. All right, any final questions now on this validation of email addresses?
So the pattern is a string, right?
Mm-hmm.
Can we use an F string?
You can. Yes, you can use an F string so that you could plug in, for instance, the value of a variable and pass it into the function. Other questions on this?
\w character, could we take it as an input from the user?
Technically, yes. That's not a problem we're trying to solve right now. We want the user to provide literal input, like their email address, not necessarily a regular expression. But you could imagine building software that asks the user, especially if they're more advanced users, to type in a regular expression for some reason to validate something else against that. And in fact, that's what Google's doing. If you play around with Google Forms and create a form with response validation and select regular expression, Google lets you and I type in our own regular expressions, which would be a perfect example of that. All right, well, let me propose that we try to solve one other problem here, whereby if I go into the same version as before, which is now ignoring case, but I type in one of my other email addresses. Let me go ahead and run python of validate.py, and this time let me type in not maylin@harvard.edu, which I use primarily, but another email address of mine, maylin@cs50.harvard.edu, which forwards to the same. Let me go ahead and hit enter now, and invalid. Even though I'm pretty sure that is, in fact, my email address. Well, let's put our finger on the reason why. Why at the moment is maylin@cs50.harvard.edu being considered invalid, even though I'm pretty sure I send and receive email from that address too? Why might that be?
Because there is a dot that has come after the @ symbol.
Exactly. There's a dot after my CS50, and I'm not expecting any dots there. I'm expecting only, again, word characters, which is A through Z, 0 through 9, and underscore. So I'm going to have to retool here. But how could I go about doing this? Well, it turns out theoretically there could be other email addresses, even though they'd be getting a little excessively long. For instance, maylin@something.cs50.harvard.edu, which does not technically exist, but it could. You can have, of course, multiple dots in a domain name like we see here. Wouldn't it be nice if we could handle that as well? Well, let me propose that we modify my regular expression as follows. It turns out that you can group ideas together. And you can not only ask whether or not this pattern matches or this one, using syntax like A vertical bar B, which means either A or B. You can also group things together and then apply some other operator to them as well. In fact, let me go back to VS Code here, and let me propose that if I want to tolerate a subdomain like CS50 that may or may not be there, let me go ahead and change it as follows. I could naively do this. If I want to support subdomains, I could say, well, let's allow for other word characters plus, and then a literal dot. And notice, I'll highlight in blue here what I've just added. Everything else is the same, but I'm now adding room for another sequence of one or more word characters and then a literal dot. So this now, I think, if I rerun python and validate.py, will work for mailin at cs50.harvard.edu, enter. Unfortunately, does anyone see where this is going? Let me rerun python and validate.py and type in, as I keep doing, mailin at harvard.edu, which up until now has kept working despite all of my changes. But now, finally, I've broken my own email address. So logically, what's the solution here? Well, there's a bunch of ways we could solve this. I could maybe start using two regular expressions and support email addresses of the form username at domain.tld or username at subdomain.domain.tld, where TLD just means top-level domain like edu. Or I could maybe just modify this one, because I'd prefer not to have like two regular expressions or one that's twice as big. Why don't I just specify to re.search that part of this pattern is optional? What was the symbol we saw earlier that allows you to specify that the thing before it is technically optional?
The straight bar. We are using the straight bar as optional, make the argument optional.
So we could use a vertical bar and some parentheses and say either there's something here or there's nothing. We could do that in parentheses, but I think there's actually an even easier way.
Actually, is a question mark.
Indeed, question mark. Think back to this summary here of our first set of symbols, whereby we had not just dot and star and plus, but also a question mark, which means literally 0 or 1 repetitions, which effectively means optional. It's either there, 1, or it's not, 0. Now, how can I translate to this code here? Well, let me go ahead and surround this part of my pattern with parentheses, which doesn't mean I want literally a parenthesis in the user's input. I just want to group these characters together. And in fact, this now will still work. I've only added parentheses around the new part for the subdomain. Let me run python and validate.py. Let me run mailin at cs50.harvard.edu, enter. That's still valid. But to be clear, if I rerun it again for mailin at harvard.edu, that is still invalid. But not if I go in here and say after the parentheses, which now is one logical unit, it's one big group of ideas together, I add a single question mark there. This will now tell re.search that that whole thing in parentheses can either be there once or be there not at all, 0 times. So what does this translate into when I run it? Well, let me go ahead and rerun it with mailin at cs50.harvard.edu so that the subdomain's there. That works as before. Let me clear my screen and run it again. Python and validate.py with mailin at harvard.edu, which used to work, then broke. Are we back in business now? We are. That's now valid again. Questions now on this approach where we've used not just the question mark, but the parentheses as well.
Okay, yeah, you said it works for 0 or 1 repetition. What if you have more?
What if you have more? That's OK. That's where you could do star. Star is 0 or more, which gives you all the flexibility in the world.
Yeah, so I was just asking that with question mark, there's only one repetition allowed.
It means 0 or 1 repetition. So it's either not there or it is there. And so that's why this pattern now, if I go back to my code, even though, again, it admittedly looks cryptic, let me highlight everything after the @ sign and before the $sign. This now represents a domain name, like harvard.edu, or a subdomain within the domain name. Why? Well, this part to the right is the same as always. \w+ means something like Harvard or Yale. \.edu means literally .edu. So the new part is this. In parentheses, I have another set of \w plus \dot now, but it's all in parentheses. I'm now having a question mark right after that, which means that whole thing in parentheses either can be there or it can't be there. It's either of those that are acceptable. So a question mark effectively makes something optional. It would not be correct to remove the parentheses, because what would this mean? If I remove the parentheses, that would mean that only this dot is optional, which isn't really what we want to express. I want the subdomain, like CS50 and the additional dot, to be what's there or not there. How about one other question on regexes here?
Can they use this for the usernames?
Absolutely. We still have other problems, right? We're not solving all of the problems today just yet, but absolutely. Right now, we are not letting you have a period in your username. And again, some of you with Gmail accounts or other accounts, you probably have not just underscores, numbers, and letters. You might have periods too. Well, we could fix that. Not using question mark here per se, but now that we have these parentheses at our disposal, what I could do is this. I could use parentheses to surround the \w to say any word character, which is the same thing again as a letter or a number or an underscore. But I could also or in, using a vertical bar, something else, like a literal dot. Now, a literal dot needs to be escaped. Otherwise, it represents any character, which would be a regression, a step back. But now notice what I've done. In parentheses, I'm telling re.search that those first few characters in your email address, that is your username, has to be a word character, like A through Z, uppercase or lowercase, or 0 through 9, or an underscore, or a literal dot. We could do this differently too. I could get rid of the parentheses and the or, and I could just use a set of characters. I could again manually say A through Z, 0 through 9, underscore, and then I could do a literal dot with a \, period. And now I technically don't even need the uppercase, because I'm already telling the computer to ignore case. I can just pick one or the other. Which one is better is really up to you. Whichever one you think is more readable would generally be the better design. All right, let me propose that I rewind this in time to where we left off, which was here. And let me propose that there are indeed still limitations of this solution, not just with the username, not just with the domain name. We're still being a little too restrictive. So would you like to see the official regular expression that at least browsers use nowadays whenever you type in an email address to a web form, and the web form, the browser, tells you yes or no, your email address is syntactically valid? Ready? Ready? Here is, and this isn't even officially the right regular expression. It's a simplified version that browsers use because it catches most mistakes, but not all. Here we go. This is the regular expression for a valid email address, at least as browsers nowadays implement them. Now, it's crazy cryptic at first glance, but note, and it's wrapping onto many lines, but it's just one pattern. But just notice the now familiar symbols. There is the caret symbol at the very top. There is the $sign at the very end. There is a square bracket over here, and then some of these ranges plus other characters. Turns out you don't normally see these characters in email addresses. It looks like you're swearing at someone in their username. But they're valid characters. They're valid officially. That doesn't mean that Gmail is going to allow you to put $signs and other punctuation in your username, but officially some servers might allow that. So if you really want to validate a user's email address, you would actually come up with or copy paste something like this. But honestly, this looks so cryptic, and if you were to type it out manually, you are so likely to make a mistake. What's the better solution here instead? This is where, per past weeks, libraries are your friend. Surely someone else on the internet, a programmer more experienced than you even, has come up with code that validates email addresses properly using this regular expression or even something more sophisticated than that. So generally, if the problem at hand is to validate input that is pretty conventional, an email address, a URL, something where there's an official definition that's independent of you yourself, find a popular library that you're comfortable using and use it in your code to validate email addresses. This is not a wheel necessarily that you yourself should invent. We've used email addresses, though, to iteratively start from something simple, too simple, and build on top of that. So you could certainly imagine using regular expressions still to validate things that aren't email addresses, but are data that are important to you. So we at least now have these building blocks. Now, besides the regular expressions themselves, it turns out there's other functions in Python's RE library for regular expressions. Among them is this function here, re.match, which is actually very similar to re.search, except you don't have to specify the caret symbol at the very beginning of your regex if you want to match from the start of a string. re.match by design will automatically start matching from the start of the string for you. Similar in spirit is re.fullMatch, which does the same thing, but not only matches at the start of the string, but the end of the string, so that you too don't need to type in the caret symbol or the $ as well. But let's go ahead and transition back now to some actual code whereby we solve a different problem in spirit. Rather than just validate the user's input and make sure it looks the way we want, let's just assume that the users are not going to type in data exactly as we want, and so we're going to have to clean up their input. This happens so often when you're using like a Google form or Office 365 form or anything else to collect user input. No matter what your form question says, your users are not necessarily going to follow those directions. They might go ahead and type in something that's a little differently formatted than you might like. Now, you could certainly go through the results and download a CSV or open the Google spreadsheet or equivalent in Excel and just clean up all of the data manually. But if you've got lots of submissions, dozens, hundreds, thousands of rows in your data set, doing things manually might not be very fun. It might be much more effective to write code, as in Python, that can allow you to clean up that data and any future data as well. So let me propose that we go ahead here and close validate.py, and let's go ahead and create a new program altogether called format.py, the goal of which is to reformat the user's input in the format we expect. I'm going to go ahead and run code of format.py, and let's suppose that the data we're going to reformat is the user's name. So not email address, but name this time. And we're going to hope that they type in their name properly, like David Malin. But some users might be in the habit, for whatever reason, of typing their name backwards, if you will, with a comma, such as Malin, comma, David instead. Now, it's fine because both are clearly as readable to the human, but if you want to standardize how those names are stored in your system, perhaps a database or CSV file or something else, it would be nice to at least standardize or canonicalize the format in which you're storing your data so that if you print out the user's name, it's always the same format, David Malin, and there's no commas or backwardsness to it. So let's go ahead and do something familiar. Let's go ahead and give myself a variable called name and set it equal to the return value of input, asking the user, as we've done many times, what's your name, question mark. I'm going to go ahead and proactively at least clean up some messiness, as we keep doing here, by just stripping off any leading or trailing white space, just in case the user accidentally hits the space bar. We don't want that ultimately in our data set. And now let me go ahead and do this, as we've done before. Let me just go ahead quickly and print out, just to make sure I'm off to the right start, hello, and then in curly braces, name. So making an F string to format hello, comma, name. Now, let me go ahead and clear my screen and run Python of format.py. Let me behave and type in my name as I normally would, David space Malin, enter. And I think the output looks pretty good. It looks as expected grammatically. Let me now go ahead, though, and play this game again, but this time maybe because I'm not thinking or I'm just in the habit of doing last name, comma, first, I do Malin, comma, David, and hit enter. All right, well, this now is weird. Even though the program is just spitting out exactly what I typed in, arguably this is not close to correct, at least grammatically. It should really say, hello, David Malin. Now, maybe I could have some if conditions and I could just reject the user's input if they type a comma or get their names backwards somehow. But that's going to be too little too late if the user has already submitted a form online and I already have the data and now I need to go in and clean it up. And it's not going to be fun to go through manually in Google Spreadsheets or Apple Numbers or Microsoft Excel and manually fix a lot of people's names to get rid of the commas and move the first name before the last, as is conventional in the US. So let's do this. It could be a little fragile, but let's start to express ourselves a little programmatically here and ask this. If there is a comma in the person's name, which is Pythonic, I'm just asking the question, is this shorter string in this longer string? Then let me go ahead and do this. Let me go ahead and grab that name in the variable, split on not just the comma, but the space after, assuming the human typed in a space after their name. And let me go ahead and store the result of that splitting of Malin, comma, David into two variables. Let's do last, comma, first. Again, unpacking the sequence of values that comes back. Now, let me go ahead and reformat the name. So I'm going to forcibly change the user's name to be as I expect. So name is actually going to be this format string. first name, then last name, both in curly braces, but formatted together with a single space so that I'm overriding the user's input and updating my name variable accordingly. For the moment, to be clear, this program is interactive. Like the users, like me, are typing their name into the program. But imagine the data already is in a CSV file. It came in from some process like a Google form or something else online. You could imagine writing code similar to this, but that maybe goes and reads that file into memory first. Maybe it's a CSV via a CSV reader or dict reader, and then iterating over each of those names. But we'll keep it simple and just do one name at a time. But now what's kind of interesting here is if I go back to my terminal window and clear it and run Python of format.py and hit enter, I'm going to type in David space Malin as before, and I think we're still good. But I'm also going to go ahead and do this. Python of format.py, Malin, comma, David, with a space in between, crossing my fingers and hit enter, and voila. That now has been fixed. Such a simple thing, to be sure, but it is so commonly necessary to clean up users' input. Here we see at least one way to do so pretty easily. Now, to be fair, there's some problems here. And in fact, can someone imagine a scenario in which this code really doesn't fix the user's input? What could still go wrong even with this fix in my code? Any thoughts?
If they type in their name, comma, and then sign them.
Oh, and then something else. Yeah, so let me try this, for instance. Let me go ahead and run a program. And I am the only David Malin that I know. But suppose I were, let's say, junior, like this. And it's common in English, at least, to sometimes put a comma there. You don't necessarily need the comma. But I'm one of those people who uses a comma. That's now really, really broken. So I've broken some assumption there. And so that could certainly go wrong here. What else? Well, let me go ahead and run this again. And if I did Malin, comma, David, no space, because I'm being a little sloppy, I'm not paying attention, which is going to happen when you have lots of users ultimately. Well, this really broke now. Notice I have a value error, an actual exception. Why? Well, because split is supposed to be splitting the string into two strings by looking for the comma and a space. But if there is no comma and space, it can't split it into two things. And the fact that I have two variables on the left, but I'm only getting back one thing on the right means that I can't do this code quite as this. So it's fragile, to be sure, but wouldn't it be nice if we could at least improve it? For instance, we now know some regular expression syntax. What if I at least wanted to make this space optional? Well, I could use my newfound regular expression syntax and put a question mark. Question mark means 0 or 1 of the things to the left. What's the thing to the left? It's literally a space. I don't even need parentheses if there's just one thing there. So that would be the start of a pattern that says I must have a comma, and then I may or may not have a space, 0 or 1 spaces thereafter. Unfortunately, the version of split that's built into the stir variable, as in this case, doesn't support regular expressions. If we want our regular expressions, we need to go use that library here. So let me go ahead and do this. Let me go in and leave this code as is, but go up to the top now and import RE to import the library for regular expressions. And now let me go ahead and start changing my approach here. I'm going to go ahead and do this. I'm going to use the same function called re.search, and I'm going to search for a pattern that I think will be last comma first. So let me use my newfound regular expression syntax and represent a pattern for something like Malin, comma, space David. How can I do this? Well, inside of my quotes for re.search, I'm going to have something, so dot plus, I'm going to have something, so dot plus. Then I'm going to have a comma. Then I'm going to have a space. Then I'm going to have something dot plus. Now I'm going to preemptively refine this a little bit. I want this whole pattern to start matching at the beginning of the user's input. So I'm going to add the caret right away. And I want the end of the user's input to be matched as well, so that I'm literally expecting any character one or more times, then a comma, then a space, then any other character one or more times. And then that is it. And I'm going to pass in the name variable as before. Now, when we've used re.search in the past, we really used it just to answer a question. Does the user's input match the following pattern or not, true or false, effectively? But re.search is actually more powerful than that. You can actually get back more information, and you can do this. You can specify a variable and then an assignment operator and get back more precise answers to what has been found when searched for. But what is it you want to get back? Well, it turns out there's this other feature of regular expressions which allow you to use parentheses not just to group things together, but to capture them. It turns out when you specify parentheses in a regular expression, unbeknownst to us up until now, everything in the parentheses will be returned to you as a return value from the re.search function. It's going to allow you to extract specific amounts of information from the user's own input. You can reverse this process too by using the non-capturing version as well. You can use parentheses and then literally a question mark and a colon and then some other stuff, and that will say, don't bother capturing this. I just want to group things. But for now, we're going to use just the parentheses themselves. So how am I going to do this? Well, if I want to get back the user's last name and first name, I think what I want to capture is the dot plus here and the dot plus here. So I've deliberately surrounded in parentheses the dot plus, both to the left and the right of the comma, not because I'm grouping them together per se. I'm not adding a question mark. I'm not adding up another plus or a star. I'm using parentheses now for capturing purposes. Why? Well, I'm going to do this next. I'm going to still ask a Boolean question, like if there are matches, then do this. So if matches is not effectively false, like none, I do expect I've gotten back some matches. And watch what I can do now. I can do last, comma first, equals whatever matches in and get back all of the groups of matches. Then go ahead and update name just like before with a format string and do first and then last in curly braces as well. And then at the very bottom, just like before, print out, for instance, hello, comma, name. So the new code now is everything highlighted here. I'm using research to search for whether the user typed their name in last, comma, first format. But I am more powerfully using re.search to capture some of the user's input. What's going to get captured? Anything I surrounded in parentheses will be returned to me as return values. How do you get at those return values? You ask the variable to which you assigned them for all of the groups of parentheses that were captured. So let me go ahead and do this. Let me go ahead now and run Python of format.py, enter, and I'm going to type my name as usual. In this case, nothing happens with this if condition. Why? Because I did not type a comma, and so this search does not find a comma, so there are no matches. So we immediately just print out hello name. Nothing interesting or new there. But if I now go ahead and clear my screen and run Python of format.py and do Malin, comma, space David, enter, we've reformatted my name. Well, how did this work? Let me be a little more explicit now. It turns out I don't have to just say matches.groups. I can get specific groups back that I want. So let me change my code a little bit more. Let me go ahead now and just say this. Let's update name actually, let's do this. Let's say that the last name is going to be in the matches, but specifically group 1. The first name is going to be in the matches, but specifically group 2. Why 1 and 2? Because this is the first set of parentheses to the left of the comma. This is the second set of parentheses to the right of the comma. And based on the input, this would be the user's last name in this scenario, Malin. This would be the user's first name, David, in this scenario. That's why I'm using group 1 for the last name and group 2 for the first name. And now I'm going to go ahead and say name equals f string again, first and then last, done. And let me refine this one last step before we take questions. I don't really need these variables if I'm immediately using them. Let's just go ahead and tighten this up further, as we've done in the past for design's sake. If I want to make the name the concatenation of the person's first name and last name, let's just do this. Matches.group2 first plus a space plus matches.group1. So it's just up to me to know from left to right, this is group 1, this is group 2. So group 1 is last, group 2 is first. So if I want to flip them around and update the value of name, I can explicitly get group 2 first, concatenate using plus, a single space, and then concatenate on group 1. All right, that was a lot. Let me pause to see if there are questions. The key difference here is we're still using re.search the exact same way, but now I'm using its return value, not just to answer a question true or false, but to actually get back specific matches, anything I captured, so to speak, with parentheses.
Why is it here we're using 1 and 2 instead of 0 and 1?
A really good question.
Capturing the first.
A good observation. In almost every other context, we've started counting at 0 and 1 instead of 1 and 2. It turns out there's something else in location 0 when it comes back from re.search related to the string itself. So